Welcome to Simplilearn's YouTube channel. In today's fast-moving digital economy, organizations are expected to release software updates quickly, reliable, and also minimal downtime. However, in traditional development environments, development and operations team often work independently. This separation created communication gaps, slower release cycles, and increased the chances of deployment failures. DevOps emerged as a modern approach to solve this challenge by bringing development and operations teams together. It focuses on collaboration, automation, and continuous improvement to accelerate software delivery while maintaining system stability and reliability. DevOps are not just tools, it's culture and a set of practices that enable teams to build, test, deploy, and monitor applications more efficiently. Companies across industry now rely on DevOps engineers to design automated pipelines, manage cloud infrastructure, and ensure seamless application deployment. In this complete DevOps engineer course, you will learn key concepts and technologies that power modern software delivery pipelines. We will begin with the fundamentals of DevOps and gradually explore essential topics such as Linux, version control, continuous integration, containerization, infrastructure as code, cloud computing, monitoring, and DevSecOps practices. Throughout the course, you will also gain exposure to industry standard tools used by DevOps professionals, including Git, Jenkins, Docker, Kubernetes, Terraform, and popular cloud platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platforms. By the end of this course, you'll have a strong understanding of how DevOps practices help organizations to automate workflows, improve deployment speed, and build scalable, reliable systems. Whether you're a beginner exploring DevOps or a developer looking to expand your skill set or an IT professional aiming to transition into DevOps role, this course will provide the practical knowledge and confidence needed to start your DevOps journey. Having said that, let's take a look at today's agenda. We will start off with Module 1, which is Introduction to DevOps and DevOps Culture. Module 2 is DevOps Lifecycle and Key Principles. Module 3 is Linux Fundamentals for DevOps Engineers. Module 4 is Version Control with Git and GitHub. Module 5 is Software Development Lifecycle. Module 6 is Continuous Integration Concepts. Module 7 is CI/CD Pipelines with Jenkins. Module 8 is Containerization with Docker. Module 9 is Container Orchestration with Kubernetes. Module 10 is Infrastructure as Code with Terraform. Module 11 is Configuration Management with Ansible. Module 12 is Cloud Computing for DevOps. Module 13 is Monitoring and Logging. Module 14 is DevSecOps and Security DevOps. Module 15 is DevOps Automation and Real-World Projects. Module 16 is DevOps Engineer Interview Question and Answers. That said, if these are the type of videos you would like to watch, then hit that subscribe button with the bell icon to get notified whenever we host. Also, just so that you know, if you want to upskill yourself, master cloud computing and DevOps skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various cloud computing and DevOps programs. Simplilearn offers a variety of master's, certification, and postgraduate programs in collaboration with some of the world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like application migration, auto-scaling, continuous integration, BI, microservices, database management, and over a couple of dozen others. And that's not all, you'll also get an opportunity to work on multiple projects led by industry experts working in top-tier data and product companies. After completing these courses, thousands of learners have transitioned into cloud computing and DevOps role as a fresher or moved on to higher-paying job and profile. If you're passionate about making your career in this field, then make sure to check out the link in the pinned comments and in the description box to find DevOps and cloud computing program that fits your experience and areas of interest. So let's get started with our small quiz. What is the primary goal of DevOps? Building website? Improving collaboration between development and operations team? Designing computer hardware? Or is it creating databases? Please let us know your answers in the comment section below. Now over to our training experts.
Right from the start, software development comprised two different departments. The development team that develops the plan, designs, and builds the system from scratch, and the operation team for testing and implementation of whatever is developed. The operations team gave the development team feedback on any bugs that needed fixing and any rework required. Invariably, the development team would be idle awaiting feedback from the operations team. This undoubtedly extended timelines and delayed the entire software development cycle. There would be instances where the development team moves on to the next project, while the operations team continues to provide feedback for the previous code. This meant weeks or even months for the project to be closed and final code to be developed. Now, what if the two departments came together and worked in collaboration with each other? What if the wall of confusion was broken? And this is called the DevOps approach. The DevOps symbol resembles an infinity sign, suggesting that it is a continuous process of improving efficiency and constant activity. The DevOps approach makes companies adapt faster to updates and development changes. The teams can now deliver quickly, and the deployments are more consistent and smooth. Though there may be communication challenges, DevOps manages a streamlined flow between the teams and makes the software development process successful. The DevOps culture is implemented in several phases with the help of several tools. Let's have a look at these phases. The first phase is the planning phase, where the development team puts down a plan, keeping in mind the application objectives that are to be delivered to the customer. Once the plan is made, the coding begins. The development team works on the same code, and different versions of the code are stored into a repository with the help of tools like Git and merged when required. This process is called version control. The code is then made executable with tools like Maven and Gradle in the build stage. After the code is successfully built, it is then tested for any bugs or errors. The most popular tool for automation testing is Selenium. Once the code has passed several manual and automated tests, we can say that it is ready for deployment and is sent to the operations team. The operations team now deploys the code to the working environment. The most prominent tools used to automate these phases are Ansible, Docker, and Kubernetes. After the deployment, the product is continuously monitored, and Nagios is one of the top tools used to automate this phase. The feedback received after this phase is sent back to the planning phase, and this is what forms the core of the DevOps lifecycle, that is, the integration phase. Jenkins is the tool that sends the code for building and testing. If the code passes the test, it is sent for deployment, and this is referred to as continuous integration. There are many tech giants and organizations that have opted for the DevOps approach. For example, Amazon, Netflix, Walmart, Facebook, and Adobe. Netflix introduced its online streaming service in 2007. In 2014, it was estimated that a downtime for about an hour would cost Netflix $200,000. However, now Netflix can cope with such issues. They opted for DevOps in the most fantastic way. Netflix developed a tool called the Simian Army that continuously created bugs in the environment without affecting the users. This chaos motivated the developers to build a system that does not fall apart when any such thing happens. So, on this note, here is a quiz for you. Match the DevOps tool with the phase it is used in. A. B. C. D. None of the above. Today, more and more companies lean towards automation, with the aim of reducing its delivery time and the gap between its development and operations teams. To attain all of these, there's just one gateway: DevOps.
Meet Tim. Tim builds a robot in his lab, a climate-controlled and pollution-free environment. Once he's done, he drops the robot off at his project partner, Mia's house. Mia takes it out to her backyard to ensure that the robot meets the requirements. But here is where the problem arises. The change in the environment causes the robot to malfunction. Mia is now really annoyed and she has a lot to correct. And it seems to her as though Tim didn't really do much. This wall between them leaves the poor robot to bite the dust. Well, what if we broke this wall? Tim and Mia now work together in a common space. Tim develops each block of functionality of the robot, which is then immediately checked by Mia. Both are now working simultaneously instead of waiting on the other to finish their task. As and when a feature is ready for use, they are put together to build the final product. They develop a common mindset and share ideas. To further speed up the process, they use several tools which can automate every stage. This means that the robot is now ready sooner with less iterations and manual work. From an organization perspective, Tim would be the developer, while Mia the operations. Their union is the core of the DevOps approach. DevOps has several stages and set of tools to automate each of these stages. Let's have a look at these. Tim first puts down a plan. In terms of software, this could mean deciding on the modules and the algorithms to use. Once he has the plan, he now codes the plan. With tools such as Git, Tim has a repository for storing all the codes and their different versions. This is called version control. Next, this code is fetched and made executable. This is the build stage. Tools such as Gradle and Maven will sort this out. Now, before deployment, the product is tested to catch any bugs. The most popular tool automating testing is Selenium. Once the products are tested, Mia must deploy it. The deployed product is then continuously configured to the desired state. Ansible, Puppet, and Docker are some of the most common tools used that automate these stages. Now, every product is continuously monitored in its working environment. Nagios is one such tool that automates this phase, and the feedback is fed back to the planning stage. And finally, we have the core of the DevOps lifecycle, the integration stage. Tools such as Jenkins is responsible for sending the code for build and test. If the code passes the tests, it's further sent for deployment. This is called continuous integration. Let's now have a look at an organization that has adopted the DevOps approach. Which of the below sequence of steps would they follow to develop a software? Leave your answers in the comment section. Keep an eye out for the right answer on the comment section or our YouTube community. Giants such as Amazon, Netflix, Target, Etsy, and Walmart have all adopted DevOps and seen a considerable increase in delivery and quality. In 2014, an hour of downtime for Netflix would cost it $200,000. It became absolutely crucial that Netflix prepared themselves for any sort of failure. And so, they took to the DevOps approach and implemented it in the most unique way. They developed a tool called the Simian Army. This tool created failures and automatically deployed them in an environment that did not affect the users. The team would troubleshoot these failures, and this gave them enough experience to deal with any degree of collapse. With everything being automated and happening simultaneously, organizations can now deliver at a much faster pace. So, considering the benefits of DevOps and its divergence from the traditional methods, would DevOps be the future? Let us know what you think in the comment section below.
So DevOps is an evolution of the Agile model. The Agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as Maven and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments, and so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another pointer here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment. So you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to the all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to Agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages. And there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams, so teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted.
Hey there, and welcome to our video on DevOps engineer roles and responsibilities. If you're new to the tech industry or just curious about the role of DevOps in software development, you have come to the right place. So what exactly is DevOps? In simple terms, it's a set of practices and tools that help developers and operational team work better together, releasing software faster with higher quality. At its core, DevOps is about breaking down barriers between development and operations and creating a culture of collaboration that focuses on delivering value to customers as quickly and efficiently as possible. Of course, this is a vast oversimplification, and there are many different aspects to DevOps that we could spend hours diving into. But for now, let's focus on some of the key responsibilities of a DevOps engineer, who is the person responsible for implementing and overseeing DevOps practices and processes. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to Simplilearn to stay updated with all the latest technologies, and hit that bell icon to never miss an update from us. So without any further ado, let's get started with today's topic. Firstly, let us understand what is DevOps. Now, DevOps is a software development approach that emphasizes collaboration, automation, and communication between development and operations team. It aims to streamline the entire software development lifecycle by integrating and optimizing processes, tools, and methodologies. It encourages a culture of shared responsibility where developers and operations team work together closely throughout the entire software development lifecycle, from planning and coding to testing, deployment, and monitoring. Now the question is, who is a DevOps engineer? Well, you got it right. A DevOps engineer is a professional who combines software development expertise with operations knowledge to facilitate collaboration, streamline processes, and improve software delivery and infrastructure management within an organization. A DevOps engineer role is to bridge the gap between development and operations team, enabling efficient and reliable software development and deployment practices. But the question is, how to become a DevOps engineer? What are the skills that you need to possess to become a good DevOps engineer? Well, a DevOps engineer possesses a wide range of skills, including proficiency in scripting and programming languages, knowledge of various tools and technologies, expertise in system administration, cloud platforms, and containerization technologies, as well as strong problem solving and communication skills are necessary. Firstly, having a good coding knowledge. Well, tools like Confluence, Jira, Git, these tools can support and enhance collaboration and project management within a DevOps environment. Next, having a good knowledge on deployment tools are also necessary. Now, tools like DCOS provides orchestration capabilities for distributed applications, Docker enables containerization for consistent and scalable deployments, and AWS offers a broad range of cloud services for infrastructure provisioning, scalability, and managed services. Next, you need to have a good knowledge on operations tools as well. Now, Chef and Ansible focus on infrastructure automation and configuration management, while Kubernetes specializes in container orchestration and management. These tools are utilized in DevOps to automate various aspects of software development life cycles, including infrastructure provisioning, configuration, management, application deployment, and scaling. Moving ahead, you need to have a strong grip on monitoring tools. Nagios, Splunk, and Datadog are three commonly used tools in the field of monitoring and observability. Now, each tool serves a specific purpose in monitoring and managing system and applications. Nagios specializes in infrastructure and application monitoring. Splunk focuses on log analysis and data visualization. Datadog provides comprehensive monitoring and analytic capabilities in cloud environments. These tools play a crucial role in maintaining the health and performance of systems and applications. Moving ahead, you need to have a good knowledge on Jenkins and CodeShip. Now, Jenkins and CodeShips are both essential tools in DevOps practices. Jenkins is a flexible and extensible automation server that supports continuous integration, testing, and deployment. On the other hand, CodeShip is a cloud-based CI/CD platform that offers simplicity, and ease of use, particularly for cloud-native applications. Both these tools contribute to improving development productivity and code quality. And finally, having a good knowledge on testing tools like Selenium, JUnit are necessary for a DevOps engineer. JUnit is primarily focused on unit testing and automated testing of Java code, while Selenium is geared towards functional testing and automation of web applications. Both these tools play critical roles in DevOps workflow, contributing to faster feedback cycles, improved code quality, and reliable software releases. So these are some of the main and important skills that you need to possess as a DevOps engineer. Well, now comes the main part. What exactly are the day-to-day roles and responsibilities of a DevOps engineer? Now, a DevOps engineer plays a crucial role in bridging the gap between development and operations team, as we discussed earlier. So here are some of the top 5 roles and responsibilities of a DevOps engineer in detail. First on the list, we have collaboration and communication. Now, DevOps engineers facilitate effective communication and collaboration with development and operations team. They actively participate in meetings and discussions to align goals and expectations. Now, as a DevOps engineer, you need to engage in regular meetings and discussions. Regular engagement ensures that they are up to date with ongoing projects, challenges, and goals, enabling them to better align their efforts and contribute effectively. Regular engagement ensures that they are up to date with ongoing projects, challenges, and goals, enabling them to better align their efforts and contribute effectively. Actively listen and understand the requirement, concerns, and feedback. Now, when engaging with development and operations team, DevOps engineers practice active listening. They pay close attention to the requirements, concerns, and feedback expressed by team members from both the sides. By understanding their perspectives, pain points, and suggestions, DevOps engineers can better assess the needs of their teams and collaborate to find suitable solutions. Facilitate effective communication channels. Now, DevOps engineers take the initiative to establish and maintain effective communication within the organization. This often involves setting up dedicated chat platforms like Slack, Microsoft Teams, or collaboration tools like Jira to foster better collaboration and ensure that information flows smoothly between the teams. And finally, encourage cross-functional collaboration. Now, DevOps engineers recognize the value of cross-functional collaboration and knowledge sharing among the team members. They actively encourage them from development and operations team to collaborate, exchange ideas, and share their expertise. Second on the list, we have infrastructure automation and configuration management. Now, DevOps engineers focus on automating infrastructure provisioning and managing configurations using certain tools. They define infrastructure as code, enabling efficient deployment and scaling of resources. Now, as a DevOps engineer, you have to identify the infrastructure requirements effectively. Now, DevOps engineers work closely with development teams to understand the infrastructure requirements of the application. This involves analyzing the needs of applications in terms of computer resources, storage, security, networking, and scalability. By gathering all these requirements, DevOps engineer can ensure that infrastructure is provisioned and configured to meet the application-specific need and future growth. Write infrastructure automation scripts and templates. Now, once the infrastructure requirements are identified, DevOps engineers use automation tools and techniques to define the desired state of infrastructure components. They write scripts and templates that specify how the infrastructure should be provisioned, configured, and managed. Automate the provisioning, configuration, and management of servers. Well, DevOps engineers leverage infrastructure as code, or in short IAC principles, to automate the provisioning, configuration, and management of servers, networks, and other infrastructure resources. They use tools like Ansible, Chef, or Puppet to automate the deployment and configuration of infrastructure components. And finally, regularly update infrastructure code. Now, DevOps engineer uses version control systems like Git to track changes, collaborate with team members, and manage different versions of infrastructure code. By regularly updating and versioning infrastructure code, DevOps engineers can easily track and revert changes whenever necessary. Now, third on the list, we have continuous integration and continuous deployment, or CI/CD in short. Now, DevOps engineers are responsible for establishing and maintaining CI/CD pipelines, which enable developers to integrate code changes seamlessly and deploy applications rapidly. So for that, they have to set up a version control system. Now, version control systems like Git play a crucial role in DevOps by providing a centralized repository for managing code and tracking changes. Setting up a version control system involves creating a repository, initializing it with the code, and defining branching and merging strategies. Configure a build server. Now, a build server automates the process of compiling, testing, and packaging application code. Tools like Jenkins and GitLab CI/CD allows you to define build pipelines that specify the steps to be executed. These pipelines typically involve tasks such as pulling code from repository, compiling source code, generating artifacts, and packaging the application. Next, automate the deployment process. Now, automation of the deployment process is crucial for achieving rapid and consistent software releases. Containerization tools like Docker provide a lightweight and portable way to package application and their dependencies. Docker containers can be created and deployed consistently across different environments, ensuring consistency between development, testing, and production. Define and enforce quality gates and monitor CI/CD KPIs. Quality gates ensure that the code meets predefined quality standards before it is promoted to the next stage of the CI/CD pipeline. Automated testing, including unit test, integrated test, and end-to-end test. Integration test and end-to-end test help catch bugs and validate the functionality of the managing applications. And finally, measuring KPIs of the CI/CD pipeline provide insights into its performance and help identify areas for improvement. Well, next we have monitoring and performance optimization. Now, DevOps engineers monitor system performance, identify and optimize the infrastructure and application stacks whenever necessary. They implement monitoring tools to collect and analyze metrics, logs, and traces. So for that, select and configure monitoring tools. Now, monitoring tools like Prometheus or Grafana can be used to collect and visualize these metrics, allowing teams to identify bottlenecks or optimize processes and enhance the overall efficiency of the CI/CD pipeline. Also, they have to collaborate with the development and operations team to fine-tune application performance. So, continuously optimizing the infrastructure, which will ensure high availability, scalability, and reliability of that application. And finally, we have security and compliance. Now, DevOps engineers play a critical role in implementing security measures and ensuring compliance with industry standards and regulations. They work closely with security teams to define and implement security controls throughout the software delivery pipeline. So they have to continuously collaborate with the security teams to identify and define security requirements and controls, and implement security measures such as vulnerability scanning, access management, and secure configuration. They have to continuously integrate security testing and code analysis into the CI/CD pipeline and monitor for any sort of potential security risks or breaches and respond promptly to mitigate any identified vulnerabilities. So these were some of the main or top 5 roles and responsibilities of a DevOps engineer. I hope you understood that.
DevOps engineers are one of the highest paid professionals in the tech industry today. And if you are watching this video, most likely you are someone who wants to get into DevOps or want to learn DevOps. But with so many different tools and technologies like Terraform, Ansible, Linux, AWS, Jenkins, Docker, Kubernetes, and so much more, learning DevOps can be very time consuming and confusing. And that is why in this video, I'm going to share with you a complete DevOps roadmap that you can follow to learn DevOps from scratch, and also an excellent resource you can use to learn all these DevOps tools at one place. So watch this video till the end. Before we start with the video and look into the DevOps roadmap, let me introduce myself. My name is Nasiullah Chaudhary, also goes by CloudChamp on YouTube, and I work as a freelance DevOps engineer for multiple companies. The roadmap shared in this video is the exact roadmap I followed to learn DevOps from scratch, and I'm pretty sure if you watch this video till the end, you will have a clear idea on what things to learn and what not to learn and get jobs faster. A DevOps engineer is responsible for deploying application and automating the manual process. But how can you automate a manual process if you don't know how is an application created? So first thing you need to know is to understand the concepts of software development. What is a build? What is software deployment? So generally try to understand the whole software development lifecycle from idea to code and to releasing the application to end users. After you understand the software development lifecycle and now you have an idea of how is an application created, second thing you need to know is Linux. Linux is very, very, very important. A DevOps engineer should have a good hands-on knowledge with Linux, need to know all the important commands, because every DevOps tools you look at, let's say Ansible, Terraform, Kubernetes, Docker, all of them work on commands, and you can only manage to work with them when you have good hands-on knowledge with Linux. So learn Linux. In Linux, you can learn things like shell commands, Linux file systems and permissions, SSH key management, virtualization, some part of networking like load balancers, how to set up firewalls, how IP addresses work, and much more. Linux is very important, so it's also called as operating system of the cloud. So spend time learning Linux. Now, most of you might be confused and you might ask, Let's say I want to learn all these tools, but where should I find the resources? You can learn this from YouTube, some of these from blogs, some from documentation, but they are all scattered, which will waste your time. So rather than that, I would suggest you checking out an excellent DevOps program by Simplilearn. This postgraduate DevOps program by Simplilearn is in collaboration with IBM, which will teach you all the important DevOps tools that you require in order to become a DevOps engineer, like Terraform, Maven, Ansible, Jenkins, Docker, Kubernetes, Git, and a lot more, along with industry projects that will provide you hands-on experience and can help you become DevOps engineer faster, and also a certification by Caltech, which will validate your learning in DevOps. So you can check out the learning path here and the reviews by previous learner. Wow, all of them are 5-star reviews. So click on the link in the description and click on apply now. For this program, you don't require any prior work experience. You require a bachelor degree with an average of 50% or higher marks. You can be from programming or non-programming background, which makes this program for everyone. So click on the link in the description, click on apply now, fill in all your details and proceed to start learning DevOps with Simplilearn. Next important thing after learning Linux is going to be Git, because every company is going to store their code online on Git repositories like GitHub, GitLab, or Bitbucket. So our DevOps engineers need to know how to work with Git to clone and push the code from local machine to Git repositories or from Git repositories to local machine. Also understand what is branching, how does branching works, what is merge request, what is pull request, and a lot more. So a DevOps engineer should have a good understanding of Git and also know all the most used Git commands. Once you have cleared your basics, now is the time to learn cloud, because DevOps engineers need to know how to create servers, databases, storage, virtual VPCs, and lot more on the cloud. You can choose any cloud like AWS, Azure, GCP, IBM, Oracle, or anything. But the DevOps engineers need to know how to create infrastructure to deploy their applications and software on the cloud. Once you have learned how to create infrastructure and deploy your applications on the cloud manually, you need to automate this, because DevOps is all about automation. So you can automate this using infrastructure as code tools like Terraform, Ansible, Chef, Puppet, and a lot more. But I would suggest you learning only these two tools, which are Terraform and Ansible, that are highly used in the industry today. Learning Ansible and Terraform can provide you with so many job opportunities. So start with learning Terraform and Ansible after you have mastered creating an application on the cloud manually. Due to rise in demand and application stability, companies are shifting from servers to containers, which is why you need to learn Docker and Kubernetes. For Docker, you need to understand the concepts of virtualization and concept of containerization. Also, you need to know how to containerize an application and run it on a server or a Kubernetes cluster. You need to know the commands on how to create Docker file, how to create Docker image, how to run containers, networking in Docker, and some of the parts. For Kubernetes, you need to understand the Kubernetes architecture, what is deployment, what is replica set, what is pod, what is node, and how to properly manage a containerized application using Kubernetes cluster, either on EKS, AKS, or GKE, which is going Kubernetes engine. So it is very important for you to understand and know the commands to properly work through containerization, which is a leading and a popular tool right now in the market. Next, very important thing for a DevOps engineer to learn is going to be CI/CD, or continuous integration and continuous deployment, because every company wants to deploy their application automatically. In DevOps, all code changes like new features or bug fixes should be integrated in the existing application and provided to the end user in an automated fashion. And you can only do this by using CI/CD. So a DevOps engineer should know how to set up CI/CD server, how to integrate code repositories to trigger pipeline automatically when there is a change, and to fix bug faster, and to provide better quality software to the end user very fast in automated fashion. Some popular CI/CD tool includes Jenkins, GitLab, Circle CI, Travis CI. So learning CI/CD will help you land your job very, very fast, and it's very important, also known as heart of DevOps. So you should master CI/CD. All the tools that we have mentioned till now will help you deploy an application on the cloud or on containers anywhere. But once the software or your application is in production, it is very important for you to monitor it, to track performance, to see if there are any issues, check system resources like CPU or RAM or anything. So one of the responsibilities of DevOps engineer is to set up software monitoring, infrastructure monitoring, collect logs, and to visualize data to check if there are any issues or if system has less resources or not. So you need to learn tools like Prometheus, Grafana, Also logging tools like CloudWatch or ELK Stack, which is very important to make sure that an application is running without any issues and without any problems. Congratulations, now you know all the tools and technologies you require to become a DevOps engineer. But DevOps is all about automation, and there is always going to be something that you can automate. So to automate this, you will require scripting language. And some of you might argue that scripting is not required, or you don't need any programming language in DevOps. Coding is not a thing in DevOps, but that's not actually true. You will require knowledge of one programming language or a scripting language because you need to automate the manual process. So some popular scripting language can be Bash, PowerShell, which are all OS related. So you can use Bash in Linux and PowerShell in Windows. And non-OS related are Python, Go, Ruby, which is what I would suggest. I would suggest you trying to learn Python, which can help you automate all the manual process like rotating passwords of your databases, like starting a deployment, starting a build, or clearing cache. Anything that you are doing manually can be automated through scripting languages using this Python or Go or Bash. My suggestion would be to start with Python. And if you learn Python, you will be unstoppable and you will have more value as a DevOps engineer. And you don't need to learn any programming language at a software engineer level. You just need to know enough Python or enough Go just to write scripts which can automate your things. You don't need to go deep in DSA and all those things, which are very common questions that I get. So just focus on learning Python in a way where you can automate things by writing scripts. So just the basics, not too advanced, only to automate stuff. So there you have it, a complete DevOps roadmap to learn things from scratch. Along with this, make sure you have your LinkedIn perfect, you attend meetups, and also enroll to the Simplilearn DevOps program. Thank you and have a good day.
Today, we are diving deep into DevOps, one of the most exciting and rapidly growing fields in tech. But what exactly is DevOps and why is everyone talking about it? DevOps at its core is a blend of development and operations. It's a culture, a mindset, and a set of practices that bridge the gap between software developers and IT operations team. And the goal? To deliver software faster, more efficiently, and with higher reliability. So in today's fast-paced digital world, businesses are racing to release new features, improve user experiences, and stay ahead of their competition. And DevOps is the secret sauce enabling them to do just that. So by automating processes, improving collaboration, and integrating cutting-edge tools, DevOps has become the backbone of modern software delivery. And here's the exciting part. As we approach 2025, the demand for skilled DevOps engineers is skyrocketing. It's one of the hottest career opportunities in tech right now, offering not just great salaries, but also the chance to work on innovative projects that shape the future. So in this video, I will guide you through the ultimate DevOps engineer roadmap for 2025. So whether you are a beginner or looking to level up, stick around. This roadmap could be your gateway to a rewarding career. But before we begin, make sure to check out the quiz linked in the description below. Take a few minutes to answer it and don't forget to share your thoughts in the comments. And we have more tricky and interesting quizzes lined up for you. So let's get started. So the first month is about choosing a programming language. So when you're diving into the world of DevOps, picking up a programming language is a game changer. It helps you automate tasks, integrate systems, and troubleshoot those tricky issues that pop up. So now the language you pick up can depend on the project you're working on. But the key skills you learn are going to be applied everywhere. So for beginners, I highly recommend starting with languages like Python or Go. Why? Because both are super easy to learn, have clean syntax, and are widely used across the IT industry. So now let's break down what all you have to learn under each of these languages. So in Python, you'll start with Introduction to Python. So you'll start with the basics like understanding how Python works, its syntax, and how to write clean, readable code. Then comes data types and variables. So here you will learn the fundamental building blocks like strings, integers, and lists. Then comes conditionals and loops. So get comfortable with if-else statements and loops. So these control the flow of your code. Then comes functions and modules. So organize your code into reusable functions and modules for clean, maintainable projects. Now next on the list is OOPS or object-oriented programming. So here you will dive into classes and objects. This is key for structuring your code effectively. And finally, you can go through some advanced concepts to explore things like exception handling, file input-output, regex, collections, and more to level up your Python game.
Now in Golang, again, you can start with introduction to Golang. Like Python, Go syntax is simple, but it's powerful for handling large-scale systems. After the introduction, you can move on to variables and constants. So here you can learn how to declare variables and constants essential for clean code. Then comes arrays and slices. Now these are Go's way of handling collections of data. After this comes concurrency and Go routines. So Go's real strength lies in handling multiple tasks at once. So you can get comfortable with Go routines for parallel processing. And finally, you can learn interfaces and methods. So Go is all about simplicity, but interfaces and methods let you write more flexible and reusable code. Now, once you have completed these modules, you'll be going to the second month where you'll be dealing with operating systems. So basically, operating systems are like the backbone of any computing environment. So they connect the hardware with the software. So as a DevOps engineer, you need a solid understanding of operating system to effectively manage applications, optimize infrastructure, and streamline deployment pipelines. So let's go through some of the key operating system concepts you'll need to know. First one is OS basics. So this is the foundation, understanding what an operating system does and how it works. Then comes processes and threads. So you can get familiar with the process lifecycle and how threads are managed within processes. Then next comes CPU scheduling. So learn how tasks are assigned to CPU resources and how time is allocated for different processes. Process synchronization. This ensures that processes don't clash with each other while running. Now next comes deadlock. So sometimes processes get stuck in a loop. So understanding how to identify and resolve these situations is crucial. And then there is memory management. So how does the operating system manage memory? So learning memory allocation strategies will make your systems run smoother. And finally, you'll learn about disk management and scheduling. So this is all about efficiently handling disk usage and optimizing read-write operations, which are key to keeping things running faster. And also in the second month, you'll be dealing with virtualization. So DevOps engineers should also be familiar with different types of virtualization to manage resources efficiently. So some of the virtualizations that you can get familiar with are application virtualization, network virtualization, desktop virtualization, storage virtualization, server virtualization, and data virtualization. Now let's move on to the third month. So if you want to be a top-tier DevOps engineer, mastering the command line interface or CLI is a must. So it gives you advanced control over systems and access to powerful features that go beyond the limitations of a graphical user interface or GUI. So being proficient in the CLI means you can manage, you can troubleshoot, and configure systems more efficiently. So whether you're working locally or remotely, this is especially crucial when it comes to infrastructure management and automating tasks across different environments and operating systems. So let's look at some key CLI skills to master. So number one is scripting. This is for automating repetitive tasks and creating custom scripts to make your work more efficient. Then next you can learn about editors. So learn CLI-based editors like Vim or Nano for editing files directly from the terminal. Then you can learn about networking tools. So get comfortable with tools like Ping, Netstat, and curl to troubleshoot network issues and manage network configurations. Next is process monitoring. So here you have to learn how to use tools like PS, Top, or HTOP to monitor processes and system performance in real time. After process monitoring comes performance monitoring, where tools like SAR and IOStat help you keep track of system performance and resource usage. And finally comes text manipulation. So you can master text processing tools like AWK, SED, and grep to handle and analyze large datasets directly from the terminal. So by becoming proficient in the CLI, you'll be able to solve problems faster, gain deeper insights into system behavior, and effectively manage infrastructure with confidence. Now moving on to the fourth month, if you're diving into DevOps, version control and hosting are non-negotiable. So they play a crucial role in collaboration, code management, and version tracking, especially if you're looking to implement GitOps or streamline your DevOps lifecycle. So when it comes to version control, Git is the go-to tool. It's the most widely used distributed version control system. So Git lets you create repositories to store your code, work with branches to make and test changes without affecting the main code base, make commits to save your progress and merge changes with others' works, and track every change made, which makes collaboration easy. And next comes hosting platforms. So once your code is neatly tracked with Git, it's time to host it. So hosting platforms let you make your code public or share it with your organization. So popular options are number one, GitHub. So this is the most popular platform for open source projects with tons of collaboration features. And then you have Bitbucket. So this is a great choice, especially for teams already using Atlassian tools like Jira. And finally, there is Git Lab. It is a feature-rich platform with integrated CI/CD pipelines for better DevOps workflow. So with Git and these hosting platforms, you'll have all the tools needed to manage your code base, collaborate smoothly with your team, and keep track of every change. So now let's move on to the 5th month. So in the 5th month, you are supposed to learn about cloud providers. So in your DevOps journey, understanding cloud computing is a game changer. So ultimately, all the applications you work on will be hosted somewhere, right? And that somewhere could be either on a cloud or on-premise. So there are a few big players in the cloud space that you'll want to get familiar with. Number one is, of course, AWS, Amazon Web Services. So AWS is one of the most popular cloud platforms, offering a ton of services. So whether it's EC2 for virtual machines, S3 for storage, or Lambda for serverless computing, AWS has a service for almost every need. And next you have Azure. So Azure is Microsoft's cloud platform and offers a wide range of services similar to AWS. However, the standout for DevOps professionals is Azure DevOps. It's a suite of integrated tools that covers everything from CI/CD pipelines to version control and project management. And then comes GCP, or Google Cloud Platform. So Google Cloud offers many of the same services as AWS and Azure, but with a unique touch. So whether you're working with Kubernetes or looking for storage options, GCP brings Google's power and reliability to the table. So now that we have completed the plan till the 5th month, you can take a moment to answer the next quiz in the description box. So I hope you have answered the quiz. So in the 6th month, you'll be dealing with containerization with Docker. So if you're serious about DevOps, Docker is a tool you can't afford to skip. So before Docker came, deploying applications involved packaging the app, downloading all necessary dependencies into the server, and manually configuring everything. So the scaling was a nightmare. But with Docker, packaging and deploying the app is a breeze, and it makes scaling super easy too. So here's what you have to concentrate while learning Docker. Number one is running containers. So learn how to run containers, essentially lightweight standalone applications on any system. Next, inspect active containers. So get comfortable with checking which containers are running, their status, and any issues that might pop up. And then you have Docker networking. So understand how containers communicate with each other and the outside world, which is key to a well-architected system. Then you'll want to persist data with Docker volumes. So by default, containers are ephemeral, meaning the data disappears when they stop. So learn how to use volumes to persist data beyond the life of a container. Next, you can learn about Dockerizing apps with Docker files. So master writing Docker files, simple text files that define how to build a Docker image for your app. Next, run multiple containers with Docker Compose. So learn how to manage multi-container apps using Docker Compose, which simplifies complex setups. And finally, there is Docker repositories. So learn how to work with Docker Hub or private repositories to store and share Docker images with others. So with Docker, deploying apps becomes faster, easier, and more scalable, making it an essential tool for any DevOps engineer. Also in the 6th month, you'll be dealing with container orchestration. So we have covered containers, right, and how they make scaling a breeze. But what if you need to manage lots of containers at once? So that's where container orchestration tools come in. So these tools let you automate the management of containers, like creating multiple replicas and scaling them as needed. So the two main players in this space are Kubernetes and Docker Swarm. So in the 7th month, you'll be moving on to networking and security protocols. So networking and security are the backbone of any DevOps process, especially since most of your work will be on servers and in production environments. So understanding networking concepts helps you manage and troubleshoot infrastructure. Deploy microservices, handle containerized application, automate network tasks. So here are some of the key concepts you have to learn in network and security. The first one is FTP, SFTP. So these are protocols for transferring files securely over the network. Then there is HTTP and HTTPS. So the foundation for web communication, and you should know the difference and when to use each of these. Then comes SSL, TLS. So these are the encryption protocols that secure the web traffic, keeping data safe. Then next you have DNS. So the system that helps convert domain names into IP addresses, basically the address book of the internet. Then you'll be dealing with SSH, which is a secure protocol used for remote server management and communication. Then you will move on to other protocols such as TCP/IP and UDP, which are also crucial. So with this knowledge, you'll have the tools to keep your network secure and your infrastructure running smoothly. Now in the 8th month, you must concentrate on understanding serverless computing. So this is a cloud computing model where you don't have to worry about managing or provisioning servers. So instead, cloud providers dynamically allocate resources as needed, allowing you to focus purely on writing and deploying your code. So as a DevOps engineer, here are the key tools and platforms you should dive into. First one is Cloudflare. So Cloudflare offers a suite of services including CDN and security, but also enables serverless computing for edge functions, speeding up your applications globally. Next is AWS Lambda. So AWS Lambda is Amazon's serverless platform, allowing you to run code without provisioning or managing servers. So you can get it to trigger in response to events, making it highly scalable and efficient. And then comes some Azure Functions. So Azure Functions from Microsoft offers similar serverless capabilities, enabling you to run small pieces of code in the cloud. And finally, there is Vercel. So Vercel is a cloud platform that focuses on serverless deployment for modern web apps, particularly for front-end applications. So by mastering these serverless computing, you'll be able to streamline your app development process, reduce costs, and let cloud providers handle the heavy lifting for you. Also in the 8th month, you'll be dealing with infrastructure provisioning. So as a DevOps engineer, you'll need to manage and set up infrastructure. But using traditional methods like ClickOps can be time consuming and hard to scale. So luckily things have gotten a lot easier. So infrastructure provisioning is all about automating the setup of your infrastructure. So some of the key tools in this area are Terraform, Pulumi, and AWS CDK. And then you have got configuration management. So basically configuration management is all about keeping track of and controlling the configuration of your infrastructure, software, and systems. So imagine in any organization, you will often need to manage multiple servers. And imagine doing this manually for hundreds or even thousands of servers. It's not only time consuming, but also prone to errors, right? So that's where configuration management tools comes in. So here are some essential tools to master in configuration management. Number one is Ansible. So Ansible is a simple and powerful automation that lets you configure servers, deploy apps, and manage tasks. So next there is Chef. This is another automation tool. So it's great for larger environments where scalability and flexibility is needed. And then you have Puppet. So Puppet allows you to manage infrastructure with a declarative language. So it's widely used for managing large-scale infrastructure and automating repetitive tasks across systems. Now moving on to the 9th month, you'll be dealing with infrastructure monitoring. So infrastructure monitoring is all about keeping an eye on the health and performance of your infrastructure and tracking its availability, checking for issues, and predicting future problems before they occur. So you collect data from system logs, metrics, and other streams and use that data to spot any potential issues. So here are some top tools you should learn for infrastructure monitoring. So first one is Grafana. So Grafana is a powerful open source tool that lets you visualize metrics and logs from multiple sources. Then you have Datadog. So again, Datadog is a cloud-based platform that offers comprehensive monitoring of infrastructure, performance, and logs. And then you have Prometheus. So Prometheus is an open source monitoring tool designed for reliability and scalability. So it's perfect for tracking time series data, and you can easily integrate with Grafana to give rich visualizations. Now finally, you have to learn about application monitoring. So application monitoring is crucial, especially when deploying updates or bug fixes. So a new change could unexpectedly take the app down. But with continuous monitoring, you can track, measure, and analyze the app's performance in real time to prevent issues from escalating. So here are some key tools for application monitoring. So number one is Datadog itself. So just like in infrastructure monitoring, Datadog is a great tool for application monitoring also, providing deep insights into your app's performance logs and other metrics. So it's perfect for real-time visibility. And then you have New Relic, you have Jaeger, and then there is Open Telemetry and App Dynamics. Now, in your final month of DevOps learning, focus on hands-on projects that put your knowledge into practice. Work on building pipelines, managing infrastructure, and monitoring systems. So this is the time to apply what you have learned and showcase your skills through real-world experience.
So the main question is, what fuels this DevOps revolution? Now, it's a powerful collection of tools specifically designed to support and amplify its principles. So these tools act as a catalyst, empowering teams to automate tasks, manage infrastructure efficiently, and monitor application performance effectively. So without any further delay, let us directly jump into the top 9 noteworthy tools, highlighting their features, benefits, and significance that have become synonymous with the DevOps ecosystem in no particular order. So first on the list, we have Jenkins. Now Jenkins is an open source automation server known for its extensive plugin ecosystem, making it highly versatile and customizable. It facilitates continuous integration and continuous delivery, or in short CI/CD pipelines, automating the build, test, and deployment processes. Jenkins enables teams to integrate code frequently, ensuring early detection of issues and faster software releases. So let us now look at some of the key features of Jenkins. Firstly, easy installation and configuration. Jenkins has a user-friendly web interface that simplifies installation, configuration, and management of build jobs and pipelines. Distributed builds for scalability. Now, it supports for a vast ecosystem of plugins for seamless integration, and it can distribute build tasks across multiple nodes, which helps in parallelizing builds and reducing overall build time, especially in large projects. And finally, extensible through scripting languages like Groovy. Now, Jenkins provides extensibility through scripting languages like Groovy, which is a powerful and versatile language that runs on the Java virtual machines, or in short JVM. So by leveraging Groovy's scripting capabilities, Jenkins becomes highly adaptable and customizable to meet the specific requirements of different development teams and projects. So those are some of the key features of Jenkins. Let us now move ahead and discuss some of the benefits or advantages of using Jenkins. So firstly, we have enables faster feedback and quicker time to market. Now, Jenkins' continuous integration capabilities enable developers to merge their code changes into a shared repository regularly. By doing so, Jenkins automatically triggers build and testing processes to validate any kind of changes. This automates feedback loop, allows developers to receive quick feedback on the quality of their code. So as a result, issues and bugs can be identified early in the development cycle, preventing the accumulation of defects and reducing the time required to fix them. As discussed earlier, it also facilitates early issue detection and reduced bug turnaround time. Now, with Jenkins running automated builds and tests every time new code is committed, potential issues and bugs are caught early in the development process. So by detecting issues at an early stage, developers can address them promptly before they propagate further into the code base. And finally, automates repetitive tasks, same time and effort. Now, Jenkins automates various tasks involved in the software development lifecycle. This includes tasks such as building the code, running tests, and deploying applications. By automating these repetitive and time-consuming tasks, Jenkins saves developers and operations teams significant amount of time and efforts. So that is what Jenkins is all about. It's widely adopted in the DevOps landscape due to its flexibility and extensive plugin support. And learning it will add a great value to your array of skills. So its ability to automate CI/CD processes and integrate with various tools makes it a crucial component of modern software development and delivery pipelines. Second on the list, we have Docker. Docker has revolutionized application deployment with its containerization approach. It allows developers to package applications and their dependencies into lightweight, isolated containers. Docker containers provide consistency across different environments, ensuring that applications run consistently regardless of the underlying infrastructure. This portability, along with the rapid startup times and efficient resource utilization, has made Docker a foundational tool in DevOps practices. So let us now discuss some of the key features of Docker. First one is packaging applications and dependencies into containers. Now, Docker allows developers to package their applications and all their dependencies into a self-contained unit called containers, and the process is known as containerization. Now, these containers encapsulate the application code, its runtime, various libraries, and system tools required to run the application. By doing so, Docker ensures consistency across different environments. Secondly, efficient resource utilization through containerization. Now, this lightweight nature of containers allows for more efficient resource utilization. Multiple containers can run on a single physical machine without the need for individual OS instances. It means that you can host more applications and services on the same hardware, reducing the number of servers needed. And finally, easy scaling and management of containers. Now, containerization simplifies application scaling and management. So when you need to handle increased application load, you can quickly scale by running more instances on the containerized application, on additional servers, or within a container orchestration platform like Kubernetes. So let us now talk about some of the benefits of the Docker tool. Now, firstly, rapid deployment and scalability. Docker enables rapid deployment of applications due to its lightweight and containerized approach. When using Dockers, developers package their applications and dependencies into containers which encapsulate everything needed to run the application. So these containers are portable and can be easily moved from one environment to the other. And next, we have the isolation of applications and dependencies for improved security. Docker utilizes containerization to isolate applications and the dependencies from the ecosystem and other containers. Each containers operate in its own user space, separate from other containers, providing a strong level of isolation. This isolation prevents applications from affecting each other and helps contain potential security breaches within the confines of the container. And finally, simplify development to production workflow. Now, Docker streamlines the development to production workflow by providing consistency between different environments. With Docker, developers can create containers that run the same way in development, testing, and production environments, thereby reducing the chances of unexpected issues arising during the deployment. So Docker has become a cornerstone of modern DevOps practices. Its ability to streamline application deployment and improve resource utilization has transformed software development and operations, enabling faster and more reliable application delivery. So that was all about Docker. So let us now move ahead and discuss the next tool, which is Kubernetes. So next on the list, we have Kubernetes. Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It provides a robust infrastructure for running and coordinating containers across clusters of machines, making it easier to manage large-scale deployments. DevOps teams can easily deploy, update, and scale applications, facilitating faster and more reliable software delivery while promoting collaboration and consistency across development and operations lifecycle through Kubernetes. So let us look at some of the key features of it. Automatic container deployment and scaling. Now, container orchestration platforms like Kubernetes provide automatic container deployment and scaling capabilities. When deploying applications on Kubernetes, you can define the desired state of your application using YAML files on declarative configuration. Kubernetes then takes care of this, ensuring that specified number of container replicas is running at all times. Service discovery and load balancing. Now, Kubernetes enables faster feedback and quicker time to market. In a containerized environment, multiple instances of an application may be running across different containers, making it challenging for clients or other services to know the IP addresses of all the running instances and detecting and keeping tracking of the locations of various services within the container cluster. And Kubernetes, for example, provides a built-in service discovery mechanism. Next, we have self-healing and auto restart of containers. Now, container orchestration platform provides self-healing capabilities to ensure that applications are always available and responsive. If a container fails due to an application crash or any other issues, the orchestration platform detects the failure and automatically restarts the failed container. So let us now move ahead and discuss some of the benefits of using Kubernetes tool. Firstly, it is scalable and highly available application, and it provides a seamless scaling of resources based on demand. Next, it has a simplified management of containerization applications across various clusters. And finally, automated deployment and updates, reducing manual intervention, which further improves resource utilization and optimization. Overall, Kubernetes has emerged as the industry standard for container orchestration. Its ability to automate application deployment, scaling, and management simplifies the complexities of running containerized applications at scale, making it a crucial tool for DevOps practitioners. Moving on, let us discuss our next tool, which is Ansible. Ansible is a powerful automation tool that simplifies configuration management, application deployment, and orchestration. It employs a declarative language to define desired state configuration, making it easy to manage and automate infrastructure tasks. Ansible follows an agentless architecture, allowing it to work efficiently across a wide range of systems and environments. So let us now look at some of its features. Firstly, it's a declarative language for defining infrastructure configuration. And it is also an agentless architecture for easy deployment and management, as we discussed earlier. Now, this is done through a playbook-driven automation for orchestration, where extensive library of modules for a wide range of tasks are employed. So let us now discuss some of its benefits. So firstly, it's simplified infrastructure management through automation, which increases the operational efficiency with reduced manual tasks. And its idempotent nature ensures that it has consistency and predictability overall. And finally, it supports a wide range of infrastructure automation use cases, and with its agentless architecture, it allows easy integration with various systems and environments. So, in a nutshell, Ansible's simplicity, flexibility, and ease of use have made it a popular choice for automating infrastructure and application deployment tasks. Active approach and agentless architecture contribute to efficient and streamlined development workforce. So moving ahead, the next tool on our list is Git. It is a distributed version control system that has become a fundamental tool for modern software development practices. It allows developers to track changes, collaborate effectively, and manage code base efficiently. Git's decentralized architecture ensures that developers can work offline and merge changes seamlessly across branches. Let us now discuss some of its key features. Now, its distributed version control system has efficient collaboration with various tools within the management of the ecosystem of DevOps, and it also has an integration with various code hosting platforms, which is the branching and merging capabilities for concurrent development. And finally, it supports for code reviews and collaboration workflows, which also gives a commit-based tracking of changes. So these are some of the key features of Git. So let us now discuss some of the advantages or benefits of using Git. So firstly, it's easy tracking and management of code changes, which ensures efficient collaboration and concurrent development within the resource files. And its ability to work offline and merge changes seamlessly will benefit a lot of DevOps engineers. And finally, its easy integration with other DevOps tools makes it a wonderful to use to manage code versions, track changes, and enable efficient collaboration, which has revolutionized the software development. So it has become an essential tool for version control, facilitating effective collaboration and enabling streamlined DevOps workflows. So moving ahead, the next tool on our list is Terraform. Now, Terraform is an infrastructure as code, or in short IAC tool, that allows teams to define and provision infrastructure resources in a declarative manner. It supports multiple cloud providers and enables consistent and reproducible infrastructure deployment. Terraform's declarative syntax and state management capabilities simplify infrastructure provisioning and configuration. Let us now look at some of its key features. Firstly, it provides multi-cloud support for provisioning resources across different providers. Its infrastructure as code approach for consistent and reproducible deployments makes it a declarative syntax for defining infrastructure configurations. And finally, automated resource provisioning and dependency management. So some of its benefits or the advantages of using Terraform is its simplified resource provisioning and dependency management. Now, Terraform's infrastructure as code approach supports for multiple cloud providers, makes it an essential tool for managing infrastructure codes and collaboration and version control for infrastructure configurations as well. And finally, it's state management for tracking infrastructure changes, which makes it a beneficial tool for DevOps engineers. Now, Nagios is used to monitor and manage the health and performance of the infrastructure, application, and network resources. It's a comprehensive monitoring solution to identify and resolve issues proactively, ensuring high availability and reliability of systems. So let us look some of its key features. Firstly, its monitoring capabilities. Secondly, its centralized configure management. And finally, its event handling and escalation tool. So learning Nagios is also crucial and beneficial if you are just starting on DevOps journey. So moving ahead, let us now discuss our next tool on our list, which is ELK Stack. Now, ELK Stack offers a comprehensive solution for centralizing logs from various applications and systems, making it easier for DevOps teams to monitor, troubleshoot, and gain valuable insights from their log data. The ELK Stack, comprising Elasticsearch, Logstash, and Kibana, provides a comprehensive log management and analysis platform. It acts as a distribution search and analytics engine, while Logstash collects, processes, and transforms logs. And finally, Kibana offers a user-friendly interface for visualizing and exploring data. So some of its key features, including real-time monitoring and alerting, scalable and efficient log storage and retrieval, and distributed search and analytics to data visualization and exploration with Kibana. Let us look at some of its benefits. So firstly, it's real-time monitoring for proactive It's real-time log monitoring for proactive issue detection with the help of centralized log management and analysis. Advanced log analytics for troubleshooting and performance optimization, making it a scalable architecture for handling large-scale volumes of data. And finally, efficient log storage and retrieval for compliance and auditing purposes. In a nutshell, ELK Stack has gained immense popularity for its ability to handle log management and analysis at scale. It empowers DevOps teams with real-time insights into application and infrastructure logs, facilitating effective troubleshooting and performance optimization. Well, finally on the list, we have Jira software. Jira is a widely used project management tool that supports Agile development methodologies. It offers robust features for planning, tracking, and managing tasks, issues, and workflows. Jira's customizable boards, backlogs, and workflows empower teams to collaborate effectively, visualize, and progress to gain transparency into project statuses. With integration to various DevOps tools, Jira facilitates seamless tracking of development activities, enabling continuous improvement and efficient project management. Some of its key features are customizable boards, workflows for project management, agile planning and estimation features, issue tracking and management capabilities. And some of its benefits include efficient task management and tracking, enhanced collaboration and visibility across various teams, and integration with various DevOps tools for streamlined workflows. It also helps in reporting and analytics for project insights and performance measurement. Finally, Jira has become a go-to tool for Agile project management in the DevOps ecosystem. Its ability to support Agile methodologies, track tasks, and integrate with other DevOps tools makes it a valuable asset for teams seeking efficient project management and continuous improvement. So learning it will add a great value to your area of skills again. So these were some of the top 9 DevOps rules that you must know, which will help you enhance and accelerate your career in DevOps.
So, today we will be talking about one of the booming technologies used, which is DevOps. We will first look into what is DevOps, then we are going to dive deep and understand the top 10 reasons why you should learn DevOps. So, what is DevOps? DevOps is a collaboration between the development and operation teams which enables continuous delivery of applications and services to our end users. Before DevOps, there was a lot of communication gap between the development and operation teams. The code that used to work fine on the development side would create a lot of errors on the operation side. This in fact led to a lot of issues. The biggest issue was the delay in project delivery. The solution to this was DevOps. In DevOps, the operation and development engineers participate together in the entire lifecycle, from the design through the development process to the delivery of the software to the end users. It enhances the process to deliver the software faster and a software of high quality. If there is any bug or error, it is fixed at the right time rather than dragging it to the last phase. Let's now look into the 10 reasons why you should learn DevOps. So, at number 10, we have technical, cultural, and business benefits of DevOps. Let me explain each benefit one by one. So, first we have the technical benefits. Continuous software delivery is the most important process of delivering the software in smaller increments to ensure that the software can be released at any time. With this approach of DevOps, the team will always be ready on delivering anytime. It has the benefit of having less complex problems to fix. The code is tested at every stage and both the development and operation teams make sure that the complexity is reduced to a great extent. DevOps also has the benefit of faster and easier resolution to every problem. If any bug or error is found at an earlier stage, it is fixed and then moved on to the next stage. Hence, this way at the final stage, there will be 0 or minimum number of bugs. Moving forward, let's look into the cultural benefits of DevOps. The workload is divided equally between all the employees, so no individual is under the pressure to code, test, debug an entire software. This results in a team that is happy and more productive. Since DevOps is a collaboration between the development and operation teams, if any issue arises on one side, the team is always ready to help. And the employees are engaged to make sure that the software is as the end user requires and hence is delivered at the set date. DevOps helps in increasing the professional development opportunities. Finally, let's look into the business benefits of DevOps. The basic principles of DevOps, that is automation, continuous delivery, and quick feedback cycle, aim to make the software development process faster and more efficient. Being an extended version of Agile methodology, DevOps ensures that the complete software development lifecycle goes smoothly. By promoting collaboration between the teams, DevOps offers continuous feedback so that the errors are fixed in time and the releases are done faster. These days, the development teams need to break down the interdepartmental constraints and collaborate, as well as communicate in a dynamic, round-the-clock environment. DevOps gives a way to improve the business agility by providing an environment of mutual collaboration, communication, and integration across the various teams in an IT organization. All the team members are responsible for meeting the quality and timeline of the software deliverables. With DevOps, organizations can improve the deployment frequency, recovery rates, and hence result in a lower failure rate. With every new release, it is possible to ensure the reliability and stability of an application. When applications perform flawlessly in the market, organizations reap the benefits of greater customer satisfaction. At the 9th position, we have work with good developers. Poor code is all too common. Sadly, users arrive at the realization when it's too late. The fact is, some developers are good at what they do, while others have poor coding skills. A team of software developers consists of excellent, good, average, and poor developers. It is important that the bad codes generated by many developers need to be stopped, else it may increase the production time. DevOps helps in reducing the bad code limits, as the bad code cannot go to the next phase until it is fixed. Also, a team member who is terrible at coding could be good at any other different roles and vice versa. Retasking team members earlier in the process prevent wastage of time and resources. So, in this way, DevOps eliminates bad developers and ensures that the team comprises of good developers. Next, at 8th position, we have increased efficiency. Due to increment in efficiency level, it results in speeding up the process of development and also makes it error-free. DevOps can also increase efficiency through automation. There are many ways to automate tasks in DevOps. DevOps allows engineers to focus on those tasks which are not automated. There are certain tools of acceleration that increase the efficiency. They are the cloud-based platforms or other scalable infrastructure which help in increasing the access of the team to the hardware resources and hence speeds up the process of testing and deployment operations. With the use of build acceleration tools, the code compiles faster. There may be a process that helps in embedding parallel workflows into the continuous delivery chain so that the delays are avoided. Moving on, at 7th position, we have a better organizational culture. With the help of DevOps, there has been an improvement in software development. The development and operation teams are more focused on performing together rather than having separate goals. The team is more focused on production. If both the teams are combined, it will result in innovative ideas in a very efficient and effective manner. There is improved collaboration and communication between the team members. DevOps facilitates better understanding among the team members, and this understanding increases worker morale. Next, at the 6th position, there is faster release of software. It is true that DevOps makes the process of software development agile, hence, it leads to the timely release of the software. Companies can quickly study the behavior of users and incorporate the changes to come up with a better product. This, in turn, helps the organization to stay competitive. There is a reduction in rollbacks and failure rates regarding deployment and the time that is taken to recover with better products. DevOps reduces the time for cycles of development and also ensures a faster rate of innovation. At position 5, we have better knowledge of software delivery lifecycle. Once you get to know about DevOps, you will get a lot of information about the software delivery lifecycle. It is divided into main phases like planning, analysis, design, implementation, testing and integration, and maintenance. In the plan phase, initially there should be a plan for the type of application that needs to be developed. Getting a rough picture of a development process is always a good idea. In analysis, a detailed study of requirements is done to check whether all the requirements are available or not. The list of all the requirements like human resources, hardware, software required to accomplish this project successfully will be clearly analyzed and listed out here. In the design phase, the whole project is divided into modules, each module into sub-modules by drawing some diagrams using unified modeling language. A pseudocode will be prepared at this phase. In the implementation phase, the application is coded as per the end user requirements. Coder now has the task to do the coding. Developers will develop the actual source code by using the pseudocode and following the coding standards. The testing and integration phase is the most important step of the application development. Here, the application is tested and rebuilt if necessary. The multiple modules of codes from different programmers are finally integrated into one. Then finally, the application is developed and delivered to the end users. The final phase is maintenance. Once the client starts using the developed software, then the real issues start coming up. In this stage, the team is required to fix the issues, roll out new features, and refine the functionalities as required. At the 4th position, we have boost product quality. The concept of DevOps does not allow mistakes in the stage of methodology. When both the operation and development stages are done correctly with no errors, then it will result in a release of better and improved product qualities. This leads to a cleaner, more efficient code and hence increases the software quality with each release. The DevOps process brings better quality to the development process and reduces the chances of unplanned work. At the 3rd position, we have exposure to trending technologies and advanced tools. DevOps works with a variety of tools. Few of them are Nagios, Chef, Docker, Git, Selenium, Puppet, Kubernetes, Ansible, and many more. You will get a chance to understand and use all these tools and learn how to design, develop, deploy, and maintain an app or software with the help of these tools. Apart from that, by knowing all things about such software and tools, you can increase your chances of getting hired by the best companies. At the 2nd position, we have increase your professional credibility. By obtaining a DevOps certification, you can increase your professional credibility. This certification will help you to let the others know that you have sufficient skills in
monitoring a software's performance, easily write and code with scripts, enhancing the software's security to a greater extent, providing the best IT hardware. You will be able to troubleshoot various issues in the software, and finally, you will be able to connect softwares, databases, and much more to ensure effective functionality. 42% of companies are now preferring open source jobs and want candidates with DevOps skills. So, if you want to become a part of developing the DevOps job market, then this is the perfect time to start getting DevOps training. And finally, the top reason to learn DevOps is to get a perfect job and increase your salary. DevOps is a very popular career choice now. Researchers have also shown that in the coming years, DevOps will be the main hiring criteria for 46% of the IT companies. However, they are not sufficient experts who can match the requirements. That's why there are massive opportunities for candidates seeking DevOps jobs. Besides, when it comes to salary, you can earn a lot of money. On an average, a DevOps professional gets a pay of $99,604 per annum in the United States, and a DevOps professional in India gets an average salary of 6,02,000 rupees per annum. Now, let me recap and call out all the 10 reasons for learning DevOps once again. At number 10, we had the technical, cultural, and business benefits of DevOps. At number 9, we had work with good developers. At number 8, we had increased efficiency. At number 7, we had a better organizational culture. At number 6, we had faster release of software. Then, at 5th position, we had better knowledge of the software delivery lifecycle. At the 4th position, we had boost product quality. And at 3rd position, we had exposure to trending technologies and advanced tools. At the 2nd position, we had increase your professional credibility. And finally, at the top position, we had get a perfect job and increase your salary.
Without any further delay, let's get started with the topic Cloud Engineer versus DevOps Engineer. Cloud Engineer specializes in designing, implementing, and managing cloud infrastructure and services. Cloud Engineer's main responsibility is collaborating with cloud providers like Amazon Web Services, Microsoft Azure, or Google Cloud platforms to design scalable and dependable solutions for application and services. Whereas a DevOps engineer focuses on the interaction of development and operation. Their role is to bridge the gap between software development team and IT operation to improve collaboration, automation, and efficiency in the software delivery process. Cloud engineers typically deeply understand cloud computing concepts, visualization, networking, and security. They may work on tasks such as provisioning and managing cloud resources, configuring networking and storage, fine-tuning performance, and ensuring high availability and disaster recovery measures. Whereas DevOps engineer commonly possess a solid software development and system administration foundation, leveraging their expertise in this domain. They work to streamline and automate processes such as building and deploying applications, managing infrastructure as code, and implementing continuous integration and continuous delivery pipelines. Some roles and responsibility of a cloud engineer include cloud infrastructure design, cloud resource provisioning, cloud administration, security and compliance, cloud cost optimization, and cloud migration. DevOps engineers have diverse roles and responsibility, which encompasses key areas such as continuous integration and continuous delivery practices, infrastructure as code implementation, configuration management, deployment and release management, monitoring and logging, and DevOps tool chain. Cloud engineers requires a diverse skill set encompassing various technical and non-technical areas such as Linux, database skills, programming, networking, security and recovery, understanding, visualization, and cloud service providers. So here are some of the skills of cloud engineers. First, cloud platforms. Proficiency in specific cloud platforms like AWS, Azure, or GCP. Next, cloud infrastructure. Designing, implementing, and managing cloud infrastructures. Then, we have networking. Understanding cloud networking concepts, including virtual networks, subnets, and security groups. And then, security and compliance. Implementing security measures and ensuring compliance within the cloud environment. And then we have automation. Using infrastructure as code tools like Terraform or CloudFormation to automate provisioning and management. And then, storage, configuring and optimizing cloud storage solutions. And then, high availability and disaster recovery, designing and implementing cloud solutions for high availability and disaster recovery. Now that you are aware of Cloud Engineer skills, this Simplilearn's postgraduate program will equip you with all the necessary skills, including cloud provider selection, application migration, performance testing, cloud workloads, web services and API, database management, multi-cloud deployment, storage services, and many more. And now, let's see the skills of DevOps engineers. First, we have CI/CD pipelines, setting up and managing continuous integration and deployment pipelines. Then, infrastructure as code, automating infrastructure provisioning and configuration using tools like Ansible, Puppet, or Chef. Then, containerization, working with containerization platforms like Docker and tools like Kubernetes. And then we have scripting and programming, proficiency in scripting languages like Python, Bash, or PowerShell, as well as programming languages. Configuration management, managing and optimizing the configuration of systems and applications. And then we have monitoring and logging, implementing monitoring and logging solutions to ensure applications and infrastructure performance. And finally, collaboration and communication, working effectively with cross-functional teams and facilitating cooperations between development and operations. Now that you know DevOps engineering skills, this Simplilearn's postgraduate program will equip you with all the necessary skills, including DevOps methodologies, continuous integration, continuous delivery, deployment automation, cloud platforms, and many more. Along with the skills, it also covers tools such as Terraform, Maven, Ansible, Jenkins, Kubernetes, Docker, and many more. In the upcoming years, there will be higher demand for cloud engineers due to the growing usage of DevOps practices and cloud computing technologies. Some career opportunities available for cloud engineers include cloud engineer, cloud architect, cloud consultant, cloud security engineer, cloud operation engineer, and many more. Some popular career opportunities in DevOps include DevOps engineer, site reliability engineer, release manager, automation engineer, cloud engineer, and many more. According to Glassdoor, the average salary for a cloud engineer in the United States is around $100,000 annually. In India, it is 6 lakhs per annum. The average salary for DevOps engineer in the United States is around $104,000 annually. In India, it is 7 lakhs per annum.
So let's go through waterfall. So waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis. And this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in Agile. And we start implementing the Agile model. So the Agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all of this in a much tighter cycle that we call a sprint. And that typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what, we need to make a change, you can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. But then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team. And then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers. But what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the Agile model. The Agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as Maven and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit, is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments. And so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another point here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment so you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to the all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to Agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages. And there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams. So teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted. What we're going to do is we're going to break up the tools into 8 different categories. Now we're going to go through the planning and code-based tools, the building tools, the testing tools, the all-important integration tool, the deployment, operation, and then finally monitoring tools. Something we should also add is that all of these tools are open source. This means that you can get up and running with your DevOps environment immediately without having to worry about licensing costs. So let's jump into the very first tool, which is Git. So Git is a distributed version control tool that allows development teams to be able to share code amongst each other in a way that allows the creation of small to extremely large applications to be created effortlessly. If we look at the architecture of Git and the way that it works, that there are 4 key areas. We have the working directory, the staging area, local repository, and then remote repository. So your working directory is where you actually create all the files that you'll be working on in your application. The staging is the area that you get ready to commit those files to your local repository for version control. And once you actually have then put them into your local repository, then you want to be able to push those files using a push command out to a remote repository such as GitHub or GitLab. In addition, if you have a distributed team, you can then also pull down the latest files. So as a team, you can always be working on all the files all the time, and then go through the whole process again by working on your local files. You can do this whole process really quickly and easily. Git is actually a free tool that you can download and run through command line off your computer. Finally, you want to be able to merge files that you may be working on, say for instance a different branch, which is a new feature. You want to be able to merge those files back into the master directory, the master branch that's running on Git itself. So some of the things to point out with Git, what makes it really useful is that it's absolutely brilliant at being able to track changes in your source code. This is something that source code tools really kind of should be able to do, but Git is exceptionally good at this. Having large teams working at different phases within the project and working on different branches within the project is really easy to do, and the collaboration tools within Git make it so that your teams can work effortlessly with each other. Inherently, you are creating backups of all your code, which is fantastic. And probably the most important part is that the environment itself is a non-linear environment. This means that you don't have to work through specific gates to be able to reach feature, to actually get a feature ready for delivery. You can actually work in a non-linear fashion. So who's using Git? Well, as you can imagine, all of the big technology companies are using Git, including Netflix, Lyft, and Intel, plus many, many other companies. So let's get on to our next tool, which is Maven. And the focus on Maven is to automate the build process of code that's being checked into a repository, such as a Git repository. So if we have a look at the architecture here, Maven itself actually executes what are called POM files, and those POM files actually then look for specific dependencies that will then go against a repository to be able to build out the project. You can actually extend the POM files with plugins, and you can actually then create a specific build profile for your environments, which is actually fantastic because you can really fine-tune the profile. And again, all of this is scripted, and this is something that is common with all the tools that you'll be using in a true DevOps environment, is that you can script all of them, which means that you can automate the processes that are in your DevOps environment and really accelerate the ability to be able to build consistent, high-quality software. Final step for a Maven environment is to actually build all the software into in our build server. So a couple of things that are important to notice with Maven. One of the things that you'll see that's key with all of the tools that we have here, really easy to use. Maven itself has got a pretty simple setup. It's highly available, which means that your teams can rely on the solution being ready for your environment, and you can actually get to it and use it very easily and consistently. You can have multiple builds happening at the same time, which is really important, particularly if you have branched software and you want to be able to test the branches. And the other thing as well is that it's open source, so you have instant access to new features without any additional configuration. So it really helps your teams to get the new code and implement new features within the environment itself, so you're always working on the latest and greatest. As you can imagine, DevOps shops such as Zillow and Zenz and JP Morgan and Chase are already using Maven, and you'll see that many DevOps shops are also using Maven for their build software. Testing with Selenium is very important, and being able to automate that environment is critical so you can actually guarantee that your code will work. And Selenium itself is designed for testing and automating web applications. It's really good in that environment. If we look at the architecture, the way that it works is that you actually have a client library that goes against the code you're writing, whether that's C#, Python, Java, JavaScript, and then there are specific drivers that go against the web browsers to actually test out the code that you have created so that you can actually see whether it works in the appropriate web browsers. And all of the popular web browsers are supported with Selenium. Selenium is an open source solution. It does allow you to write scripts in multiple different languages, which is a real big bonus. You can as well run parallel test execution, so this balances very well with Maven. And as with other tools that we have, it's really easy to use. And Selenium is being used by Google, HubSpot, and Salesforce, as well as many other companies. So let's talk about the really important part, which is integrating all of this. And Jenkins really is the de facto tool in this space. And so the role of Jenkins is to be able to manage and allow for that continuous integration that you need to make DevOps successful. So allowing the development team, to integrate effectively with the ops, the operations team, and do that through testing and management of the code that has been created. So if we look at the architecture here, we have our remote source code repository. It's going to be waiting for a Jenkins pull to be able to create a commit, and then that Jenkins serve master will then push out and distribute the work to multiple slaves so that you can actually have the actual code being pushed around your environment. So Jenkins is really easy to use. It's very mature. It's been around for many years. There are a significant number of plugins that allow for the Jenkins environment to be scaled very effectively, and it is portable across multiple platforms. In fact, most of the leading operating systems will support Jenkins. And as you can imagine, Jenkins is being used by companies such as LinkedIn and Microsoft, eBay, Dell, and Cloudera. So let's talk about the other side of DevOps and talk about some of the operations tool. And we'll start off with Docker. So the role of Docker is to make it easy for people to be able to simulate full environments quickly and easily on their desktop for building and testing, but at the same time make that real easy to be able to port those environments across multiple areas. So let me talk a little bit about how that would work. So with the Docker engine, you have a Docker client locally that allows you to emulate the whole Docker environment without having to have the overhead that you would typically have if you're doing virtualization or dedicated servers running specific dedicated operating systems. Because you are scripting the entire environment, Docker is a very scalable and repeatable environment for being able to take across the entire cloud network. So some of the features that are really important for Docker, it's incredibly portable across multiple platforms. The Docker team have done a fantastic job on portability. It does run in isolation. So what this means is that you can actually have multiple Docker environments running on a server concurrently, and they will not interrupt each other. They actually fully isolated sandboxed environments. So the other part to Docker is because it is stripped of needless operating system and host environment APIs and services, the actual startup and boot time for Docker is really very fast, which in turn makes this very scalable and efficient to run. And you can actually reuse volumes very easily. So who's using Docker? Just about everybody. Spotify, Uber, PayPal, BBC. Really, Docker is used by a lot of people. Just a side note, probably something that would complement Docker very well is Kubernetes, and Kubernetes is becoming a very popular alternative to Docker, and so really get to know both of those tools. So let's talk about some of the operation and management tools that you have for your environment, and the three big ones here are Chef, Ansible, and Puppet, and we'll start with Ansible. And Ansible is a configuration software package, and unlike the other two products here, unlike Chef and Puppet, Ansible doesn't actually require a client to run on the host server where you're pushing out a configuration. You can actually have a defined operation configuration, so like a web server configuration or a database configuration or an IoT cloud configuration. You can actually have that running effectively from a script that is written on a client machine and then on your local machine, and then you can push that script that you've created out to your remote servers and have everything work as you'd expect quickly on your remote servers. Just some of the key features of Ansible. It's incredibly lightweight. One of the things that's really important with Ansible is that it's actually very easy to use. There is, unlike the other two tools we'll be covering, unlike Puppet and Chef, Ansible actually has a full GUI that you can use to actually interact and build out solutions. So there is a visual interface that you can actually go in, so you're not just working completely in command line. Companies that are using Ansible include Twitter, EA Sports, Cisco, and NASA, as well as Verizon. So complementing Ansible, but probably a little bit more popular right now, are Chef and Puppet, and we'll cover Chef first. Both Chef and Puppet are somewhat similar in configuration, and both of them rely on having a client-server relationship with their architecture. The way that Chef works is that Chef actually creates recipes, and each recipe is a server configuration setup. And what you actually do is you create individual recipes, and then for your entire network you create what's called a cookbook, and that cookbook actually can be used to control the setup of your entire network. And this works really well for being able to create consistent and highly scalable environments. The things that are great with Chef is that it's actually a very flexible configuration, and you can actually do an awful lot with it. It has really good security features which are very appealing to, particularly if you have a DevSecOps environment where the security team are integrated with your DevOps environment, and that's something that's becoming more and more popular. Chef itself is actually pretty easy to use. It is a command line tool, but it is actually fairly easy to use, and the actual scripting of the recipes is something that you can do even if you don't have much scripting experience. It's something, there are so many recipes out and available, you can actually use many of the templates that have already been written and just either copy them or modify them to your environment. As you'd expect, a lot of the companies using Chef are the big technology companies such as Facebook and IBM. Microsoft in particular has really invested heavily in Chef. In fact, you'll find that Chef is probably the most popular management tool used within the Azure environment. So a complementary product to Chef is Puppet, and if we look at Puppet, as you can imagine, it's again another open source configuration tool. The structure, as you can see, is actually very similar in concept to Chef, in which you have a local server that actually has all the configuration environments, the templates and the files and the manifests, and it will actually then communicate with all of your entire environments, such as, and with Puppet they refer to them as nodes, and within your node you have multiple servers. But it's similar in concept to Chef in many ways, in that it's just another way of being able to control your environment. Both are really great tools. In fact, really all three of them, Ansible, Chef and Puppet, are great tools. What you have to do as a DevOps team is really just decide which tool is the one that's appropriate for your environment. So some things that are great with Puppet: it's multi-platform compatible, it's very scalable, and it allows you to push out changes to your environment really fast. And who are using Puppet? You've got Red Hat, HP, Google. Leading DevOps teams are using Puppet today. So let's get into the two tools that we have that actually monitor our operations environment, Splunk and Nagios. So Splunk is, as you expect, is a monitoring tool, and its goal is for actually monitoring the operations of all the environments that you have, make sure that they're working correctly. And it does this by going through and reviewing your entire environment and writing the operational information to disk, and then searching that environment to make sure everything works correctly. It does a lot of analysis in real time. It is a very easy to set up and use tool for testing for analysis, and to then be able to then troubleshoot any failures that may come up. The thing that's great about Splunk is that you can actually put it in a distributed environment so that it's no single point of failure, which makes it itself inherently very scalable. So Cisco, Facebook, Domino's Pizza, Dubai airports are all customers that are using Splunk today in their DevOps environments. So finally, let's jump into our final monitoring tool, which is Nagios. And very similar to Splunk is Nagios. Probably the big difference is that it's client-server setup, but really, again, it's all about being able to monitor and check the status of your entire environment and your network and your servers in real time, and give you the appropriate visualizations, whether it's on your laptop or whether it's an alert that's sent out to your phone, and so you're aware in real time how your network is performing and can then check and adjust to actually making changes. And the bottom line in this kind of architecture with Splunk and Nagios is that it allows you as the operations lead to be able to be ahead of any perceived impact. So say for instance you are putting in specific check marks for your environment, you can actually have alerts being sent out to your team when certain thresholds are met, and so that means that you are aware of problems with your environment before your customer is. There's nothing worse than somebody emailing and saying, hey, your website doesn't work, or like a page is down, or it's slow, or something like this. With Nagios and Splunk, these are tools that really address those kind of problems so that you stay ahead of the curve. So some of the things that are really good with Nagios is Nagios itself is very, very comprehensive. You can do an awful lot with it, and it allows you to be able to get to the root of monitoring and analyzing your problems within your operations and network environment very quickly. It has a very modular architecture, which also then makes it extremely highly available, because the system itself is not reliant on just a single large application. Actually, the modular architecture allows it to be scalable and very easy to manage across your entire environment. Companies using Nagios include Uber and Hike and Webedia. Again, these are all technology companies, but there's no reason why you shouldn't be using them as well.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GetTech postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course.
What are we going to cover today? So we're going to introduce the concept of version control that you will use within your DevOps environment. Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like Git Lab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes, and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code, and that your code will be stored in a centralized location. However, the challenge you run in is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves, so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to just a traditional version control system is that all developers have the entire code on their local systems, and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here, and developer here, and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. so that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code changes you've made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git client to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, it's actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public and shareable, is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are thousands, 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You will want to push out all of your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. Later, when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way, way, way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project, but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merge into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and reestablish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means, though, is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. And you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it can be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time. Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here, and then here we have a separate parallel branch which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch. And we want to do a Git rebase. So we're at stage C, and what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's being done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So Git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. And it makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. Good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the git command, commits changes to head up. So the git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config -global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author of by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you're going to merge that into the main branch. A Git rebase will reapply commits on top of another base tip. And Git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simplilearn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory. So I'm actually going to be in that folder before I actually create and make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. And that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the git command init to initialize, and that's going ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our hello world folder, and I'm going to go ahead and using my text editor, which happens to be Sublime, I'm going to create a file, and it's going to have in there the text hello world, and I'm going to call this one readme.txt. If I go to my hello world folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the README file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into README file, and I can change this. So we can go hello Git. Git is a very popular version control solution, and we'll save that. Now what we can do is we can actually go and see if we have made differences to the README text. So to do that, we'll use the diff command for Git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world. And then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. And so what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and select git config, and we're going to do dash, and it's going to be a global user name, and we're going to put in our username that we use for GitHub. In this instance, we're using the Simplilearn -GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello world.git account. And we do that by using this command from Git, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in git remote add origin https github.com/Simplilearn-GitHub, and you have to get this typed in correctly when you're typing in the location hello-world.git. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote add origin, and we'll connect to the remote location github.com/Simplilearn-GitHub/ hello-world.git. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right-hand corner of the screen. Now, right now, I'm actually logged in with the default primary account for this project. So I can't actually fork the project because I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this. And so this is the, I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that. And I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in. And we could, for whatever reason we wanted to, we could call this folder patchwork, and that would be maybe a new feature. And then we can then paste in the URL of the new directory that has the forked work in it. And now at this point, we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch, and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators. So we can actually then go over to GitHub, and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators. And here we can actually see we have different collaborators that have been added into the project, and you can actually then request people to be added via their GitHub name, or by email address, or by their full name. One of the things that you want to be able to do is ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder. We call it test, and we're going to move into the test folder, and we will initialize that folder. And we're going to move some files into that test folder. Call this one test1, and then we're going to do file save as, and this one's going to be test2. And now we're going to commit those files. Git add, git add, and then we'll use the dot to pull in all files, and then git commit -m files committed. Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit. And it's gone ahead and added those files. And so we can see the two files that were created have been added into the master. And we can now go ahead and create a new branch. You can call this one git branch test _ branch. And let's go ahead and create a third file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file. And do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test _ branch. And it switched to the test branch. And we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test _ branch. And it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test _ branch. And we can modify the files, the test3 file that we took out, and pull that file up. And we can now modified. And we can then commit that file back in. And we've actually been able to then commit the file with one changes, and we see it's the text rechange that was made. And we can now go through the process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a, and we're going to commit those files. Git commit -a -m, adding 2 new files, and it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master. So we do git rebase master, and that will then give us the command that everything is now completely up to date. And we can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test underscore branch, and now we can list, and there we have all of our files.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course.
Start by downloading and installing Git on our system. We'll then have a look at the Git bash interface. We'll type in some basic Git commands. Next, we'll create a local repository. That is, we'll create a repository on our local machine. We'll then connect to a remote repository, and finally we'll push the file onto GitHub. First things first, we need to download and install Git. So download Git for Windows, and I'll select the second link. So 2.19.1, which is the most latest version of Git, that's the one we want for Windows system. Choose your version. So mine is a 64-bit system, and it's downloading. So this will take a while. So Git is finally downloaded. Now we need to install this on our system. Click here, run. So go to next. We don't have to change this path. Just click on in quick launch and on desktop. Next, next, again next. Nothing to change here either. And install. So now Git is getting installed on our system. So we don't need to view the release notes. We just want to launch the Git bash. So let's just tick that and then click on finish. And your Git bash interface appears here. So we are on the master branch. The first thing we do is we'll check the version for our Git. So the command is git -- version. And as you can see, version 2.19.1 on our Windows system, which is exactly what we just downloaded. We'll now explore the help command. So let's just type git help config. So config is another command, and as I hit enter, the manual page for the second command opened up, which is config. So what help command does is that it provides the manual or the help page for the command just following it. So in case you have any doubts regarding how a command is used, what a command is used for, or the various syntax of the command, you can always use the help command. Now there's another syntax for using the help command itself, which is git config --help. Enter. This does the exact same thing, as you can see. Now that we looked at the help command, let's begin by creating a local directory. So mkdir test. Now test is my new directory. I'll move into this directory. So cd test. Great. So now that we are inside our test directory, let's initialize this directory. So git init is the command for initializing the directory. And as you can see the path here, this is the local path where a directory is created. So I'll just show you the directory test, and it's completely empty. What we do now is we'll create a text file within this new directory that we created. So new text document, and I'll just name this demo. I'll open this and just put in some dummy content. So hello Simplilearn. Save this file and go back to your bash interface. Let's just check the status now. So git status, and as you can see, our file has appeared, it's visible, but nothing is committed yet. So this means that we have not made any change to our file through the Git tool itself. So the next thing that we are going to do is we'll be adding demo to our current directory. The next command that we'll be applying is the commit command. And when you add certain files to the current directory, the commit command is applied on all the above directories. So git commit -m and a message that will appear once the file is committed. So as you can see, one file is changed and one insertion. I'll just clear the screen. Next thing we need to do is we need to link our Git to our GitHub account. So the command for doing that is git config global user.username. And this will be followed by our username. So let me just show you my GitHub account. So this is my GitHub profile, and my username is Simplilearn-GitHub. So guys, before you begin this procedure, just make a GitHub account. Type in my username here, Simplilearn-GitHub, and enter. And there you go. Our Git is successfully linked with GitHub. Next thing we do is we'll just open our GitHub and we'll create a new repository. Give a repository name. So I'll name it test_demo and create repository. Great. So our repository is created. This is our remote repository. What we do next is just copy the link and then go back to your bash interface. Now we need to link our remote and our local repository. So git remote origin and then paste the HTTP link. And now that our local repository and our remote repository are linked, we can push our local file onto our remote repository. So the command for doing that is git push origin master, as we are on the master branch. And that's done. So now let's move back to GitHub. I'll just click on test demo. And as you can see here, our local file has been pushed to our remote repository. With that, we have successfully completed our demo. If you have any queries regarding this, please post them in the comment section below and we'll get back to you as soon as possible.
I'm going to cover a few essential Git commands and walk you through a demonstration for most of it. I begin by installing a Git bash or the Git client and configuring it for its first time usage. Once I'm done with configuring the Git client, I'm going to spin up few repositories locally and work on these repositories using Git commands. Once I'm happy with my local changes, I'm going to commit few of them and then push these changes to a Git server of my choice. For today's demonstration, I plan to use github.com, which is a cloud-hosted free service, and it provides free account registrations for anyone. Eventually, I will cover a few topics regarding Git branching and merging, because these two, in my opinion, are the killer features of the Git distributed version control tool. Git is one of the most popular distributed version control tools of recent times, and like any other distributed version control tool, it allows us to perform various version control tasks without really needing a network connection. Before I jump into my demonstration, let me spend some time explaining to you the Git client-server working model. What does it take for a couple of users to collaborate and start working with Git? The bare minimal thing that any user would need in order to start working with Git is something called as Git Bash or the Git client. This comes as an installer for all popular operating systems like Windows, all flavors of Windows, Linux, macOS, and other operating systems. So once you install Git Bash, you get a command line utility using which you can fire up your Git commands and ensure that you can bring up repositories. You can work with these repositories by adding files to it, committing changes to it, and all those Git commands would work perfectly well. So you can bring up a small repository and you can work with your repository using this Git Bash. But what does it take for you to share this repository with another user who has also got Git Bash installed on his system? This is where you would need something called as a Git server. So for user 1 or one user to share his repository with another user, he would need to collaborate using something called as a Git server. So in the present market, there are a bunch of Git servers which are popularly available. Some of them are free, some of them come with a cost because they are licensed. A bunch of these servers that I can think of are GitHub, which is one of the most popular Git servers that is around in the market for a long time now. It comes with two variants. One is the cloud hosted one, which is the github.com. And then the other one is an enterprise server, which comes as a black box that can be installed into your data centers. So typically organizations who don't want their source code to be put up on the cloud would go for this GitHub enterprise servers, wherein they buy these servers and these servers are hosted on their data centers. Other popular variant of the Git server is Bitbucket. This is from the famous Atlassian products and it integrates very well with all other Atlassian products like Jira. In recent times, there's one other variant of the Git server called GitLab, which is getting very popular these days because GitLab not just provides a Git server, it also provides something called as a runner. This is a part of the continuous integration strategy where as soon as you have a source code check-in that is going in, you have this runner that kicks up and builds your particular project. So all these are bundled together in a GitLab. And GitLab also provides you with a community edition which is almost free of cost. Having said that, there are a bunch of these tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. And I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I've already registered myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with say user 2, the first thing that I got to do is have an access to a Git server where both user 1 and user 2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user 2 or the other developer who wishes to collaborate with me on this repository can use his credentials as long as he's registered properly on the Git server. He can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server. So that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into the server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git Bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git Bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows. Open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client. I need this one. So this is the Git client or the Git bash that I was referring to. It's about 40 megs. And let me just download this. Pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. All right, I go ahead choosing all the default options. I want it to be installed in C: program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git bash from Windows. Yes, I may want to use git from Windows command prompt. That sounds good for me. Open SSH. That's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the git bash or the git client so that I can start using my git commands. And the version that I'm using is 2.19.0, which as I record this video, this happens to be the latest version. All right, so looks good. I don't want to see the release notes. I'll say launch git bash. So what I get is this window. So this is the git command prompt. So let me check if everything is looking good. Say git version, it sounds good. Say git help. All right, a lot of git help commands. Everything looks good. So I ended up installing the git bash. I can go ahead with all other commands. Now that I have git bash installed on my system, let me open up a git bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the git bash to be configured with. The command to do that is git config -- global, which means that this setting that I'm going to set would be a global setting. User.name, and the name of the user would need to be specified within a double quote. In my case, I am using a Simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config -- global. This is also a global setting, and this would be the email ID. The email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. All right, let me check if the configurations were set correctly or not. All right, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right, so what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, Git_demo. All right, there's already a folder called Git Demo. So let me just delete it in the first place and let me create this Git Demo again. All right, let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my Git Demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right, as of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay, so let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you'd see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders, I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory, a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder, and this is created whenever a repository is initialized. So by default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now, when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder, and by default there is a branch called master, and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set, you're on the master branch, there is an untracked file, and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a git notices that there is a new file in this repository called master.txt. If at all you want us to let Git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add. I can specify either the name of the file or I can give a wild character saying git add dot. Now if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. All right, it also gives you something called git remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. All right, I run the git status command again and see it says on the branch master, nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier. And this was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file. Write something into this. Alright, I save this change. Let me also open up the older file, make some more change into this. Alright, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which was an untracked file. Alright, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again, and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right, if I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description, I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that because I already have a repository with some content with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the create repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git remote add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got 2 commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream. origin master. So git push -u upstream linking origin master, link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. All right, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I've registered. I would say login. Okay, success. So I'm able to create a repository on the server, and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, one line chain that was there. I also added this new file which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial, wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is ssh keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. Alright, so generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that. That's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase, because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated, and by default it is created in this particular folder. So let me go over to that particular folder, and this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings, and you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I would click on new SSH key and let me paste my public key that I've copied, and I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right. Now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right. Pretty good. I've been successfully authenticated. So that means now my SSH keys are good. And just by using my passphrase, I can connect to my GitHub server using SSH. Alright, so for the second use case, what I would do is create a repository on the server with some content in it and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository. And let me kind of initialize that with a README file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some README file in it. A random README file with no content in it, but then I want a repository to be created on the server. Alright, I say create a repository. So a random README file with some content in it gets created, and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. Alright, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. Alright, so if you notice, there is no HTTPS to it. I'm just cloning the URL, that is SSH URL of the repository. It asks for my passphrase again. Okay, so I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there is just a simple README file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push. To be on the safer side, I would say origin and master. It asks me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added all this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial wherein I created a repository on the server, cloned it, made some changes to the repository and pushed it to the server using SSH. A quick recap of all the Git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a Git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder, and from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 files, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you've done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted. All the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local, none of the developers or none of the other users who are collaborating with you would be affected by this change. You're good to go ahead and make this change. However, if your repository has been pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes because whatever changes I did not really fix things the way I expected it to fix. So there is a git command called git reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist, I would do command called git reset -soft. Now this would go back or unwind my changes back to this particular snapshot getting rid of all the commit messages that were there as a part of these two commits. But a soft would ensure that the file changes that were done as a part of these two commits would still exist or full remain. So the command for that is git reset -f soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. All right, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. All right, now I can make some more changes that I want if as a part of my commit, and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this. Along with those old changes, I also added a new file. I made some changes and I was able to commit it. Now if you look at my git history, it's all nice and clean. However, do this activity only when you don't push your git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. Take this scenario wherein, let's say I have a Git server and I have the changes which are C1, C2, C3, and possibly C4. All right. So this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer 1 is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer 1 then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all the Git server would not allow him to go back in history, but assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer 1 wants to get rid of C3, better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit But to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people you're using this repository collaboratively and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the git revert command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit, and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say, looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the git revert command. So git revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does Git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right, and if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead. From C5, I see another commit. But what was there as a part of this commit? Actually is getting rid of this commit C3. So if at all I see my files here, there's only M1, M2, and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic Git commands, let me get into a very interesting topic regarding Git, which is about branching. The topic is interesting because Git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it's a very expensive operation, both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch. And once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is Git Demo, and then I'm going to create a new folder here. I'll create a folder called org details. All right, this is my folder here. All right, I navigate into this folder and let me create a repository here. I initialize a repository and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this notepad. employees.text. Simplilearn has over 3k employees. I just put in some content in this. Save this content. Alright. So if at all I do a git status, I just see 2 files in it. So let me go ahead and add these 2 files and let me commit my changes. So git commit -am or -m. First commit. So if I do a git log, I see only 1 commit and there are 2 files here. You can see those 2 files that is here. Alright. So at this stage, let me go ahead and create a new branch. And the command for creating a new branch is git branch name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these 2 branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, there's exactly 2 files the way it was earlier. Because I've created a branch from my base branch, which is the master branch. And when I created a branch, there were 2 files existing here. If you see the content of these files, they would all be the same. Alright, so let me create a file that is specific to Bangalore branch. So I would just say notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say notepad address.txt. I'll say Simplilearn Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. And I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. Alright, if you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical git folder. So what happened is, now git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. Alright, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. I'll go here and say new repository. All right, this is the name of the repository, Git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. All right, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server. And let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. All right. I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch and it says what is the name of the branch, master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. All right, now it created a branch out here. Let me do a refresh of this. All right, it says 2 branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout, Bangalore branch, I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which was nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server. And now, if at all I do a refresh out here, okay, I'm in 2 branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these 2 branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. Alright, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. We need to specifically push our changes onto the server. Okay, there are two branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -- delete and the name of the branch. All right. So this went ahead and deleted the branch from the server. Let's check that. Okay, if you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch, the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git checkout, the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push -u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch -av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. And this would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin --- delete and the name of the branch. This would also delete the branch that you created on the server.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GitTech postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course.
Now we will be talking about that how exactly we can make use of Maven here in performing various kind of operations, whether it's a build, compilation, various kind of stuff there. So let's talk about it, why exactly we use Maven here. Now, Maven is something which is a kind of a build tool which is there for most of the Java-based projects here. So this tool also helps us in building up the source code by downloading some couple of dependencies. These dependencies are something which is being configured by the developers, which a developer feels that the project is dependent on, and he requires those dependencies to be downloaded. So this tool is specifically used to build and manage any kind of a Java-based project, whatever the complexity of the topic or the project is there. So this tool will be able to handle that particular requirement or that project. So it simplifies the day-to-day work of a Java developer and helps them in their projects for performing daily to daily activities. Right now, Maven also helps us in getting the specific jar files for each and every project. So if you are going, you can pretty much make a jar file, var file, or ER file, any kind of a package mechanism you can follow for your Maven there. So to download the dependencies, we don't have to actually go to the official website of each and every software. You can easily get it, the dependencies of each and every third-party binaries on the mvnrepository.com. This is a website which is present, on which if you visit, you will be able to download the dependencies which is required by your project or by your specific project over here. So it totally depends on how exactly you want to download and you want to get together a specific repository over here. So mvnrepository.com is the one. If you visit, you will be able to download and go through all the jar files, dependent jar files as in dependencies which you require for your current project. Right. So now what exactly is a Maven all about? So let's see on that part. So Maven is a popular open source build tool which is developed by the Apache group, and the primary ownership of this tool is to build, publish, and deploy several projects at once. Maven is written in Java, and it can be used to build projects written in C#, Scala, Ruby, etc. So apart from Java, these are the different programming languages or the tools which is supported by the Maven here for performing the build activity. So the tool is used for build and management of any kind of a Java-based project. It simplifies the day-to-day work of a Java developer and helps them to automate most of the compilation or build perspective tasks on the projects. Right. Now Maven is a kind of a BOM-based project, so it also known as a project object model, and it focuses on simplification and standardization of the building process. In the process, it takes care of all the followings here: builds, dependencies, reports, distribution, releases, mailing list. So all these things are being taken care as in this particular process here, and ultimately it's an ability inside the Maven that how the overall build process needs to be automated and standardized here. So all these particular mechanisms can be followed as such over here, so that we can have a good standards and the simplifications implemented as such here. Now what exactly is a Maven repository all about? So Maven repository is something which is a kind of a directory, or it's kind of a location where we have all the jar files packaged all together in a single location. So depending on the software which you want to download, the dependent jar files can be downloaded from there. So the metadata refers to the POM files relevant to each project here. This metadata is what allows Maven to download the dependencies. Now there are three types of repositories from where we can download the dependencies. The first one is the local repository, second one is the remote repository, and the third one is the central repository. So these are the primary three types of repositories which is available there for a specific Maven over here. So whatever repository you want to follow, you want to access, you can pretty much access it and you can go with that. Right now, the local repository will be primarily present onto your PC. That's the way that how it's present there. And the particular remote repository is something which you can store on any remote machine or remote server. And the central repository is something which you can have it onto the internet. So usually the central repositories is something in which we can actually host our different kind of dependencies and the jar files over there. So local repository on the machine of the developer where the project material is saved. So all the particular dependencies jar file will be available on your local machine. Remote machine is the location where you can actually store all your particular dependencies, from where you can download these dependencies whenever you require it. So this repositories work similar to the central repository. Whenever anything is needed from the remote repository, it's first downloaded into your local repository and then it will be utilized. So if you feel that the dependency is something which is not there in the local, it will be first downloaded from the remote repository and then it will be utilized or will be referenced onto the local machine there. And central repository refers to the Maven community repository there, where you will be able to see each and every dependency present on that repository. So Maven downloads the repositories from here in the local repository whenever they're needed or whenever required. All these dependencies are cached locally, from where it will be referenced in the next, or whenever we want to refer that, we will be able to do that particular reference easily on that part. So this is the way that how the three particular repositories or Maven repositories really helps us for performing various kind of automations as such here. Right, now what are the basic concepts of Maven here? So some of the couple of basic concepts which is present in Maven is, like, for the first time we have the project object model. So project POM refers to the XML file which has all the information regarding the project, how this particular project should be built up, how the different build process should be automated there. It also has a description of the project, details regarding the versioning information is also stored as such in this XML file, in this particular POM reference file as such over here. The XML file is which is there in the project home directory. So Maven is something which search for the POM file in the current directory. If it's able to find that particular POM file, so it will execute or it will proceed with the build step, otherwise it will halt there itself. So this POM file is very important because it will act as a kind of a build script, and primarily the Maven tool will be able to process each and everything which is configured as such in this specific XML file there, and according to that only it will function or it will proceed further. Right, now second thing is the dependencies and repositories. So dependencies usually refers to the jar files, so the Java libraries which we need into our particular project. So while working on the project, we may be having the dependency on couple of dependencies. So these dependencies we have to actually download or we have to actually refer, and once these particular information or these details are referred, so what will happen that we need to download these specific dependencies from the particular Maven repositories. So if the dependencies are not present in your local repository, then Maven will try to download it from the central repository and cache it into your local repository. But first of all, it will look on into the local repository, and if it is not present in local, then only it will go to the remote or the central repository. Then we have build life cycles and phase and goals there. So build life cycles consists of the sequence of build phases, and each build phase consists of sequence of goals here. Now each goal is responsible for performing a specific task. When a phase is running all the goals related to that phase, and its plugins are also used to performing the compilation, preparing the artifacts, downloading the dependencies, all different things being done by the plugins here. Then we have the build profiles. So build profiles refers to a set of configuration values. Now generally we have the generic build process for all the environments or all the particular code base there, but sometimes we do have some kind of a differences there. So that is where we can go for the profiles, because a specific profile can have its own configuration, and whatever it's required for the build process, we can have different configurations stored inside the Maven build script here. Then different build profiles are added to the POM files, and which enables the different build as such here. So depending on these profiles, we can actually decide that how we need to proceed with the build process and how the different kind of build automations needs to be performed here. Then a build profile helps in customizing the build for the different environments, so that also we can perform as such while performing or while working on the different components and the different management here. So a build profile is something which you can configure, you can utilize, and depending on that build profile, we will be deciding whether to proceed further or how to decide on that particular factor. So these are something which we need to take care, or we need to work according to which we can decide that how the specific configurations and specific automation needs to be performed here. Now usually when we go for the Maven there, so we have to use some couple of Maven plugins. Now the goal of using these specific plugins is to automate some of the basic stuff like compilation, creating the var file, creating the jar file. So when we are using the plugins, we don't have to configure the steps or write the steps that how these specific plugins should be installed or should be referenced. It's ultimately the internal configurations which we are looking forward or which we are using while working on these specific plugins. So you can download some couple of plugins using which we will be able to decide that how a specific goals needs to be achieved here. So Maven has its own standard plugins that can be utilized. So if want to go for a custom one, so you can do that, but pretty much you can go for the default one, and you can pretty much have some specific goals executed with the help of these build plugins. Now next thing is the Maven architecture. So in Maven, what happens that let's talk about the basic architecture of Maven here. So the Maven executable, when it's deployed, so it usually reads the pom.xml file, which is the build script here. Now once the specific pom.xml file is being read out, so it will process the components. It will download, or it will process the dependencies, plugins, life cycles, phases and goals, and even the build profiles. And if any kind of interaction is required, so it will try to connect to the central repository or a remote repository, and according to that it will provide the information and provide the details as such. So Maven repository is something which is very important because it's ultimately trying to connect to the Maven repository and try to achieve the various kind of automation here. So it's very important because ultimately it's trying to help us to go for the complete end-to-end build automation when we'll go for a specific POM based build automation. So Maven executable will read the pom.xml file, then download the dependencies defined into the pom.xml file, and that dependencies are cached locally from the remote or the central repository. Now then create and generate a remote report according to the requirement and execute the life cycles, phases, goals, plugins, etc. So it will process the pom.xml file there, and whatever the plugins and goals or the life cycles which is configured there, step by step each of them will be executed into a sequence here. Now let's talk about the overall build lifecycle of the Maven here. So what happens that the Maven build lifecycle is something which is a kind of a collection of different steps there, and this is something which is followed to perform a build automation for a specific project. So that there are pretty much 3 steps which is being done. So first one is the default, so it handles the project deployment there. Second, handles the project cleaning, which is a clean there, and then we have site, so it handles the creation of the project sites documentation there. So these are the 3 built-in particular life cycles which is available there at the Maven level, which you can utilize to perform a various kind of particular steps execution for your project. Right, so the build cycle has the different build phases or stages there, because when we are performing a build, a variety of things needs to be performed over here. So the first one is the compile, then test compile is there. So compilation is there for the source file, and test compile is there for the test cases. Test will execute the test cases, package will package the bundle, then we have the integration test to run the integration test cases, then we have the verify, then install goal is there, and the last one is the deploy, which is there to deploy the artifacts to the artifact tree. So all these things are the different phases and the stages which is being followed as per a specific build here. So during these builds, these are the different phases and the stages which we normally follow for performing the build automation. Now what is the exactly advantage of a specific Maven here? So that is something which we need to talk about, that how the particular automation needs to be done, or how we can actually go for the configurations where we feel that yes, we want to perform or we want to take certain benefits out of the implementation of Maven here. So for that, what happens that we have to see that the various kind of benefits. The first one is that Apache Maven helps manage all the processes there, such as building, documentation, releasing, and distribution in project management here. So the tool simplifies the process of project building. It increases the performance of the project and the building process altogether. And the task of downloading jar files and other dependencies is also done automatically. We don't have to indulge in any kind of download part as such manually over here. right? And Maven provides easy access to all the required information. So Maven makes it easy for a specific developer to build a project in the different environments. So we don't have to worry about the environment, we don't have to worry about the infrastructure, nothing is required. Everything is available there inside this package. And depending on the particular, you can write the source code on one machine and you can pretty much do the build on another machine. And this is the reason how the build automation really happens on the first place, because the developer is writing the source code in one location and the same code is deployed onto the particular, or built onto this Jenkins or any kind of build tool there. Right, in Maven you can easily add new dependencies, so you must write the particular dependencies in the POM file. So if you feel that you want to download some particular dependencies, so all you have to do is that you have to put that dependency into the specific pom.xml file there, and depending on that the execution will be really performed and executed as such here. Right, so let's talk about the demo now. So let's see that how exactly we can go for this demo and we can perform the various kind of automations. So this is the virtual machine which we have here, on which the Maven is already installed. So we can run like mvn. So Maven will be available as in 3.6.3 here. Now I'm going to run a particular command called mvn archetype generate here. Let me create a directory here, a temp directory, and to perform this activity over there. So mvn archetype generate. Now once we run that, so what will happen, that it will download some of the binaries there, because ultimately what we are trying to do is that we are trying to generate a new project, like a Maven project. So a couple of particular plugins will be downloaded by the Maven executable so that it can achieve that particular execution. So we just have to wait for downloading all these values. Now here it's trying to give us a particular attributes, like it's asking the different attributes over here. So what exactly we want to configure. So if you want to configure, you can provide that details, otherwise you can perform or whatever the setup you want to perform. Now here it's asking for the version, so which kind of version we want to follow. So I'm going to follow like 5 here, so I'll press 5. Then a group ID which is there, so it's basically a kind of a group mechanism, so I can say like com.Simplilearn. So that's the value which I'm providing here. Artifact ID, I can make it like a sample project or something like that. I can do, so that will be the artifact ID which is there. So version I am keeping the same only. So and yeah, so package same here. So I just want to create, so I'll just provide the value called yes and enter. So with this, what will happen, that a sample project will be created here, right? So whatever the artifact ID you provided, so according to that the project is created in this directory. So you have to go into this directory and see that what exactly the files are created there. So you have the pom.xml file. Now this pom.xml file, when I open, so you can see here that there are some attributes, like you can have the values related to what version or group ID you want to follow. So this is the group ID, this is the artifact ID. So this is jar file. By default you can change it according to your requirement. Then this is the version, and if you feel that you want to do the changes to the name, that also you can perform here. So by default the JUnit dependency is added, but if you want to keep on adding your own custom dependencies, you will be able to do that. Now in this case, if you run like mvn clean install, so it will be considered as a particular Maven project. A pom.xml file is already there present in the local directory. So according to that, the execution of the steps will be performed, and according to that you will be able to get some desired values here. So ultimately in the target directory you will be able to see that some couple of jar file or a specific jar file is generated here. So you can see that in the target directory this jar file or this artifact is generated here. So this is a way that how we can actually go for a generic one, like a new particular project, and later on you can, depending on your understanding, you can keep on adding or you can keep on modifying the dependencies, and that's how you can get the final result there. So that's it for this demo, in which we have find out that how exactly we can go for a particular project preparation with the help of mvn executable. So that's it for this demo. Thanks. Right, so that was the demo in which we saw that how exactly we can go for the Maven, and we can execute some build process related to Maven there. So this is the Mac system which we have here. Now in this one, what we are going to do is that we are going to open the terminal. So we are going to open a terminal here. So this is my terminal. So usually in Mac, you don't require any other mechanism. So the inbuilt terminal is more than sufficient for doing this stuff because it's similar to a Linux based platform here. So I'm going to run the command here. So first of all, I'll just double check that if my brew executable is working fine. So I'll just run the brew help command to see that if my brew is working fine as such over here in this one. Now I have the command called brew install. So that is a command which we need to use. Now in this one, we have to actually give the specific package which we want to install. So we will say like brew install maven. So it will download the specific executables on the system. From the website, it will download the Maven executables. So it will take some time, but ultimately it's trying to download it under the particular tar file. So you can see here that it's downloading a 3.6.3 tar file over here. So I can see that the installation is done. So the 3.6.3 version should be installed over here. So when I do like Maven mvn under hyphen version over here, so you can see that the 3.6.3 version is deployed as such over here. Now this is something which is done with a purely command over here called brew, which really helps us to do any kind of package installations. Not only Maven, other packages also can be installed pretty much with the help of this executable. Now, in order to see the manual stuff, what we really need to do is that we need to actually clean this specific installation so that I will be able to show you the manual installation also over here. So what I'm going to do is that I'm going to run the command called brew uninstall Maven so that the Maven should be removed from your system. So we are just trying to remove the Maven from here, and you can see that the Maven executable is not working as such over here. So which means that the Maven is uninstalled in this case. But why I have uninstalled here? So that I should be able to go ahead and download some custom Maven over here in this one. So I have opened the browser here. So I'll go for the Maven executable. So we'll go for Maven download so that we should be able to download a specific the executable here. So I'm going for this directory. So here 3.6.3 version same is available here. So I'm going to download the bin.tar.gz, which was the file we have. So this is also a kind of a Linux platform, right? So that's the reason why here the tar file should work perfectly fine. So here I'm going to the OPT directory where we can have all the optionals related packages. So if it is not there, so I can create a directory called /opt. So I can log in with root. So if you don't have the root access, so you can go for the applications. In the applications, you can actually create a directory called Maven. So here I can go for Maven. Yeah. So here we will be downloading the var file here. So the tar.gunzip file we are downloading over here. So I'll give the path here. So once the var file or wget command I am using to do the installation, but sometimes the wget is not available. So I can go for the brew install wget also. If that package is available on brew, the installation will be done. So we'll try to do the installation using wget so that we will be able to get a tar file generated or downloaded. There are other ways also. You can download it from the browser also. Yeah, you can go to the browser and here you can actually click and download it, and then you can transfer it locally to this specific directory also. So both the possibilities are there, but I'm just trying to download the wget command so that it will be easy for me to do the setup and to do the download over here. So I'm going to run the same command again. So it will download the tar file. So this is the tar file which is available over here. So I'm going to extract it over here. So once the extraction is done, so I'm going to rename it like to Apache Maven so that I should not have any kind of versioning or these kind of parameters over here. And the Apache.maven hyphen this tar file I'm trying to remove as such over here. So this is what I have got as an end result over here. Now this is the current directory in which I have these applications and these setups going forward over here. So if I run the mvn hyphen version command, so that will not be giving me any kind of output over here because still I have extracted the tar file, but that is not, the activity is not complete. I have to exactly set up some environment variables so that I should be able to run this mvn command. So what I really need to do over here is that we have to export certain variables. Application/maven Apache Maven. So this is the home directory which I'm trying to configure over here. And then next thing is that path variable. So I'm going to have, we are going to coordinate the path variable with the folder. So I'm going to have the folder structure here. So the bin directory we have to provide. So I'm going to copy here and paste, and then I'm concatenate it with the bin here. So now my environment variables are established. So my mvn -- version command, as you can see here, is that it's being picked up over here, but it's saying that the particular Java runtime is not available. So I can go for Java brew install Java. So that should be enough there to install a Java package there. So you can see that it says that it's already installed, so and up to date. So that's the reason why it's not able to do the installation. So I'm going to reinstall OpenJDK. Because what happens that when we do the installation, some environment variables related to Java should be formatted or should be extracted over here, right? So as you can see that here it's saying that if you want to really use the executable of Java, you have to concatenate the path like this. So let's run that, and then we can see that the particular executable of Java will also be find out over here. So Java -version showing that yes, it's available there. And now my command should be able to show me that yes, it's working fine. The JDK was already installed, but the problem with that is that since it's installed into a particular location, so you have to actually override your path value so that you should be able to see in that directory and find out the Java executable. So that I have got by doing the deinstallation. I got the command over there in the output saying that this is the installation which is done, and now you just have to extract, or you have to just put that path directory into the specified path variable, and that's how you got the Maven and Java both command lines working over here. So this is how you will be doing the Maven installations all together, how the overall installation of Maven and the JDK really works on Mac operating system. Right. So before even going for Maven, we have to install the JDK onto our Windows machine so that we can proceed with Maven, because Maven requires the JDK installations to be there. Now there are two ways of JDK installation. Either you go for the exe file, or you extract the binaries of JDK to a directory and then set up the Java_home path for that. But if you are using the executable, that will perform the path configurations for you also. So in that case, you don't have to reconfigure it again and again. So that's what we are going to see here. So first of all, we will try to do the installation of JDK. So for that, we'll go to the website of JDK, and then we have to click on this one to access the Maven installations part here. So that's what we are going to do. So let's proceed, and let's open the Chrome and try to go through these two URLs so that we can do the installations one by one. So here I have to just search for JDK 8 download. So it will show me the URL for oracle.com. So here you will get the JDK for the different platforms, for different operating systems. Now here what you can see here that you have the configurations in which you have the JDK installation. So we have to So here I'll go for the Windows 64 version, because that is something I will be using to do the installation. So this is the complete executable link. So here you can download. So we are downloading the SDK U251. So just search for Windows 64. Yeah, this is the one. So let me click on this one. Let me quickly log into the web page. So once the login is done, you will be able to see that it's trying to download the exe file. So that was for the JDK, for the Java. Now for the Maven, I'm going to go for the Maven download over here. So in this one, the Maven repo, link is there. maven.apache.org is the link for this one. Now here we have the different options. You can see here that the binary zip archive is there, then source zip archive is there. So depending on the installation which you want to perform, you should be able to download that file and it works there. So let's first install the JDK portion and then we'll go with this one. So we'll click on this one also anyways, because it's something we have to anyways do it. So we'll click on this so that this Maven is also getting started downloading over here. So once both of them are downloaded, we will proceed further with the setup. So let's wait for another 1 minute to do this one. So the Apache Maven is kind of downloaded over here. So we wait for the JDK download also over here. So next 5-10 seconds only left out. So first JDK will be there and then Maven installation configurations will be there. So for Maven we just have to extract into a directory and give the MVN home path into the properties into the variables so that it can pick it up over there. Okay, so we have to extract the zip file for Maven, give the path, and then we will check with the Maven command whether it's working fine or not. So let's try to install the executable. So we'll open the directory where the executables are there. So first of all, we'll install the JDK. So we'll double click the installer for JDK. It's of around 200 MB. So the complete JDK will be installed. So we have to just go for next. Now when you go with the installer, so usually the Java home paths and all that stuff is already configured, so you don't really have to change the passwords or Java home any kind of variable you have to put it up. All those things will be automatically cleaned up. So it's running the installation. Close. So then we have to extract the Maven. So we have to extract this directory because here the Maven complete executables and libraries are there. So we just have to extract it and place into a directory so that we can further on use it and access the path. So once the access is done, yep, so this is done there. So I can rename it to like Maven. So I can rename it like to as Maven and I can cut it down and put it into the C drive here. Now this is the Maven home path which is going to be there, right? So all I have to do is that I have to close this one and this one and this one and this. So what we have to do is that we have to really go to the system properties so that we can extract it. So I'm going to open the system properties over here. Properties. Now here the advanced system settings. Now in this one we will be setting up the paths. So environment variable will go. Now here if you scroll down you will see all the different paths which is available there as such over here. Now if we want to see that if the Java is fine or we require for JDK also, so all we have to do is that we have to open the CMD prompt. Window R we are providing. So using the window R I'm opening the run window where I can say like CMD. Now in this CMD I'm going to say like Java -version. So Java is there, so which means that we don't have any problem as such. Now I'll just go here and set up a new one called MVN_home. So here the same path. So you can browse for directory also, but I am using the MVN home over here in this one. Now I have just added that, and in the path variable in the last we have to actually add the bin directory also, so that whenever we run the mvn command, so that should also be resolved. So mvn_home is not the only variable which you will be configuring. In fact, you will be configuring the path variable also, that you can go ahead and put up a new directory entry for the cmd here. So cmd till the cmd directory, you will go there, and whatever the executable is there, you should be able to resolve that. So for that, again you have to open the window R, cmd prompt, java-version, and then you can run mvn-version here. When you run the mvn-version, it will let you know that which particular Java runtime you are using, 1.8.0/251. That's the same one which we have configured. And it also let us know that where exactly the executable is there, and we can now proceed further with the execution of the Maven build. So you just have to check out your source code or go to that directory where source code is there, and you can run the mvn clean install. So that will ultimately go for the build process. So this is the way that how we can do the installation of Maven on the Windows platform. Now since this is done, now we will go ahead with the second installation where we are going to do the installation of Maven and JDK onto the Ubuntu machine. So for that we will log into the particular cloud lab of Simplilearn LMS. So let's log into the LMS here. So now we are going to do the installation of JDK and Maven on the Ubuntu virtual machine here. So for that we will log into the LMS. So let's log into that. So this is the LMS over here. Here I have already started the lab here. So all I have to do is that I have to just click on this link here. So it will open the lab into a new tab. It's a GUI mode of Ubuntu server, so which we will be using to configure it. So here first of all I can open the Chrome browser also. So let me open the browser here so that I can download the Maven executables as such over here. So JDK we can do it using the package installation. So using the apt executable we will be doing the installation. So I have to just open the terminal here. So once the terminal is opened, you have to log in through the root ID. Now why we require root ID? So that we should be able to do the package installations and other configurations. So that requires root access. Now once that is done, you have to run the particular app update command. Next you have to install the installer. So the Oracle installer we have to install. Now once the setup is done, so let's install the latest package over here for Oracle-Java 14-installation. So this will install the JDK 14 over here. So for that configurations. Now at the same time we'll go for Maven download also. So here we'll go for download Maven. So this is the tar file for executable. So I'm going to copy this URL here, and over here we'll say yes. So now the Java should be configured and should be set up over here in this one. So what we really need to do is that we need to run the Java command to see that if the installation is done properly or not. So let's open the terminal again, another terminal, so that I can perform the steps related to Maven. So I have got the URL, so I'm going to the opt directory, which is always an optional directory where we can do the setup and all those configurations. So I'm going to run the wget command and then the URL which I have downloaded. So this should download the tar file over here of Maven. Now once that is done, so I have to extract it. So tar-xvzf and the tar file name. This is a tar gunzip file, so I have to use tar-xvzf parameter over here to extract it. Now what exactly I have got the Apache Maven directory over here. So I'm going to rename it. In order to rename it, what we need to do, we need to actually go for the particular move command. So move whatever the existing folder you have, and then I'm going to rename it with the Maven directory. Now once that is done, I'm going to the Maven directory, and this is the path or Maven_home path which is available as such over here in this one. So here all the bin directories, executables, all this stuff is there. So now I can use it like mvn_home and the same configuration just like we did in the Windows. So here also the same process we have to follow. So Java version should be let me know that which version is deployed. So 14.01 version is deployed over here. So for Java I don't have to set up the path again here because I'm using for the installer, so I don't have to set up the path, right? So for Maven, now what exactly I have to do, I have to go to the etc profile D. Now here I'm going to put up a particular file. Now here you can see that we have the JDK file here, which means that the path variables and everything is configured as such over here. So you can see that Java_home, path, all these variables are copied here. So I'm going to also create a same file similar to this one here, but in this case what I'm going to use it that I'm going to remove some of the values. So I'm going to have some of the parameters added. So in order to do it effectively, I can do the echo command so that I can copy the things from here and I can simply put it up into the file here. So I'm going to have the path variable added up over here. Now why I'm putting up the paths, because it's the same configuration which we did over there also. So opt/maven/bin. So all the bin directories should be added to the specific path variable. So I'm just trying to create a file called maven.sh. Just like a jdk.sh over here, I'm also creating similar kind of file over here called maven.sh. Now I'm not going in the VI mode or other editors, because I just want to make you understand that how I'm copying it, the content. I'm taking the jdk.sh as a reference and putting up the details over here in this one. And then I'm going to export mvn_home over here, which is related to like opt/maven. So this is what we are going to put up over here, and then maven. In the end, maven, this is the file which you should be having. Now why we are using it? Because of the fact that it's being used, or it will be utilized in such a way that you can perform the changes or whatever configurations you want to perform. This will help you to set up the certain paths like a path and mvn home, so that you can run these scripts as such over here. So I'm going to give the executable permissions to this one, and that's it. So now what exactly I have to do is that I have to do the source here, profile.d maven. Once that is done, I will be able to run the mvn-version over here, and the JDK part is already open, so it's going to refer to that part. So this is the way that how we configure the maven and the JDK specifically on the Ubuntu virtual machine. So pretty much that's it for this demo. In this demo, we primarily talked about that how we can do the installation of JDK and Maven on Windows, and how we can do the similar task on the Maven on the Ubuntu virtual machine also here.
Introduction. Let's get into what all will be covered as a part of this tutorial. I will get into some of the prerequisites required for installing Jenkins, post which I will go ahead and install Jenkins on a Windows box. There are a few first-time configurations that needs to be done, and I will be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part. I'll create few users, and I will use some plugins for setting up various kinds of access permissions for these users. I will also put in some freestyle jobs. Freestyle job is nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon a time schedule. I will also connect Jenkins with GitHub. GitHub is our source code repository, where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box, and run few commands to build this particular repository that is pulled from GitHub. Sending out emails is a very important configurations of Jenkins or any other continuous integration server for that matter. Whenever there is any notifications that has to be sent out as a part of either a build going bad or build being good or build being propagated to some environment, and all these scenarios, you would need the continuous integration servers to be sending out notifications. So I will get into a little bit details of how to configure Jenkins for sending out emails. I will also get into a scenario where I would have a web application, a Maven based Java web application, which will be pulled from a GitHub repository, and I will deploy it onto a Tomcat server. The Tomcat server will be locally running on my system. Eventually, I will get into one other very important topic, which is the master slave configuration. It's a very important and pretty interesting topic where distributed builds is achieved using a master slave configuration. So I will bring up a slave, I will connect the slave with the master, and I will also put in a job and kind of delegate that particular job to the slave configuration. Finally, I will let you know how to use some plugins to back up your Jenkins. So Jenkins has got a lot of useful information set up on it in terms of the build environments, in terms of workspace. All this can be very easily backed up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. I have listed popular 3 mechanisms in which Jenkins is usually installed on any system. The topmost one is as a Windows or a Linux based services. So if at all you have Windows like the way I have, and I'm going to use this mechanism for this demo. So I would download a MSI installer that is specific to Jenkins and install this service. So whenever I install it as a service, it goes ahead and nicely installs all that is required for my Jenkins, and I have a service that can be started or stopped based upon my need. Any flavor of Linux as well. One other way of running Jenkins is downloading this generic WAR file, and as long as you have JDK installed, you can launch this WAR file by the command opening up a command prompt or shell prompt if at all you're on Linux box, specifying java-jar and the name of this WAR file. It typically brings up your web application and you can continue with your installation. The only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt. You either do a Control-C and then bring down this prompt and your Jenkins server would be down. Other older versions of Jenkins were run popularly using this way, in which you already have a Java-based web server up and running. So you kind of drop in this war file into the root folder or the HTTPD root folder of your web server. So Jenkins would explode and kind of bring up your application. All user credentials or user administration is all taken care of by the Apache or the Tomcat server or the web server on which Jenkins is running. This was a very older way of running, but still some people use it because if they don't want to maintain two servers, if they already have a Java web server which it's being nicely maintained and backed up, Jenkins can run attached to it. Alright, so either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very, very same or similar one, with the subtle changes in terms of user administration if at all you're launching it through any other web server which will take care of the user administration. Otherwise, all the commands or all the configuration or the way in which I'm going to run this demo, it is going to be same across any of these installations. Alright, so the prerequisites for running Jenkins, as I mentioned earlier, Jenkins is nothing but a simple web application that's written in Java. So all that it needs is Java, preferably JDK 1.7 or 1.8. 2 GB RAM is the recommended RAM for running Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variable Java home to point to the right directory. This is something very specific to JDK, but for any other open source tools that you install, there is always a preferred environment variable that you got to set in, which is specific to that particular tool that you're going to use. This is a generic thing that is there for, for any other open source projects, because the way open source projects discover themselves is using these environment variables. So as a general practice or a good practice, always set these environment variables accordingly. So I already have JDK 1.8 installed on my system, but in case you do not, what I would recommend is just navigate on your browser to the Oracle homepage and just type in or search for install JDK 1.8 and navigate to the Oracle homepage. You'll have to accept the license agreement, and there are a bunch of installers that you can pick up based upon the operating system on which you're running. So I have this Windows 64 installer that is already installed and running on my system. So I will not get into the details of downloading this or installing it. Let me show you once I install this, what I've done with regard to my path. So if you get into this environment variables, all right, so I've just set in a Java home variable. If you see this, C: program files Java JDK 1.8. This is where my Java is located. C program files Java. Okay, so this is the home directory of my JDK. So that is what I've set it up here in my environment variable. So if you see here, this is my Java home. All right, one other thing to do is ensure that in case you want to run Java or JavaC from a command prompt, ensure that you also add that path into this path variable. So if you see this, somewhere I will see, yes, there you go. C: program files Java JDK 1.8 bin. So with these two, I'll ensure that my Java installation is nice and good enough. So to check that, to double check that, or to verify that, let me just open up a simple command prompt. And if I type in Java -version, all right, and Java C -version. So the compiler is on the path, Java is on the path, and if at all I do this, even the environment variable specific to my Java is installed correctly. So I'm good to go ahead with my Jenkins installation. Now that I have my prerequisites all set for installing Jenkins, let me just go ahead and download Jenkins. So let me open up a browser and say download Jenkins. All right, LTS is nothing but the long-term support. These are all stable versions. Weeklies, I would not recommend that you try these unless until you have a real need for that. Long-term support is good enough. And as I mentioned, there are so many flavors of Jenkins that is available for download. You also have a Docker container wherein you can launch Jenkins as a container, but I'll not get into details of that in this tutorial. All right, so what I want is Yes, this is the WAR file, which is a generic WAR file that I was talking to you earlier. And this is the Windows MSI installer. So go ahead and download this MSI installer. I already have that downloaded. So let me just open that up. All right. So this is my downloaded Jenkins instance, or rather installer. This is a pretty, maybe a few months old, but this is good enough for me. Before you start Jenkins installation, just be aware of one fact that there is a variable called Jenkins Home. This is where Jenkins would store all this configuration data, jobs, project workspace, and all that specific to Jenkins. So by default, if at all you don't set this to any particular directory, if at all you install an MSI installer, all your installation gets into C:\program files 86 and Jenkins folder. If at all you run a WAR file, depending upon the user ID with which you're running a WAR file, the Jenkins folder, there's a .jenkins folder that gets created inside the user home directory. So in case you have any need wherein you want to back up your Jenkins or you want Jenkins installations to get into some specific directories, go ahead and set this Jenkins home variable accordingly before you even begin your installation. For now, I don't need to do any of these things, so I've already downloaded the installer. Let me just go ahead with the default installation. All right. So this is my Jenkins MSI installer. I don't want to make any changes into the Jenkins configuration. C:\program files is good for me. Yeah, this is where all my destination folder and all the configuration specific to it goes. I'm happy with this. I don't want to change this. I would just say go ahead and click installation. Okay, so what typically happens once the Jenkins installation gets through is it'll start installing itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in a hash key. All right. So there's a very, very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a WAR file, you would see that in your logs. All right. So this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it will crib about it, but this looks good. So it's going ahead. All right. One important part during the installation. So you would need to install some recommended plugins. What happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins as a part of the installation would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment, Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very, very simple username and password. Something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI is little hard for many people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you would kind of appreciate, all the effort that has gone into the UI. Bottom line, UI is little hard to, wrap your head around it, but once you start using it, possibly you'll start liking it. All right, so let me get into something called as Manage Jenkins. This can be viewed like a main menu for all the Jenkins configuration. So I'll get into some of those important ones. Something called as Configure System. Configure System, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email IDs that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com. I'm using the SMTP authentication. I've provided my email ID and my password. I'm using the SMTP port, which is 465, and reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right, so no other configurations that I'm going to change here. All of these look good. All right, so I come back to Manage Jenkins. Okay, one other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that it's going to pull in and how is it going to build. So you would have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from your source code repositories. So just to give an example, in case your source code is a Java source code and assuming that, because in this demo, this is my laptop and I've put in all the configurations, JDK, everything on my laptop because I'm a developer, I'm working on the laptop. But my continuous integration server would be, a separate server without anything being installed on it. So in case I want Jenkins to, run a Java code, I would need to install JDK on it. I need to specify the JDK location of this out here this way. Okay, since I already have the JDK installed and I've already put in the Java home directory, or rather the environment variable correctly, I don't need to do it. Git, if at all I want the Jenkins server to use Git, Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you would need Git to be installed on that particular system and set the path accordingly. Gradle and Maven, if at all you have some Mavens as well, you want to do this. Any other tool that you're going to install on your system, which is your continuous integration server, you will have to come in here and configure something. In case you don't configure it, when Jenkins runs, it will not be able to find these tools for building your task and it'll crib about it. That's good. I don't want to save anything. Manage Jenkins. Let me see what else is required. Yes, configure global security. All right, the security is enabled. And if you see by default, it's the security access control is set to Jenkins own user database. So what does this mean? Jenkins by default, it uses file system where it stores all the usernames, which hashes up these usernames and kind of stores them. So as of now, Jenkins is configured to use its own database. Assuming that you are running in an organization, you would probably want to have some sort of an AD or an LDAP server using which you would want to control access to your Jenkins repository, rather Jenkins tool. So you would specify your LDAP server details, the root DN, password or the manager DN and the manager password and all these details in case you want to connect your Jenkins instance with your LDAP or AD or any of the authentication servers that you have in your organization. But for now, since I don't have any of these things, I'm going to use this own database. That's good enough. All right. So I will set up some authorization methods and stuff like that once I put in few jobs. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own servers, which is happening as of now. So I'm going to save all this stuff. That's good for me. So enough of all these configurations. Let me put in a very, very simple job. All right. So job, new item. Little difficult to kind of figure out, but then that's the new item. So I'll just say, first job, this is good for me. I just give a name for my job. I would say it's a freestyle project. That's good enough for me. I don't want to choose any of that. So unless until you choose any of this particular button would not become active. So choose the freestyle project and say, okay. At a very high level, you would see general, source code management, build triggers, build environment, build and post build. In case you install more and more plugins, you will see a lot more options. But for now, this is what you would see. So what am I doing? At the moment, I'm just putting up a very, very simple job. And the job could be anything and everything. So I don't want to put in a very complicated job for now. For the demo purpose, let me just put in a very, very simple job. I'll give a description. This is an optional thing. This is my first Jenkins job. All right. I don't want to choose any of these. Again, there are some helps available here. I don't want to choose any of this. I don't want to connect it into any source code for now. I don't want any triggers for now. I'll come back to this in a while. Build environment. I don't want any build environment. As a part of this build step, I just want to, run few things so that I kind of complete this particular job. So since I'm on a Windows box, I would say execute Windows batch command. All right. So what do you want to do? Let me just echo something. Echo. Hello. This is my first Jenkins job, and possibly I would want the date and the timestamp pertaining to the job. I mean, the date and time in which this job was run. All right. Very, very simple command that says, this is my first job. It just puts out something along with the date and the time. All right. I don't want to do anything else. I want to keep this job as simple as this. So let me save this job. All right. So once I save this job, the job names comes up here, and then I need to build this job. And you would see some build history out here. Nothing is there as of now because I've just put in a job. I've not run it yet. All right, so let me try to build it now. You see a build number, you would see a date and a timestamp. So if I click on this, you would see a console output. If I go here, okay, as simple as that. And where is all the job details that is getting into? If you see this, if I navigate to this particular directory, all right, so this is the directory what I was mentioning earlier regarding Jenkins home. So all the job related stuff that is specific to this particular Jenkins installation is all here. All the plugins that is installed, the details of each of those plugins can be found here. All right, so the workspace is where all the jobs that I've created, whichever I'm running, there will be individual folders specific to the jobs that has been put up here. All right, so one job, one quick run, that's what it looks like. Pretty simple. Okay, let me do one thing. Let me put up a second job. I would say second job. I would say freestyle project. All right, this is my second job. I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put up on Jenkins, which will be triggered automatically. Remember what I said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, so what I'm going to do, I will just keep everything else the same. I'm going to put in a build script pretty much similar to second job that gets triggered automatically every minute. All right, let me do that. Percentage date, and I'll put in the time. All right, so I just put in another job called second job, and it pretty much does the same thing as what I was doing earlier in terms of printing the date and the time. But this time I'm just going to demonstrate the powerfulness of the automation server that is there. If you see here, there's a build trigger. So a build can be triggered using various triggers that is there. So we'll get into this GitHub triggering or hook or a webhook kind of a triggering later on. But for now, what I want to do, I want to ensure that this job that I'm going to put in would be automatically triggered on its own. Let's say every minute, I want this job to be run on its own. So build periodically is my setting. If you see here, there's a bunch of help that is available for me. So for those of you who have written cron jobs on Linux boxes, you'll find it very, very simple. But for others, don't panic. Let me just put up a very, very simple regular expression for scheduling this job every minute. All right, so that's 1, 2, 3, 4, 5. All right, come up, come up, come up. All right, so 5 stars is all that I'm going to put in. And Jenkins got a little worried and is asking me, do you really mean every minute? Oh yeah, I want to do this every minute. Let me save this. And how do I check whether it gets triggered every minute or not? I just don't do anything. I'll just wait for a minute. And if at all everything goes well, Jenkins would automatically trigger my second job in a minute's time from now. This time around, I'm not going to trigger anything. Look, there you see. It's automatically got triggered. If I go in here, yep, second job that gets triggered automatically. It was triggered at 1642, which is 4:42 my time. That looks good. And if everything goes well, every 1 minute onwards, this job would be automatically triggered. Now that I have my Jenkins up and running, a few jobs that has been put up here on my Jenkins instance, I would need a way of controlling access to my Jenkins server. This is wherein I would use a plugin called role-based access plugin and create few rules. The rules are something like a global role and a project role, project specific role. I can have different roles and I can have users who have signed up or the users whom I create kind of assigned to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwarranted. All right, so first things first, let me go ahead and install a plugin. for doing that. So I get into manage Jenkins and manage plugin. A little bit of a confusing screen in my opinion. There's updates available, installed and advanced. As of now, we don't have the role-based plugin. So let me go to available. It'll take some time for it to get refreshed. All right, now these are the available plugins. These are the installed plugins. All right, so let me come back to available, and I would want to search for my role-based access plugin. So I would just search for role and hit enter. Okay, role-based authorization strategy enables user authorization using a role-based strategy. Roles can be defined globally or for particular jobs or nodes and stuff like that. So exactly, this is the plugin that I want. I would want to install it without a restart. All right, looks good so far. Yes. Go back to the top of the page. Yes. Remember, Jenkins is running on a Java using a Java instance. So typically many things would work the same way unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So let me go into, yes, global security. And I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I've already installed a role-based strategy plugin, and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to manage Jenkins, configure. All right, let me see, where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some roles for this particular Jenkins instance. So I would say first manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. At a very, very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer. And I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there. And each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is it sounds a little different, but I would want to give very, very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That looks good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah. delete, I don't want, read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very, very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs, or build jobs, or cancel jobs, or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I would say configure, manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer one sounds good. Some password that I can remember. Okay, his name is developer one, d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer one is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I've already configured. The role shows up here. I would need to find my user, whoever created, and then assign him to that particular role. So if you remember, the user that I created was developer one. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer one to this particular global role, and I would go ahead and save my changes. Now let me check the permissions of this particular user by logging out of my admin account and logging back as developer one. If you remember, this role was created with very less privileges. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new job. I can't do anything. I see these jobs. However, I don't think so I'll be able to start this job. I don't have the permission set for that. The maximum I can do is look at the job, see what was there as a part of the console output and stuff like that. So this is a limited role that was created, and I added this developer to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs, because the Jenkins instance is owned by a QA person. He doesn't want to give developer any administrative rights. So the rights that he set out by creating a developer role, and anybody who is tagged, any user who is tagged as a part of this developer role would get the same kind of permissions. And these permissions can be, fine grained. It can be a project specific permissions as well. But for now, I just demonstrated the high level permission that I had set in. Let me quickly log out of this user and get back as the admin user, because I need to continue with my demo. With the developer role that was created, I have very, very less privileges. One of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins that is provided by users or community users who don't charge any money for these plugins, but it's got plugins for connecting anything and everything. So if you can navigate to, or if you can find Jenkins plugins, you would see index of over so many plugins that is there. All of these are wonderful plugins. Whatever connectors that you would need, if you want to connect Jenkins to an AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you would have a plugin. You can go and search up. If I want to connect Jenkins to Bitbucket, Bitbucket is one of the Git servers. There's so many plugins that is available. Okay, so bottom line, Jenkins without plugins is nothing. So plugins is the heart of Jenkins. For you to connect, or in order to connect Jenkins with any of the containers or any of the other tool sets, you would need the plugins. If you want to connect, or you want to build a repository which has got Java and Maven, you would need to install Maven and JDK on your Jenkins instance. If at all you're looking for a .NET build or a Microsoft build, you would need to have MS Build installed on your Jenkins instance, and the plugins that will trigger MS Build. If at all you want to listen to some server-side webhooks from GitHub, you would need GitHub specific plugins. If you want to connect Jenkins to AWS, you need those plugins. If you want to connect to a Docker instance that is running anywhere in the world, as long as you have The URL which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. SonarQube is one of the popular static code analyzers. So you can connect a Jenkins build, you can build a job on Jenkins and push it to SonarQube and get SonarQube to run analysis on that and get back the results in Jenkins. All of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to GitHub. I already have a very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. All right. So this is my very simple repository that is there called Hello Java, and this is what is there in the repository. There is a hello.java application that is here, or a simple class file that is there. It's got just one line of system.out. So this is already present on github.com at this place, and this would be the URL for this repository. If I pick up the HTTPS URL, this is my HTTPS URL. So what I would do is I would connect my Jenkins instance to go to GitHub, provide my credentials and pull out this repository which is on the cloud hosted github.com and get it to my Jenkins instance and then build this particular Java file. I'm keeping the source code very simple. It's just a Java file. How do I build my Java file? How do I compile my Java file? I just say Java C and the name of my class file, which is hello.java. And how do I run my Java file? I would say Java and hello. Okay, so remember, I don't need to install any plugins now because what it needs is a Git plugin. So if you remember when we were doing the installation, there was a bunch of recommended plugins. So Git is already installed on my system, so I don't need to install it again. So let me put up a new job here. It says Git job. Let it be a freestyle project. That's good for me. I would say okay. All right, so the source code management. Remember in the earlier examples, we did not use any source code because we were just putting up some echo kind of jobs. We did not need any integration with any of the source code systems. So now let me connect this. So I'm going to put up a source code and Git would show up because the plugin is already there. SVN, Perforce, any of those additional source code management tools, if at all you would need, just install those plugins and Jenkins connects wonderfully well to all these particular source control tools. Okay, so I would copy the HTTPS URL from here. I would say this is the URL that I'm supposed to go and grab my source code from. But all right, that sounds good. But what is the username and password? So I'll have to specify a username and password. All right, so I would say the username, this is my username, and this is my HTTPS credential for my job. Okay, so this is my username and this is my password. I just save this. I say add, and then I would say, use these credentials to go to GitHub and then on my behalf, pull out a repository. All right. If at all at this stage, if there's any error in terms of Jenkins not able to find Git or the git.exe, or if my credentials are wrong, somewhere down here, you would see a red message saying that, something is not right. You can just go ahead and kind of fix that. For now, this looks good for me. I'm going to grab this URL. What am I going to do? This step would pull the source code from the GitHub. And then what would be there as a part of my build step? Because this repository just has a Java file, correct? Hello.java. So in order for me to build this, I would just say execute Windows batch command. And I would say Java C hello.java. That is the way I would build my Java code. And if I have to run it, I would just say Java hello. Pretty simple, 2 steps, and this would run after the repository contents are fetched from GitHub. So Java C, Java, that sounds good. I would say save this and let me try to run this. Okay, if you see, there's a lot of, it executes Git on your behalf. It goes out here, it provides my credentials and says, it pulls all my repository, and by default, it will pull up the master branch that is there on my repository. And it kind of builds this whole thing, Java C hello.java, and it runs this project Java hello. And there you see, this is the output that is there. And if at all you want to look at the contents of the repository, if you can go here, this is my workspace of my system. Hang on, this is not right. Okay, Git job. If you see here, this is my hello.java. This is the same program that was there on my GitHub repository. Okay, so this is a program that was there on my GitHub repository. All right, so this was the same program that was here, and Jenkins on our behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to my local system on my Jenkins instance. It compiled it and it ran this particular application. Okay, now that I've integrated Jenkins successfully with GitHub for a simple Java application, let me build a little bit on top of it. What I will do is I have a Maven based web application that is up there as a repository in my GitHub. So this is the repository that I'm talking about. It's called MVN Web App. It's a Maven based repository. As you would know, Maven is a very simple Java based build tool that will allow you to run various targets, and it'll compile. It will, based upon the goals that you specify, it can compile, it can run some tests, and it can build a WAR file and even deploy it into some other server. For now, what we're going to use Maven is just for building and creating a package out of this particular web application. It contains a bunch of things, and what is important is just the index.jsp. It just contains an HTML file that is there as a part of this web application. So from a perspective of requirements, now since I'm going to connect Jenkins with this particular repository, Git, we already have that set. We only need two other things. One is Maven, because Jenkins will use Maven. So in order to use Maven, Jenkins would have to have a Maven installation that is there on the Jenkins box. And in this case, the Jenkins box is this laptop. And after I have my Maven installed, I also need a Tomcat server. Tomcat is a very simple web server that you can freely download. I'll let you know how to quickly download and install the Tomcat. All right, so download Maven first. There are various ways in which you can kind of download this Maven. There is zip files, binary zip files, and archive files. So what I've done is I've just already downloaded Maven, and if you see, I've unzipped it here. So this is the folder with which I've unzipped my Maven. So as you know, Maven again is a one open source build tool. So you'll have to set in a few configurations and set up the path. So mvn -- version, if I specify this, after I set in my path, Maven should work. And if at all I echo m2 home, which is nothing but the environment variable specific to Maven home, it is already set here. So once you unzip Maven, just set this m2 home variable to the directory where you unzipped your Maven. Also, just set the path to this particular directory /bin, because that is where your Maven executables are all found. All right, so that's with Maven. And since I've set the path and the environment variable Maven is running perfectly fine on my system, I've just verified it. Okay, next one is the Tomcat server. Download Apache Tomcat server 8.5 is what I have on my system. So I'm just going to show you where to download this from. This is where you download Tomcat server, and I already have the server downloaded. Again, this doesn't need any installation. I just unzip it here, and it kind of has a bin and configuration. I've made some subtle changes in the configuration. First and foremost, Tomcat server also by default runs on port 8080. Since we already have our Jenkins server running on port 8080, we cannot let Tomcat run on the same port. There will be a port clash. So what I've done, I've configured Tomcat to use a different port. So if I go to this configuration file here, there is a server.xml. Let me open this up here. All right. Okay. So this is the port. By default, it will be 8080. I've just modified it to 8081. So I've changed the port on which my Tomcat server would run. All right. So that's one change. Second change, when Jenkins kind of tries to get into my Tomcat and deploy something for someone, he would need some authentications so that he'll be allowed deployment by Tomcat. So for that, I need to create a user on Tomcat and provide this user credentials to my Jenkins instance. So I would go to Tomcat users.xml file here. I've already created a username called deployer and the password is deployer, and I've added a role called manager-script. Manager-script will allow programmatic access to the Tomcat server. So this is the role that is there. So using this credentials, I will enable or I'll empower Jenkins to get into my Tomcat server and deploy my application. All right, only these two things that is required. Let me just start my Tomcat server first. So I get into my bin folder, I open a command prompt here, and there's a startup.bat. It's pretty fast. It just takes a few seconds. Yes, there you go. Tomcat server is up and running. Now this is running on port 8081. So let me just check if that looks good. So localhost 8081. Okay, my Tomcat server is up and running. That sounds good. The user is already configured on this. That's also fine. So what I'll do as a part of my first job, Maven is also installed on my system. So I'm good to use Maven as a part of my Jenkins. So I will put up a simple job now. I will say job MVN web app. I'll call this freestyle job. That's good. Okay, so this will be a Git repository. What is the URL of my Git repository? Is this guy, HTTPS URL. Okay, that's this URL. I will use the credentials. The old credentials that I set up will work well because it's the same Git user that I'm kind of connecting into. All right, so now the change happens here where after I get this, since I said this is a simple Maven repository, I will have some Maven targets to run. So the simple target first is, let me run Maven package. This creates a war file. Okay, so MVN package is the target. Package is the target. So whenever I run this package, it kind of creates it, it builds it, it tests it, and then creates a package. So this is all that is required. Maybe let me try to save this, and let me first run this and see if it connects well, if there's any problem with my war file, or the war file gets created properly. Okay, wonderful. So it built a war file, and if you see, it all shows you what is the location where this war file was generated. So this will be the workspace. If you see this war file was successfully built. Now I need to grab this particular war file, and then I would need to deploy it into Tomcat server. Again, I would need a small plugin to do this because I need to connect Tomcat with my Jenkins server. Let me go ahead and install the plugin for the container deployment. So I will go to manage plugins, available, type in container, container, deploy to container. Okay, so this would be the plugin that I would need. I would install it without a restart. Right, seems to be very fast. Nope, sorry, it's still installing. Okay, it installed the plugin. So if at all you see this, if you go to my workspace, okay, in the target folder, I would see this web application war file that is already built. So I would need to configure this plugin to pull up this war file and deploy it onto the Tomcat server. For deploying onto the Tomcat server, I will use the credentials of the user that I've created. Okay, so let me go to configure this particular project again. And okay, all this is good. So the package is good. I'm going to just create a package. That's all fine. Now add a post build step. So after the war file is built as a part of this package directive, let me use this deployment to container. Now this will show up after you install the plugin. So deploy this one to the container. Now what is that you're supposed to specify? You're supposed to specify what is the location. Okay, so this is a global configuration that is there that will allow you to, from the root folder, it will pick up the war file that is there. So *****war, that's good for me. Okay, what is the context path? Context path is nothing but just the name of an application that, under which it will get deployed into the Tomcat server. I will just say MVN Web App. That's the name of my thing. Now I need to specify what kind of a container that I'm talking about. All right, so the deployment would be for this Tomcat 8.5 is what I need. Okay, because the server that we have is a Tomcat 8.5 server that I have. So this would be the URL. So the credentials, yes, I need to add a credential for this particular server. So if you remember, I had created a credential for my web application. So let me just find that. My Tomcat server, yes, configuration of this. Okay, so deployer and deployer. Username is deployer, password is deployer. Okay, so let me use that credential. I would say add a new credential, Jenkins credential. The username is deployer and the password is deployer. So I would use this deployer credentials for that. And what is the URL of my Tomcat instance? So this is the URL of my Tomcat instance. So take the WAR file that is found in this particular folder, and then context path is mn web app. Use the deployer deployment credentials and get into this localhost which is there 8081. This is the Tomcat server that is running on my system, and then go ahead and deploy it. Okay, so that is all that is required. So I would say just save this and let me run it now. Okay, it successfully built the WAR file. It is trying to deploy it, and looks like the deployment went ahead perfectly well. So the context path was mvn web app. So if I type in this, right, if at all I go ahead into my Tomcat server, there would be a web apps folder. You would see the the date timestamp. So this is the file that got recently copied, and this is the Explorer version of our application. So the application was built, the source code of this application was pulled from the GitHub server. It was built locally on the Jenkins instance, and then it was pushed into a Tomcat server which is running on a different port, which is 8081. Now for this demo, I'm running everything locally on my system, but assuming that this particular Tomcat instance was running on some other server with some other different IP address, all that you got to go and change is the URL of the server. So this would be the server in case you already have that, if you have a Tomcat server which is running on some other machine, that's all fine. With a different IP, that's all good enough. The whole bundle or the WAR file that was built as a part of this Jenkins job gets transferred onto the other server and gets deployed. That's the beauty of Jenkins and automatic deployments, or rather deployments using Jenkins and Maven. Distributed build or master slave configuration in Jenkins. As you would have seen, we just have one instance of Jenkins server up and running all the time. And also I told you that whenever any job that kind of, gets started on the Jenkins server, it is little heavy on in terms of disk space and the CPU utilization. So which kind of, if at all you're in an organization wherein you're heavily reliant on the Jenkins server, you don't want your Jenkins server to go down. So that's wherein you kind of start distributing the load that is there on the Jenkins server. So you primarily have a server, which is just a placeholder or like a master who will take in all the kind of jobs. And what he will do is based upon trigger that has happened to the job or whichever job needs to be built, if at all, he can delegate these jobs onto some other machines or some other slaves. That's a wonderful thing to have. Okay, use case 1. Use case 2, assuming that, if you have a Jenkins server that is running on a Windows box or on a Linux one, and if at all you have a need where you need to build based upon operating systems, you have multiple build configurations to support. Maybe you need to build a Windows, Windows based .NET kind of a projects where you would need a Windows machine to build this particular project. You also have a requirement where you want to build Linux based systems. You also have a Mac, you support some sort of an apps or something that is built on Mac OS. You would need to build, Mac based system as well. So how are you going to support all these needs? So that's wherein a beautiful concept of master slave or primary and delegations or agent and master comes into play. So typically you would have one Jenkins server who will just configure with all the proper authorizations, users, configurations, and everything is set up on this Jenkins server. His job is just delegations. He will listen to some sort of triggers, or based upon the job that is coming in, he will, if there is a nice way of delegating these jobs to somebody else and taking back the results, he can control a lot of other systems. And these systems may not have a complete, or there's no need to put in a complete Jenkins installation. All that you got to do is have a very, very simple runner or a slave that is a simple jar file that is run as a low priority thread or a process within these systems. So with that, you can have a wonderful distributed build server that can be set up. And in case one of the servers goes down, your master would know that what went down and kind of delegate the task to somebody else. So this is the kind of distributed build or the master slave configuration. So what I'll do in this exercise or in this demo is I will set up a simple slave. But since I don't have too many machines to kind of play around, what I'll do is I will set up a slave in one other folder within my hard drive. So I've got the C drive and D drive. My Jenkins is on my C drive. So what I would do is I would just use my E drive and set up a very simple slave out there. I'll just show you how to provision a slave and how to connect to a slave and how to delegate a job to that slave. Let me go back to my Jenkins master and configure him to talk to an agent. So there are various ways in which this client and server talk to each other. What I'm going to choose is something called as JNLP. Java Network Launch Protocol. So using this, I would ensure that the client and server talk to each other. So for that, I need to ensure that I kind of enable this JNLP port. So let me try to find out where is that. Let me try this. Okay, yes. Agents, and by default, this JNLP agents thing would be disabled. So if you see here, there's a small help on this. So I'm going to use this JNLP, which is nothing but Java Network Launch Protocol. And I'll configure the master and server to talk to each other using JNLP. So for that, I need to enable this guy. So I enable this guy instead of making by default, the configuration was disabled. So I make him random. I make him, enabled, and I say save this configuration. All right. So now I configured or I made a setting for the master so that the JNLP port is kind of opened up. So let me go ahead and, create an agent. So I'll go to manage nodes. So if you see here, there's only one master here. So let me provision a new node here. So this is the way, in which you bring up a new node. You have to configure it on the server. Jenkins would put in some sort of security around this particular agent and let you know how to launch this particular agent so that he can connect to your Jenkins master. So I would say new node. I would give a name for my node. I would say Windows node because both of these are Windows only. So that's fine. I'll just give an identifier saying that Windows node. I would say this is a permanent agent. I would say, okay. So if you see the name, let me just copy this name here with the description. Number of executors, since it's a slave node and both of these are running on my system, I will keep the number of executors as 1. That's fine. Remote root directory. Now this is where, let me just clarify this, since I have both my master is running on my C drive program files 86, or hang on, not 86, C:\program files. It is indeed 86. All right, Jenkins. So this is where my master is running. So I don't want the C drive. What I'll do is I'll use something called as A drive. I have another drive in my system, but please visualize this like, you're running this on a separate system altogether. So I create a folder here called Jenkins node, and this is where I'm going to place I'm going to provision my slave, and I'm going to run him from here. So this is the directory in which I'm going to provision my slave node. So I'm going to copy this here, and that is the remote root directory of your particular agent or slave. So I just copy it here. The label, probably this is fine for me. And usage, how do you want to use this guy? So I don't want him to run all kinds of jobs. I will only build jobs with label expressions that match this particular node. And so this is the label of this node. So in order for somebody to kind of delegate any task to them, they will have to specify this particular label. So imagine this way, if I have a bunch of Windows mesh system, I name it as Windows star. Anything that starts from Windows, I can give a regular expression and say that anything that matches Windows, run this particular task there. If I have some Mac machines, I name all these Mac agents as Mac star or something like that. And I can delegate all tasks, saying that start with whatever starts with Mac in this node, run the Mac jobs there. So you identify a node using the label and then delegate the task there. All right. So launch method, we will use Java Web Start because we're going to use JNLP protocol. Okay, that sounds good. Directory, I think nothing else is required. Availability, yes, we'll keep this agent, yep, online as much as possible. That sounds good. All right, let me save this. All right, I'm just provisioning this particular node now. So if I click on this node, I get a bunch of commands. along with an agent.jar. So this is the agent.jar that has to be taken down to the other machine or the slave node, and from there I need to run this along with a small security credential. So let me copy this whole text here in my notepad. Notepad plus plus is good for me. Okay, I copy this whole path there. I also want to download this agent.jar. I would say yes. And this agent.jar is the one that is configured by our server. So all the details that is required for launching this agent.jar is found in this. For launching this agent is found in this agent.jar. So typically I need to take this jar file onto the other system and then kind of run it from there. So I have this agent.jar. I copy this, or rather I cut this. I come back to my folder, my Jenkins node. I paste it here. Okay. So now with this provision agent.jar, and I need to use this whole command, Control A, Control C, and then launch this particular agent. So let me bring up a command prompt right here and then launch it. So I'm saying in the same folder where there is agent.jar, I'm going to launch this particular agent, java-jar, agent.jar, JNLP. This is the URL of my server. In case the server and client are on different locations or different IPs, let us specify the IP address. All this anyway would show up. And then the secret and the root folder of your Jenkins or the slave node. Okay. So something ran, and then it says it's connected very well. It seems to have connected very well. So let me come back to my Jenkins instance and see, if at all you see earlier, this was not connected. Now let me refresh this guy. Okay, now these two guys are connected. Provision a Jenkins node, and then I copied all the credentials of the slave.jar along with the launch code, and then took it to the other system and kind of ran it from there. Since I don't have another system, I've just got a separate directory in another folder, another drive, and I'm launching the agent from here. As long as this particular agent is up and running, or this command prompt is up and running, the agent would be connected. So once I close this, the connection goes down. All right, so successfully we've launched this particular agent. Now this would be the home directory of this Jenkins node or the Jenkins slave. So any task that I'm going to delegate to this particular slave would all be run here. It will create a workspace right here. All right, so good. So let me just come back and let me kind of put up a new task here. I will say that, delegate job is good. I say freestyle project. I'm going to create a very, very simple job here. I don't want it to connect to Git or anything like that. Let me just create a very, very simple echo delegated to the slave, delegated to, I don't like the word slave, delegated to agent. Put this way. All right. So delegated to agent sounds good. Now, how am I going to ensure that this particular job runs on the agent or on the slave that I've configured? Right? Do you see this? If at all you remember how we provisioned our particular slave, we gave a label, right? So now I'm going to put in a job that will only match this particular label. So I'm going to say that whatever matches this, Windows label, run this job on that particular node. So we have only one node that's matching this, Windows node. So this job will be delegated out there. So I save this and let me build this. This is again a very, very simple job. There's nothing in this. I just want to demonstrate how to kind of delegate it to an agent. So if you see this, it ran successfully. And where is the workspace? The workspace is right inside our Jenkins node. It created a new workspace, delegated job, it put in here. So my old or my primary master job is in SQL program files under Jenkins. And this is the slave job that was successfully run. Very, very simple, but very, very powerful concept of master slave configuration or distributed build in Jenkins. Okay, approaching the final section where we've done all this hard work in bringing up our Jenkins server, configuring it, putting up some jobs on it, creating users and all this stuff. Now, we don't want this configuration to kind of go away. we want a very nice way of ensuring that we back up all this configuration. And in case there is any failure, hardware crash or a machine crash, we will want to kind of restore from the existing configuration that we kind of backed up. So one quick way to do that would be, or one dirty way to do that would be just, take a complete backup of our C:" program files Jenkins directory, because that's where our whole Jenkins configuration is present. But we don't want to do that. Let's use some plugins for taking up a backup. So let me go to Manage Jenkins and click on Available. And let me search for some backup. There are a bunch of backup plugins. So I would recommend one of these plugins that I specifically use. So this is the backup plugin. So let me go ahead and install this plugin. All right, so we went ahead and installed this plugin. So let me come back to my manage plugins. So this plugin is there. So hang on, backup manager. So you will see this option once you install this plugin. So first time I can do a setup. I would say backup this particular. I'll give a folder. This folder is pertaining to the folder where I want Jenkins to back up some data, and I would say the format should be zip format is good enough. Let me give a name or a template or a file name for my backup. This is good. I want it in verbose mode. I don't want to shut down my Jenkins, or should I shut it down? No. Okay. One thing that you got to remember is that whenever a backup happens, if there are too many jobs that is running on the server, it can kind of slow down your Jenkins instance, because it's in the process of copying few of those things, and if the files are being changed at that moment, it's a little bit problematic for Jenkins. So typically you back up your servers only when there is very less load, or typically try to bring it to a shutdown kind of a state and then take a backup. All right, so I'm going to back up all these things. I don't want to exclude anything else. I want the history. I want the Maven artifacts. Possibly I don't want this guy. I would just say save, and then I would say back him up. So this would run a bunch of steps, and all the files that is required as a part of this is pretty fast. But then if at all you have too many things up on your server, for now we didn't have too many things up on our server, but in case you had too many things to kind of back up, this may take a while. So let me just pause this recording and get back to you once the backup is complete. So there you go. The backup was successful. Created a backup of all the workspace, the configurations, the users, and all that. So all this is kind of hidden down in this particular zip file. So at any instance, if at all I kind of crash my system for some instance, or it's a hard disk failure, and I bring up a new instance of Jenkins, I can kind of use the backup plugin for restoring this particular configurations. So how do I do that? I just come back to my manage Jenkins, come back to backup manager, and I will say restore Hudson or Jenkins configuration.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GitTech postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of prime DevOps professionals. Click the link in the description box to unveil the wonders of this course.
First, we'll see how to install Java Development Kit. JDK is one of the prerequisites you need in order to run Jenkins. Then, we'll set up the JDK path in the environment variable. After that, we'll see how to download and install Jenkins on Windows. Once that's complete, we'll run Jenkins on localhost 8080, which is the default port for running Jenkins. Then we'll have a glance at the Jenkins server interface and look at some of the features present on Jenkins. Finally, we'll learn how to build and run a job in Jenkins. To download and install JDK, simply type install JDK on Google and click on the first link, which is Java SE Development Kit 8. As you can see, we get a list of downloads for JDK. Since I'm on a Windows 64-bit system, I have already installed JDK version for Windows 64. Before you install JDK, you also need to accept the license agreement. Let me show you where my JDK has been installed. First, I go to my C drive, Program Files. Under the Java folder, you find two more folders, that's JDK and JRE. Now, let's set up the path in the environment variable. Go to System Properties. Under the Advanced tab, select Environment Variables. Under System Variables, there are two more variables called Java Home and JRE Home. Java Home contains the path for JDK. I'll show you where it is. Go to JDK folder, copy the path and paste it in the value section. JRE Home contains the path for JRE. Similarly, go to the JRE folder, copy the path and paste it in the corresponding value. One more thing you need to do is set up the bin folder location for JDK in path variables. Let's see where the bin folder location is. Here it is. After setting up the location, click OK to finish the setup. Now, shall we check if Java has been successfully installed? For that, go to the command prompt and type Java-version. You can see our Java is successfully installed and it's up and running. The version we've installed is shown here. Now, let's download Jenkins on Windows. Simply type download Jenkins on Google and click on the first link. Here, we can see that Jenkins provides two types of releases, long-term support release and weekly release. As I'm interested in a more stable release, so I will go for LTS. Now, when I scroll down, I'll get an option for Windows. Once I select that, a stable installer starts to download. You can see it says, "Thank you for downloading Windows Stable Installer." So now our Jenkins has started downloading. This might take a few seconds. Till then, maybe you can catch up if you're left behind. Okay, so the download is complete. Now, let's go ahead and unzip the downloaded Jenkins file. After the unzipping has been done, we'll start the installation. Click on this folder. Click Run. Next. This is the default path where Jenkins will be installed. We don't need to change it, so we can just go ahead with Next, Install. After this, your Jenkins installation is successfully completed. Select Finish. Yes, that's all. Now that installation is complete, let's go and explore Jenkins. Go to your web browser and search localhost:8080. You can see that it says Welcome to Jenkins. So I have already created a username and password for Jenkins. I'll enter my credentials. And that's all. This is how the Jenkins homepage and interface looks like. And that's all. Signing in. Yes, so that's the dashboard, and this is how the Jenkins homepage and interface looks like. So if you're installing Jenkins for the very first time, it will ask you to install some recommended plugins. I've already installed mine, so I don't need to install them once again. Now, there are a lot of things you can do in Jenkins. Let me run you through a few of them. There's some jobs that I've already created and run. This is new item. It allows you to create a new project. So you can create a freestyle project, a Maven project, a build pipeline, etc. Then, going back to the dashboard, there is build history. So this section shows you the status of your build. Here you can see what's the build name, the time since the build is running, and what's the status of your build. There is another very important section called Manage Jenkins. Here you can configure your system, you can configure global security, credentials, then there's some global tool configuration. You can also download and manage your plugins. Here you can see there are 4 tabs where you have some updates, you have some available plugins, You have the plugins that you've already installed. And then there is advanced plugin as well. Now let me show you how to create and run a job in Jenkins. So coming back to the dashboard, let me select new item. We can name our job here. Let me name the job as Jenkins Demo. I will create a freestyle project. So select that and click OK. This might take a few seconds. So when we have created that, here we have a number of options that we can go ahead with. You have your source code management, building triggers, building environment, and then of course some post-build actions. So that's about creating and running a job in Jenkins. Let's give some description to our job. So we have created the job. We give description something like, this is my first Jenkins job. So we will not use any source code management tool. In the build section, as you can see, there is an option to execute Windows batch command. Click on that, and here you can give your command. Let's use the echo command. I will write something like, hello, this is my first Jenkins demo. And then I'll also give the date and time parameters so that I can track on what date and time this job was built. That's it. So click apply and then save. Okay, so this job is created. Now let's build it. Go to build now. Once you click it, you can see a build history has been created. Click on that. In the console output, you can see the output of your very first Jenkins job. It says, hello, this is my first Jenkins demo. What you gave in the command box, you can see that. And you can also see the date and time when this job was created. So we've successfully created our
Hello everyone. Today we will be taking a look at Docker. It is one of the hottest technologies in the DevOps space right now. Okay, let's take a look at the agenda. We'll answer the question, what is Docker? We will discuss why we need Docker, Docker versus VMs. We'll look at Docker Hub. We'll go over the Docker basic commands. We'll discuss Docker images, and we'll see the Docker demo. So what is Docker? Docker is basically a container engine, and it allows you to run your applications inside containers. Now, until now, we've been running our applications in virtual machines. Every virtual machine used to be the base of our application, but now with the advent of Docker and containerization technologies, each application is run in a container-like logical space. So to define a container, it is a logical grouping of all the binaries and all the dependencies that each application requires, and then bundling it into a single whole and running it on top of a Docker engine. Docker is typically used to run applications, typically like microservers, which are single bundled applications. Now, they don't really depend on a lot of external factors. Now, the benefit of having applications in containers is that you don't really need to worry about the base infrastructure. You just need to make sure that you have the Docker engine running, and that will make sure that the container is running in the same way on any platform. Docker is open source, so you don't need to pay to use Docker, at least the open source version or the community edition. The enterprise version has been recently launched, and it has a few more features. But I have seen many projects implemented with the open source version, and it is more than enough for what you need to get your basic applications containerized. When we talk about Docker, it's kind of like a mini platform as a service. So in a normal platform as a service offering, what you get is just the actual thing that you need to run. So let's say you are using Elastic Beanstalk on Amazon Web Services. You get a Ruby platform on which you can run your application. Now with Docker, you get a real platform, but just the platform required to run your application. And that is more than enough to get yourself into production. Docker integrates easily with other tools, so it integrates with other ecosystem tools like Swarm, which is a cluster management system. It integrates with monitoring systems. You can monitor things on the user ports using Nagios or any other monitoring system you've been using within your existing infrastructure. You can monitor the base hosts in Docker, on which Docker actually runs using your normal monitoring tools. So why do we need it? What is the benefit of using Docker? We're really good on VMs and we've been running them for the last decade. So what's the real need to go to Docker? Well, the first thing is you get really efficient utilization of your resources. Now, let's say I've got 10 VMs and I'm running 10 applications on VMs, and things are good, but the only problem is VM number 4 is at 50% utilization. So I'm actually wasting half of capacity on VM number 5, and on VM number 6, say I'm just using 40% of the entire power I have. So in that case, a lot of the provisioned capacity goes to waste. Now, in order to use that space and capacity in a more efficient way, you need to have some sort of mechanism which abstracts the base hardware allocation and the application. Now, Docker forms the best combination for that. So it allows you to run your applications in containers, and at the same time, it allows you to optimize your resource utilization. So let's say you're on 10 VMs earlier and you were running 10 applications, and when you move to Docker, and you've Dockerized your applications, you can use those same 10 VMs and on top of those VMs run a cluster of Docker containers. And those 10 VMs now will be available as a whole to Docker Swarm or any other cluster management system. And you can run all your applications across those 10 containers. So in effect, those 10 VMs would be available as a whole for the containers to easily run anywhere. You can actually bump in more containers on the same number of VMs. So let's say you were on 50% utilization and you want to increase the utilization, and you can actually run more containers, so you could actually get up to 90% utilization of the same hardware. So with this, you easily get scalability, since you can scale up or scale down any cluster management system. So if you're running Docker Swarm, for example, you can scale up your containers to any number just by a single command. You get the portability of the cloud as well as Docker containers. Let's say you are on AWS Cloud and you want to move to Google Cloud. You can import your containers to Google Cloud just by running a Swarm cluster there and then porting the image, and that's it. You don't need to worry about any networks for anything else. You just run your application on top of Docker Swarm or Docker Engine. Now, with this portability, you get the advantage of having multiple environments, and with those multiple environments, you can have disaster recovery in place. Disaster recovery will give you a high availability and your business will never be down. That's one of the biggest advantages of Docker, and you can easily set up DR zones in your environment. Now, let's compare Docker with VMs. Docker's fast. You can run a Docker container like in 1/120th of a second, whereas a VM takes almost 3 minutes to boot up if it's a GUI VM. If it's a CLI VM, it takes almost 1.5 minutes to boot up. So Docker containers are lightweight since they follow the layer file system approach. Any Docker container, which is like a base image, would be around 120 to 150 megabytes. Now, if you look at a VM OVF file or a VMDK file from VMware, you'll find that it's almost 2 gigabytes for the CLI version, and for the GUI version, it's more than 4 gig. Docker containers are portable. You can easily port them by committing them to a Docker hub and then importing them elsewhere. VMs are not that portable. So let's say you've got a VM in a VMware sphere in your house, and you really have to import that entire image using a PIM drive or some sort of network share, and it takes like 4 or 5 hours to do the transfer. So the portability aspect for the VMs is less desirable. Let's talk about Docker Hub. Just like you have GitHub for code, there is Docker Hub for Docker containers. Now, Docker Hub is used to store Docker images and share them as well with the community. Docker Hub has both open source and pay repositories. So it's an open repository managed by Docker Inclusive. So they have it for the community. So you can get one private repository and unlimited public repositories for free. On the Docker Hub, you've got official images of almost every software on Earth, like Nginx, Apache 2, Enterprise Edition images. It's a hosted solution for private repos, so if you pay Docker Hub for private repositories, you can get a cloud-hosted solution there, so you don't need to manage a local repository in your infrastructure. There are some Docker basic commands, which we will take a look at in the demo. There is Docker PS that is used to show how many containers are running. Docker pull, which allows you to see and pull images from the Docker Hub. Docker run is used to run Docker containers. Docker images will show you the images you have in your local repository. Docker attach will attach to the shell of a running container. Docker stop will stop a running container and will start a stopped container. Let's take a look at the demo. So I've got a Linux machine here on Ubuntu 16.04 command line version, machine ready set up. It's running on a virtual box, and I'll be using the terminal on my MacBook to access the machine. We'll proceed with the installation of Docker on that machine first of all. Then we'll pull some images from the Docker Hub. We will also try to run some containers, and then we will look at the usage of some normal commands. Then we will try to make some changes in the image and commit to the local repository and push it to the Docker Hub. So that will be all for the demo. So this is my Ubuntu 16.04 image. So you see LSB_release-A. You see it's Ubuntu 16.04, codenamed Xenial, and it's the latest LTS release. We'll be using apt first of all to install a couple of dependencies which Docker has. So I'll say apt-get install apt-transport -https ca-certificates curl software -common -properties -y. The -y is used as a yes to automatically accept the agreement. Pretty much all of these are there by default in the installation of Ubuntu, so you don't really need to worry about those, but just as a security check, we did that. Now the next step, we are going to download the GPG key of Docker from the official repository, so they host it at download.docker.com. The reason we need to have that is that we want to make sure we don't get any spoofed packages. So we do a curl -f. So I'm doing it in the silent mode using these switches because I'm going to pass that the apt-key add command. It's hosted on https download.docker.com /linux/ubuntu/gpg, and I'll pipe it to the apt key command. So I'll say apt-key add -. So what this will do is get the GPG key from the Docker repository and add it to the local apt cache. Okay, have pressed it. It should say okay. So this means the key is added now. Now I want to add the repository for the Docker installation. There's a remote, but my local installation doesn't know there's a remote repository. So I'll be using the add-apt-repository command to do that. So I'll say add-apt-repository to do that. And then I'll say deb arch equals AMD64 https download.docker.com/linux/ubuntu. Then $LSB release-cs and then stable. This command will add the repository to my etc apt sources.list. So if I open the file and etc apt, if I open the sources.list file, you'll see so I've added the AMD64, which is the 64-bit version, since my machine is 64-bit. So if I do a uname-a, it says x86-64. So I want a 64-bit machine, and that's why I've added the 64-bit repository of Docker. Next step I want to do is update my apt caches because I want to get the latest package indexes. So I'll say apt-get update-y. After updating the local cache, I need to restore the Docker Community Edition, so I'll use the apt command again. apt-get install docker-c-y. This will install the Docker Community Edition on my local machine. It will fetch all the repository packages. Now Docker is installed on this machine. Let me check and see what version of Docker I have. So I'll do docker -- version. So you see I have Docker version 17.03.1 Community Edition, build C6D412E. The next thing I need to do is I need to go and run a Hello World container because that's like a health check. So I'll say docker run hello-world. We'll do a couple of health checks in the background. Now you see it says unable to find the image locally, pulling file system layer from Docker Hub. And it gives me this nice clean output that says hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. So basically it did a whole lot of health checks in the back end to contact Docker daemon. Then the Docker Hub was contacted. The image was downloaded. So everything seems to be fine now. Now I'm going to download a couple of images there. So the first thing you do is you search for those images. So I'll search for the Ubuntu image. So I'll say docker search Ubuntu. So you see a lot of images are out there, of which only the first one is an official one. So you see this is official, okay. So I'll download all 4 major versions. So I'll say docker pull Ubuntu. This will pull the Docker Ubuntu image. So you see it's pulling down the layers. I'll pull the Fedora image. These are the 4 most popular versions. So I'll say docker pull Fedora. Docker pull Debian. And then docker pull CentOS. That's the 4th one. So all of these images have been pulled from the Docker Hub. Now let me give you a quick look at the Docker Hub. So if you go to hub.docker.com, you go to Explore, you'll see almost every major software is in there. Nginx, Redis, BusyBox, Ubuntu, Alpine, Registry, MySQL, Mongo, Elasticsearch, Logstash, Node, Hello World, Swarm, HTTPD, everything. So I've pulled 4 images here. So if I do a Docker images, it will list out all the. So in addition to the Hello World, I've got 4 more images, which I've pulled down. So you see, it shows me the tags, which is the latest. There's an image which corresponds to a unique image ID on the Docker Hub. It shows me the created date, 6 days ago, 12 days ago, whatever date image was created, and the size. So you see the size is considerably small. 119 meg, 100 meg. The Hello World is just 1 KB. CentOS is just 193 MB. Fedora is 231 MB. The next thing we're going to do is I want to run the containers. So let me run the Ubuntu container. So I'll say docker run -ti Ubuntu. So this will run the Docker Ubuntu image in interactive mode. So I'll be able to switch to this container. So you see the prompt will change now to root at 480. So I'm inside the container now. So I'll do a free -m, and the container has the same amount of memory as the base machine. So let me go to the base machine. So I'll open up a session to the base machine here. Okay, now in this image, root at this is the container. If I do a free hyphen here in the base machine, you see almost the same amount of RAM is free. So this means Docker containers use the same RAM that is available on the base machine. Now I'm going to do a docker ps-a here. It shows me that there are 2 containers running. One has the Hello World container, which I ran 4 minutes ago, and was used just as a health check. And then you see there's a Ubuntu container running, and its name has been given randomly by the Dr. daemon as Happy Pasteur. So this container is running in the background, and it's up in this VM. Now we're going to stop this container using the docker stop command. So I'll say docker stop and then the container ID. This will stop the containers. So if I do a docker ps-a, you see it shows that it has exited. But I can restart this container by doing a docker start. And then I can attach the command line of that container using the docker attach command. You see I've restarted it and I was able to attach it. Now let me exit from this container and let me remove all the containers. So the command to remove all the containers is docker rm and then the container ID. Now you can see I have one container remaining. I've removed all of them at once by just doing the docker rm. And then in brackets I'll be placing docker ps-aq, which will get all the container IDs. Now if you run it as a standalone, you'll see docker ps-aq gives you all the container IDs. Now let me run one container in the background. Once I do docker run -ti-d Ubuntu. So you see it's running in the background. So if I do a docker ps-a, there's a container, agitated Euler, running in the background. I can attach to that container by using the docker attach command. Docker attach and then the container ID. Now let me update this container and make some changes so I can commit to the Docker Hub. So I'll say apt-get update -y. This will update my Docker container to have the latest package indexes from the Ubuntu repositories. Now I'll do an apt-get, so I'll install the Apache web server on this. So I'll say apt-get install Apache 2-y. This will install the Apache 2 web server actually on this container. I'm doing this because I want to save the state of this container on the Docker Hub. So this is downloading the Apache 2 from the remote repositories. Then I'll start the Apache service. So I'll say service Apache 2 start. So if I do a service Apache 2 status, you will see it is running. Now the next thing I want to do here is exit from this container and then try to commit it. So I'll use the docker commit command and to save the state of this container. So you see docker ps-a. This is the container for which I'll save the state for. So I'll say docker commit -m. This is the commit message. So I'll say installing Apache web server. And then I'll say author name Amir and then container ID and the name, which I won't put. Now, there's one thing which we need to take care of here. You have to make sure that your image has the following formatting. It should be your username on the Docker Hub, Amir Ahmad 170, / whatever your container has. So I'll say Ubuntu-Apache 2. Now when I commit this container, it comes into the local images list. So if I do a Docker images, you can see it's here. Now I've got to push this to the Docker Hub, so I'll say Docker login -u. Log into the Docker Hub from the command line using my username. So I'll say Docker-u Amir Ahmed 170. I'll give it my password. So I'm logged into the Docker Hub now. It says Docker login succeeded. Now I can commit that image, so I'll say Docker push. I've already committed it, so I'll push it now. So I'll say Docker push and then the image ID. So if I just do a push here, it's doing this. But in the meantime, if I go to my dashboard, I already have two things here. And in a moment, you'll see one more here. So it's pushing all the layers of the image. And then once you push this, I can just remove my local thing. So when I refresh this here, you'll see a third image coming up here. Actually, it has over it in the one I already had. So let me just delete and repush this. I'm going to clean up my Docker Hub here. Delete. I'll delete this one as well. Delete. Delete. Okay. Now if I push again, you'll see it will create a new image here in my Docker Hub. We'll take some time to do that, but that would be a confirmation that the image has been pushed from my Docker machine here. So it's pushing 137 MB of the image layer, the top layer. So you see this is pushed. So now the basic idea behind this pushing was I really wanted to keep this saved in the remote Docker hub. So I'm going to remove all my local images. So I'll say Docker images. Okay, I'll remove all of them. So I'll say Docker. First, I'll clean up my container. So I'll say Docker RM. So there's no container running, so I'll remove all the images locally. So I'll say Docker images, and then I'll do a Docker RMI-F. So I'm removing it forcefully. But I'll do the single command remove, so I'll say Docker images -AQ. This is a single command remove. It basically gets all the image IDs in this command, so let me show you this. Right now there is no image, but it will put all those image IDs here and forcefully remove all those images. So if I do a Docker images, no Docker images there. If I do a Docker PS-A, no container is there. Now let me run the container from here. So I'll pull the image first using this command. So the beauty of Docker Hub is that it gives you a command for pulling the container. So I'll do Docker pull Amir Ahmed 172/Ubuntu -Apache 2. So it statically goes to the Docker Hub. It's pulling the layers from there.
Desktop for Windows, so you can go for the stable or you can go for the edge, right? So you also have the comparison that what is the difference between these two versions, right? So the particular edge version is something which is getting releases every month, and the stable version is getting the releases every quarter. So they are not doing much of the changes to the stable version as compared to the edge there. So you just have to double click on the installer, and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more, and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there. Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory, to the downloads, and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there. So it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop. So you can say okay. I'm going to click on OK. So it will unpack the files, all the files which is required for Docker to successfully install, that is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the execution of the installer to be completed, and once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line, and any docker command if you can run, so that will give you the response whether the docker is installed or not. So you can see here that docker is something which is installed, so you can run like docker version. You will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the docker server will also be started, and then this particular error message will go off. Right now the docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a docker installation, and we can go on that part.
So before we begin, let me give you an intro to Docker. So what is Docker? Docker is a tool which is used to automate the deployment of applications in lightweight containers. So when I say containers, I mean a software package that consists of all the dependencies required to run the particular application. And when you deploy containers, you're basically providing the capability for the application to run in any kind of environment. So Dockers have multiple features, some of which are that multiple containers can run on the same hardware. It has very high productivity when compared to virtual machines. It maintains isolated applications and has a very quick and easy configuration process. So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I'll just open the terminal. So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so. Sudo apt-get remove docker docker engine docker.io. Enter your password and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, so before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt-get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt get install Docker. Now as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. Just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install Docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install Docker. So snap install Docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install docker. Enter your password. So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version. And as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we pull an image from the Docker hub. So docker run hello world. Now hello world is a Docker image which is present on the Docker hub. Docker hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. The command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. Sudo docker ps -a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed, and all of them are in exited state. So I did this demo previously too, which is why the 2 hello worlds which is created 2 minutes ago is also displayed here. And the first hello world which has been created a minute ago is the one we just did for this demo. Now as you have probably noticed that all the hello world images over here, all these containers are in the exited state. So when you give the option for docker ps -a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker ps. And as you can see, no container is visible here because none of them are in running state. And with that, we come to an end of our Docker installation.
So we're going to go through a bunch of things today around Kubernetes. We're going to cover what Kubernetes is and why you should be using it, along with the features of Kubernetes. We're also going to take a little bit of a look at Kubernetes versus Docker Swarm, as the two technologies do tend to get referred to quite frequently. And then we're going to do a deep dive into the actual Kubernetes architecture itself and how Kubernetes runs and operates within your network. And then finally, we're going to look at some Kubernetes use cases of how you can actually apply best learnings that other companies have used with Kubernetes. We'll finish everything off with a demo where we actually step through and use some of the actual codes that you can actually use to run from your terminal window to actually activate Kubernetes itself. So with that said, let's jump in. So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of network networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made it open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done, Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need, how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products products are actually pretty good, and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong clusters management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. The actual control of data within a cluster is very, very flexible within Kubernetes. You can have local storage, such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual machine. But Kubernetes itself will actually manage the containers that you have within your nodes. And so you have a collection of containers working together, and then you pull those together into what's called a pod. And what's great is Kubernetes will actually manage the health of that pod. So if a container or a pod fails, Kubernetes will automatically deploy out a replica so your entire environment can stay running and being efficient. And so the pods themselves will actually be managed by Kubernetes. You really want to let Kubernetes do this because it's allowing you to step away from the manual management of pods. Your environment is just going to be healthier relying on Kubernetes to do the actual management of all the pods you have out there. So you are able to allow access to, from services outside of your Kubernetes, and this is done through a process called ingress. And going back earlier, we talked about how security is a key part of all all the work that goes into Kubernetes. And this is a great example of where you can use an external service but still have that layer of security that is vital for your solution, because to be able to provide the ingress connection, Kubernetes requires an SSL connection, which automatically allows for a secure data transfer. Absolutely fantastic. So here we have an overview of the actual architecture. On the right hand side we have our nodes and the pods within our nodes, and within those pods are the containers. On the left hand side we have the master architecture, and the master architecture is the actual brains behind the work that you're doing. It's actually managing the schedules, the controllers for all of the nodes. And then at the bottom left hand side we have commands which are written on a local workstation, and those commands are pushed up to the master. So let's kind of dig a little bit further into the architecture of the master. So the master itself is comprised of a number of key components. Again, this is the tool that's going to manage your entire Kubernetes infrastructure. The key components that you have are the etcd, control manager, scheduler, API server, and the key four components are etcd, or the cluster store, the controller manager, the scheduler, and the API server. The cluster store is the tool where all the details of the work that you're doing is stored. It's going to manage the rules, it's going to manage all the instructions, and this is where you're going to post that information. The controller is actually going to then perform the tasks that are stored in the cluster store. And as you'd expect, the scheduler is the tool that actually controls when instructions and tasks are pushed out to all the pods and nodes within your network. And then finally, you have an API server which allows you to be able to control all the operations. The actual operations themselves are all instructions written as REST instructions, which allows you to take advantage of the security that has been built into REST. And so you end up with a worker-slave architecture, and slaves are all the different nodes and pods within your network. And so a pod itself will have one or more multiple containers, and then each container and then each pod will have a Docker container, a kubelet, and a Kubernetes proxy. And these are tools to allow you to communicate back up to the master layer. So the Docker is the actual container itself, and this is going to actually run your application. And the instructions here are to pull down the correct container from the Docker images that you have within your library. The kubelet is going to manage your containers, and your container instructions that will be deployed to the kubelet are going to be written in either YAML or JSON format. YAML is just great. If you haven't had a chance to start working with YAML, I certainly encourage you to do so. It's very easy to pick up. If you know any XML, you'll pick up YAML very quickly. And finally, the Kubernetes proxy is the tool that interacts with the master environment within the Kubernetes network and allows all the instructions that are pushed to the kubelet and to Docker to be able to perform effectively. So let's have a look at some of the companies using Kubernetes. There are a lot. And if you're doing any work today in the cloud, or even if you're just starting off and doing some simple work in the cloud, there's a really good chance that you are using Kubernetes. But some of the companies that you would probably not surprised are using Kubernetes are Spotify, SAP, eBay, and of course some of the big companies out there, Google with their entire network of solutions, and Microsoft with Office and their tools. So let's take a step into now let's have a look at a Kubernetes use case. And in this example, we're going to look at the New York Times and how they use Kubernetes to solve a problem that their IT department was struggling with. So when New York Times started working out of their data centers, their actual deployments were small and the applications were managed across VMs. But the problem is that as New York Times became more of a digital company, they started building more digital solutions. And at some point, they realized that what they needed to do was to embrace the cloud and move all their solutions to the cloud. However, their first step of using the cloud, and this is, I think, typical for a lot of companies, is that they treated the cloud-hosted provider in the same way as they would with a data center. And at some point, they realized they had to take a change. And this is where the development team came in and they said, look, how about we stop thinking of our solutions as a data center, even though they're being run in Amazon, and start thinking of them as cloud-first solutions. And so what they proposed and what they ended up doing was using Google Cloud Platform with Kubernetes as a service to provide greater efficiency. And so by using Kubernetes, they had the following advantages. They're able to deliver solutions at a much faster speed, and in the world of digital content, speed is everything. They were able to reduce the time for deployment from minutes to seconds, and by doing this, they were able to increase the amount of time, uptime for the actual infrastructure. Updates began to be deployed independently and when required, so you didn't have to schedule an event when you do the deployment. It just happened. And there was a more unified approach to deployment from the engineering staff, which just made the whole solution more portable. So the fundamental end line for the New York Times is that by leveraging Kubernetes, they were able to automatically manage their deployments and scheduling of solutions instead of having to do solutions through a more traditional ticket-based system. It just really speed up the efficiency of the New York Times website. So let's finally kind of look into some of the important terminologies before we take our time to do a demo. So we have 6 terms that we're going to look through, and we'll let you read through these, but we have a cluster, which is a set of machines, physical or vertical, in which applications are managed and run. We have a node, that are the worker machines that run containerized applications and other workloads. There is the pod, which is within a node and is a group of containers that are deployed together on the same host. We have replication controllers, and a replication controller is used to define a pod's lifecycle rather than to create the pods directly. We have a selector, which is an expression matched label to filter specific resources. Labels are key value pairs that are attached to objects such as pods. The key value pair or the label can be filter, organize, and perform operations on resources. Replication sets define how many replicas of each pod will be running and managed when you want to either replace a pod when it dies. Annotation is a label with much larger data capacity. A name is a resource as it is identified. Volume is the directory in which data is accessible to a container. Namespaces provide additional qualification to a resource's name. And then finally, service is an abstraction of a top tier pods which provide a single IP address and DNS name by which the pods can be accessed. So at this time, what we want to do is take you through Kubernetes demo, actually runs through some of these basic controls. So we're going to take you through a video of how to actually install Kubernetes and to use some of the basic instructions. So Kubernetes is the most widely used platform for container management. The first step is to actually install the necessary dependencies. So let's see if there's any updates first. So to check if there's any updates, we're going to use the command sudo apt-get update. We're going to enter in our password, and this looks like it's going to take a few minutes because we've got a few updates that need to be running. All right, we're done. All right, next we're going to write sudo apt-get install -y apt-transport-https, and this will install all of the dependencies we need to actually start installing the solutions needed for Kubernetes. All right, that was quick. Now we're going to put in the Docker dependency, and the way we do that is write the command sudo apt install docker.io. Got a typo, correct that quickly, and put in y, so for yes, and we continue. And it's going to take a while because we're going to download and install Docker off the internet, and it's quite a large installation. Now would be a good time to go get a cup of coffee because it'll take us about a minute to get this all done. Once we actually have Docker installed, we'll actually go ahead and we'll start Docker and enable Docker using our sudo commands. All right, so that's all done. So let's start to enable Docker. We're going to use sudo systemctl start Docker and sudo systemctl enable Docker. This will be quite quick. So the next step is to install all the components for Kubernetes, and we're going to install the curl command and then kubelet, kubec, and then kubeadm. We're going to install all the necessary tools. We're going to do the curl command, kubelet, kubec-c2, and kubeadm. And so let's go ahead and put in the sudo apt-get install curl. We're going to get a prompt. We can say yes for that. And then after this, we'll go ahead and install Kubernetes. So the first, what we're going to do is we're going to actually put in the Kubernetes key. So that's going to be sudo curl -s, and then we have a long URL, which is https packages.cloudgoogle.com apt doc apt-key.gpg sudo apt-key. There we go. Correct my typo there. Okay, now we have to go ahead and change permissions of a folder. So we do that with sudo chmod 777 /etc /apt/sources.list.d. All right, we're good. Okay, now you want to go ahead and open up your text editor, and we're going to make an actual edit, and we're going to create a simple file. And so what we're going to type in is the following command: db httpt apt-kubernetes.io /kubernetes-xenial main. And we're going to save this file in the etc folder, and then look for, and then apt, which is going to be down a little bit. And there we have it. And we're going to save it in the apt-get updates. And we're going to name this file as kubernetes.list. And we'll save that. And then we can close out the notepad and go back to the terminal window. And let's look and see if there are any updates again. So we're going to go ahead and run apt-get update. And it's going to run any updates from what we've created. And we want to check what's in the folder. And so we can do cat /etc/apt/sources.list.d/kubernetes.list. And there we are. It shows what we have in that text file. And so we're going to go ahead and we're going to install Kubic 2 and ADM. But first we're going to have to initialize the master. I'm going to show you an error you would get if you were to install kubelet and the other files too quickly. You get the following error. All right, so we have installed kubelet, kubeadm, kubectl, and Kubernetes CNI. And so we're going to go ahead and use sudo swap-up -a. And now we're going to initialize the master node. And we're going to do that with sudo kubeadm init. And this will take a few minutes for it to initialize. All right, so that's all done. All right, so we're going to deploy the pod to a network. And we have two commands that we're going to use. We use sudo kubectl apply, and then we have a long path we have to type out, which is -f https raw githubs content.com corios flannel master documentation cube-file.yml. What we have to do is we have to actually go ahead and deploy the nodes first. So we're going to do that by creating mkdir-p, and then we have $home-.cube. We'll create that new directory, and sudo cp-i, and then the path will be etc /kubernetes/admin.conf, and then $home/.cube.config. And then the final one will be sudo chown $open paren id-u close paren $open paren id/-g close paren $home/.cube/config. All right, now we're going to go ahead and deploy, and let's see. Oh, yeah, I think I have a typo in my command here. Yep. Oh, yeah, I did have a typo, and so I've got that incorrect now. So documentation is actually spelled with a T, not an S. And then we're going to go ahead and we're going to put in the next line, which is sudo kubectl apply -f, and then we're just going to change a little bit of the actual link here, and that runs great. And now we want to be able to see all of the pods that we have in our network, and so we're going to do that by writing the command sudo kubectl get pods -all -namespaces. And it should list all of our pods. We only have one. There we are. There's all of our content. Now we're going to, so there's only one node, so let's see what we have here. So we're going to use the command sudo kubectl get nodes. There we are, just one node. So our final step is to actually go ahead and deploy a service. And so what we're going to go ahead is deploy the nginx service. And we're going to do that with the command sudo kubectl run --image equals nginx. And we're going to put this into port 80. So it's going to be nginx-app port equals 80 environment env equals open quotes domain equals cluster close quotes. And we're going to write one more command, which is sudo kubectl expose deployment nginx-app port equals 80 name equals nginx-http. And once we've done this, we'll be able to then run the command to actually see our services. And there'll be quite a few of them. And our final command is sudo docker ps-a. And we have quite a lot of lists, quite a lot of services listed. So there you are. That's the instructions on how to get Docker up and running, and with some basic commands. It's worth going through a few times to get right, but once you actually have the Kubernetes environment up and running, managing your Docker environment and containers, it's extremely powerful.
Now, the first step is to install the necessary dependencies using two of the commands. First is sudo apt get update, which gets all the updates. And then you have to enter a password. So this will take a few seconds. That's done. The next step is to install apt transport HTTPS. This is basically used to make repositories via HTTPS. So let's go ahead with that. Sudo. Okay, that's done. Going ahead, the next thing we have to do is to install the Docker dependency using the command sudo apt install docker.io. You have to choose Y, and this will take a few minutes. Okay, that's done. So after installing the Docker, we have to start and enable the Docker using the command sudo systemctl start docker and sudo systemctl enable docker. So now the Docker is enabled. So now we are done with the first step of installation. The next step is we have to install the necessary components for Kubernetes. Before that, we have to install the curl command because curl command is used to send data using a URL syntax. Let's install the curl command using the command sudo apt-get install curl. So you have to select Y, and this will take a few minutes. So moving on, the next step we have to do is download and add key for Kubernetes installation from a URL. So let's go ahead with that. Sudo curl. So this is where we get the key, and then we have to add it using sudo apt key add. And it's done. So the next step is we have to add a repository in a certain location. So before doing that, we have to change the permission of that file. So we do that using sudo chmod command. Okay, so the permission is changed. Now let's go ahead and save this file in that location. First, we have to enter this command into the file. This is a URL. Save as. So we have to save it in this location. Let's rename this to Kubernetes.list. Now let's see. Okay, so here it is. Now, moving forward. Now we have to check for any updates available. In the next command, we are going to install the Kubernetes components, that is kubelet, kubeadm, kubectl, and Kubernetes CNI. So let's go ahead with that. So this is going to take a few minutes. Now that's done. So the next step, we have to initialize the master node, and to do this we have to first use a swap off command to disable the swapping on other devices. So let's do that. Sudo swap off -a. Now let's go ahead with the initialization. Sudo kubeadm init. This is going to take a few minutes. Okay, so before going to the next step, to start the cluster, we have to use these 3 commands. Let's just copy paste it. Okay, that's done. So, moving forward, the next step is to deploy pods using the following command. Now the pods have been deployed to our network. To see all the pods, you have to use the command sudo kubectl get pods. There you can see the pods that have been deployed.
So what will you be learning today? You'll learn why you should use Ansible, what exactly is Ansible, the Ansible architecture, how Ansible works, the various benefits of Ansible, and finally we'll have a demo on the installation of Apache or the HTTPD package on our client systems. We'll also be hosting a very simple web page, and during this demo, I'll also show you how you can write a very simple playbook in YAML and your inventory file. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, a local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting 2 virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these 2 machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the two. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of a client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing we need to check if the syntax of our YAML file is absolutely right because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook. and the name of your playbook. So our playbook's executed, as you can see here, gathering facts. That's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made, so it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go, your Apache server is installed and your web page is hosted. So that was very simple, wasn't it? If you have any doubts about the procedure or any other part of the tutorial, please post your doubts in the comment section below and we'll get back to you as soon as we see them. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, a small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using 2 systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one thing we must remember with Ansible is that unlike Chef or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file, and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address 192.168.2.11. Once you have typed in your IP address, give a space and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this file and go back to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML's extremely simple to both write and understand. It's in fact very close to English. So now we'll write our playbook. The playbook or any code in YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file or the playbook in our case will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root's called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically an Apache server. So now my command's yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name, run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task. And the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats. And then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. And that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK. Because this does not need to be changed, our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost. And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible. If you have any doubts, please post them in the comment section below and we'll definitely get back to you as soon as possible. So before we begin, let's have a brief look at all that you'll learn today. First, we'll get to know why should we use Chef and what exactly is the Chef. 2 of the most common terms used with Chef, configuration management and infrastructure as code. We'll have a brief look at these. We'll also have a look at the components of Chef and the Chef architecture, quickly go through the various flavors of Chef, and finally we'll wrap it up with a demo on the installation of Apache on our nodes. So let's begin, guys. Why should we use Chef? Well, consider a large company. Now this company caters to a large number of clients and provides a number of services or solutions. Of course, to get all of this done, they need a huge number of servers and a huge number of systems. Basically, they will have a huge infrastructure. Now, this infrastructure needs to be continuously configured and maintained. In fact, when you're dealing with an infrastructure that size, there's a good chance systems may be failing. And in the long run, as your company expands, new systems may even get added. So what do? Well, you could say the company has the best system administrator out there, but all by himself, could he possibly take care of an infrastructure that size? No, he can't. And that's where Chef comes in, because Chef automates this entire process. So what does Chef provide? Chef provides continuous deployment. So when you look at the market space today, you see how products and their updates are coming out in a matter of days. So it's very important that a company is able to deploy their product the minute it's ready, so that once it's out, it's not already obsolete. Chef also provides increased system robustness. As we saw, Chef can automate the infrastructure. But in spite of this automation, there's a good possibility that errors do creep in. Chef can detect all these bugs and remove them before deploying them into the real environment. Not only this, Chef also adapts to the cloud. We all know how today the services, tools, solutions, everything's revolving around the cloud. So Chef does really play along by making itself easily integratable with the cloud platform. So now that you know why to use Chef, let's look at what exactly is Chef. Chef is an open source tool developed by Opscode. Of course, there are paid versions of Chef, such as Chef Enterprise, but other than that, most of it is freely accessible. Chef is written in Ruby and Erlang. If you would have gone through any previous material on Chef, I'm sure you would have come across Ruby being related to Chef, but not Erlang. So this is why, because Ruby and Erlang are both used to build Chef, but when it comes to actually writing the codes in Chef, it's just Ruby. And these are the codes that's deployed onto your multiple servers and does the automatic configuration and maintenance. And this is why Chef is a configuration management tool. So I've used this term configuration management a couple of times. What exactly does this mean? Let's start with the definition of configuration management. Configuration management is a collection of engineering practices that provides a systematic way to manage entities for efficient deployment. So let's break this down. Configuration management basically is a collection of practices. And what are these practices for? These practices are for managing your entities, the entities which are required for efficient deployment. So what are these entities that you need for efficient deployment? They are code, infrastructure, and people. Code is basically the code the system administrators write for configuring your various systems. Infrastructure is the collection of your systems and your servers. And then finally, you have the teams that take care of this infrastructure. So codes need to be updated whenever your infrastructure needs a new configuration or some sort of updation in the operating system or the software versions. Your code needs to be updated at first. And as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D, and so on need to be well aware when the change is made as to why it was made, what was the change made, and where exactly this change was made. So there are two types of configuration management. On our left, we have the push configuration. Here, the server that holds the files with instructions to configure your nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems, Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. We don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code, and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something, and at his 10th command he realized the very first command he wrote, there was something not right there. Well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it, and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. A second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And a final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine and 2 nodes. You can have any number of nodes. First things first, the system administrator must create a recipe. So the recipes that are mentioned in our Chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have 1 recipe, 2 recipes, 3 recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have Simplilearn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the OHI service. The OHI service will collect all information regarding the current state of your nodes and send it over to the Chef client. When you run the Chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then fetched from the server and executed at the node. This sets the node to the right state. There are various flavors of Chef. We'll quickly go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now, this kind of configuration is used only when you have just a single node to take care of. The next flavor is the Hosted Chef. With Hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical Chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional Chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these 3 machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using 2 virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have 2 machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK installation. go to the first link, which is your chef's official page, and under Red Hat Enterprise, because our system's a Red Hat system, select the link of the version that you're using. So I'm using CentOS 7. So my operating system version is 7. So I'll take this link. Now this is the link for downloading your Chef DK. You copy this link and go to your terminal. Guys, notice I'm in the home directory of my root user. So let's install our Chef DK. And it's getting installed. Now this will take some time because it's quite a large file. And Chef DK is downloaded. Next step, we need to install it. And this is the version of the Chef DK that we have downloaded. So type the same. Okay, so that's done. So now we need to make our recipes, and the recipes will exist within cookbooks. So first let's make a chef repository. So within that we'll have a folder for holding all our cookbooks, and within our cookbook we'll write our recipe. So we start with the directory for chef repository. Move into it. Create a folder called cookbooks, within which we'll store each of our cookbooks. Move into this folder. Okay, so we'll just check the contents here right now. So we have our Chef DK, we have a chef repo folder here, and let's check the contents of the chef repo. And this has cookbooks. Okay, so our first cookbook that we'll be making will be under this folder cookbooks. So let's move into cookbooks. We are in. Now we need to create our first cookbook. So the instruction for creating your first cookbook is chef generate cookbook and the name of your cookbook. So I'm just giving the name as sample. Yeah, so our cookbook sample is created. Now when you create your cookbook, you'll notice that a hierarchy is also automatically created. So let's just check the hierarchy of our cookbook. Let's move into sample, and tree is the command for checking the hierarchy. So here, as you can see, we have recipes, and under recipes we have default.rb. So we'll be editing this default.rb to create our recipe. Okay. So let's begin with that. Let's move into our recipes folder and open your default.rb. And here we are. So now we'll type in our code. So what's our recipe for? Our recipe is for installing the HTTPD package on our node, and then we'll also create a small index file where we'll just have a simple content such as welcome or something like that, just to check if our HTTPD is working fine. So let's begin typing the code here. Package HTTPD service HTTPD do. And what must be done with this package is that once it's installed, it needs to be enabled and it needs to be started. And so that's our first task. Our next task is creating our HTML file. So as you know, all your HTML files will follow this path name. And this is the content of your file. You have successfully configured your node. And that's it. That's our simple code. So our recipe is now ready. Save it and exit back to your terminal. Now what we need to do is that we need to configure our server. So go to your browser. On the search engine, type manage.chef.io. So as I mentioned earlier, we'll be using a server as a service on the cloud. So you'll enter your login page for the Chef server, Most of you may not have a profile already, so you go to click here to get started and fill in the details. It's just like creating an account on Facebook. So I already have my account. I've put in the credentials here. I'll just sign in. Now the first thing once you sign in is you'll get an option to create an organization. So all you have to do there is you gotta enter the name of your organization, and just below that there's another box for entering a short form of your organization. Now my organization name was Simplilearn and the short form was SLP123. So when you come to the administration tab under organization, you can see this organization name. Next step, click on this arrow and you got to download your starter kit. Okay, so once you click on starter kit, you'll come to this page where there's a button for download starter kit. So do download it. Save the file. So now come back to your terminal. So you come back to your terminal, and next what you need to do is you need to unzip your chef starter.zip. So for that, first we'll move our chef starter to the root. So it's currently present under the downloads folder. Let's move it. So we have moved our chef starter.zip. Now let's unzip it. First, let's just check the contents of our root directory right now. So we have our chef repository, chef repo folder that we created, the chef starter zip that we just moved, and of course the chef DK. So now we can unzip our chef starter kit. And that's done. So our next step, we got to move the chef starters.zip file into our cookbooks, which lies inside the chef repository. This is done because we'll be executing our further commands to connect our workstation with the server from the cookbooks, because that is where our sample cookbook is. And that's moved. So now we'll run a knife command. So what knife does is that it uploads your recipes or your cookbooks onto the server. So here's the command for running your knife. Samples the name of the cookbook that you're uploading, and uploading sample 0.1.0 and uploading sample. Yeah, so our cookbook is uploaded. Now let's just check this at our server. How we do that is go back to your browser where you have opened your server. So there's no node here yet because we have not configured our node with the server, but we have configured our workstation with the server. And you see here our cookbooks uploaded, sample. So our workstation and our server are connected. So now we need to connect our node with the server. So first we move on to our node machine. We need to take the IP address of our node machine. So for the IP address, we'll just type ifconfig. Right, so this is your IP address. 192.168.2.190. Note this down somewhere, guys. Now that's done. Go back to your workstation. I'll just keep it this way so I can see both. Okay. Go back to your workstation's terminal, but this time to connect our server with the node. So we have taken the IP of our node, and this is where we'll be using it. 192.168.2. The username, which is root in our case, and then enter the password, and then finally you enter your node name. So this is the name that will appear for this particular node on our server. I'm just giving it chef node. You can give it whatever you like. We'll just check the command knife bootstrap, the IP address, SSH user, our user, which is root, SSH password, the password for the root, and finally the node name. And the node's getting created. So once the node is connected to your server, we'll go back to our browser, open our server service on the cloud, and we'll check the node tab. So ideally, your node name should appear there. Great. So our node is added. Also, if you notice here, our chef client service on the node has started running. So let's just check this with the server. Go to your nodes. And here we go. So chef node, a CentOS 7 platform. This is our IP. So it's all done. So now we need to add a cookbook to the run list of this node. So come here, click on this arrow, edit run list. Here's sample. This is the cookbook that we want to run on our node. Put on the current run list. And here we have the run button. Just click on that. So this should have transferred our cookbook onto the node. Let's check that. Go to your node machine. Clear this. We need to be the root. Let's run the chef client service. So we are running it once again because after it was started, we did add something to our run list. The changes in the run list is updated. So in 1 minute 56 seconds, our cookbook has run on our node. So the configuration changes should have been made. Let's check that. It's pretty simple. Just go to your browser. On the search engine, just type localhost. And here's our HTML page that we created on our workstation. Congrats, you configured your first node. And I really hope you did. So that is the end of our demo. We have successfully installed the HTTPD package on our node, and we have also executed a HTML file.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GitTech postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of prime DevOps professionals. Click the link in the description box to unveil the wonders of this course.
Now I'm using my Oracle VM VirtualBox Manager, as you can see here. I'll have two machines, the master and the node. Both of these are CentOS 7 machines. As of the server, we'll be using this as a service on the cloud. So let's begin. Let's have a look at our master system first. This is my master system. The terminal is open over here, and the terminal color here, it's black background with green text. And this is my node system. So the terminal here has a black background with white text. So you can differentiate between the both. So we start at our master system. The first thing we need to do is we need to download the chef DK. So you can write wget, which is the command for downloading, and then go to your browser and just type chef DK here. The first link. So here you have different versions of chef DK. Depending on the operating system that you're using, you need to select the appropriate one. I'm using the Red Hat Enterprise version, and that's number 7. So I'm using CentOS 7. So this is my link for downloading chef DK. Just copy this link and go back to your terminal and paste it here. So your chef DK is being downloaded. This will take a while. Right after we download the chef DK, our next step is to install it on our system. So our chef DK is downloaded. Now let's install it. So guys, this is the version of chef DK that you have downloaded. So make sure this is exactly what you type down here too. So great, our chef DK is installed. So basically our installation for the workstation is done right now. But just so you understand how the flow is, we'll also write a sample recipe on our workstation. So before we do that, let's first create a folder. My folder name is chef repo, basically the chef repository. And let's move into this folder. Okay, so we're in. Next, what we need to do is, as I mentioned earlier, all your recipes will be within a cookbook. So let's create a folder which will hold all our cookbooks. And let's move into this too. Okay, so our next stage is to create the actual cookbook within which we'll have our recipe. So the command for creating the cookbook is chef generate cookbook sample quiz. So sample is the name of my cookbook. So guys, please notice here, cookbooks is the directory that I created, which will hold all our cookbooks. And here cookbook is the keyword. So sample is that one cookbook that we are creating under our folder cookbooks. And our cookbook's being created. Great, so that's done. Moving into our cookbook. Okay, so when our cookbook sample was created, automatically there's this hierarchical structure associated with it. So let's have a look at this hierarchical structure to understand what our cookbook sample exactly is before we move on. So the command for looking at a hierarchical structure is tree. So as you see here, within our cookbook, we have a folder recipes, and under this there's the default.rb recipe. This is where we'll be creating our recipe. So we'll just alter the content of default.rb. So let's move on to finally writing our recipes. So we'll move into this recipes folder first. So now we'll open our recipe default.rb in gedit. So the recipe for this particular demo is to install the HTTPD package on our client node, that is basically your Apache server, and we'll also be hosting a very simple web page. So let's begin. So the recipes in chef is written in Ruby. So I'll explain you the recipe in a while. Okay, so the first line is where you install HTTPD. The second line for service is where you start or enable the HTTPD service on the client node. That's our first task. The second part is where we need to create our web page. So this is the part where your web page will be stored. If you have written any HTML file previously, you know that this is probably like a default path where our web pages are created. Yep, that's it. So this is the content that will be displayed on your web page if everything works right. And I'm pretty sure it will. So now we can save our recipe, and that's done. Close your gedit. So now that we have created the recipe, all our work at the workstation is completed. The next thing we do is we move on to the server. So as I mentioned earlier, we'll be using the server as a service on the cloud. So go to your browser and here just type manage.chef.io. So this is the home page of your Chef server. Click here to get started. We need to first create an account for using the Chef server. This is completely free. We just need to give our email ID and a few other details. It's in fact a lot like creating an account on Facebook or Instagram. Fill in all the details. Check the terms of service box. So the next thing you need to do is go back to your inbox and verify your email ID. So I have my inbox opened here on my Windows machine. So this is my inbox. You would have received a mail from Chef Software. Just click on this link to verify it and create your password. And that's done. So let's continue this on our workstation machine. So type in your username and password. So the first time you log into your Chef server, you'll have this pop-up appear where you need to create a new organization. So create your organization. So this organization is basically the name that will be associated with a collection of the client machines. First thing you do, go to your administration tab and download the starter kit. So guys, when you're doing this part, make sure that you're on your workstation. That is, you're opening your Chef server on the workstation because you need this folder to be installed here. You save the file. So this gets downloaded. So the Chef starter kit is the key to connecting your workstation with the server and the server with the node. So basically it has a tool called Knife, which we'll come across later in our demo. This Knife is what takes care of all the communication and the transferring of cookbooks between the three machines. In our case, the two machines, the workstation and the node, and the one server. So let's go back to our root directory. So our chef starter zip file is within our downloads folder. What we do first is we'll move the zip folder into our cookbooks folder and then we'll unzip it there, because our cookbooks folder is the one that contains the recipe, and that is where we require knife tool command to be present so we can send these recipes over to the server. So we'll just check the contents of our cookbooks right now to ensure that our chef starter.zip file is within the cookbooks. Yep, so it's here. So next thing we do is we need to unzip this folder. Great, so that's unzipped. And this means that our workstation and our server are now linked. So we just need to use the knife command tool to transfer or to upload our recipes, which we created on the workstation, onto the server. So before we execute this command, we need to move into our cookbooks directory. As you know, that is where we unzipped our chef starter kit. So that is where our knife command is present too. And now let's execute the knife command. So it's knife, cookbook, upload, and sample. So as you probably recall, sample is the name of the cookbook that we created. And within sample, we created our recipe, which is default.rb. So we're uploading the entire cookbook onto the server. Execute the command. Great, so our cookbook's uploaded. Now let's check this on our server. So move to your browser where you opened your chef's server and go to policy. So here you go. This is the cookbook we uploaded sample, and it's the first time we uploaded it. So the version 0.1.0, the first version. Now what you would notice is if you go to the nodes tab, there are no nodes present. So if you have no nodes, you basically have no machine to execute your cookbooks. And the nodes are not seen right now because we have not configured them yet. So that's the next thing we need to do. All this so far was done on your master machine. Now we'll move on to the node machine. So before moving on, let's just check the IP of our node machine. So that's our IP. Note this down somewhere. And now we move back to our workstation. As we already saw that we uploaded a sample workbook, next thing we need to make sure that our server and node are able to communicate with each other. So again, we use the knife tool for this too. The command here is knife, bootstrap, and enter the IP address of your node, which we just checked. We'll be logging in there. So we'll be using the node as the root user. And then we also need to specify our root password for the node. And we give a name to this node. So this is the name by which we'll be identifying our node at the server. So as you have probably noticed here, we're using the term SSH, which is a secure shell. So it basically provides a channel of secure communication between two machines in an unsafe environment. Okay, so it's done. So if your command has executed right, which in our case, as we can see, has, our chef server and our chef node must be able to communicate with each other. So if this is so, we should be able to send the cookbook that we previously uploaded from our workstation onto the server, now from our server to our node. So to do that, before we move on to the node machine, we need to go back to our chef server. Let's refresh this page. And as you see here, previously under the nodes tab, we did not have any node mentioned. Now we do. Chef node, which is the node we wanted to identify our node by, which is a CentOS platform. And that's our IP. So it's active for 2 hours. That's the uptime. Last check-in, the last time we checked into our node was a minute back. And yeah, that's pretty much it. So now we'll create a run list and we'll add our sample to this run list. So just click on your node. And you'll see the small arrow here in the end. Click on that, edit run list. And under available recipes, we have our cookbook sample present. So drag and drop this to the current run list and accept it. Okay, so now that we updated our run list, our recipe is sent to our node. What we next need to do is that we need to execute this at our node. So now we'll move on to our node machine. Chef client is the command to execute your. So while this recipe is executing, you can see what exactly is happening. Our recipe was to install HTTP repackage first, which is your Apache server. So the first line, that's done and it's up to date. The second line, it's enabled. Third line, the service is started. And the fourth line is where your contents created for the web page at this very location. So by the look of this, everything should work fine. So how do we check this? We can just go to our browser and in the search bar, just type localhost. And there you go. So our HTTPD package, which is the Apache server, is installed and our sample web page is also hosted. Congratulations on completing the chef demo. If you have any doubts regarding the demo, please put them in the comment section below and we'll definitely reply to you. So I hope you guys really liked the video. If you did, please hit the like button. Also subscribe to our channel. If you haven't so yet, we have more installation videos coming up. So stay tuned. Installation procedure for the configuration management tool Puppet. So what exactly is the use of Puppet? If you consider the scenario of an organization which has a very large infrastructure, it's required that all the systems and servers in this infrastructure is continuously maintained at a desired state. This is where Puppet comes in. Puppet automates this entire procedure, thus reducing the manual work. So before we move on to the demo, let me tell you what the architecture of Puppet looks like. So Puppet has two main components. You have the Puppet master and the Puppet client. The Puppet master is where you write the configuration files and store them, and the Puppet client are basically those client machines which require the configuration. In case of Puppet, these configuration files that you write are called manifests. So let's move on to the demo. So here are my two machines. The first is the server system, which is basically your master where you'll write your configuration files, and the other is the node or the client system. So let's have a look at both of these machines. This is my node system. The terminal is open here and the terminal has a black background with white text. And as of my server or the master machine, it has a black background with green text. So we start at our server machine. The first thing that we need to do is we need to remove the firewall. So in a lot of cases, there are chances that the firewall stops the connection between your server and your node. Now, since I'm doing a demo and I'm just showing you how Puppet works between two virtual boxes, I can safely remove the firewall without any worries. But when you're implementing Puppet in an organization or a number of systems on a local network, be careful about the consequences of doing so. So our firewall is disabled. Next thing that we do is we'll change the host name of our server system. Now while using the Puppet tool, it's always advisable that you name your server's host as Puppet. This is because the Puppet tool identifies the host name Puppet by default as the host name for the master or the server system. Let's just check if the host name is changed successfully. Yep, so that's done. So as you see, still localhost is appearing as the host name. So just close your terminal and start it again. And you see here, the host name has been changed to Puppet. Okay, so the next thing that we have to do is we install our Puppet labs. Make sure your system is connected to the net. Right, so Puppet labs is installed. Next, we need to install the Puppet server service on our server system. Now that our Puppet server service is installed, we need to move into the system configurations for our Puppet server. So the path for that is etc sysconfig Puppet server. So this is a configuration file for the Puppet server. Now if you come down to this line, now this line here, this is the line which allocates memory for your Puppet server. Now you must remember that Puppet is a very resource extensive tool. So just in case, to ensure that we do not encounter any errors because of out of memory, we will reduce these sizes. So as of now, we have 2 GB allocated by default. We'll change this to 512 MB. Now in a lot of cases, it may work without doing so, but just to be on the safer side, we make this change. Save it and go back to your terminal. We are now ready to start our Puppet server service. The first time you start your Puppet server service, it may take a while. Next, we need to enable this. And if your Puppet server service is started and enabled successfully, this is the output that you would get. In case you're still not sure, you can always check the status at any point of time. And as you see here, it's active. So everything's fine as of now. Next thing we do is we'll move on to our agent system or our client or node system. So here too we'll have to install Puppet Labs. But before we do so, we need to make a small change in our host file. So let's open the host file. Yeah, so this is our host file. We need to add a single line here which specifies our Puppet master. So first we put our Puppet master's IP address followed by the host name, and then we'll add a DNS for our Puppet server. So let's just go back to our server system and find out its IP address. And that's my IP address for the server system. Now the host name of our Puppet server and a DNS for it. Save this file and return to your terminal. So now we can download our Puppet Labs on the node system. It's the exact same procedure that you followed for downloading Puppet Labs on your server system too. So in my node system, the Puppet Labs is already downloaded. So the next thing is we need to install our Puppet agent service. So Puppet is a pull type of configuration tool. What this means is that all your configuration files that you'll be writing on your server is pulled by the node system as and when it requires it. So this is the core functionality of the agent service which is installed on your client node or agent system. So my Puppet agent service is installed. So next I'll just check if my Puppet server is reachable from this node system. So 8140 is the port number that the Puppet server must be listening on, and it's connected to Puppet, so that guarantees that your server is reachable from the node system. So now that everything's configured right, we can start our agent service. So guys, you would have noticed that the command for starting the agent service is a little more complex than the command for starting your server service. This is because when you start your agent service, you're not just starting a service, but you're also creating a certificate. This is the certificate that will be sent over to your master system. Now at the master system, there's something called the certificate authority. This gives the master the rights to sign a certificate if it agrees to share information with that particular node. So let's execute this command, which does both the function of sending the certificate and starting your agent service. So as you can see here, our service is started successfully. It's in a running state. Now we'll move to our master system or the server system. So first we'll have a look at the certificates that we received. The certificate should be in this location. So as you can see here, this is the certificate that we just received from our agent service. So this here within quotes is the name of our certificate. So next, when we are signing the certificate, this is the name we'll provide to specify that this is the particular certificate that we want to sign. So the minute we sign a certificate, the node that sends the certificate gets a notification that the master has accepted your request. So after this, we can begin sharing our manifest files. Now here's the command for signing this certificate. Okay, so our certificate is signed, which means that the node's request is approved, and the minute the certificate is signed, the request is removed from this list. So now if we execute the same command as we did to check the list of all the certificates, we will not find this certificate anymore. Let's just check that. So as you see, now there are no more requests pending because we have accepted all the requests. If you want to have a look at all the certificates that is signed or unsigned, you can use the same command with the addition of all. And all the certificates received so far will be listed. As you can see here, the plus sign indicates that the certificate request has already been accepted. So now that our certificate is signed, the next thing we do is we'll create a sample manifest file. So this is the path that you create your manifest files in. Our file name is sample.pp and our file's created. So right now we have no content in this file. We'll just check if the agent is receiving it. And once that's confirmed, we'll add some content to the file. So let's move to our agent system. Now this is the command to execute at the agent system to pull your configuration files. So our catalog is applied in 0.02 seconds. So now that the communication between our agent system and our master system is working perfectly fine, let's add some content to the previous placeholder file that we created on our master system. So now we open the same file in an editor. Okay, so we are going to write a code for installing the HTTPD package on our node system, which is basically a Apache service. Node, and then within quotes insert the host name of your node system. So my node system's host name is client, the package you wish to install, which in our case is HTTPD, and the action to be performed, and that's it. A very small and simple code. Save this file. Now let's go back to our node system and let's pull this second version of the same configuration file. So every time you execute this command, as we did previously too, what happens is that the agent service basically checks on your master system if there's any new configuration file added or if there's any change to the previous configuration file made. If so, then the catalog is applied once again. So now our catalog is applied in 1.55 seconds. So now to check if our catalog served its purpose, let's just open our browser. Just type localhost here. And as you can see, if your HTTPD package has been successfully installed, the Apache testing page will appear here. So we come to an end of our installation and configuration of the configuration management tool Puppet. If you have any doubts regarding this, please post them in the comment section below and we'll definitely get back to you. So what will we learn today? Today you'll learn about why we should use Puppet, what exactly is Puppet, the Puppet architecture, how Puppet works, and finally, we'll have a demo on the installation of Apache on our node. So let's begin. Why Puppet? So consider the scenario of an MNC. The MNC puts together the small team of system administrators. They're responsible for taking care of the infrastructure of this organization. Now this infrastructure could consist of data centers, server centers, and many such components. Fortunately for the MNC, they were doing extremely well. So the number of clients kept growing consistently, and with this came a boom in the infrastructure size. Now here is where the problem came in. With such a large infrastructure, the small team that they put together in no way could manage this. So what do we do? The solution seems pretty simple, right? Just increase the size of the team. Sure, we'll increase the size of the team. But when do you think we can put an upper limit on the size? When do we get to stabilize this team? So here is where Puppet comes in. With Puppet, a small team is enough to take care of this large infrastructure. This is because the data centers, server centers, all of them can be updated in a matter of seconds with Puppet. Entire load of doing so has now shifted from the team onto the tool. Not only this, with Puppet, if servers do fail, and there's a very high chance of servers failing when you're considering an organization the scale of an MNC, Puppet can instantly roll them back to their previous working states. And if that wasn't enough, Puppet also provides the capability to deploy servers on demand and enforce security on them. Now all of this is done through simple coding which is written in Ruby. We'll look at how Puppet works more. So now that we know why we should use Puppet, let's have a look at what exactly is Puppet. So first and foremost, Puppet is a configuration management tool, as I already mentioned in the beginning of this video. So this simply means that Puppet ensures that all your systems are maintained at a consistent state. So consider that you want to deploy a number of servers. Now you require these servers to be identical. If this task is given to a human, there's a very good chance that those systems will not be identical, or some of them may even fail. Humans are prone to errors, you cannot blame them. So Puppet ensures that all these servers are deployed on time and they are identical. Secondly, Puppet is also a deployment tool. This simply means that Puppet has the capability to deploy your applications, your services, your softwares, all of this on your nodes automatically. And finally, Puppet implements infrastructure as code. Now, this term infrastructure as code is a very important one when it comes to the DevOps approach. You would have noticed this term being used in our previous video on Chef 2. If not, you can always click the top right corner to know more. So, what does this term infrastructure as code mean? Infrastructure as code simply means that all your policies, your tasks, your instructions, everything is written in coded format. So, in case of Puppet specifically, all of this is written in the Ruby language. So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we'll look into each of these components in detail. Firstly, we have the Puppet Master. So the Puppet Master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet Master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifest, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is, you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different. Because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest templates and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet Master, CA, which stands for Certificate Authority. Now, as we will see later in this video, the Puppet Master and the Puppet Client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet Client, of course these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our clients and sending this data over to the Puppet Master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure Socket Layer is a security protocol and it forms an encrypted channel between 2 components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet Master or the Puppet Client. They are just 2 systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as System A. So System A sends over a client certificate to the master. Associated with this client certificate is the host name of system A. Now master goes through this certificate, it sees the host name, and then it decides whether it wants to form a communication link with the system A. If it does, it signs the certificate, and the signed certificate is sent back to system A. Now the system A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first three stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifest or even could be your files. So what happens after this request? After this request, the factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact, and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs, and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes your systems will be configured. And we reach the final and the most exciting part of our video, which is the hands-on. So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines, and I have Oracle VM VirtualBox installed on my machine. So on that I've simply created two virtual boxes, both CentOS 7 of course. So before we move on to the actual demo, I'll just take you through the various steps. So first we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it will sign this certificate. So once your master or the server signs the certificate, you can write your manifest. So the manifest are just the code for configuration, and once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your catalogs, because as you know, the manifests are compiled into catalogs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text. And Puppet client here has a black background with green text. So we'll move on to server machine or the master machine because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys, under ENP0S3, init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall d, and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with a Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce this size. "512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet -master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Sign certificate request. Here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write a manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp, which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalog's applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client.
What is that you should be expecting from this video? Let's see what is Selenium. Whenever we are learning about any tool, it's good to know a little bit brief history of it. So we will look into how Selenium has evolved over years to become the most popular web application automation tool and why use WebDriver. And then we will understand what is Selenium driver. While we learn this, I will also be touching upon some drawbacks of manual testing and how automation helps. And then a deep dive into architecture of WebDriver. As you know, every automation tool has its own advantages and limitations. So we will be understanding the limitations of Selenium WebDriver and how we work around this. And then I will demonstrate the WebDriver in action, for which I will use a simple web application use case to automate. So let's get started. So before we talk about Selenium, let's understand a few drawbacks of manual testing. Let's take an example of a very simple use case. As a user, I want to log in to my web application using username and password. A very simple use case, and it's a very common use case for any kind of web application you're working. So as a tester, what do? I need to write multiple test cases to test this use case. So I can use multiple data sets like valid credentials, invalid credentials, null values, and so on to test this particular use case. And then what you do, you start executing the test cases one by one. You find bugs, then your developers fixes them, and then you will need to rerun all the test cases again and again until all the bugs for this use case are fixed and your application is ready to ship. Now look into this. Now this brings us to the first demerit of the manual testing, which is what? If one has to run test cases with 100 transactions and repeat them again and again, this is going to be a very time-consuming process and very boring. Also, it is more error-prone since it's done manually and human mistakes are bound to happen. The third challenge is the scope of manual testing itself is very limited. For example, say regression testing. Ideally, you would want to run all the test cases which you have written, but since it's a manual process, this is going to be very tedious to do. And also, you would not have all the luxury of time to execute all test cases. So what do? You start picking up those test cases which are very important to be run. And that way, you are kind of limiting the scope of your testing. Also, working with large amount of data manually is going to be impractical. What about performance testing? You want to collect metrics on various performance measures as a part of your performance testing. You want to simulate multiple loads on your application under test. And all these things, manually, it is very difficult to perform. And it's not feasible also. And to sum it all this,
creating manual test reports after running all the tests. Who wants to really do that? And again, another level of challenge here is, say if you're working on an agile model where code is being churned out by developers, the testers are building their test cases, executing them as and when the builds are available to them. This happens iteratively, and hence you will need to run all those test cases which you have written multiple times during your development cycle. And doing this manually definitely is going to be very tedious and boring. And is this the effective of doing it? No. So what do? We automate it. So this tells us why we want to automate. 1, for faster execution. 2, to be less error prone. 3, to help frequent execution of our tests. So there were many tools available in the market for automation. One such tool was Selenium, and that brings us to the slide, Advent of Selenium. So much before Selenium, there were various tools in the market like RFT, QTP, just to name a few popular ones. So Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks. He was kind of working on a web application which needed frequent testing, and he realized the inefficiency in doing manual testing of his application repeatedly. So what he did was he wrote a JavaScript program that automatically controlled the browser actions, and then he named that as JavaScript Test Runner. He made this open source, which was later renamed as Selenium Core, and this is how the Selenium came into existence. So with this brief history of Selenium, let's understand what is Selenium and what are its main features. Selenium is the most popular and widely used automation tool for automating web applications. It enables us to test web application on different kind of browsers like Internet Explorer, Chrome, Firefox, Safari, Opera, and so on. And also they introduced support for Edge browser after Microsoft introduced it. Selenium is a set of tools and libraries to facilitate automation of web application. It is not a single tool. It has multiple components, and those we will be seeing in some time. All these tools together help us test the web application. So Selenium is open source and it is platform independent. This is the biggest reason why people are preferring this tool, because it is free of cost. QTP and RFT, which I just talked about, are a chargeable one. Selenium scripts can run on any platform because Selenium is primarily developed in JavaScript. So it is platform independent. Well, as you know, it's common for manual testers not to have in-depth programming background. So Selenium has a record and replay back tool called the Selenium IDE, which can be used to create a set of actions as a script and to replay that script. But this is mainly used for demo purpose. Why? Because Selenium is such a powerful tool that you should be able to take advantage of all its features and not just be with a record and replay tool, right? So that way there are a lot of record and replay tool anyway available in the market. The Selenium provides support for different programming language, Java, Python, C#, Ruby, PHP, and so on. You can write your test scripts in any language you prefer or you like. And again, as I said, one need not really know in-depth or advanced knowledge of these languages. You would still be able to write the Selenium scripts with the basic knowledge of this programming language. And also Selenium supports various operating systems. You can run Selenium test on Windows, Mac, or Linux, or even say if you have a Ubuntu machine, you can always run your Selenium test on Ubuntu machines. So you can run the test on any platform of your choice. Okay, so let's go now a little more deeper into Selenium. So I said that Selenium is not a single tool, but it is a suite of tools, right? So now let's look at what are those major components which comprises of the Selenium suite. First one is the Selenium IDE. So Selenium IDE is the most simplest tool in the whole suite of the Selenium. It is nothing but it's an integrated development environment. Earlier, this IDE was simply a Firefox extension and it offered a record and playback functionality. It was a very simple and easy to use. And as I said, mainly this is used for prototyping or for only the demo purposes, right? And not creating automation for your real-time projects because you know of its own limitation of being a simple record and replay tool. However, Selenium, what happened? Selenium IDE, it died with Firefox 55. So that means the support for IDE was stopped from Firefox 55 version. But the good news is very recently brand new Selenium IDE has been launched. And also what they have done is they have made this cross browser. That means you can install the extension on Chrome, the IDE extension on Chrome, or as an add-on on Firefox. So it is supported on both the browsers, Firefox and Chrome. Alright, so while we are talking of this IDE, let me also show you how the latest IDE on the Chrome looks. Okay, for that, let me go and launch my Chrome browser. So let me just open a new tab, and what I'll do is I'll search for Selenium IDE for Chrome download. Then I go to this website and then you can see here Selenium IDE offered by seleniumhq.org. So what I simply need to do is, like you install any extension on your Chrome browsers, I just say add to Chrome, and this adds this extension on your Chrome browser. Now it has added. So Selenium IDE has been added to Chrome. Use this extension by clicking this icon. So can you see this icon here, which is Selenium IDE? That's it. So once you have installed this, you are free to start using the IDE on this Chrome browser. Similarly, you can do adding of this add-on, which is called as add-on on Firefox. So go to the Firefox browser, search for the Selenium IDE and just install that add-on. So let's get back to our presentation. So that's about the IDE. So what's our next component? Our next component is Selenium RC, which is nothing but Selenium Remote Control. Selenium RC is used to write web application tests in different programming languages. It interacts with the browser with the help of RC server. It has an RC server through which only it can interact with the web browsers. And how does it communicate? It uses a simple HTTP GET and POST request. And this is what was called as Selenium 1.0 version. But it got deprecated in 2.0 version and it was completely removed in 3.0 and was replaced with something called as WebDriver. So we will be talking in detail about why this happened, what were the drawbacks of RC which led to replacing with the WebDriver. So now that brings us to the third component, which is the Selenium WebDriver. This is the most important component. It is just a programming interface to create and execute our test cases. Of course, it's a successor of RC because there were certain drawbacks which I just mentioned, and we will be going in detail of what it were. So WebDriver, what the major difference what we see with the WebDriver is the architecture of the WebDriver is much simpler than RC for the reason that WebDriver interacts with the browser directly, unlike your RC where it needs an RC server to interact with the browser. So this gave a lot of advantage and edge over the RC. The fourth component, Selenium Grid. Selenium Grid is used to run multiple test scripts on multiple machines at the same time. With Selenium driver, you can only do the sequential execution. However, in real-time environment, you know that there is always a need to run tests on distributed environment. For example, say you have a web application and say you have automated around hundreds or thousands of test cases and you need to run them as a regression suite. And also one of the asks is that you need to run this on multiple browsers and multiple OS. Why? Since you have automated them and your application supports multiple browsers and OS. Now imagine the time taken to run these 1,000 test cases sequentially with the WebDriver, right? It's going to take quite a bit of time. So what you need is to run this parallel on multiple machines, matrixed across the browsers and operating system, and that is where the grid helps you in achieving that. So grid has this hub and node concept and it helps in achieving the parallel execution which I just talked about. So you can check out our detailed video on Selenium Grid on Simplilearn. Alright, so now we talked about the components of the Selenium. So let's look at the different versions it evolved into. So when I talked about RC, I mentioned that this was Selenium 1 version. So now let's understand how this evolved over years and what it offers today. So when Jason Huggins introduced Selenium, the tool was called JavaScript program. He called it as JavaScript Test Runner. It had one major issue. Now that is something called as same origin policy. So what is the same origin policy? It says that a JavaScript, when executed in a domain, can access web pages in that domain only, and it cannot access any web pages in another domain. I will repeat it. Same origin policies dictates that a JavaScript is executed in a domain can access web pages in that domain only, and it cannot access web pages in another domain. For example, say every web page in say google.com domain like search, email, drive can be accessible, but nothing outside of google.com, like say if you want to access a web page in say Amazon or Yahoo, is possible to access. Why? Because of the simple reason, which is a security reasons. Now to overcome this, Paul Homan created something called a Selenium Remote Control Server. And why did he create that? He wanted to trick the browser in believing that the Selenium core through which you're going to run your scripts and your web application under test are in the same domain, with which you are able to achieve run your test on your web application without having to get into this issue of same origin policy. So this is what was the version 1 of Selenium, and we called it as Selenium Remote Control. And then what happened in 2007, Simon Stewart, okay, he invented this WebDriver. Now why did he invent this? Because the architecture of Selenium RC was little complicated. RC required a separate server to talk to your browsers. So what he did was he removed the requirement of having a separate server in the RC, and this was the Selenium 2 version. Now since it was a transition phase, both the Selenium RC and the WebDriver coexisted in Selenium 2, while the WebDriver was still under development. And then what happened in 3.0 Selenium is the Selenium core, which is the RC, was completely deprecated and only the WebDriver was made available. So in this series of videos, we will be working with Selenium 3.0. And now Selenium 4 is already around the corner. So alpha is already released as of the day when this video was made, and I believe some of the features what the Selenium 4 is going to offer is they are moving towards W3C WebDriver standardization 1, and also there is going to be an improved IDE, the IDE which I just talked about, that it's a improved version of the previous IDE, and then an improved version of Selenium Grid also. So they might be doing a GUI based grid, right? So these are some of the major features expected in this version. Why Selenium WebDriver? So let's look at what led to replacement of Selenium RC with this WebDriver. For that, first we need to understand the Selenium RC and its shortcoming. As I said, Selenium RC is a simple tool to write tests for web applications in various supported programming languages like Java, Python, Ruby, and C#. And this is the architecture of the Selenium RC at a very high level. First, you need to write test scripts in any of the supported languages of your choice. So if you're more familiar with Java, you would be writing your test scripts, all your commands in the Java language. So before we start writing the test, one of the major required for the RC to run is your RC server. So first you need to start this RC server before you run even a single line of code. And this RC server is a separate application. And now what is the function of this RC server? This Selenium server or the RC server is responsible for receiving Selenium commands from your test script. It interprets them and then reports the result back to your Selenium test script. Now what are the Selenium commands? These commands are nothing but the commands written in your test script. These are called as Selenium command. That is what the Selenium server does. Now after the Selenium server's function, let's look at how the browser interaction happens. The browser interaction happens through this RC server. This RC server uses a simple HTTP post and get request to communicate. And how does this communication happen? This RC server acts like a proxy. Say for example, your test scripts asks for launching a browser. This command from your test script goes to the server, and then this RC server launches the browser, injects its JavaScript into the browser. Once this is done, all the subsequent calls, that is all the subsequent calls is all the rest of the commands which you have written after launching the browser, go to this RC server and then to the actual web server. So it routes, all the commands are getting routed through your RC server to your web browser. Upon receiving this instruction, so what does the code do? It executes these commands as the JavaScript commands on your browser. So once these are executed, the response from the browser or the results what you say are sent back to the RC server, and RC server is responsible for sending it back to your test script, and then the test results are displayed here. Now if you see this complete cycle from starting your command from your test script, talking to the RC server, then RC server talks to the web browser, it injects the JavaScript here, runs your command, takes back the results, sends it to RC server, and then back to this test script. This whole cycle gets repeated for every command which is written in your test script. And this is how your test case gets executed. Alright. So now everything is fine. So great. We are enabled to run the scripts. We are able to launch the browser. We are able to execute all the commands. So what was the problem here? Why was still RC not good enough? For the reason why the RC was still not good enough was, one, the architecture of RC is very complicated because of that intermediate RC server to communicate with the browser. So there is no direct interaction with the browser. This RC server needs to be installed before running any test scripts. That means it has an additional setup, because that is RC server is a mediator between your Selenium commands and your browser. The execution of the commands takes very long time. It is very slow. Why? Because we saw that every command written in your test scripts needs to make a full trip from your test script to the RC server, to the core, to the browser, and then back, which makes your overall automation test execution very, very slow. So how does Selenium WebDriver now overcomes this? This is a simple architecture of Selenium WebDriver. Even in WebDriver, we have test scripts. We have a web browser and a web server. However, we do not have an additional server for communication like the RC server, which we saw in the Selenium RC. This makes the architecture of WebDriver very simple. The Selenium WebDriver, that's one of the biggest advantages. The Selenium WebDriver does not use an additional server. Then secondly, it makes direct calls to your browser using your browser's native support automation. So since there is no intermediate server there, the browser is controlled directly from the operating system level itself. Now, due to this direct communication, the trips what we saw from the RC server to the browser and from the browser back to the RC server and to the test scripts, right? This was an indirect communication. Since this whole thing was avoided, the speed of test execution is much faster in RC. And this overall architecture of the WebDriver, if you see, is much simpler than what the RC provides. So this was the major drawback from the RC, and this is where WebDriver replaced RC. Now, was that all because of the architecture? No, there were few other shortcomings with the RC. APIs in Selenium RC. A single function has several commands. Redundant and confusing APIs. RC is less object-oriented API. Though there are good set of APIs to work with, they are pretty redundant and confusing. For example, how and when to use a type key or a type command. Another example is the mouse commands. Click or to use click at, or when to use mouse at or mouse down. So this was getting pretty confusing for the developers. And to top it all this, every browser interprets the command differently, which makes your test cases brittle when it has to work on the multiple browsers. Developers had a tough time making their scripts cross-browser, and they had to add browser-specific code. Whereas Selenium driver comes with a set of more matured and simpler APIs, which are pretty straightforward to use. For example, a simple click to simulate a click action on any web element. Send keys, which simply means send the text to any web element on your web page. Scroll up or down on the web page, and so on. So we will see more of these commands when we actually start working with the WebDriver. Another difference is the browser support. Though both RC and WebDriver supports multiple browsers, RC does not have support for HTML unit, which is a headless browser, whereas the WebDriver supports testing on headless browser. Now, what is this headless browser? Headless browser is a browser which does not have a UI. It makes testing much faster because it does not need a real browser for testing. Now, to summarize all this, so if you look at the RC and the WebDriver comparison, which we talked about, RC is a complex architecture, whereas WebDriver has a simple architecture, for the main reason that WebDriver removed the need of having an intermediate server. RC, the execution of your test cases or your automation scripts, it's much slower than the WebDriver. RC requires a RC server to interact with the browser, whereas the Selenium WebDriver interacts with the browser directly using the WebDrivers. Also, we saw the APIs which RC provides, which are pretty confusing, and WebDrivers, we have much easier and easy to use APIs. No support for HTML unit browser, which is a headless browser. Selenium driver also provides support for HTML unit browser. Now that we have understood what Selenium RC is and why WebDriver replaced RC, let's go another level deeper into WebDriver. So what is Selenium WebDriver? We know that the WebDriver in its simplest term is a tool or a programming interface to create and execute test cases on a web application. It supports multiple browsers, i.e. Firefox, Chrome, Opera, Safari, Edge, and it also has support for headless browser. So we will know in some time what is a headless browser. Some of the features of WebDriver. So while RC was introduced in 2004, WebDriver got introduced by Simon Stewart in 2006. WebDriver can run on any platform of your choice, Linux, Windows, Mac, and even if you have a Ubuntu machine, you can run your Selenium WebDriver. And what is this actual WebDriver? Is it an IDE? No, it is a simply a programming interface to run your test cases. And how does it work? The test cases are created and executed using web elements or the objects using web locators and WebDriver methods. So once we get into the demo, or once you start understanding how Selenium works, you will understand what are these WebDriver methods and the locating techniques which are used to perform these actions on web element. Selenium WebDriver is pretty fast. Why? Since the WebDriver interacts directly with the browser and does not have an intermediate server like RC. Each browser with which you want to work with has its own driver on which your application runs. And this driver is responsible to make the browser understand the command which are being passed from your script, like a click of button or entering some text in any of the input fields. Through your scripts, you tell which browser you want to work with. Say you want to do all this action, say on the Chrome browser. If you want to work with Chrome browser, then the Chrome driver is responsible for interpreting your instructions from your test case and executing them on the web application, which is launched on Chrome browser only. So like RC, WebDriver also supports multi-programming languages in which you can write your test scripts, like the ones which are listed here. Also, WebDriver supports different frameworks like TestNG, JUnit and NUnit. When we talk about the limitations of WebDriver, you will appreciate how this support for various frameworks and tools help in making the Selenium a complete automation solution for web application. Now let's try to know what is the architecture of Selenium WebDriver. WebDriver has 4 different components in it. One, we have the client libraries, or what is also called as language binding. Since I said Selenium supports multiple languages and you're free to use any of the supported languages to create your automation script, there are libraries available on Selenium website which you need to download and use them. Let me show you that. So let's go to my Chrome browser. So I have the Selenium HQ website already launched here. So guys, if you're working on Selenium, this website seleniumhq.org is going to be Bible. So everything and whatever you need to know and work with Selenium is available here. For now, we want to see the client libraries or the language binding. So for that, what you need to do is, if you go to the download section here, can you see here the Selenium client and WebDriver language binding? So for each of the languages which is supported, you have a client library which you can download from here. So if you're working on Java, you need to download the Java libraries. If you're working on Python, you need to download the Python libraries, right? So these are called as language bindings. So Selenium provides a lot of APIs for us to interact with the browsers. And when we do the demo, I will be showing some of those APIs. Now, what are these APIs? These APIs are the REST APIs. REST is representational stateful APIs, and everything for Selenium happens through this REST calls. The second component is the JSON wire protocol. So what is JSON? JavaScript object notation, and it's a standard for exchanging data over the web. So for example, you want to launch a web application through your script. So what Selenium does is it creates a JSON payload and posts the request to the browser driver, right? And where are these browser drivers? These are here. Right? And what are these browser drivers? These are a driver specific to each browser. So if you see here, you can see drivers for Chrome, Firefox, Opera, Safari and Edge, right? So we interact with the actual browsers here using these drivers. And how does this happen? This driver establishes connection with the real browser without revealing the internal logic of browser functionality, right? That's exactly the function of this browser driver. Now, what does that mean? Let's say we want to execute a test script. So what happens when the script is executed is an HTTP request is generated and sent to browser driver for each command in the script. And then the driver receives the request through this HTTP server and does all the execution on the actual browser. Once the execution is done, the execution results are just sent back over the same HTTP server to your test scripts. So this is the simplest form of the architecture of the Selenium WebDriver. Well, now as every tool has its own advantages and its limitations, so let's look at what Selenium WebDriver limitations are. Cannot test mobile applications, requires framework like APM. Selenium is for automating web application. It cannot handle mobile. Right? Mobile applications are different and they have its own set of automation tools. However, what Selenium provides is the support for integrating this APM tool. APM tool is one of the popular tool for mobile application automation, right? So it provides a support for integrating APM tool. So using APM and Selenium, you can still achieve mobile application automation. Now, when do you usually use this? In cases where, say, your application under test is also supported on mobile devices. So that means you need a mechanism to run your test cases on your web browser as well as your mobile browsers, right? And this is how you achieve it using Selenium. When we talked about components of Selenium, I said that a WebDriver can achieve only sequential execution. But in real time, we know that we just cannot live with this. we need to have a parallel execution on multiple machines and on multiple processes. So this limitation of WebDriver is replaced by having the grid, which helps us in achieve the parallel execution. And do check out our video on more details on Selenium Grid. Selenium WebDriver has limited reporting capability. It can help create basic reports, but definitely we need more, especially when we are working on a big project. We need good reports to be created. So what it does is we have a support for multiple tools like TestNG, ReportNG, and even the extent reports, which you can integrate with Selenium and generate beautiful reports. Isn't it really powerful? Alright, there's another challenge what we have. These are amongst few of the challenges what I have put across here. There are other challenges also, but always there is a workaround to get through those challenges. So another challenge which we have mentioned here is Selenium is not very good with image testing, especially designed for web application automation. But then we have other tools which can be used along with Selenium to achieve any kind of image testing you want to do, like AutoIt and Securely. So same way, the way it provides a mechanism to integrate APM, so Selenium also provides a way for integrating AutoIt and the Securely tools. So if you look at all this, Selenium still provides a complete solution for our automation need. And that's the beauty of Selenium that makes it most powerful tool today for automation. Okay, so let's look at WebDriver in action. So before we do that, let's understand some of the basic browser commands and functions that we will be using in our demo today. The get commands. So there are 6 get commands to perform various actions on the browser. Driver.get. This is used to launch any website application. It takes a string argument and this needs to be a fully formed URL which you want to launch. Driver.getTitle. So this method fetches the title of the web page which you're working with. So for example, let's go to eBay. So if you just hover your mouse here, can you see the text there? Electronics, cars, fashion, collectibles, coupons and more, eBay. So this is nothing but title of this current page. And this command helps us to get the title. Get current URL. So to get the URL of any page is when you want to use this command. So this will be used especially when you're working with multiple web pages and you want to say print whatever the current URL you're working on the console. Get page source. This method dumps the complete HTML page source on your console. Actually, this is not really much used unless you really need to look at anything in your HTML pages. And then there are 2 more get commands related to Windows handles. These are used for handling multiple tabs and multiple windows on the browser. Now, we will not be dealing with this in today's demo. However, if you want to know the details of this command, these are available in our video tutorials for these commands. The next set of commands are the navigational commands. So these are self-explanatory and basically are used to navigate between the multiple pages of your web application. The first one, the driver.navigate.to, is very similar to driver.get. So both does the same function. And then you have navigate.back, navigate.forward and navigate.refresh. So this is used for refreshing your browser page. And then there are 2 commands, browser commands, which we use. One is the driver.close. So this closes the current browser window. So if you have got multiple tabs open in the window and you want to close a particular tab, so that is when you use driver.close. And driver.quit, what it does, it quits the entire browser session. Then there are few other commands. And some of the commands are listed here. However, if you see, there is a huge list of commands available in Selenium. And since we'll be using just a few of them in today's demo, I have listed here. So let's just understand these very basic commands which we will be using. Driver.findElement. Now, when you want to work with any application, what is that you need to do? You need to perform actions on the elements of the web page. And these are called as web elements. For example, let's go to our ebay.in. So on this website, say you want to search for JBL speakers. And what do you do when you want to search for this? You would identify the search box and you will enter the text JBL speakers, right? And then you go ahead and click on the search button. So this is the set of operations which you will do. Now for us to write this, and this is exactly what you need to do through your commands. For us to really write this text as JBL speakers, I need to know what this particular element is. Okay, so this particular input box is my web element which I need to identify. Similarly, if I want to click on the search button, I need to identify what this button is. And that's exactly is done by using driver.findElement. Selenium has multiple ways of finding these elements. It has 8 element locating techniques. and our future videos on Selenium do cover these 8 element locating techniques very much in detail. So for us right now we will be using couple of them. So one is with ID and one is with a link text. The next one, the send keys. So as the name indicates, it is used to send a certain text to any web element you have identified or you want to work with. Like in this example, as I said, since we want to search for JBL speakers, right? I would be basically sending the text JBL speakers to this web element using send keys. Click. So after entering the text, what we need to do, I said, we need to click on the search button. So for all such actions, we have methods defined in Selenium, and one of them is this click. What this does is it just clicks on the web element or the button which we want to work with. So now with these basic commands, let's go ahead and start writing our code for our test case. So what is the test case we are going to write today? So this is my use case today. So use case 1, as a user, I want to log into eBay application, search for JBL speakers, and then I want to check the today's deal. So there is something called as the day's deal. We will go and click on that and see what are the deals available. I have another use case here. What says is, from this website, from wherever we are, right, navigate to the Simplilearn website and navigate back to the ebay.in. So this, using this use case 2, what I want to show you is how do we use the navigational commands. And my third use case is, from the ebay.in, I want to print the page title and close the browser. So with this, we are trying to demonstrate at least few commands from each of the categories which we talked about. So I will be using Eclipse for writing our test scripts. And if you want to know how to get started with Selenium, how do we install Selenium, you can refer to our videos on installation of Selenium by Simplilearn. Okay, let me go to my Eclipse. So in Eclipse, what I have done is I have already created a project called Selenium Demo. And in this project, I've gone ahead and created a Java class in which we would be writing our test case. So the Java class which I have created is ebaysearch.java. And also what I have done is, if you look at few import statements here, I have imported all the required Selenium jars here. So if you look here in the referenced libraries, the way after we work with Java here, right? So Java is the prereq for your Eclipse. So you already have the Java libraries available here. So what I need to do is I also need to import the Selenium jar files, and this is the list of Selenium jar files which you will need to work with the Selenium, and this I've already imported for you. Then another thing what I do as following a best practice is, instead of writing all my code under this main function here, what I do is I create methods for each of the use case or the test case which I'm writing. So same thing, I'm going to do that today for all the use cases which we have taken for this demo. Now let's get started. So what is the first thing which we need to do? The first thing what we need to do is you need to declare your WebDriver. So which I've already done here. I've said WebDriver driver. And then I need to launch the browser before even I go into ebay.in and start performing the other testing. Now for me to launch browser, this is one method which I've already written here. So let me walk you through this. So there are multiple steps we need to follow for launching the browser. The first thing is set system property. So let's understand this particular command here, the one which I have highlighted. So this is used to set the property for your Gecko driver. Now what is a Gecko driver? If you remember, while we are talking of WebDriver architecture, I said for whichever browser you want to work with, you need to tell the WebDriver as which browser is what you're going to test with. And in my case here, I'm going to be using Firefox browser. And also if you remember, while explaining the architecture, I said every browser has its own driver which you need to download and install. And where is this driver? Let's go ahead and see that on the seleniumhq.org. So let me go to my Chrome browser. I already have a seleniumhq.org website open here. Now on this website, in the download section, if you go down, you can see something called as third-party drivers, binding and plugins. And here you would see a list of all browsers: Gecko driver, Chrome, Opera, Edge, right, and HTML unit, which is headless browser. So all these browsers which Selenium supports listed. And for each of this browser, we have a driver associated with it, which we can download. So if I want a Gecko driver, what I need to do is I need to click on this latest link. This will take me to the latest web driver which is available. So depending on the operating system which you're using, right now I'm using a Mac, so I've already downloaded it. So once you download, you need to place it in a particular directory. Okay, so let's go back to this. And now if you see this path here, what I'm highlighting, this is where I have kept my Gecko driver. So this Gecko driver, what you see is my executable. So if you're using a Windows machine, it will be gecko driver.exe. So this is the driver which should be working with. Now coming back to the system.set property. This particular method or this particular command is used to set your driver property. It is a key value pair and you will need to know which keys depending on which browsers you're working with. Since I'm working on the Firefox browser, the key which I need to set is the web driver gecko.driver. If I'm using Chrome, what I simply do is I have a key called Chrome and then I would set this path to Chrome driver, and this is exactly you need to do. So for you to even before launch the browser, you need to do this set property. So let me change this back to Gecko. So now we are clear till here. Now what is the next command which we need to after setting the property is after setting the property you have to instantiate the WebDriver, which is done by using this particular command driver is equal to new Firefox driver. So once you do this, your browser is going to get launched. Then once your browser is launched, what is the next step you do? You would be launching the application on which you want to perform your test, and that is done by using the command which we just saw now, driver.get. Now since I'm going to be working with ebay.in, I have just said driver.get and the URL, fully formed URL. So this particular method is going to help me launch the Firefox browser and also launch the eBay application. Now advantage of using methods like this is you can reuse these methods in every test case which you're going to write, or you can make a common function of this and just call this function in any of your test cases. Now for me to call this method, what am I going to do? I'm going to create an object of this class. Let's do that. Object is equal to new, done, and then I need to call this method obj.launch browser. Good so far? Alright. So now let's get to the first use case. So let's go back to our presentation and see what was our first use case. Our first use case was that we want to launch the eBay application, which we have already done in the launch browser method, and then we want to search for JBL speakers. Now for that what we will do, let me create a method here. So I will call this method, I'll say public void say search product. That's my method name. So I have created a method called search product. Now what I need to do is I need to search for JBL speakers. So for that, let me go to my Firefox browser and I need to first identify the search box element. So for identifying what I do, I go to this website, I go to this element and then I say inspect element. So now I know that there is already an ID which is unique to this particular web element available. So I'm going to make use of this ID. I need to go to my Eclipse. So now here I'm going to use the find element method. So for that I'll say driver.findElement, I'll say by.id and it's a string argument. I'll just copy the ID which I copied from the Firefox browser. And then what is the operation I need to do here? I need to send keys. And what is the keys I need to send? The product which I'm searching for. I'm searching for say JBL speakers. Done. So with this command, what it will do is it will enter the text JBL speakers in the search box. After doing this, I need to click on the search button. Now similarly, I need to identify what is the web element search. For this again, I already have a unique ID here, which I'm just going to simply copy from here and use it in the find elements. So same thing I will do, driver.findElement by.id, and this is the ID of the button. And here what is my operation? I need to click. Done. Good so far. Now other thing what we also need to understand here is, so what happens sometimes depending on the websites, some websites are pretty slow even while loading the page and some are pretty fast. Now for the Selenium to work without having to fail or without having to create exception of not finding the elements, it is good to use certain waits. So why we need to use waits is, say for example, when after entering the JBL speakers and after clicking the button, it's going to take a while for it to search for JBL speakers and give us that web page with the list of JBL speakers. And even before we start doing the first command, like searching, once we load the page, it takes time for the complete page to get loaded. Okay, so Selenium provides a lot of synchronization commands, right? And it's a very big topic on its own, which needs to be used, especially when you're working with any kind of website. Okay, so there is since it's a separate topic, there's a separate video which will help you understand how to use the synchronization. Now, for the demo purpose, we have certain wait commands which can be used, and that is exactly which I'm going to use here. So that is called as thread.sleep. So what this does is, say I'm going to give 2000 here. What this does is, this script waits for 2 seconds, right, after the previous command is executed, and then it executes your next command, which is our find element. Now this is showing us an exception because it wants us to add a exception here, add throws declaration, which is interrupted exception. Okay, we need to do this. So once we are done, okay, we have done the click. So let's see what is the first use case which we had. Have we covered everything in the first use case? Okay, we said log into eBay, done, search for JBL speakers, and then I want to check on the days deal. Okay, we need to do this also. So for that, again, what we need to do is we need to go and identify. So what I will do, I'll use the inspector here and look for this daily deals. Now this is a link text, it's an anchor tag. So what I will do, I'll copy this link text, daily deals. I'll go to my Eclipse. Now after this, I will give another thread.sleep of say 2 seconds. That should be more than enough. And then I'll say driver.find element. Now this time I will be using something called as link text. And here as an argument, as a parameter, I'm going to paste the daily deals which I just copied. And then what do I need to do on this web element? I just need to do a click operation. Done. So the complete first use case we have covered. So what we will do is let's go ahead and execute this first use case. Now I have launched the browser here. I also need to call this method which is search product. Now again here, since we are doing that add throw declaration on the method, we also need to do it for the main function. Exception added. I'll save this, and for me to run this, what I do is I simply right click on that and I say run as Java application. Now we see that our Firefox browser is launched, the eBay application is also launched, and JBL speakers entered and search clicked. So we have a list of JBL speakers here. And now as per our test case, it has to go on the daily deals, which it just did. Great. Alright, so we have our first use case working. So right now I have not used the browser.close. So what I will do is I'll just manually go and close this browser. So we are done with our first use case. Now let's move to our second use case. So what second use case says is from wherever you are, right now we are on the ebay.in, navigate to Simplilearn website and then navigate back to ebay.in. So let's see how to handle that. So let's go back to my Eclipse here. Now let's create another method. Instead of saying test case 2 or use case 2, we'll give a more meaningful name. I'll say navigate, since we are exercising the navigate commands here. I'll just use this method. Now, so we have done the click. So I need a quick thread.sleep here because I want it to wait so that we can see. Otherwise, it's going to be so fast, we will not be able to see what are the operations it did. So I'll just add a thread.sleep before we start navigating to the new website. Okay, thread.sleep, and I guess 2 seconds should be good enough even here. So same thing, we need to add the exception. So add throws declaration and interrupted exception. All right, done. So now what we need to do is we need to navigate to the simplilearn.com. So for that, first I need a fully formed URL of the website which I want to launch. Okay, so let me go to, and here instead of ebay.in, I would say let's search for Simplilearn. I have it here, and I just pick this from here, https www.simplilearn.com. So let me go to my Eclipse, and here we saw another command like get. We said navigate.to. So let's use the same command. So I'll say driver.navigate.to, and I'm going to use to URL because, or you can just use a string because this is going to be a string variable. Now what does this command do? This will simply navigate to the URL which we have specified here. Now here again I'm going to give a quick sleep here so that we are able to see the website before we navigate back to the ebay.in. So I'll use a thread.sleep. This time probably I'll give a 3-second wait. Then what does our use case say? Let's go back to use case once and check. And it says and navigate back to ebay.in. So that means I need to use a driver.navigate. Can you see the list of commands here which provide, which the navigate class provides? Okay, and the back is what we need to use so that it comes back to the ebay.in. Done. So far so good. Now let's do one thing before even we go to the use case 3. Let's execute our test case till here. So what I'll do, I'll save this program, and after search product I will call navigate method. Okay, I will save this and then right click, run as Java application. So our Firefox is getting launched. It has launched. The eBay application is on. So it's going to first find the JBL speakers, click on the search. We have a list of JBL speakers. Then it will click on the daily deals. Yes, it is doing that. We got the deals of the day. Yes, it is now navigating to simplilearn.com. Now after 3 seconds, it should take me back to the ebay.in. Okay, cool. So this was the last page where we left before we navigated to Simplilearn, right? And that is where we have come back using the back command. So now let me close this again because I have still not incorporated the driver.close. Now let's look at the use case 3. Now use case 3 says once you're back to ebay.in, print the page title and then close the browser. Cool, very simple. So we'll go back to Eclipse. Probably in the same method, what I can do is, once I'm back here, I will say, so I have to use driver.getTitle. That was a spelling mistake, driver.getTitle. Okay, this is the method which we are going to use to get the title of the page. Now, we also said that once we get the page title, we want to print it on the console. Now, how do you print it on console? You just use a sysout statement. So instead of just writing this, what I will do is I'll directly write a sysout statement, system.out.println, and I'll write a text as the title of this page is, and then we will concatenate with driver.getTitle. As simple as that. And after I do this, I will simply call, it's actually, I want to call the driver.list, but it's always good to create a separate method. So I'll say public void close browser method. And here I'll simply say driver.quit. You can use close or you can use quit. So let me demonstrate how do we use quit here. Now I need to call the close browser. So simply what I'll do, I'll say obj.close browser method. Okay, so this completes our all three use cases. So now let's execute all these three use cases now. And we should be able to see the title of this page on the console. So same thing, what I do is right click, run as Java application. Okay, same thing, our eBay is launched now. Send keys the JBL speakers, click on search button, executed, and then it has to click on the daily deals, that it is done. Moves to Simplilearn website. Now it has to come back to ebay.in and we should be able to see the close browser, which just happened at the snap of the finger, right? So now for us to know whether it really happened, what we have done is we have printed the page title. Okay, now can you see here? We have the complete page title printed here. All right. Selenium installation is a three-step process, so it has certain prereqs. The first prereq is you need to have Java on your system. So we will be installing Java first, and then we will be working with Eclipse IDE. So we will be installing Eclipse, and then we will install Selenium. For Java, we will install the version Java 8. And for Eclipse, we have a version 4.10. This was the last stable version which was released in December last year. So I'll be using that version. And Selenium, we will download the latest 3.14 version. Okay, so let's get started with our first step, which is the Java installation. So to install Java, let's go to the browser and simply just search for Java 8 download. So now you will see that there is an Oracle site which is listed there, and that is where you would be downloading all your Java package. So go ahead and click on that. And for you to download any JDK package from the Oracle site, you need to create an account. So if you already have one, you just need to log in using that account and then you can download any of the JDKs. And if you do not have one, please go ahead, create a new account on the Oracle, log into that account, and then you can just download the Java 8. So since I already have an account and I have already downloaded the package, but I'll show you how and where to download it from. So in this page, if you scroll down, so you will see this Java Development Kit 8211. So this is the version we'll be downloading it. So click on the Accept License Agreement, and then since we are working on the Windows system today, so we will be downloading this, the Windows package. So just click on that and it will get downloaded in your downloaded folder. And as I said, I've already downloaded the packages. So here it is. What I've done is I've just created a directory called installers, and I'm going to be keeping all my installables here. So here I have a folder called Java installer, and this is where my installable is. So now that we have this file, so we will just go ahead, double click on it and launch this installer. The installer is launched and just click on run. So this will take a few minutes to install Java. The installer is launched. Now just click on the next button here. So here for the installation directory, you can change the directory to the choice of whatever drive and the folder structure you want to. I would like to leave it as default here, and we'll just go and click on next, and then the Java installation is in progress. So let's wait until this is completed. It really shouldn't take too much time, maybe just a few more minutes here. Okay, accept the license term, just click on next. We'll leave the destination folder as it is. So JDK 8 is successfully installed on your system. So close the installer now. And let's go ahead and check whether the installation is done properly. So for that, what I'll do is I'll go to my command prompt and I'll just say Java -version. So it says Java version 1.8, and this tells us that the Java is installed successfully. Now, after this installation, there are a couple of configurations which we need to do. And what are those configurations? One is you need to set the path variable, and then we are also going to set a Java home directory. So for that, first let's go ahead and check where is the Java installed actually. Let's figure out the directory first. So if you remember, the directory structure where the Java got installed was in program files, Java. There are certain previous versions which I had installed and then uninstalled it. So that is why you see some residuals here sitting here. Let's not worry too much about that. Instead, let me go to the latest one what I have installed, which is this. Okay, and there is a bin folder here. And this is the path which we need to set in our path variable. So what I will do is I'll just copy this path and then go to your control panel. Here, go to your, where is my system? Yeah, so click on the system, go to advanced system setting. And here in the environment variables, find the path variable, okay, and then say edit. Now, what are we doing here in the path variable is we are going to add the Java bin directory to the path. Be very careful whenever you are editing your path variable. Do not overwrite anything. Always go into the edit mode, go towards the end here, and then just say Ctrl V, paste the path which you have just copied from the Explorer window. That's it. Now just say OK, done. So your path setting is done. So what's the next one we need to do? We need to add a new environment variable called the Java home. Now what I'll do for that is I'll just say new. I'll just type Java home here. And what is the value of this we need to set? We need to set the same path but without the bin directory. So we just need to set the path till your Java directory. That is this. So we'll just copy the path again and paste it here. That is all. Just say OK, click on OK here, and we are done. So again, let's go to our command prompt and just say Java -version. So everything seems to be fine. So now successfully we have installed Java on the system. So what is our next installation step what we have? Now we need to install the Eclipse. So let's go back to the browser again. So to download Eclipse, we will be downloading the package from the eclipse.org. So when you go here to eclipse.org, you can see the latest version which is available. And the latest version available when this video was made was 2019-06. So especially with Eclipse, since it's an open source, I prefer to work with the last stable version, and so does most of the developers too. And hence that is the reason why I have picked up the version which is like last year's version, which is 4.10, which was released in last December. So you can always choose to go with the latest version, but then if there are any issues and if you're like first time working with the Eclipse, you're going to get confused as where these issues are coming from, right? So I would still recommend that you use the last stable version which is available with your Eclipse. So now to get the last stable version, what you need to do is go and click on this download packages. And here, if you scroll down this page, you can see here more downloads. So there is a list of all the previous releases of Eclipse which is available, and this is what we need to download. So just click on that 4.10 version and then click on the OS on which you want to install Eclipse. For us it is Windows, so I'll just click here on the 64-bit Windows and then click on the download and you will be downloading the complete package. So once you download, this is what it will look like. So let's go back to our directory of installers. So this is the installer for the Eclipse which I got. Now what's the next step I need to do? Just launch this installer and install Eclipse. So I'll just say double click on this. I'll say run. So here you'll see multiple options here for Eclipse installation. So depending on your requirement, you can go ahead and install any of these packages. So for us, we just need an Eclipse ID for Java developers. So I'll select this and I'll say install. So again, you'll have a choice of directory where you want to install. So I have chosen D drive here. This is the default directory name it takes, which is okay. We can leave it as it is. And then also you have an option to create a start menu entry and desktop shortcut. So just leave the default selection as it is and go ahead and click on install. So this will take a while to install the Eclipse. This says select all. You can close this window. This says select all and accept it. Okay, so the installation has been completed successfully. So let's go and click on this launch and let's see the first window what opens. When you launch the Eclipse, you need to specify a workspace directory here. Now what is this workspace directory? So this is a directory or a folder wherein all the Java files or any programs or any artifacts which you're going to create through Eclipse will be stored in this particular folder. So this could be any location on your system. So this is, you can go ahead, browse the location and change it. So for in our case, what we will do is I'll go to the D drive and I already have a directory. So here I'll just select this folder and then create a folder called workspace. I'll say my workspace, and then I'll say launch. So every time I open the Eclipse, right? So this is going to take as my default workspace, and all my programs, all my Java scripts or my automation scripts are going to be stored in this particular location. So we'll say launch. So this is a welcome window which opens. We can just close this, and there we go. The Eclipse is open with a certain perspective. So there are certain windows here which we do not need. Let's just close them. So now the first thing what you do after launching the Eclipse is go ahead and create a new project. So I'll say file, new, and since I'm going to be using Java with Selenium, I'll say create Java project. So give a project name. Let's say my first project. Now you have an option here to select the JRE which you want to use. So we just installed this JDK 1.8. Okay, so I'm going to click on use default JRE. Otherwise, you also have an option to use a project specific JRE. For example, I could have two different projects where one project I'm going to be working with JRE 1.8 and there is another project which I want to work with the latest Java, maybe Java 12. And I can have more than one Java installed on the machine. So this gives me an option to select whichever Java I want to work with. So if you have another Java installed here, it will show up in this list. So and you can just go ahead and select that. Now since we have only one Java installed on our machine, which is Java 1.8, I will say use default JRE, which is 1.8, and I will click on finish. Now if you observe this folder structure, the project which is created, see all the reference libraries to this particular Java have been created here. Now we are ready to create any kind of Java programs in this project. So now we have successfully done the second step of our installation, which is the Eclipse installation. After this, we need to install the Selenium. So again, let's go back to the browser and see what files we need to download to install Selenium. So let me go to my browser, and here I will be going to the seleniumhq.org. So if you're working with Selenium, this particular website, the seleniumhq.org, is going to be a Bible. Everything and anything related to Selenium is available in this website. Whether you want to download the files, whether you want to refer to the documentation, anything regarding to Selenium is available here. So what we want now is the installables for Selenium. So here, go to the download tab. Now, for you to install Selenium and start working with Selenium, there are three things which are required for you to download. One is a standalone Selenium server. So this is not required immediately when you get started with Selenium. However, when you start working with remote Selenium WebDriver, you would be requiring this. When you have a grid setup, you will be requiring the standalone server. So for that, what you can do is you can just download the latest version available here. So when you click on that, it will download the file into your download folder. So this is one particular file which you need to keep. Next, Selenium client and WebDriver language bindings. Now in today's demo, we will be looking at Selenium with Java. So that means my client package of Java is what I need to download. So whatever programming language Selenium supports, we have respective downloadables available with that. Say if you're working with Python, then you need to download your client library for Python. And since we are working with Java, you need to download this package. So simply what you need to do, click on this link and it will download the Java package for you, which are basically the jar files. So we have client libraries now, and then there is another component what we need. Now with Selenium, you're going to be automating your web browser applications, correct? And you also want your applications to run on multiple browsers. So that means your scripts, the automation scripts which you create, should be able to run on any browser. Selenium works with multiple browsers like Edge, Safari, Chrome, Firefox, and other browsers. Even it has a support for headless browser. Now every browser which it supports comes with its own driver files. Now say for example, we want to say work with Firefox driver. So that means for us to start working with Firefox browser, we need to download something called as a Gecko driver here. And if you want to work with Chrome browser, you need to install the Chrome driver. So depending on what browsers you'll be testing with, go ahead, click on each of this link and download the latest driver files. Now, since we are going to be working with Firefox in this demo, what I need to do is I just need to click here on the latest link. So when I click on the latest link, it is going to take me to this driver files. So driver files are specific to each of the operating system. So if you go down here, you will see there is a separate driver file available for Linux, for Mac, and for Windows. So depending on which operating system where you'll be running your test, download that particular driver file. And this is the driver file I need because we are working on Windows machine. So these are the three different packages which we need to download from the seleniumhq.org for us to install Selenium. So let me show you the folder where I have already downloaded all this. So if you see here, Selenium Java 3.141.59. Okay, this is nothing but our client library, which we saw here. Let's go back to the main page here. That is this. So once I download this, this is a zip file. After I unzip the file, this is the folder structure I see. And let's see what is there in this folder structure. So there are 2 jar files here. And then in the libs, there are multiple jar files. And we will need all this to work with Selenium. And then we also downloaded the driver files. So what I did was, after downloading those driver files for the browser, I created a directory here called drivers. And I've kept all my browser drivers here. So I have a driver file downloaded for Chrome. I want to work with Firefox. So I have a Gecko driver here. And then for Internet Explorer. That's it. So this is all we need. So once we have all this, what you need to do is go to your Eclipse. In the Eclipse, right click on the project which you have created and then go to the build path and say configure build path. Go to the libraries tab here. Now, do you see this JRE libraries here? This is what got installed first. And now similarly, we are going to add the Selenium jars to this libraries. And how do we add that? On your right, you can see this add external jars. Click on add external jars. Go to your folder where you have downloaded your Selenium, which is this. Select all the jar files which is available. So I have 2 jar files here. I'll just say click open. Again, I will click on add external jars. Now from the libs folder, I will select all this 5. So select all the 5 jars and click on open. So you should see all the 7 jar files here. So once you have this, just say apply and close. Now, if you look into your project directory here, you will see a folder called referenced library. And this is where you will see all the Selenium jars here. This is a very simple installation. In Eclipse, when you want to install Selenium, you just need to export all the jars of the Selenium into Eclipse. And now your system is ready to start working with Selenium scripts. Alright, so now let's just test our installation by writing a small Selenium test script. So for that, what I will do is, I'll go to the source folder, right click, new, and I'll say Java class. So let's name this as, say, first Selenium test. And I will select this public static void main and I will click on finish. Alright, so now let's create a use case. Say we want to launch a Firefox browser and then we want to launch the Amazon site. So these will be just 2 simple things which we will be doing in this test scripts. So for me to do that, what I usually do is I create a method for any functionality which I want to create here. So now I want to do a launch browser. So I'll create a method here called launch browser. Now, whenever you start writing your Selenium scripts, the first line what you need to do is you need to declare an object of WebDriver class. So here I'll say WebDriver driver. So now if you hover over this error, what it is showing, it says import WebDriver from org.openqa.selenium. So if you remember, when we installed the Selenium, we imported all these jars, right? So that means whenever we want to use a WebDriver, we need to import this class from these packages. So just go ahead and click on this import state. Done. Now next step. Now for us to launch a Firefox browser, it is a 2-steps process which is involved here. One is you need to set the system property and then you need to launch the driver. So let's do that. I'll say system.setProperty. So use this method set property. So this takes 2 arguments, the key and the value pair. Now what is the key I'm going to mention here? I'm going to be mentioning the Gecko driver and the path for the Gecko driver. Okay, because since I'm working with the Firefox. So in double quotes, I'll say webdriver.gecko.driver. This is my key. And the value is going to be, the fully qualified path for your driver files. And you know where we have kept our driver files. Let's go to that. Driver files in D:, I have Selenium tutorial. In installers, I have driver folder. Okay, so I'm just going to copy the complete path from here. Control C and I paste it here. Control V. Along with this, I need to provide the file name for the Gecko driver, which is geckodriver.exe. And let's complete this step. Next. So once I've set the property, I need to provide a command for launching my Firefox driver. And how do I do that? I simply use this driver object which I've created, driver equal to new Firefox driver. Again, similarly, the way we imported packages for WebDriver, we also need to import the package for Firefox driver. So just hover the mouse over that and select import Firefox driver. With these 2 statements, we will be able to launch the Firefox browser. And as I said in our use case, what is the next thing we want to do? We want to launch, say, Amazon.in website. For that, there is a command in Selenium which says driver.get and you pass the URL here. So for me to write the URL, what I usually do is I go to my browser, I open the website which I want to work with. In our case, it's amazon.in, and I just simply copy this fully formed URL, go to my Eclipse, and just paste it here. Now this ensures that I don't make any mistakes in typing out the URL. Let's complete this statement and we are done. And now in the main function, I'll just create an object of this and we will call this method. So I'll copy this class. First Selenium test, say obj equal to new first Selenium test. And now I'll say obj dot, this is our function, launch process. So let's save this and execute this. Control C, right click, run as Java application. Okay, so the Mozilla Firefox has been launched. Now it should launch your Amazon.in. Bingo. So Selenium installation on Mac is a 3-step installation. One, we need to install Java, which is a prereq, and then we need an IDE to work with. So we will be installing Eclipse and then we will install Selenium. And these are the versions of the installers which we are going to use. So we will be using Java 8, Eclipse version 4.10, which was released in 2018 December, and then Selenium version 3.14. So let's get started with our first step, which is the Java installation. So for us to install Java, let us go to our browser. And simply what I'll do is I'll just Google for Java 8 download. Okay, so we would select the Oracle site for downloading the SDE. Okay, so once you go here, you can see that we have something called as Java Software Development Kit 8U211. So this is the version we'll be working with. So in order for you to download, you need to have an Oracle account. So since I already have one, I have directly been logged into that. So if you do not have an Oracle account, please go ahead, create an account for yourself so that you can download any of the Java installers. Now let's go for and download our package. So I'll be downloading this package. For that, I need to click on Accept License Agreement. And then since we are going to be working on Mac, this is the package which I'm going to download. So let's go ahead and click on that. And now the download is going to start. However, we will not wait for the complete download to happen since I have already downloaded the package and I have kept it in one of my folders. So let me show you where that is. So let me go to my Finder. So what I have done is I have created a folder called installers, and all the software which we are going to require today for us to work with Selenium is what I have downloaded it and kept it here. So we'll go step by step so that you understand what each of these packages are. So as you see here, I have the JDK 8, which I've already downloaded. So let's go ahead and install JDK. So how do we install JDK? So you have the DMG file here. You just go ahead and double click on that. Okay. And then I'll double click on this package. And then we will say continue and install. So it's going to ask me for my password. Okay. I've given my password and I'll say install the software. Probably it will just take a couple of minutes to install Java. Okay, there you go. So now the Java has been installed. So let me close this window. Let me close this window too. And then now I'll go to my terminal window. So let's open my terminal. And here, let's say Java minus version. Bingo. So there we have Java 1.8 installed on our system. Now, there are a couple of other things which you need to do. Apart from installation of your JDK, you also need to set some system variables, right? So in Mac, how do you set the system variables or the environment variables? You do that in your bash profile. So let's see how we do that, all right? So what I will do is, I'll use an editor, which is my VI, okay? And then I'll open my bash profile. So what is bash profile? It's a config file for your bash shell. This is mainly used to export variables in your shell. Like in Windows, we are going to do the system variable setting from the advanced setting, right? So similarly, we are going to do that here. So I'll say vi dot bash underscore profile. So this is the file where I will be adding Java home path. Okay. Now I have other paths here already written because I'm working with other multiple software on this machines. And now I'll go to the end of this file and I'll say export Java home equal to. Now what is the path we need to give for Java home? We need to give the path where the Java has been installed on your system. Okay, first let's go and find out that path. So let's go back to our Finder and then I have a folder called library here. So here there is a Java, and then there is something called as Java virtual machines. So if you have a single Java or multiple Java versions installed, so all those versions you're going to see under this directory, which is Java virtual machines. And Java 1.0 is what we installed just now. So let me go and open that folder. There is something called as content and then home. And in this you have your JRE and bin folder. So that means I need to give my Java home path until here, till this home directory. So simply what I'm going to do is, I'll just go here, say get info, because I want to just copy the path. And what you can do is, you copy this path, okay, and then go back to your shell, and here I'm going to paste this path, plus I want it till the home directory. So I'm just going to type out HOME home. That is it. So you have now set your Java home environment variable. So simply you do save the file, escape:\wq and come out of it. And now what you need to do for this bash profile to be activated, you just exit out of this terminal. Okay, close this terminal window, and I'll go ahead and open another terminal. So let me close this info text. So here, let me again give Java -version. Okay, so everything seems to be working fine. So this completes our Java installation. Now your system is ready and you have your Java up and running. Other thing which you also can do is go to your system preferences. Okay, here you will see this Java control panel. Okay, this is another way of finding out that your Java has been installed successfully on the machine. So you can just open this Java control panel, and if there is any settings which you want to do here, you can do it through your control panel also. Alright, let's close this. Let's minimize this window and this folder windows. So we have successfully done our step 1. So what's our step 2? We need to go ahead and install the Eclipse. Now same thing what I will do, I'll go to my browser, okay, and now I'll open another tab here and I'll say Eclipse download, and we'll go to this eclipse.org. Now here, whenever you're going to do this installation, you will see the latest version appears here. My recommendation to you is, if you're working first time, instead of working on the latest version available, I would suggest that you work with the last stable version. And that's exactly what we are going to do today. So for me to go to the previous versions, I just need to go here on this download packages, click on it. Okay, so once you click on that, on this page, if you scroll down, you will see something called as more downloads. Right? In this, you will see all the builds of Eclipse which is available, all your previous versions. So since today I'll be working with 4.10 version, I will go ahead and click on this 4.10. This 4.10 was released last year, this is 2018 December. Okay, and now when you look at this installer, you have multiple packages available here. So depending on your need, you can choose which package you want to work with. So today for our demo, what I would be using is Eclipse IDE for Java developers. So since we are going to be working on Mac, I will go ahead and click on this downloadable. And then I'll click on this download, which is going to download this particular file for me. I've already downloaded this file and kept it in my folder. Let's go to my folder. Okay, it's not opening, so let me click from here. And then let's go to our Selenium demo folder, and in that installers. Okay, so now do you see this? Eclipse Java 2018-12 R blah 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 .dmg. So this is the file which we are going to be using to install Eclipse. Now as simple as what we did for JDK, I'm going to double click on this and install the Eclipse. So let's see how the Eclipse gets installed. Alright, so now I'll just move this folder into applications. Done. So my Eclipse is ready now. So simply let's go ahead and launch. So what I'll do, I'll just simply search for that on my system. Eclipse, there you go. And I'll just double click this. It's an application downloaded from the internet. Are you sure you want to open it? Yes, please go ahead and open it. Okay, it is launching it. So did you see how simple the Eclipse installation is? It's just downloading the package and just installing it on your Mac machine. Alright, when you start the Eclipse for the first time, you need to set your workspace. So workspace is place where you're going to keep all your folders, all your Java code or whatever you're going to do in Eclipse, all under that particular directory. So right now it gives me a default directory. Rather, what I will do is, since I have created a separate folder for our demos, I will go ahead and select that folder, which is my Simply Demo. And then in this, I will add a folder called Workspace. Okay. So that means in this particular location, whatever files I'm going to create, whatever code I'm going to write in Selenium is going to be stored at this location. And then I'll go ahead and say launch. So it will take a minute to load your workbench. Yeah, there it goes. So when you launch your Eclipse, right? So let me just make this window bigger. The first screen, what you're going to see is the welcome screen. Okay. Just go ahead and close the welcome screen. And this is the first view of your Eclipse, what you're going to get. So let's close out all the windows which we are not going to be working today. And I just need this main screen here. Now, what is the first step you're going to do once you have the Eclipse? I would go ahead and create a project first. So I'll simply say open file new Java project. Let's give a nice name to this since this is our first project which is going to be created. So I'll say Selenium first project. Now, if you observe here, so we have a JDK already installed and Eclipse needs a JDK to work with. And what it has done while I create my new project, it has already given me an option to use the execution JRE which you already have in the system. Okay? That's why it has already chosen Java 1.8. In case you have multiple Javas installed, in that case, what you can do is you can always go here, select this and select the Java of your choice. So say if you have got the latest Java, which is Java 12 installed on your system, it will give you an option here along with Java Software 8, it will give you Java 12 here. So you can go ahead and select that for this particular project. That option is also available. Now since we have only one JDK installed here, I will go ahead and create this project. So I'll just click on finish and it's going to create a project from me. So there are a few default things which it gets created. One is definitely the JRE system libraries, right? This is what we told Eclipse when we created project that my Java is 1.8. So what it has done is it has imported all those jar files which it requires for our Java programs to work in our Eclipse IDE. And then it creates a SRC, which is your source directory, wherein we'll be creating all our Java code or our Selenium test scripts. Okay, good so far. So this is a simple way of installing your Eclipse and getting your Eclipse ready to work with your Selenium. Alright, so now let's go back. So we have done the installation of Java, we have done the installation of Eclipse. Now what's left? Just the Selenium. Right. So what is that we need for Selenium? Let's go back to our browser. Okay. And this time we will go to seleniumhq.org. So this is going to be a Bible for you if you're going to be working with Selenium. So in this website, what I do is I go to downloads. And there are two things which we need to download for us to work with Selenium. One is the Selenium standalone server. Right? So when you're going to be working with remote Selenium WebDriver is when you would require this. However, I would suggest that we download whatever is required for us, even though we might not use it immediately. So what I just need to do is I need to click on this and it's going to download this server for me. Okay? So I have already downloaded it and I'll show you that. And then what we need is the Selenium client and WebDriver language bindings. Okay, we need a client. So what is the client which you are going to work in? We are going to working with Java client with the Selenium. And for that, I need to go ahead and download this. If you're working on say C# or Ruby or Python, then you have the respective packages which you can go and download. Now, since we are going to be working with Java here, I would go ahead and click on this and this is going to download the Java client for me. Now, as I said, since I've already downloaded it, so let's go ahead and look at what are those downloadables, what we have. So let's close out this window. Now, if you see here, one is the Selenium server standalone, which we just downloaded. And then when you download the client libraries, what it does, it creates a zip file. It downloads a zip file and it unzips it. And what is contained in that particular folder? So if you look here, Selenium Java 3. In this folder, you have multiple jar files, with which is what we'll be working with Selenium. Okay. So here you have two jar files here, and then under the folder libs, you have other jar files. Now these are the files which we will need. And now let's see how do we utilize this file in our Eclipse. So for that, let's go back to our Eclipse. Okay. So let me maximize this window. So in Eclipse, first thing what you need to do is click on your project. Okay. Right click on that. And then you have something called as build path. Go to the build path and say configure build path. Now here in this configure build path, what you need to do is go to your libraries, okay, go to add external jars. Now when you click on that, this is where you need to select all your jar files from what you have downloaded from the Selenium site. So that is present in our Selenium Java 3. So what I'll do, I'll simply select these two first, okay. Then again you click on the external jar files. So what we have is in libs. So select all the jar files in the lib, say open. Okay, you have all the jar files what we need identified here. Go ahead and click on apply and close. Once you do that, how do you know whether all those jars have been imported correctly? Go to the reference libraries. Here you should be able to see all the Selenium jars which we have downloaded to be listed out here. And so it lists here. So that means we have successfully imported Selenium. To test our installation, let's go ahead and write a small test script. So for that, I'll go to my source folder, right click, new, and we'll create a Java class. So let's name it Selenium first test. And I will also use a public static void main here. And I'll click on finish. Let's remove all these comments here which we do not need. So before even we write a first line of code, first what we need to do is create an object of WebDriver. So I'll say WebDriver driver. Okay. So now if you see this error, it asks us to import this particular WebDriver class from a package. And that package is org.openqa.selenium. Okay. So now you can see this import statement. Now let's go ahead and write our test case. Now for this test case, what we will do is we will simply launch a browser, say Firefox browser, and we will also launch a website. Now I'll create a method for that. I'll say public void launch browser. So if you have looked at our previous videos on Selenium WebDriver basics, I have explained there that every browser which you want to work with in Selenium comes with its own driver. And this driver is what we need to download from the website of Selenium. And I'll show you how to do that. So if we go to that seleniumhq.org, under the downloads tab, if you go down, you will see something called as third-party drivers, bindings and plugins. So all the browsers supported by Selenium are listed here and their corresponding driver files are available. So now since we are going to be working with Firefox in this demo, I will go ahead and click on this latest release of Mozilla Gecko driver. So Gecko driver is the one which we'll be using for launching our Firefox. So just click on this and this will take you to the latest version of the Gecko driver available. So just scroll down and depending on the OS which you're working with, in our case it is a Mac OS. So just click on this file and download this file. Similarly, say if you are working with the Chrome driver, what you need to do is go to this Chrome driver, go to the latest, click on that and select the release which you want to work with and just download it. Now I've already downloaded this file and I'll just show you where they are. Alright, so in this directory, which is my installers directory, I have another directory created called as drivers. And what I do is usually I keep all my driver files under this folder. Okay, so I have a Chrome driver and Gecko driver already downloaded and kept here. Now let's go back to our code and see what is that we need to do to launch our browser. So there are two steps which we need to do for launching any browser which you want to work with. Right? First is you need to set a system property. So for that, what I do is system.setProperty and this accepts a key and value pair. Now key for this is Gecko driver is what I need to provide here. And now that is in the quotes because it's a string argument. I say WebDriver dot Gecko dot driver. And the value is nothing but the path to your Gecko driver which you have just downloaded. Okay, let's go to my Finder. So that's here. So what I do is I simply right click on this file, get info, and I copy this complete path. Go to my Eclipse, paste this path here, and then the file name, which is Gecko driver. Done. So this sets a path to my Gecko driver. Now next step is actually launching the web browser. And how do I do that? I say driver equal to new Firefox driver. Now we need to do the same thing again. We need to import this class. So I say import Firefox driver. Alright. So now with these two steps, what we do is we simply launch the Firefox browser. And then let's go ahead and also launch a website, say amazon.in. So for that I have a command called driver.get, which accepts a URL. Now this URL needs to be a fully formed URL. So for that, what I do first is I go to my any browser, I launch the amazon.in website, okay, and then I copy this complete URL, go to my Eclipse and just paste it here. That's it. We are ready to launch the browser and launch amazon.in. So let's quickly create a class here, object here of this class. So Selenium first test, obj equal to new, Selenium first test, done. And then I need to call the method, which is launch browser. Okay, so now I save this file, I do a right click on this and I say run as Java application. Now this should launch our browser, okay, which it just did, and then it should take us to amazon.in. Bingo, there goes our first script. So we have successfully executed our first script. So that means your Selenium is up and running.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GetTech postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of prime DevOps professionals. Click the link in the description box to unveil the wonders of this course.
The first understanding that what exactly is in Gradle all about. Now Gradle is a kind of a build tool which can be used for the build automation performance, and it can be used for various programming languages. Primarily it's being used for the Java based applications. It's a kind of build tool which can help you to see that how exactly automatically you can prepare the builds, you can perform the automations. Earlier we used to do the build activity from the Eclipse, and we used to do it manually, right? But with the help of this build tool we are going to do it like automatically without any manual efforts as such here. There are like a lot of activities which we will be doing during the build process. Primarily there are different activities like compilations, linkage, packaging. These are the different tasks which we perform during the build process, so that we can understand that how the build can be done and we can perform the automations. This process also, it's kind of standardized, because again if you want to automate something, standards or a standard process is something which we require for that before being going ahead with that part. So that's the reason why we are getting this build tool, because this build tool helps us to do a standardization process to see that how the standards can be met and how we can proceed further with that part. Also, it's something which can be used for a variety of languages, programming languages. Java is the primary language for which we use the Gradle, but again other languages like Scala, Android, C, C++, Groovy, these are some of the languages for which we can use the same tool. Now it's actually using, like, it's referring to as a Groovy based domain specific language rather than XML, because Ant and Maven, these are the XML based build tools, but this one is not that dependent on XML. It's using the Groovy based domain specific language. DSL language is being used here. Right now, again, it's something which can be used to do the build. It can further on be used to perform the test cases automations also there, and then further on you can deploy to the Artifactory also, that okay, I want to push the artifacts to the Artifactory, so that part also you can get it done over here. So primarily this tool is known for doing the build automations for the big and large projects, the projects in which the source code, the amount of source code and the efforts is more. So in that case this particular tool makes sense. Now Gradle includes both the pros of Maven and Ant, but it removes the drawbacks or whatever the issues which we face during these two build tools. So it's helping us to remove all the cons which we face during the implementation of Ant and Maven, and again all the pros of Ant and Maven is implemented with this Gradle tool. Now let's see that why exactly this Gradle is used, because that's a very valid question, that what is the activity, like what is the reason why we use the Gradle. Because the first one is that it resolves issues faced on other build tools. That's a primary reason, because we all already having the tools like Maven and Ant, which is available there. But primarily this Gradle tool is something which is removing all the issues which we are facing with the implementation of other tools. So these issues are getting removed as such. Second one is that it focuses on maintainability, performance, and flexibility. So it's giving the focus on that how exactly we can manage the big large projects, and we can have flexibility that what different kind of projects I want to build. Today I want to build in different ways, tomorrow the source code modifies, gets added up, so I have the flexibility that I can change this build scripts, I can perform the automations. So a lot of flexibility is available which is being supported by this tool. And then the last one is like it provides a lot of features, a lot of plugins. Now this is one of the benefit which we get in the case of Maven also, that we get a lot of features. But again, when we talk about Gradle, then it provides a lot of plugins. Like let's say that normally in a build process we do the compilation of the source code, but sometimes let's say that we want to build an Angular or a Node.js application. Now in that case we may be involved in running some command line executions, some command line commands, just to make sure that yes, we are running the commands and we are getting the output. So there are a lot of features which we can use, like there are a lot of plugins which is available there, and we will be using those plugins in order to go ahead and in order to execute those build process and doing the automations. Now let's talk about the Gradle and Maven, because again, when we talk about Maven, like it was like something which was primarily used for the Java, but again when we are talking about Gradle, so again it's just being used primarily for the Java here. But what is the reason that we prefer Gradle over the Maven? So what are the different reason for that? Let's talk about that part, because this is very important. We need to understand that what is the reason that Gradle is preferred as a better tool for the Java as compared to Maven when we talk about for the build automation here. Now the first one is that the Gradle using the Groovy DSL language, domain specific language, whereas the Maven is considered as a project management tool which is creating the POMs or XML format files. So it's being used for the Java project, but XML format is being used here. And on the other hand, Gradle is something which is not using the XML formats, and whatever the build scripts you're creating, that is something which is there in the Groovy based DSL language. And on the other hand, in the POM we have to create the XMLs, dependencies, whatever the attributes you're putting up in the Maven, that's something which is available there in the format of XML. The overall goal of the Gradle is to add functionality to a project, whereas the goal of the Maven is to to complete a project phase, like to work on different project phase, like compilation, test executions, then packaging, so then deploying to Artifactory. So these are all different phases which is available there into the Maven. But on the other hand, Gradle is all about adding the functionality, that how you want to have some particular features added up into the build scripts. In Gradle, there are, like, we usually specify that what are the different tasks we want to manage. So different tasks we can add it up into the case of Gradle, and we can override those tasks also. In case of Maven, it's all about the different phases which is being happening over here, and it's in sequence manner. So these phases happens in the sequence order, that how exactly you can build up the sequence there. But in case of Gradle, you can have your own tasks, custom tasks also, and you can disrupt the sequence, and you can see that how the different steps can be executed in a different order. So Maven is something which is a phase mechanism there, but Gradle is something which is according to the features or the flexibilities. Now Gradle works on the tasks, whatever the task you want to perform, it works directly on those tasks there. On the other hand, Maven is something does not have any kind of inbuilt cache, so every time you're running the build, so separate things or the plugins and all this information gets loaded up, which takes definitely a lot of time. On the other hand, Gradle is something which is using its own internal cache, so that it can make the builds a little bit faster, because it's not something which is doing the things from the scratch. Whatever the things is already being available in the cache, so it's just pick that part, and from there it will proceed further on the build automation. And that's the reason why Gradle performance is much faster as compared to Maven, because it uses some kind of a cache in there, and then helps to improve the overall performance. Now let's talk about the Gradle installation, because this is a very important aspect to be done, because when we are doing the installation, we have to download the Gradle executables. right? So let's see that what are the different steps is involved in the process of the Gradle installation. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the Open JDK or you can go for the Oracle Java, so you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly used nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output that whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably, in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one, right? Now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part and on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see like we will give this path here. There is 2 environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle_home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these 2 variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd Java version to check the version of the Java, and then the Gradle underscore version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it shows that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation performed into our particular system. So let's go back to the content. Let's talk about the Gradle core concepts here. Now in this one, we are going to talk about what are the different core concepts of Gradle are all about. The very first one is the projects here. Now, a project represents an item to be performed over here, to be done, like deploying an application to a staging environment, performing some build. So Gradle is something which is required. The projects, the Gradle project which you prepare is not having multiple tasks which is available there, which is configured, and all these tasks, all these different tasks needs to be executed into a sequence. Now sequence is again a very important part, because again if the sequence is not met properly, then the execution will not be done in a proper order. So that's the very important aspect here. Tasks is the one in which is a kind of an entity in which we will be performing a series of steps. These tasks may be like compilation of a source code, preparing a jar file, preparing a web application archive file, or a ER file. Also we can have, like, in some tasks we can even publish our artifacts to the artifact tree so that we can store those artifacts into a shared location. So there are different ways in which we can have this particular tasks executed. Now build scripts is the one in which we will be storing all this information. What are the dependencies, what are the different tasks we want to refer. It's all going to be present in the build.gradle file there. Build.gradle file will be having the information related to what are the different dependencies you want to download and you want to store there. So all these things will be a part of the build scripts. Now let's talk about the features of Gradle. What are the different features which we can use in case of Gradle here. There are different type of features which is available there. So let's talk about them one by one. So the very first one over here is the high performance. Then high performance is something which we can see that we already discussed, that in case you are using a large projects, so Gradle is something which is in better approach as compared to Maven because of the high performance which we are getting. It uses an internal cache which makes sure that you are using, like, you are doing the builds faster, and that can give you a higher performance over there. Second one is the support. It provides the support. So it, yes, definitely provides a lot of support on how you can perform the builds, and it's being the latest tool which is available there. So the support is also quite good in terms of how you want to prepare the build, how you want to download the plugins, different plugin supports, and the dependencies information also there. Next one is multi-project build software. So using this one you can have multiple projects. In case in your repository you have multiple projects here, so all of them can be easily built up with the help of this particular tool. So it supports multiple projects to be built up using the same Gradle project and Gradle scripts. So that support is also available with this Gradle build tool. Incremental builds are also something which you can do with the help of Gradle. So if you have done only the incremental changes and you want to perform only the incremental build, so that can also be possible with the help of Gradle here. The build scans, so we can also perform the build scans. So we can use some integrations with SonarQube and all, where we can have the scans done to the source code on understand on how the build happens or how the source code really happens on there. So that code scan or the build scans can also be performed with this one. And then it's a familiarity with Java. So for Java, it's something which is considered as an by default. Not even Java, in fact Android, which is also using the Java programming language, is using the particular Gradle over here, so that the build can be done and it can gain benefits out of that. So in all the manners, in all the different ways, it's basically helping us to see that how we can make sure that this tool can help us in providing a lot of features, and that can help us to make a reliable build tool for our Java based projects or any other programming based project here. Right, now let's see that how we can onboard a Java project with the Gradle here, and for that we have to go back, and Gradle is something which is already installed. We just have to create a directory where we can have, like, how we can perform some executions, we can prepare some build scripts, and we can have a particular execution of a Gradle build happened over there. So let's go back to the machine. Okay, so we are going to open the terminal here and we'll see that how we can create it. So first of all, I have to create a directory structure. Let's say that we'll say like Gradle -project. Now once the project is created, so we can go inside this directory, so to create some Gradle related projects and preparing the files. Now in this one, let's first create a particular one. So we will be saying like vi build dot Gradle. So in this one we are going to put like two plugins we are going to use. So we are going to say like apply plugin Java, and then we are going to say like apply plugin application. So these two plugins we are going to use, and when we got this file over here in this one, so it shows like build.gradle, which is available there in this case. So two these files are available. Now if you want to learn like what are the different tasks, so you can run like Gradle tasks command over there. So Gradle task will help you know that what are the different tasks which is available over here by processing the build scripts and all. So this will definitely help you to understand on giving you the output. So here all the different tasks are being given, and it will help you to understand that what are the different tasks you can configure and you can work over here, just like jar files, clean and all that stuff, build, compile, then init is there, then all these different executions, assemble, then Java doc, then build, then check, test, all these different tasks are there. And if you really want to run the Gradle build, so you can run like Gradle clean to perform the clean activity, because right now you are doing like a build, so before that you can have a clean, and then you can run a specific command, or you can run the Gradle clean build, which will perform the cleanup also, and it will at the same time will have the build process also performed over there. So build and cleanup both will be executed over here, and what is the status, whether it's a success or it's a failure, that will be given back to you. Now in this case, in the previous one, if you see that when you ran the Gradle clean, it was only running one task, but when you go for the build process, when you run the Gradle clean build, it's going to give you a much more information. In fact, you can also give me further information, like you can have the -info flag also there, so that if you want to get the details about the different tasks which is being executed over here, so that also you're going to get over here in this one. So you just have to put like -info, and then all these steps will be given back to you, that how these tasks will be executed and the response will be there. So that's a way that how you can create a pretty much simple straightforward project in form of Gradle, which can definitely help you to run some couple of Gradle commands, and then you can understand that what are the basic commands you can run and how the configurations really works on there, right? Let's go back to the main content. Right, now let's move on to the next one. So in the next one we are going to see that how we can prepare a Gradle build project in case of Eclipse. Now we are not using the local system, we are not directly creating the folders and the files here, we are actually using the Eclipse for creating a new Gradle project over here. So let's move on that part. Okay, so now the Eclipse is open, and I have opened in this one. The very first thing is that we have to do the Gradle plugin installation so that we can create new projects on Gradle, and then we have to configure the path, that how the Gradle plugin can be configured on the preferences and all that stuff, and then we will be doing the build process. So the very first thing is that we have to go to the Eclipse marketplace. In there we have to search for Gradle. So once the search is done, it will show us the plugins related to Gradle. So we have to go for build ship Gradle integration. So we'll click on the install. It will proceed with installation. It will download it. In some cases, maybe it's part of the Eclipse as in the ID. So you can go to the installed tab and you can see that also, that if this plugin is already installed or not. But in this case, we are installing it. And once the installation is done, we just have to restart the specific ones. We have to restart this Eclipse so that the changes can be reflected. So it's downloading the Gradle here, and once that is installed, we will be able to use it over here in this case, in this scenario. So we have to just wait for that part. So still downloading the jar files. So once the jar file is done, it's now over the areas and downloaded. So after that, we will be able to proceed further on that download aspect. So it's going to take some time to download it, and once it's done, we will be able to proceed further. Now once the progress is done, so it's asking us for the restart now. So before that, we just have to click on restart now, and then the Eclipse will be restarted altogether again here. So you can do it manually, or you can go for that options. It just require a restart so that the new changes can be reflected over here. So the plugins can be activated and can be referenced here. Now we have to just put up like the the configuration where we can have the system. So we can go for the Gradle configuration. So we can go for Windows and then preferences. Now in this case we have to go for the ones in which the Gradle option is available there. So Gradle is what we are going to select. Now user home, the Gradle user home is what we need to use, right? So you want to go for the Gradle, you want to go for local installation. So all these options you can use. You can, if you go for the Gradle wrapper, then it will be downloading the Gradle locally, and it is going to use the Gradle W or Gradle W.bat file. But if you already have an installation locally, so you can prefer that also, right? Now in the previous demo we have already got the Gradle extracted, so we just have to go for the downloads. In the downloads already Gradle is available, so we are going to select that part here. So this is what we are going to select, right? So this represents that this is the directory structure in which we are having the mechanism. So you can either go for the build scan, so you can select the build scan also. So once this is enabled, then all the projects will be scanned and will be published, and it's in kind of additional option which is available. If you really want to disable it, you can disable it also, and you can go with this configuration also. So this is where the particular Gradle folder is being put over here in this case, and then we have to just click on apply, and we just have to click on apply and close. So with this one, the particular execution is done. Now we will be going for the project creation, so you can right click over here, or you can go to the file also. So here we are going to go for the job project, and in this we are going to have a Gradle project. So Gradle project is what we are going to create here. And next, so we are going to say like Gradle project, and then next. So once that is done, so finish. So with this one, when you create the project, so what will happen that automatically there will be a folder structure will be available there, right? And there are some Gradle scripts which will also be created there. So we will be doing the modifications to there, and we'll see that how the particular Gradle build script looks like, and how we will be adding some couple of Selenium related dependencies, and we'll see that how we can have more and more dependencies added, and what will be the impact of those dependencies on the overall project. So that also it's very important aspect to be considered. So let this processing be happen over there. It's just creating, and some plugins and binaries are getting installed and getting downloaded. So we'll see that once the project is imported, completely executed over here and got created, we can extract that. Now if you see here, the particular option is available about the Gradle tasks, so you can extract it also, and you will be able to know that what are the different tasks which is available there. Let's see that in the build they are running like build. These are the different tasks which is happening inside the build process. So Gradle executions will be also available over here in this case, and Gradle tasks will be different. It will be represented over here in this one. So you just have to extract on the Gradle build project. Okay, so this is the library which is available. Now what happens that you will be able to have like settings.gradle. In this one you will be able to have like, okay, Gradle -project is something which is available there in this one, so that's what I'm being referring. Then we have over here as in these folder structures which is created like source, main, Java. This is the one. Source, test, Java is the one which is available as in the folder structure, and source, test, resources are also available here. So the main source, main, resources are also available. Now in this case, what happens that these are the dependencies, project and external, these are the different dependencies are available there. So let's see, let's add a dependency over here in this one in the build.gradle script, and see that how we can do that. If we open build.gradle file, so you can see that these dependencies are there, like test implementation, JUnit is available there, right? And then we have a implementations of this one which is available. Now these jar files when you put up, it will automatically be added up as in part of this one, as in part of the particular dependencies over here, and which means that you don't have to store them as an within the repository, and automatically they can be happened over there. So let's open a dependency page. So we will be going to MVN repository, where we will be opening a dependency link. So this is the dependency link here. So selenium-java is available, and it can give you the dependency for all the different options. Now we have for Maven, this is the one, and for Gradle, this is the one here. So we have to just copy this one, and we have to use it as a dependency. So this is the group, and this is the name and the version which we are using here. Now we have copied this one, so we will go back to the Eclipse. So here we have to just put that dependency, and we have to just save it. So this is something which is providing like Selenium dependencies which is available. So now we have to just refresh the project. So right click over here, then you will be able to see the options in the Gradle saying that refresh Gradle project. Now once the moment you do that, so you will be able to do, like, for the first time maybe it will take some time to download all the dependencies which is related to Selenium, but after that you will be able to see like the dependencies will be simply added up over here in this case. So you can see that all the Selenium related dependencies are added up. For any reason, if you comment these ones and you say like synchronize again, so you will see that all the dependencies which you are adding up from this Selenium from the Selenium perspective will be gone back again. So this is the way that how you can keep on adding the dependencies which is required for preparing your build for your source code, and from there you will be able to proceed further on the execution part. So that's the best part about this Gradle here. So that's a way that how we are going to prepare a Gradle project within the Eclipse, and now you can keep on adding like the source code in this one, and that's the way that how the code base will be added up over here. Right, so that's the way that how the particular executions or this Gradle project is being prepared in case of Eclipse, or the zip file gets downloaded. So you can add the environment variables, and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output at whether the Java is installed into your system or not. So in case my system, the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one. Right now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded, we have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see, like, we will give this path here. There is two environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle_home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these two variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd Java version to check the version of the Java, and then the Gradle_version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it shows that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation. As part of the installation of JUnit, you don't require to install any exe file or any kind of program there. There are a couple of jar files which is required, which needs to be there into the class path, so that every time when you write some JUnit test cases, you should be able to refer those jar files, because without having those jar files into your class path of your project, you will not be able to run the JUnit test cases. So that's the only dependency you require. If you are running a Maven build, then these dependencies will be added up into the pom.xml file. If you are referring or doing the build from the Eclipse or doing the development from the Eclipse, then you have to put up these jar files into the class path of the project, so that these jar files can be loaded up and the JUnit can be referred over here. So the installation is pretty straightforward, but let's see like what are the different steps we need to follow. Now, as a prerequisite of understanding the demo about JUnit, the first initial two things is like you require a JDK to be installed. Now you can download the JDK 8 over here from this Oracle website, and this is something which you can download for the Windows or whatever platform you have. You can pretty much install it for whatever platform is there. So for Windows platform, you can download for 32-bit and 64-bit both option over here. And once it's installed, so you should be able to use the Eclipse latest tool. Now all you need to do is that you need to go to eclipse.org, and there you can download the latest version of the Eclipse. Now these two main things which you require, because Eclipse will be required for creating the JUnit test cases, and of course a kind of IDE where you can run some test cases, JUnit test cases and all. And then Oracle is something which is required as a runtime for running the JDK also, and the JUnit test cases also, and Eclipse here. So that's a prerequisite which we got over here in this one. So I have already got these two things installed into my system, and I have Eclipse there. So let's move on to the Eclipse and see that how it goes on there. But before that, you also require the JUnit jar files, because in order to have a particular JUnit framework loaded up, we require some particular files, jar files over here in this case. So I can just search for JUnit 4 over here, and when you search for JUnit 4, so what happens, like this particular page will help you or give you all the details about the JUnit 4. Now you can go for the version notes of the different versions, but if you want to download, all you need to do is like you can say like download and install, and the moment you go there, so it will give you the details. Now there are two jar files which is required. JUnit.jar file is required over here. hamcrest-co.jar file. These two jar files are required here if you want to download it into the test class path. If you feel that you want to use a Maven based project, then in that case you have to specifically go for this dependency into POM file, and according to that, that particular version will be downloaded and will be referred over there. So these are the ways that how you can get the particular softwares, the required things into the place. So I'm going to put up these jar files into a location so that I should be able to get the particular details stored, and I can refer to them into my Eclipse. So I'm going to download this one here from the Maven Central. So I'm going to download this jar file, and then I'm going to go back hamcrest-core, so that also I want to download. Download jar. So these two jar files I have downloaded, and I will be referring these ones into my project because these are the ones which is being required into my project as such. So let's go back to the Eclipse and let's place these jar files into a location so that into my class path I can refer the complete folder with all these two jar files inside that. So let's go ahead with that. So let's create a particular new project over here. So we'll go for new Java project, and here I can give it like a simple one. A simple project name I can provide here, and JDK I'm using like 1.8, so that's the JDK version which I have utilized over here, and then finish. So this is the project which I have got like in the source directory. Now I'm going to create a simple file over here, a new class file over here. So I'll create it like JUnit class. So I'm going to create a class over here in this one, and of course I need to have a particular void main also over here in this specific class over here, because this is the initial class I'm trying to create over here in this one. I can create a custom particular methods also over here, but let's see like if we can execute or we can run some particular functions as such over here. Now I'm going to declare a function over here, public void JUnit method. So I'm just going to create a method over here. I'm just going to run a particular print statement over here. Executing JUnit test cases. Right now this is a kind of a method which is there, which of course I can run into my public void main, and this function will be executed, will be called upon over here. Now the thing is that right now since it's just a normal function, but the moment I convert it, like I have a @test mentioned over here, so what will happen, like this will be converted into the form of a test cases. Now of course, like right now there is no imports which is available there as part of this one, so you can see that the time I have added this annotation @test, I will be able to see like yes, add JUnit4 library to the build path is something which is coming up over here, or it's saying like add JUnit5. So whatever the library you feel that you want to add, you can do that, and that particular library will be added up over here. Now let's go for the JUnit4 library here. The moment I do that, what will happen, you will see some changes. First you will see the changes in the top saying that import org.junit.test. That's a first import, and second import will be like JUnit4. You will see like these two jar files is automatically being picked up by the Eclipse. Now even if you don't download these jar files, this is the main benefit of the Eclipse, that these are already a part of the plugins. You can see their paths, that these are already installed in the.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
plugins directory. So the moment you use these particular methods that you want to use the JUnit, these will be automatically imported over here into your system. Now you can just simply call this method into the main void main, and then the specific method will be executed as a form of test cases. So this is the mechanism that how you will be setting up the project. Initially you got the imports, you got the particular annotations configured, and with that the specific jar files will be automatically being added up into your class path. Whatever the jar files we added up, we downloaded previously, we can also have that added up into the custom class path. We can modify this build path of JUnit 4 which is coming up automatically. We can just simply say right click, build path, and configure. So this JUnit 4 we can actually import, we can remove it from our system, and we can add our external jar files also into the build path or the class path over here. So that depends upon you, that how you want to perform the customizations around that part. But yes, the particular main benefit of using the Eclipse is that it's already having the JUnit plugin installed. Both 4 and 5 version is installed. Whatever version you feel that you want to include, it will be included, and the plugins are already installed, so you don't even have to download the jar files manually. So that's how you will be able to do a very basic initial setup of JUnit, and how a basic project can be created over here in case of JUnit.
JMeter or Apache JMeter is an open source software which is a 100% pure Java application. The application is designed to load or test functional behavior and measure performance. Performance testing means testing a web application against heavy load, multiple and concurrent user traffic. It was originally designed for testing web applications but has since expanded to other test functions. To simplify, let's assume that someday your team lead tells you to perform performance testing of some website like google.com or facebook.com for around 100 users. What would be the first thing that comes to your mind? Do you think it's practically possible to arrange 100 people with computers and access to the internet and accessing the same website? Now just imagine the infrastructure requirement when this testing has to be done for 1,000 or 10,000 users. This is when a need for software like JMeter arises. So what JMeter actually does is that it simulates. It will simulate real user behaviors and perform load tests on a server, group of servers, network, or object. Moving further, let's have a look at the prerequisites to install JMeter. The only prerequisite of installing JMeter is that Java must be installed in your system. Since JMeter is an entirely based application, that's why having Java installed in your system is a must. Other than that, JMeter can be used in many operating systems such as Linux, Windows, Mac OS, or even Ubuntu. Now that we know the basics of JMeter, let's go on to installing JMeter onto our system. First, let's check if you have Java installed in your system. For checking that, we shall go to the command prompt and type java-version. We can see that Java is present in our system. Here, it will show the version of Java present in our system. The next step is to download JMeter. Go to Google Chrome and type JMeter download. Now go to the official Apache JMeter website and go to the binary sections. In the binary sections, we shall download the zip folder. Once the zip folder is downloaded, open the folder location. Then extract the zip folder. Once the folder is again extracted, go inside the folder and go inside the bin folder here. The bin folder contains the JMeter script file for starting JMeter. Now it's time for us to launch JMeter. But before we launch JMeter, we need to know that there are typically two types of modes in which JMeter can be launched: the GUI mode and the non-GUI mode. The non-GUI mode may refer to two types, the first being running JMeter in the server mode, and the second refers to running JMeter in the command line. And if we talk about the GUI mode, then the GUI mode has a limitation which slows down the CPU utilization while running the recorded script. But GUI mode of JMeter is perfect for adding and editing new configuration elements, thread groups, and samplers, as a result of which you can view a number of different listeners helping for debugging. Here, today, we shall be using the GUI mode. So to open the GUI mode, inside this bin folder, select the jmeter.bat file. Double click on this file. This may take a while and then the JMeter window will open up on the screen. The home window is divided into two sections. On the left side, all the elements of the test plan are added, and on the right side, all the configuration of that element are added. As we see on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, listeners, and everything will be stored here. So, moving forward, let's rename this test plan. Let's name the test plan to be first JMeter. Now, when you click outside this window section, you can see the element name will change. Otherwise, you can just save this and also the name will change. Now, when this is done, the next step is to add thread groups. Right-click on first JMeter here and select the Add option. Then, in this option, select the Threads option and then Threads group. The thread group refers to the users that are used or created or needed to run this test. So let's name this thread group to be JMeter. It has several different options, like the action to be taken after there is an error. You can choose it in the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the users' hits. Third, there is also a loop count where you can choose how many times the test will run for the number of users. You can choose the test to run infinite number of times. There is also a scheduler here that will help you schedule the start time and the test's end time. For now, let's leave everything to be one only. The next step is to go to first JMeter and again to go to Add. In the box that appears, select Samplers. You can see all types of requests that JMeter can work on. For now, we will choose the simplest of them all. Let's choose the HTTP request. Here, you will have to give the address to some home pages or websites. So let's make it a little easy. Let's rename it to be Home Pages. Here in the server name or IP box, we have to give the server name or the IP. Let's pick a website. Let's go to the Simplilearn website. Copy the URL from here. Come back to the JMeter window and paste it in the server name box. Keep in mind we don't need to give HTTP or HTTPS since these are protocols which will come in the other box, and they will be automatically taken in the HTTP request case. Then in the path dialog box, since we have to access the route page, we will leave a / there. Now when our HTTP test is ready, we will perform the test on it. To determine what the result of the test will be, we need to add some more test elements. We shall again right-click on first JMeter, go to the listener options. Then in the box we can check the different type of reports that JMeter provides us. For now we shall select two of these. Let's choose View Results in Table and the View Results tree. Now save the test and run it. For running the test, there are three simple ways. First, you can simply click the green button here to run. Second, you can go to this Run option and choose Run the test. And the third way is you can right-click on first JMeter and choose to run. Let's simply choose the green button and run the test. After we run the test, we shall go to check the results of the test. Since we had put the number of threads and loop to be 1, there's just one entry in both the results. Now let's try one more thing. We shall go to JMeter and change the number of threads and the loop count. Let's make the number of threads to be around 10 and also the loop count to be 10. And now run the test. After running the test, we shall see the results in the table and see the testing being performed. And the same happens in the case of View Results in tree. Since we have increased the number of users and the loop count, we can see the test being performed accordingly. Since the loop count now was 10, so for each user, the test will run 10 times. And here on the screen, we can see the time taken and the number of tests being performed and the status of each hit onto our website link.
let's get started with what is performance testing. So, performance testing is one of the most important phases of any product launch, as it verifies and validates the overall product performance. This testing can be done in different forms depending upon the resource availability and the type and volume of the user base. The main agenda behind conducting performance testing on any product is to make sure that the product's performance is as expected before it gets launched into the market. So, performance testing is the process of testing a software application under a specific workload. Performance testing is a software testing process used to test the speed, response time, stability, reliability, scalability, and resource usage of a software application under a particular workload. The main purpose of performance testing is to identify and eliminate performance bottlenecks in the software application. Performance testing mainly focuses on three factors of a software program. First one is the speed. Here it identifies whether the response of the application is fast or not. Then comes scalability, where the maximum user load is determined, and the third one is stability, where the stability of the application is checked under various workloads. Now we know what is performance testing. Let us understand why we need performance testing. The only concern of a software system is not features and functionality. The response time, reliability, resource, and scalability are also important factors. So, the goal of performance testing is not to find bugs, but to eliminate performance glitches. Performance testing is performed to help the stakeholders with information about the application concerning the application speed, stability, and scalability. Furthermore, performance testing reveals what needs to be improved before the product goes into the market. If there is no performance testing, the software might suffer from issues such as running slow while several users use it simultaneously, inconsistencies across different operating systems, and poor usability. Performance testing determines if the software or application meets speed, scalability, and stability requirements under expected workloads. Applications sent to market with poor performance metrics due to non-consistent or poor performance testing are likely to bring a bad reputation and fail to meet the expected sales goals. Now we know the relevance and need for performance testing. Let's look at the types of performance testing. So there are 6 types of performance testing. Namely, load testing, stress testing, volume testing, capacity testing, reliability testing, and scalability testing. Let's have a look at all the 6 types of testing one after the other. So the first type is load testing. Load testing is a type of performance testing where the application is tested for its performance on normal and peak usage. An application's performance is checked concerning its response to the user request and its availability to respond consistently within accepted endurance on different user loads. Here, the main consideration is the maximum load the application can hold before the application starts behaving abruptly. Then, another consideration is regarding how much data the database can handle before the system crashes. The second type of performance testing is stress testing. Stress testing is a type in which different ways to break the system are found, that is, how much load a system can sustain. Stress testing has an incremental approach where the load is increased gradually. The test is started with a load for which the application has already been tested. Then, more load is added slowly to stress the system. The point at which we start seeing servers not responding to the request is considered the breaking point. Here, the major considerations are the maximum load to a system can sustain before it breaks down. Then, how is the system broken down? And how will the system be able to recover once it has crashed? We also see in how many ways a system can break and which are the weak nodes that are to be kept in mind while handling the unexpected load. Moving forth, the next type is volume testing. Volume testing is the type where the performance of the system is checked with respect to the volume of the data. To execute a volume test, a huge volume of data is entered into the database. This test can be incremental or steady test. In the incremental test, the volume of the data is increased gradually. Generally, with the application usage, the database size grows, and it is necessary to test the application against a heavy database. If we consider an example, let's say there is a website of college having small amounts of data to store initially. But after 5 to 10 years, the data stored in the database of the website is much more and has become huge. Now comes the fourth type of performance testing, the capacity testing. So capacity testing is a type of testing where the application is checked for its capability to meet the business volumes. Capacity testing is generally done for future prospects. Here, the main concerns are if the application would be able to support the future load, if the environment is capable of standing the upcoming increased load, and what are the additional resources required to make the environment capable enough. Capacity testing helps in determining how many users or transactions of a given web application is capable of supporting and will perform well. During this testing, resources such as processor capacity, network bandwidth, memory usage, disk capacity, etc. are considered and altered to meet the goal. To consider an excellent example of capacity testing, we can see the case of online banking. Moving forward, the next type of testing is the reliability testing. Reliability testing is a type in which the application is verified if the application would be normal again after an abnormal state. It estimates the time that the system would take to return to its normal state to understand the concept. Let's say there is an online trading site that experiences some failure, and because of which the users are not able to buy or sell shares at a certain point of the day. But after a couple of hours, they were able to operate their shares and the application became normal. This is when it can be said that the application is reliable and can recover from its abnormal state. The last type of testing is scalability testing. Scalability testing is a type where the application is determined if it would be able to scale up whenever needed. The need for scaling up comes when there is an increase in user load. Now when we have learned the types of performance testing, we must learn the process of performance testing. So the process of performance testing is divided into 8 parts. That is, requirement gathering, selection of tools, performance test plan, performance test development, performance test modeling, execution of test, test result analysis, report. Now let's have a look at all of these processes one after the other. The first step in the process is requirement gathering. The requirements are identified and gathered from the clients by the performance team. This includes getting information on the application's architecture, technologies, database used, intended users, functionality, application usage, test requirement, hardware and software requirements, etc. The second step in the process is selection of tools. After the previous step, POC or proof of concept is done with the available tools. The proof of concept is a sort of demonstration of real-time activity, but in a limited sense. The list of available tools depends on the tool's cost, the protocol that the application is using, the technologies used to build the application, the number of users we were simulating for the test, etc. Now, the third step. The third step is the performance test plan. In reference to the above two steps, test planning and designing are conducted. The process of test planning involves information on how the performance test is going to take place, like the test environment, workload, hardware, etc. Moving forth, the fourth step is performance test development. In this step, the use cases for the identified functionalities are created. These use cases are shared with the client for their approval. Once the clients approve the use case, the script development begins. These scripts are validated against several different users and parallel to script creation. The performance team sets up the test environment. The performance team also takes care of metadata through scripts if the client does not take up that activity. So the next step is performance test modeling. Performance load model is created for the test execution. This step aims to validate whether the given performance metrics are achieved during the test or not. Then, the sixth step is execution of tests. The scenario is designed according to the load model in controller or performance center. Initially, the tests are not executed with maximum users that are in the load model. The test execution is done in incremental order. Let's say there are 1000 users. Then the scenario will begin testing from 100, then go to 250, then 350, and so on. It will gradually increase and go up to 1000 users. The next step is the seventh step in our process. That is the test result analysis. The test results are the most important deliverable for the performance tester. This is where we can prove the return on investment and productivity that a performance testing effort can provide. What makes the result analysis process more effective is that we must have a unique and meaningful name for every test result, which will help us understand the test purpose. In the test summary, certain things must be included, like the reason for failure, how the performance of the application changes regarding the previous runs. It is also a good practice to make a result summary after each test run so that the analysis results are not compiled every single time the results are referred. Then the final and the last step in performance testing process is the report. The test results should be simplified so that conclusion is clearer and should not create any derivation. The development team needs more information on analysis, comparison of results, and details of how the results were obtained. The test report is considered to be good if it's brief, descriptive, and to the point. Now that we know the performance testing, the next important topic to discuss is the understanding of performance testing metrics. The first is processor usage, which refers to the amount of time the processor spends executing the non-idle threads. Second metric is memory usage. Memory use is the amount of physical memory available to the processor on a computer system. The third metric is disk time, which is the amount of time the disk is busy in executing read or write request. The fourth metric is the bandwidth, that shows the bits per second used by a network interface. Moving forth, the next metric is the private bytes. It is the number of bytes a process has allocated that can be shared amongst the other processes. These are used to measure memory leaks and usage. Then comes the committed memory. This is the amount of virtual memory used. Then the next metric we have is the response time. It is the time between when the user enters a request to time to the first character of the response is received. Next metric is the throughput. It is the rate at which a computer or a network receives requests per second. Moving forth, the next metric is the hit ratios. The hit ratios are concerned with the number of SQL statements that are handled by cached data instead of expensive input-output operations. And the last metric in our list is the top weights. These are monitored to determine what wait times can be cut down to make the data retrieval faster from memory. Apart from this, some metrics like the rollback segment, garbage collection, thread counts, hits per second, CPU interruption per second, disk queue length, etc. Now, when we know almost everything that is needed regarding performance testing, it is very important to know the tools that make performance testing possible. Here are the top 5 performance testing tools in the market today. The first tool we have is the Load Runner or HP Load Runner. As the name suggests, the Load Runner is great when it comes to handling a large amount of users for testing. The second tool in our list is WebLoad. WebLoad is one of the best testing tools for stress and load testing. The next tool in our list is Load UI. Load UI is a great testing tool to map the scalability and speed of the target product. The fourth tool in our list is NeoLoad. It is one of the fastest testing tools with a speed of around 10 times the traditional testing tools that are integrated seamlessly into our existing software with a wide array of tests. The last tool in our list is the Apache JMeter. Apache JMeter is one of the best and most used testing tools in the market right now. It is highly capable of creating a large number of virtual users working on web server. Moving forth, we shall talk about JMeter and understand why JMeter is preferred over all the other performance testing tools in the market. So moving forth, let's see what JMeter is. JMeter or Apache JMeter is an open source software that is 100% pure Java application. The application is designed to load or test functional behavior and measure performance. JMeter is originally designed for testing web applications but has since expanded to other test functions. To understand the concept of JMeter, let us assume that someday your team leads tell you to perform performance testing on some website like Facebook or Google.com for 100 users. What would be the first thing comes to your mind? Do you think it's practically possible to arrange 100 people with computers and access to internet and accessing the same website? Now, just imagine the infrastructure requirement when this testing has to be done for 10,000 users. This is when a need for software like JMeter arises. So what JMeter does is, it actually simulates. It will simulate the real user's behavior and perform load tests on server, group of servers, network, or object. Now, let's have a look at some reasons why JMeter is used for load testing. We have divided these reasons into 6 parts. The first one is it's free of cost. Second one is performance testing of applications. Next one, platform independent. The fourth one is customizable. Fifth is recording and playback. And finally, sixth is the community support. Let's see all of these one after the other. The first reason we have is free of cost. One of the main deciding factors in any software is its cost. Normally, a software can range from high as 6 to 7 figures per license. Here, JMeter is free of cost, very intuitive, and has all the possibilities you need to automate your work. Then the second reason is performance testing of applications. The application is used to perform performance testing on different types of applications like web applications, web services, LDAP, database, and shell scripts. JMeter can conduct load and performance tests for many different servers and server types: web, HTTP and HTTPS, database via JDBC, LDAP, and JMS. The third reason is platform independence. JMeter is written and developed using Java to run on any environment or workstation that accepts Java Virtual Machine, for example Windows, Linux, Mac, etc. The next reason we have is that JMeter is customizable. Since JMeter is an open source application, it enables developers to customize whenever needed. JMeter has a comprehensive and user-friendly graphical user interface. Parameters are easy to define and understand. Scripting is simpler and clearer, and adding and defining elements is more intuitive. Also, one screen shows everything you need: the script, the scenario, and the analysis. These samplers are highly customizable when determining which request to be sent to the host. However, samplers don't enable full control of test actions. Moving forth, the following reason is recording and playback. The application provides record and playback options enabled with the drag and drop feature, making the application faster and easier. The next and the last reason on our list is incredible community support. JMeter is an open source tool with a brilliant community that keeps adding features and supports users who run into issues and problems. This ensures new users always have someone to answer their questions, and long-time users can improve their abilities on JMeter. Also, having an open source tool ensures that it keeps getting better and is always in line with users' needs and requirements. Finally, let's have a look into the demo that shows the working of JMeter. So the first step is we shall go to the Apache JMeter folder. In that folder, go inside the bin folder and select the jmeter.bat file. Double click on this file. This might take a while, and then the JMeter window will open on the screen. The home window is divided into two sections. On the left side, all the test plan elements are added, and on the right side, all the configurations of that element are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will be using to perform this test will be stored. All the requests, listeners, and everything will be stored here. I have renamed this test plan as Performance Testing. Now the first step is to add thread group. Right-click on the performance testing, go to Add, then go to Thread or Users, and select Thread Group. Let's name this as Perform. Here, the thread group refers to the used or created users or needed to run this test. It has several different options like the action to be taken after there is an error. You can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the user hits. Third, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run infinite times. There is also a scheduler here to help you schedule the start time and the test end time. Let's make the number of threads to be 2 and let's make the loop count to be 100. The next step is to add an HTTP request. For that, right click on the thread group, go to add option and go to the sampler option. In the menu that appears, select the HTTP request option. Here on the screen, there is a server name or IP box. We have to give the server name or the IP in that. Let's pick up a website and place the link in the box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from here. Then come back to the JMeter window and paste it onto the server name box. Keep in mind, we don't need to give the HTTP or HTTPS since these are protocols which will come in the other box, and they will be automatically taken in the HTTP request case. Then in the path dialog box, we will leave the / there since we have to access the root page. And let's rename this HTTP request as simple. Now, to get results, we shall add listeners. Listeners are something that are used to provide the outputs of a load test. There are different types of listeners present in JMeter, and many may be added using plugins. We will use 3 different listeners here to have an idea about the representation that the JMeter provides. For that, right click on the thread group, then go to the add, select listener option and go to the view results in tree option. Then again, right click on the listener option and choose graph results. And for the third listener, again right click and select the view results in the table option. Now it's time to run the test. For running the test, there are 3 simple ways. First, you can simply click on the green button here to run. Second is you can go to the run option and choose the run the test. And the third way, you can right click on the first JMeter and choose to run. Let's simply choose the green button and run the test. First, we will have to save this JMeter test, and then we shall go on to check the results of the test. Here in the view results tree, we can see the test being run. The same in the case of graph results. We can see the throughput option, then we can also see the time the test has been executing. Since we had put the threads to 2 and the loop count to 100, so the test will run for a while. We can check the view results in the table. We can see different performance testing metrics on the screen. You can see the thread name, label, sample time per second, bytes, sort bytes, and the latency. And in the tree option, when we click on the test, we can see a lot of information appearing on the screen. These are again several performance testing metrics. And in the graph results, we can see the graph coming up on the screen now, which represents the test taking place with respect to the IP address, thread, and loop counts. So what JMeter exactly does is creates a request and sends it to the server. Once it receives the server's response, it collects them and visualizes those details in a chart or graph. After that, it processes the server's response, and finally it generates the test results in several formats such as text, XML, JSON, so that the tester can analyze the data. Let's get started with what is load testing. Load testing is a type of performance testing that determines an application's behavior when a large number of users access the application together. Here, performance testing is a software testing process used to test the speed, response time, stability, and reliability of the software application under a particular workload. The testing determines a system's performance according to real-life conditions. To give you a better idea, let's say you have a printer. So you want to test a printer by transferring large number of documents for printing, or test a mail server with thousands of concurrent users, or to test a word processor by making a change in a large volume of data. This helps to know whether the existing infrastructure is capable of running the application or not. Load testing checks how much load can a system handle. The testing identifies the limitations due to hardware like CPU maximization, network bottleneck, memory limitation, etc. And it also identifies the issues in software configuration such as web server, application server, database server, etc. It helps to identify the maximum operating capability of an application and checks the performance of the application under different load conditions of system components and database components. Load testing is conducted to determine the number of concurrent users that an application can support without performance deterioration. The response time of each transaction of an application and the network delay between the client request and server response are also checked. Load testing proves itself very significant when it comes to determining user demands and satisfaction. Several tools make load testing possible, such as Apache JMeter, WebLoad, LoadUI, LoadRunner, NeoLoad, LoadNinja, etc. Here in this session, we shall be using JMeter for load testing. So JMeter or Apache JMeter is open source software that is 100% pure Java application. The application is designed to load or test functional behavior and measure performance. Performance testing means testing a web application against heavy load, multiple and concurrent user traffic. It was originally designed for testing web applications but has since expanded to other test functions. To simplify, let us assume that someday your team leads tell you to perform performance testing for some websites like yahoo.com or google.com for 100 users. What would be the first thing that comes to your mind? Do you think it's practically possible to arrange 100 people with 100 computers and access the internet and accessing the same website? Now, just imagine the infrastructure requirement when this testing has to be done for 1,000 or 10,000 users. This is when we need a software like JMeter. So what JMeter does is it simulates. It will simulate real user behaviors and perform load testing on a server, group of servers, network, or object. Next, let's have a look at some reasons why JMeter is used for load testing. We have divided these reasons into 6 parts. It is free of cost, performance testing of applications, platform independent, customizable, recording and playback, and community support. Now, let's see all of these one after the other. The first one, free of cost. One of the main deciding factors in any software is its cost. Normally, a software can range from high as 6 to 7 figures per license. Here, JMeter is free of cost, very intuitive, and has all the possibilities you need to automate your work. The next one is performance testing of applications. The application is used to perform performance testing on different applications like web applications, web servers, LDAP, database, and shell scripts. JMeter can conduct load and performance tests for many different server types like web, HTTP and HTTPS, database via JDBC, LDAP, and JMS. The third important reason is its platform independent nature. JMeter is written and developed using Java programming language to run on any environment or workstation that accepts a Java virtual machine, for example, Windows, Linux, Mac, etc. The next reason we have is JMeter is highly customizable. Since JMeter is an open source application, it enables developers to customize it whenever needed. JMeter has a comprehensive and user-friendly graphical user interface. Parameters are easy to define and understand, scripting is simpler and cleaner, and adding and defining elements is more intuitive. Also, one screen shows you everything you need: the script, the scenario, and the analysis. The samplers are highly customizable when determining which request is to be sent to a host. However, samplers don't enable full control of test actions. Moving forth, the following reason is recording and playback. The application provides record and playback options enabled with the drag and drop features, making the application faster and easier. The next and the last reason in our list is incredible community support. JMeter is an open source tool with a brilliant community that keeps adding features and supports users who run into issues and problems. This ensures new users always have someone to answer their questions, and long-time users can improve their abilities on JMeter. Also, having an open source tool ensures it keeps getting better and always in line with users' needs and requirements. Now, after we know about JMeter and the reasons to use JMeter, let's understand the process to perform load testing with a hands-on demo. The only thing that is kept in mind before this demo is we must have a fully functional JMeter on our system, and by now we know that JMeter can be used in any operating system like Linux, Windows, Mac OS, and Ubuntu. In this demo, we shall look into both graphical user and non-graphical user interface mode of load testing. So the first step is we shall go to the Apache JMeter folder. In that folder, go inside the bin folder and select the jmeter.bat file. Double click on this file, this might take a while, and then the JMeter window will open on the screen. The home window is divided into two sections. On the left side, the elements of the test plan are added, and on the right side, all the configurations of the element that are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, the listeners, and everything will be stored here. So the first step is to add listeners. For that, go to test plan, right click on the test plan, go to add, then go to threads, users, and select a thread group. The test group refers to the users that are used or created or needed to run this test. It has several different options, like the action to be taken after there is an error. You can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the user's hits. Then the third one, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run infinite times. There is also a scheduler here to help you schedule the start time and the test end time. For now, let's leave everything to be only one. The next step is to add the HTTP request. For that, right click on the thread group and go to the option and go to the sampler option and go to the HTTP request option. Here on the screen, there is a server name or IP box. We have to give the server name or the IP in that. Let's pick a website and place the link in that box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from there. Now we have copied the Simplilearn's URL. Now let's come back to the JMeter window and paste it in the server name box. Keep in mind that we don't need to give up the HTTP or HTTPS since these are protocols which will come in the other box and they will be automatically taken in the HTTP request case. So this is what I was talking about. Now let's rename this name as Simply. Moving forth, let's create one more HTTP request. For that, again right click on the thread group, select samplers and select HTTP request and go to Simplilearn's website again, and there we have the resource link. Go to that link and copy the URL, then place that URL in the server or IP address box. We shall remove the HTTP from that link and add from the end. Cut the resource part and paste it in the path box there. Here we will rename the HTTP request as resources. Moving forward, to increase a load a little bit more, we shall use one more HTTP. So this time we shall add one more HTTP request. Again right click on the threads group, go to the samplers option and select the HTTP request option again. To add one more link to the server and IP address, go to Simplilearn's website, go to the corporate training link. Now copy the URL and go back to the JMeter window and paste that URL in the IP box. Now cut the corporate training part from the link and paste it to the other path box. We shall again rename this HTTP request box as corporate. Now let's save this file. In the save dialog box, let's name it as loadtesting.jmx. Now to get the results, we shall add listeners. Listeners are something that is used to provide the outputs of the load test. There are different types of listeners present in JMeter and many may be added using plugins. The listener we will use here is the tree, as it is comparatively easy to interpret. For that, right click on the thread group, then go to add, select listener option and go for the view results in tree option. Now it's time to run the test and check the load. For running the test, there are three simple ways. First, you can simply click on the green button here to run. Second is you can go to the run option and choose the run test. And the third is the way you can right click on first JMeter and then choose run. Let's simply choose the green button and run the test. After we run the test, we shall go to the check the results of the test in the view results in tree section. We can see the green symbol that states the test has successfully completed. Since we had left all the values to be 1 in the beginning, that's why there is just one test for each HTTP request. Now let's increase the load and let's change some numbers. Let's make the number of threads to be 10, ramp up the periods to be 2 and the loop count to be 10. Now let's run the test again with the green button. After running the test, we shall see the results in the tree and see the testing being performed. Since we have increased the number of users and ramped up the periods and the loop count, we can see the test being performed accordingly. Since the loop count now was 10 for each user, the test will run 10 times. So here on the screen we can see the time taken and the number of tests being performed on the status of each hit onto the website. This is how you perform load testing in graphical user mode. Now perform the same test in non-graphical user mode. We shall remove the listener, so let's remove the view results in tree. After this, we will go to the command prompt. Then in the command prompt, we shall put the bin folder path in the Apache JMeter folder. Let's go to the bin folder and copy the location from here. Now paste the path in the command prompt and execute it. Once that is done, the next step is to put the command prompt for JMeter load testing. This command has got 3 parts. The first part is the -n, -t and -l. Here the -n represents the non-graphical user interface mode. -t is used to specify the location of the test script. -l is used to specify the location of our output result. Now go to the location where our JMX file is stored. Let's search for the load testing.jmx file. Copy the path and paste it in the command prompt -t. In the link that we paste towards the end, make sure that you add the name of the file with .gmx. Now go back to the folder and make a .csv file, make an Excel spreadsheet and rename it with .csv extension. Now copy this path and go back to the command prompt and paste it after the -l. In the path, don't forget to add the name of the CSV file towards the end. Then execute the command and wait for the command to end. After the command is successfully run, you can see that the tree is successfully created, and towards the end of that execution, you can see that the message is the end of the run. Now you can go back to the folder and open the loadtesting.csv file. In that file, you can see the entire test result has been generated. This shows that the command has been successfully executed and the load testing is successful in the non-graphical mode without any errors. This is what we had in this demo. We saw the load testing in graphical user interface and non-graphical user interface mode. To have a better picture, we use dashboards. Dashboards include several graphs that explain the working of the website link we use in the HTTP request. The dashboard generator is a modular extension of JMeter. Its default behavior is to read and process samples from a CSV file to generate HTML files. It generates the report and at the end of the load test or on demand. The dashboard reports provide metrics like the APDEX or Application Performance Index. The dashboard also provides a statistics table, response time over time, response times percentiles over time, active threads over time, and response times in percentiles. We shall learn about dashboards and more in the forthcoming videos. In this video, we learned how critical is load testing in the software testing process and how it ensures high user satisfaction. A successful load testing will help to release high quality software.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's get started with what an API is. We often come across this term while reading any technical blog or magazine. An API, or Application Programming Interface, is a programming code that enables data transmission between one software product and another. It is an intermediary software allowing two applications to communicate with each other. To understand API even better, let's take an example. For example, you're booking a flight. For that, you will begin with searching flights online concerning your destination, departure, return dates, and many more filters. To make all these choices, you interact with the airline's website and access their database and see if there are any seats available on those dates and what the costs might be. While you're doing all this, from the time to begin to the time you finish booking your tickets, you're doing that with the help of an API. To simplify it even more, it can be said that whenever we use an application on our mobile phone, the application connects to the internet and sends data to the server. The server then retrieves the data, interprets it, performs necessary actions, and sends it back to our phone. The application then interprets the data and presents the information we wanted in a readable way. This is what an API is. So that means each time we use an application like Facebook, send an instant image, check weather on our phone, or make some specific choices while online shopping, we use an API. Now when we have a good idea about what an API is, let's look at another major thing before going on to the hands-on demo. That is why we use JMeter for API testing. Apache JMeter is an open source software and it is used to simulate loads of various scenarios and output performance data in several ways, including CSV and XML files and graphs. We know that the Apache JMeter is 100% pure Java application, so it is available on every OS that supports Java 6 or later. Some of these specific reasons what makes JMeter a perfect fit for API testing are: JMeter enables fast API testing. It performs quick scope tests and enables load and stress testing. Then, as we know, it is an open source tool and supports load testing and stress testing. It has a lot of plugins and extensions. JMeter can be used across several platforms and can use various programming languages. Now, we know about API basics and why we use JMeter for its testing. It is the right time to see the process of API testing in JMeter. To download JMeter, you can go to the Apache JMeter website and download the file. To know the entire downloading process and installing JMeter, you can check our JMeter download and installation video in our JMeter playlist. Moving on, I have my JMeter installed. I will go to the Apache JMeter folder, go into the bin folder and open the batch file. This might take a while and then the JMeter window will open on the screen. The home window is divided into two sections. On the left side, all the elements of the test plan are added, and on the right side, all the configurations of that element are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, listeners, and everything will be stored here. So moving forward, right click on the first JMeter here and select the Add option. Then in this option, select the Threads option and then Threads group. The thread group refers to the users that are used or created or needed to run this test. It has several different options, like the action to be taken after there is an error, or you can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the user hits. Third, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run in finite times. There is also a scheduler here to help you schedule the time for starting the test and the time for ending the test. For now, let's leave everything to be one only. Now, for some sample APIs, go to your browser and search for some sample REST API for testing. In this, we will go to the first link, that is reqres.in or requestresponse.in. We will create and run get, post, put, and delete REST API request in JMeter in the demo. Here, in this link, we have all get, post, put, delete APIs. So we shall choose the first link here, list users. Here we have the link request. Open this link in the new tab. Then we have got the URL for this API. Copy this URL and go to the JMeter window. Then in the JMeter window, right-click Thread Group and go to Add. In the box that appears, select Samplers. You can see all types of requests that JMeter can work on. We shall choose the HTTP request. Here, you will have to give the address to some home pages or websites. Here, in the server name or IP box, we have to give the server name or the IP. So here, we shall paste the Get API request URL. In the protocol box, we shall put the HTTPS. If in the URL the protocol would have been HTTP, then we would have left this box empty. In the URL, we shall put the URL link. Remember that we do not put any slashes here and that anything after the URL would be put in the path. So we shall remove the path from the URL and put it in the path box. Then we shall take part from the question mark and use it to give parameters. Since it is the Get API, we will have to give parameters. We will add the name in the parameters and give the name as page and value as 2. In this HTTP request drop-down, we can see all the different types of HTTP requests that JMeter accepts. For now, we shall leave it to be Get since we are using the Get API. And also, let's name this HTTP request as Get API. Now, when our HTTP request is ready, we shall perform the test on it. To determine what the results of the test will be, we need to add some more test elements. We shall again right-click on the thread group, go to the listener options, then in the box, we can check the different types of reports that JMeter provides us. For now, we shall select 2 of these. Let's choose View Results Tree and the View Results in the table. Now, save the test. I will save the test with the name API Testing. And finally, let's run it. For running the test, there are 3 simple ways. First, you can simply click the green button on the run. Second, you can go to this run option and choose to run the test. And the third way is you can right click on the first JMeter and choose to run. Let's simply choose the green button and run the test. After we run the test, we shall go to check the result of the test. Let's go to the View Results tree. Here, we can see the green status that shows the test was successful. And the view results in a table. We can see again the status is green. Since we had put the number of threads and loop to be 1, there is just 1 entry in both the results. Now, let's try one more thing. We shall go to the thread group and change the number of threads to be 10 and run the test again. After running the test, we shall see the results in the table and see the testing being performed. And same happens in the case of view results in table. Now in the view results tree, we can click on a request and see different information. Here, we can see the sample start, load time, latency error, etc. Same in the view results in table. You can see all such information in a tabular format. You can also see the response data here. This is the same data as it was there when we copied the URL from the browser. You can furthermore check the response headers and the request that was placed. Now, we are done with the Get API request. Let's add the second request, that is the post request. Again, add a HTTP request by going to the sampler in the thread group. Then, come back to the browser window and click on the Post API option. Then, open the request URL in the new window. Then, go to this window, copy the URL, and come back to the JMeter window. First, let's rename this HTTP request as Post API. Then, let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box, address in the server or IP address box, and path in the path box. And in this HTTP request drop-down, select the post option this time. Then let's go to the parameter part. Here, select the body data option, and we shall have to add body now. So go back to the browser window and copy the body from here. Come back to the JMeter window and paste the body here. Here you can check some advanced settings also in case you need them. For now, since this is just a demo, we shall keep it really simple. So let's run this. We shall go to our two listeners and clear the previous output. Then we shall save the test and run it. Now you can see the two tests are here. Since the thread count is 1, let's make the thread count to be 10 again. Let's see what happens. Now when I run the test, I can see the test running a required number of times, that is 20 times. Again, I can see information about different requests that include different parameters like latency, errors, etc. Now, let's move on to our third API request, that is the put request. Go back to the browser and click on put request. Open the request in the new tab. Copy the URL and come back to the JMeter window. Make a new HTTP request by going to the sampler in the thread group. First, let's rename this HTTP request as put API. Then let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box. Address the server or IP address box and path in the path box. And in the HTTP request dropdown, select the put option this time. Here also we shall have to add body data. So go back to the browser window and copy the body from here. Coming back to JMeter window, select the body data option and we shall have to add body now and paste the body here. We shall go to our two listeners and clear the previous output, make the thread count to be 1 and then we shall save the test and run it. Now you can see the 3 tests here. Since the thread count is 1, here by clicking on the API request, we can check a lot of data like the response, body and response headers. And same in the case of view results in the table. You can see the data in a tabular format. Let's make the thread count to be 10 and again see what happens. Now when I run the test, I can see the test running a required number of times. And here I can see information about different requests. Now let us add our last API request, that is the delete request. Go back to the browser and click on the delete request. Open the request in the new tab, copy the URL and come back to the JMeter window. Make a new HTTP request by going to the sampler in the thread group. First, let's rename this HTTP request as delete API. Then, let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box, address in the server or IP address box, and path in the path box. And in this HTTP request dropdown, select the delete option this time. Here, there is nothing to be added in the parameters section. So let's go to the two listeners and clear what all is there. Then save this test and run it. Since we did not make the number of threads 1 this time, we can see the test running n number of times. We can see the information of any API request by just clicking on it.
Let's get started with what is script recording. Record testing in JMeter helps testers to record and run their activity against test targets. It is a type of automated testing, but for multiple users, the test script is designed to record such scenarios. The proxy server allows JMeter to watch and record user activity while browsing web applications with a normal web browser. When we talk about proxy, it is a component that is present between you and the remote server. Let us say that you want to record web browser interactions when JMeter starts acting like a proxy. This is when JMeter script recording is used. Script recording is one of the advanced and impressive ways to figure out and eliminate the complexity of browser interactions in software testing. Now when we know what script recording is and how it is relevant, let's look into how to do it in JMeter. But before that, let's check the prerequisites of script recording in JMeter. There are 3 major prerequisites. First is having JMeter installed in your system. The second requirement is having Java installed in your system. The third and final requirement is having Mozilla Firefox in your system.
Now, let us have a look at the hands-on demo of how to perform script recording in JMeter. So, the first step is we shall go to the Apache JMeter folder. In that folder, we will go into bin folder and then select the jmeter.bat folder. Let us double click on that. This might take a while. And then the JMeter window will open on the screen. The home window is divided into 2 sections. On the left side, all the test plan elements are added. And on the right side, all the configurations of the elements are added. As we are on the test plan element, we can see the configurations of the same. Here, you can think of the test plan like a place or a container where all the elements we will be using to perform this test will be stored. All the requests, all the listeners, and everything will be stored here. Now, the first step is to add thread group. So for that, right click on the thread group. Select add, and from add, go to threads or users, and in that, select thread group. Here, the thread group refers to the users. It has several different options, like the action to be taken after there is an error. You can choose it the way you want. Then, there is this number of threads where you can choose the number of users you want. Then, there is a ramp up period and second option that states the time gap between the user hits. Third, there is a loop count where you can choose how many number of times the test will run for a number of users. You can also choose the test to run for infinite times. There is also a scheduler here to help you schedule the start time and the test's end time. The next step is to add an HTTP request. For that, right click on the thread group, go to the add option, and now go to the sampler option. Select the HTTP request option. Here, there is a server name or IP box. We have to give the server name or IP in that. Let us pick a website and place the link in the box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from here. Then come back to the JMeter window and paste it in the server name box. Keep in mind that we don't need to give HTTP or HTTPS since these are protocols that will come in the other box and they will be automatically taken in the HTTP request case. Then in the path dialog box, we will leave a / there since we have to access the root page. Now the next step is to add the HTTP test script recorder. For that, right click on the test plan, then go to non-test elements and select the HTTP test script recorder option. The window on the screen shows several options. Here, we can see the start option to begin the test. Then, there is a box that has the port number. You can make this number whatever you like. I'll put this number as 1234 for now. Then, let's go back to the Simplilearn's website and go to the resources page. Then, come back to the JMeter's window and rename the recording controller as resources.
Now, let us add another recording controller so that JMeter works like a proxy with the help of HTTPS test script recorder. Then again, go back to the resources page that we just opened and scroll down a little bit. Here, we can see several technologies and several other links. In those links, you can select any one of the links. I will select digital marketing here. Then, go back to the JMeter window and rename the recording controller as digital marketing. Then finally, let's add a recording controller for the home page and rename it as Simplilearn's home page. So now, we can see that we have a thread group here. Then there is a HTTP request where we have Simplilearn website in the server name. Then there are 3 recording controllers, one for the resources, the second for digital marketing, and a third one for homepage. And last we have a HTTP test script recorder. Here, I will rearrange the recording controllers in sequence, putting the Simplilearn's homepage controller on the top and then placing the resources, finally digital marketing recording controller. Now, let us open Mozilla Firefox in our system. Go to the general option here and scroll down to the network settings. In the network settings option, select settings. In the window that appears, select the manual proxy configuration. Here, we shall put the port number. For now, I will put the port number as 1234 in this box. Here in the HTTP proxy, we have localhost and we have selected to use this proxy for FTP and HTTPS and then click on OK. Now go back to the Apache JMeter folder and now we shall use this Apache JMeter temporary root CA file, which is a security certificate file. So coming back to the Mozilla Firefox window, go to the options tab and in this tab, I will type certificates and here we shall select view certificates. In the window that opens, let us import the security certificate from JMeter folder. Here we shall select these 2 boxes so that the proxy server can access the website that we shall enter here in the browser and then select OK. Coming back to the JMeter window, let us add some listeners to get the results. Listeners are something that are used to provide the outputs of a test. There are different types of listeners present in JMeter, and many may be added using plugins. For adding listeners, right-click on HTTP Test Script Recorder. For adding listeners, right-click on the HTTP Test Script Recorder. Then go to Add option and then go to Listeners option and then Add View Results tree. Now, let us add one more listener in the same way. We shall add View Results in tree. Now, in the HTTP Test Script Recorder, in the Target Controller option, save the target controller. Here in the drop-down, select the Simplilearn homepage option as we will begin the script recording for the homepage. Finally, let's start the test by clicking here. Click on OK. Now, go back to the Mozilla browser and here, let us open the Simplilearn's homepage. Now, come back to the JMeter window, go to the homepage recording controller. You can see the homepage controller has started. As you can see, the homepage controller has started recording the scripts that are being performed. These are the tasks that are performed on the client side to the server side. Now, we can check both the listeners that we have put to see what all functions are working fine and what all are not. All the tasks from the time that we have entered to simplilearn.com in our browser are recorded in this homepage controller. To take the test further, go to the test script recorder and stop the test. Now here in the target controller, select the second controller, that is the resources controller. Now start the test again. Select OK. Go to Simplilearn's website, select resources. After opening the resources link, go back to the JMeter window. And now in the resources controller, you can see what all events are recorded from the client side to the server side. Once we click on the resources link, now again in the 2 listeners, you can check all the scripts and tests are successful or have failed. Now for our last recording controller, go back to the test script recorder and stop the test. Now here in the target controller, select the third option, that is the digital marketing. Now here in the target controller, select the third option, that is digital marketing. Start the test and select OK. Now get back to the Mozilla Firefox window, go to resources, go to digital marketing. After digital marketing link has opened, go back to the JMeter window. And now in the digital marketing controller, you can see what all events are recorded from the client side to the server side. Once we click on that link, I guess this is taking a while. You can see all steps coming under the recording controller, and then you can also see the 2 listeners. Some of the tests are being successful and some are not. We can sum this entire process as a way of communicating between the server and the client with a proxy server help. In this case, the proxy server is our JMeter. That is why it was able to record all the steps that are happening while we were performing any task. This is how we can perform the JMeter script testing in few simple steps. Now, when you are done with the proxy server, do not forget to go back to your browser and change your network settings back to normal. That is, go to these settings, select Use System Proxy Settings.
Hello everyone, welcome to an amazing video of Simplilearn on Azure DevOps. This video will help you understand the use of DevOps in Azure, as well as it will help you explore the in-depth services and features provided to you by Azure DevOps. So without doing any further ado, let's start with the video. But before moving ahead, please do subscribe to our YouTube channel and hit the bell icon for more updates from Simplilearn. So let's see what we are going to cover in this video. First, we will understand what is Azure DevOps, followed by features of Azure DevOps. Then we will dive into and explore Azure DevOps services, followed by Azure DevOps Server, and then we will look into the Azure DevOps services and Azure DevOps Server differences. And at last, we will explore Azure DevOps Labs with proper demonstration. So let's get started. So what is Azure DevOps? Azure DevOps enables teams to organize work, collaborate on code development, and build and deploy applications using developer services. Azure DevOps is a culture and set of protocols that brings together developers, project managers, and contributors to collaborate on software development. It enables businesses to create and enhance products more quickly than they could with traditional software development methods. You can use Azure DevOps services in the cloud or Azure DevOps Server on premises. Azure DevOps has built-in functionality that you may access via a web browser or an IDE client. Depending on your business needs, you can use one or more of the following standalone services. Azure Repos. Azure DevOps are built-in functionality. So for source management of your code, Azure Repos offer Git repositories or Team Foundation version control. Azure Pipelines. Build and release services provided by Azure Pipelines to assess continuous integration and delivery of your applications. Azure Boards. Using Kanban and Scrum methodologies, Azure Boards provides a set of agile tools for planning and tracking work, code bugs, and issues. Azure Test Plans. Manual and exploratory testing and continuous testing are among the options available in Azure Test Plans for testing your applications. And at last, Azure Artifacts. This allows teams to share packages from public and private sources, including Maven, NPM, NuGet, and more, and incorporate package sharing into their pipelines. So this brings us to the features of DevOps. First we have is dashboard control. You can rapidly navigate to different regions of the project, build and manage dashboards, and set dashboard widgets using the DevOps dashboard functionality. Then we have improved source control. Git and Team Foundation version control, a centralized client-server system, which are two prominent methods of source control supported by Azure DevOps solution. To observe change history, you can add and manage Azure Git tags, reviews, downloads, and modify files. Following that, we have plan and track your work. You can utilize Azure DevOps systems to track features, requirements, user stories, tasks, issues, and more using a variety of work items. Then we have integrated collaboration servers, a tool that allows teams to collaborate throughout the whole Azure DevOps feature set, including team dashboards, project wiki, discussion within work item forms, and many others. Then we have support for exploratory testing. Manual exploratory and continuous testing are made easier with Azure DevOps, which include workflow customization, end-to-end traceability, criteria-based selection, and real-time visualization that show the test activities. And at last comes continuous integration and deployment. Many developers use CI/CD, and Azure DevOps makes it so easy to do so. Developers may automate various design activities with Azure pipelines, including defining and building association steps, writing test instructions, and managing simultaneous releases. Well, this brings us to Azure DevOps services. You get an integrated set of services and tools with Azure DevOps to manage your software project. from planning to development to testing and deployment. A client or server model is used to deliver these services. Many of them are offered via a user-friendly web interface that works with all major browsers. So source control, build pipelines, and work tracking are just a few of the services that may be managed through a client. You can see the left pane is where you access Azure DevOps Services as demonstrated in the figure below. So now that we have covered Azure DevOps Services, let's move on to Azure DevOps Server. Version control, reporting, requirements, management, project management, automated builds, testing, and release management are all capabilities of Azure DevOps Server, a Microsoft product. It provides DevOps features and spans the complete application cycle. So now that we know what Azure DevOps Services and Azure DevOps Server are, so let's have a crisp comparison between them to know how exactly they differ from each other. Despite the fact that Azure DevOps Service is a hosted version of Azure DevOps Server, there are several features that differ. Some functions of Azure DevOps Server aren't available in Azure DevOps Services. So when deciding which platform to use or considering a transition from on-premises to the cloud, keep the following points in mind: scope and scale data, authentication, users and groups, and manage user access. So first is scope and scale data. Azure DevOps Services and Azure DevOps Server are slightly different. Organizations and projects are currently the only alternatives for scoping and scaling data. Azure DevOps Services organization get their own URLs and always have exactly one project collection, whereas deployment, project collection, and projects are the three methods for scoping and scaling data in Azure DevOps Server. Then we have authentication. To connect to Azure DevOps Services using the public internet, depending on your organization's arrangement, you can use Microsoft account credentials or Azure AD credentials to log in. You can also configure Azure AD to require multi-factor authentication, IP address restrictions, and other security features. But you connect to an intranet serving using Azure DevOps Server. Windows authentication and your Active Directory domain credentials are used to log in. So this method is completely open and you will never be asked to sign in. Next we have users and groups. You may use a similar technique to grant access to groups of users in Azure DevOps Services. Azure AD groups can be added to Azure DevOps Services group. So you must add users one at a time if you utilize Microsoft account instead of Azure AD. On the other hand, by adding Active Directory groups to multiple Azure DevOps groups, you may grant user access to deployment in Azure DevOps Server. The membership of AD groups are kept in sync, so users gain and lose access to Azure DevOps Server as they're added and withdrawn in AD. And at last, there is Manage User Access. You manage access to features in Azure DevOps and Azure DevOps Server by assigning users to an access level. Each user in your Azure DevOps Services organization must be assigned an access level. As usual, as Visual Studio subscriber sign in, Azure DevOps Services verifies them. So without a Visual Studio subscription, you can give basic access to 5 users for free. Whereas all use of Azure DevOps Server is on the honor system. Specify the access levels on the administration page to set access levels for users based on their license and assign unlicensed user stakeholder access only. So now that we have covered all the important features and concepts of Azure DevOps, now let's move on to the next very important aspect of Azure DevOps, which is Azure DevOps Lab. The Azure DevOps Lab is a place where you can learn about software development and operations with Azure DevOps services. You can simplify and speed up the DevOps process. It explains how to use Azure DevOps services to automate software delivery and satisfy business requirements. So to understand it in a better way, let's have a demo of Azure DevOps Lab. So let's start with our Azure DevOps demo. So first, what we need to do is navigate to this website, azure.microsoft.in, or we can directly log in through dev.azure.com also. So first, what we need to do is sign into a Microsoft Azure account. So after signing in, you'll be led to this page that you just need to click on continue. And here what you need to do is create an organization under which you're gonna create your projects, multiple projects, and you're gonna attach your team members to it or group members to it whom you want to give the access to your projects. So what is the difference between organization and project is, if you have given anybody access to your organization or somebody is a part of your organization, then that particular individual will have access to all of your projects. But if you have given somebody only access to your project, then he'll be only restricted to that particular project. He won't be able to access any other project that is present under that particular organization that you both are part of. So basically, organization is something that is used to connect to groups of a related project or somebody who is already a part of a particular organization. So here we will give it a name. So I am giving simply Demo as the organization name. And here you can see that the projects under this organization will be hosted under the South India region. And we need to enter the CAPTCHA. And click on continue. Just a second. So now you can see it is saying that it is taking you to an organization. Okay, so we already have an organization of the same name. So let's just change it to something else. Let's give it simply Demo org. So here you can see this saying that it's taking to your Azure DevOps organization where you'll be creating your projects. So now you can see your organization name here, and here you just need to create a project name. So I'm giving it simply Demo project. Now below you can see visibility. We can opt either public or private. So what is public or private? So basically, if you keep the visibility of the project public, then once you copy this URL, so as I was saying, once you copy this URL into some other browser or incognito mode, you will be able to have the access to the project. But if you keep its visibility private, then only the people who have real access to your organization or to your project will be able to access that project or will be able to see that project or work on it. As you can see, public projects are disabled for our organization, so we can't select public. So we'll go for private and click on create project. Now here you can see the home page of your organization where you have this project, and here you can access the statistics of project, how it is performing, how much time you have contributed to it, or what all services you have added to your project. And down below you will be able to see that there is just one member, which is the root user of this project, and once you start adding more members to your project, their details will be added to this particular block. So now here you can see these are the services, boards, repos, pipelines, test plans, and artifacts services that is provided to you to add to your project. So now let's have a look at them one by one. So first one is boards. As we click on boards, you can see multiple options, your work items, boards, backlogs, sprints, queries, delivery plans. Here you can see it is all empty as we haven't added any service or we haven't worked on a project yet. So let's just click on new work item. So here you can see one is epic, issue and task. So epic is an option that is, you can see a pro option for work items. So basically epic represents business initiative to be accomplished, and it is basically available for basic, agile, scrum and CMMI process templates. So what it exactly does is increases customer engagement, that whatever your project is, if it's the engagement of your project, that how it's performing and how it is performing towards the people whom you have given access to the project. Also helps to create new architecture to improve the performance of your project, and it also supports mobile applications. So basically when you're deploying any mobile application in your project or creating a mobile application as a project, so it will be able to support that as well. Let's click on Epic. So here you can see you need to enter a title for your Epic option. So here you need to add the title of your Epic, like for say we are creating a healthcare or an e-commerce application. So obviously it will be segmented into different parts, like you'll be having search options or support options or home page. So we just need to give it a name, and here you can see its state is to do. For now we just have to do, because we haven't actually created anything in our project and we haven't given any input. So it's in to-do list, and once we start working on it, we can change the state. It can be in progress or completing. So there are multiple states for your Epic. And here you can see the area is simply demo project. That means that we want to assign this search new Epic into this project. And we can also click description over here, that what exactly our new Epic is about. Like for search options, we need to specify or give a description that this is for searching options related to our application. Like for healthcare, one can type medicines or doctors or slots. So that is thing that we can add in our description, that it will help the user to understand what this feature is about. So this was Epic, and once done we can click on save. So here you can see other stuffs also, like priority. So we can select priority according to our will. So here by default it is priority 2. So priority basically is which function will come first. And here you can mention start date, target date. So once it's done, you can click on save. Now let's move to the next one. Second, what we have is issue. So basically issues are for you to track your work, and epics are used to track the group work and the large scenarios. But this is track like we saw the project statistics, so it will help you to understand the individual progress. So basically issues are raised when you find any obstacle in your progress or in your work. So it can be compared to impediments also. So when you're working with Agile, you need to deal with issues. So by default we have Agile to our project assigned. So like for example, we can see that we have a meeting. So during the meeting, members report if they have encountered any bug or any impediments. So what next we have to do is we have to track them and resolve it. So these are the issues that one can find like possibilities. So you can assign here and give it a description again and just save it. So once a user faces these issues, we can keep a track of it, and once it is raised, we can resolve it. Coming to the next one. Next we have is task. So by the name only we can well understand what task is. So a task is a smaller item or smaller segment to track activity that contains all the information needed to accomplish a part of an issue, or you can say user story requirements. So this option is available for basic, Agile, Scrum and CMMI process templates. So again we can give it a name, what task we want to assign, and give it a description, and according to that we can select the priority and save it. So the task will be added to your project. We are not assigning any task right now because, as I said, we haven't added any particular project or particular details or application, or we haven't deployed any application yet in our project. So that is why we are not adding anything over here again, because first we need to understand what these services are and what these services are used for. Next we have backlogs. So backlogs helps you to understand the flow of your project. Like today you have contributed 10% of your time, and you have completed the 10% of the work, or you have worked on certain segments of the project, like for say you have worked on the support area. So it helps you to understand and keep a track of the flow of your project, how it is performing and how it is developing and how it is built every day. Next we have is sprints. So sprints are basically a time-boxed intervals that supports your team's ability to work using the agile processes and tools. So what you can do is, whether you're having, let's say you're having a healthcare application, so you just need to have a segment of it and drop it over here. So what it will do is it will get the attention of all the team members. So basically what it does, it makes your project more manageable. It increases the quality of your project and also makes it work even more faster and more frequently once you add the segment to the sprint. So you can say it in one way, it gets the priority and people need to work on it, and it gives your project more flexibility to adapt to change. Now sometimes what happens is many associate Scrum sprints with Agile software development. So sometimes Agile are often thought to be the same thing. Coming to the next one, we have queries. So the query page basically remembers the view you have last navigated, and when you log in again or when you come back again to the same portal, it returns you to that very particular view only. So you can say that it runs with Azure DevOps command line interface, and all the open like all the pages like you have gone through, you can keep a track of it over here. You just need to click over here all, and you can just see all the queries you have defined in all this while, and also you can share the queries with the team members, so they can also know that where you have been working lately or which segment you have been working on. or what was the last navigation which you have been going through in this whole project. So it can help you manage your project in a more efficient way and keep a track of how and what all segments you have been working on and what all segments you need to work on in your project. Coming to the next one, we have delivery plans. So here you can see we haven't created any plan yet. So basically, delivery plans are a calendar view of multiple teams or team backlogs or individual backlogs from different projects. So basically, it replaces the delivery plans marketplace extension, and it is only available for Azure DevOps services. So here you can say it's a summary or time summary of all the projects you have been working on in a particular organization. So now that we have covered both, let's move to the next one, which is repos. So with the name itself, we can well understand that repo stands for repositories. So basically, it is a set of repositories that allows you to control and manage your project code. Like, for say, you're deploying a healthcare application. So these repos options help you create repositories and manage your code of that particular application in a more efficient way. So what you can do is you can connect project solutions by using the repos link. As you can see here, it is shown. So let's look into its option one by one. First, we have files. So in files, your project solution will be available in this section. So repositories can create, manage, and import those solutions. Okay, so you just need to upload your solutions of your code or your project here, and it will just create repositories for it, and it will help you manage those solutions in a better way. And you can see these clone to your computer, push an existing repository from command line, and import a repositories if you want to import any solution. Like here, you can just click on import and add the solution to a repository. So this is what files do. Basically, you can see it's like a physical folder itself where you have all your mini files or repositories or solutions, you can say, of data. So basically, it functions like a physical folder itself. So it helps you keep a track of your codes and everything. Next comes is commits. So in commit section, we can manage commit history for your repositories that you have created in files. So it just commits those repositories with author details from branches. Like for say we have a team, one from support branch and one from management branch. So whoever creates that repositories and adds the solution, it commits that repositories under that particular member of the team with the branch name. Then comes pushes. So push histories are available in this section from each pull request done by the developers. Developers, for say, the team members who have been working on this particular project and creating repositories and solutions. So what is pull request? So pull request or PRs are a way to change or review or merge code in our repositories. So basically, team uses these PRs to review code and give feedbacks or changes, whether like for say you are deploying a code or a solution. So one can review them, what all changes needs to be made or what all upgradation needs to be made, or whether the code is already fine or not. So basically, teams use these PRs to review the solutions and codes stored in these repositories, or you can merge multiple solutions or multiple codes into the main branch. So basically, reviewers can step through the proposed changes and leave those comments and vote to approve or reject that particular code, or you can say to upgrade or what all changes we want to make it. They vote for it, that whether that needs to be made to that particular solution or not. So these are the PRs. Next, we have branches. So we can manage multiple branching information in this particular section. You can create or release branches from master to dev. Okay, so all users can actually create or release branches from branching information available in this particular section. Next come tags. So tags are used to point out specific commits, like giving message tags and data information to branches. You can create your naming conventions to branches by using commit tags. And the next one is pull request, which we have already discussed. The PRs that are basically used in pushes. So now we have completed repos also. So let's move on to the next one, which is pipelines. So here you can see that we don't have any pipeline created for us yet. So let's have a look at its provided options one by one. The first one is environments. So basically it is a collection of resources where you actually deploy your application that you're working on. So you can say it contains one or more virtual machines, containers, web apps, etc. Whatever resources you have actually used for deploying your application, or what all services you have used for creating the environment for the deployment of your application. For say we need to deploy our application and it needs an Windows Java environment. So whatever resources you need to create that environment, that will be added to this environment list. It will be listed over this section. Next we have releases option. So basically this pipeline stores the data of your pipelines or stages or tasks and deployments in Azure pipelines, that deployments you have done so far in your applications, for your applications actually. So you can say that it helps your team continuously deliver software to your customers at a faster pace with a very minimum, you can say lower risk. So you can fully automate the testing and the delivery of your software or applications on multiple stages. Or you can also set up an automated process with approvals and on-demand deployments. Then comes library. So again you can see the page is blank. From the name itself we can scrutinize that it will be a collection of assets from Azure DevOps projects. So basically it is a collection of build and release assets of a particular project. So assets defined in a library can be used in multiple builds and multiple releases pipelines of the project. Okay, so all assets that are defined in a library share a common security model. So you can control who can define new items in a library and who can use an existing item that you have already added in this library. So roles are defined for library items. Per se, you have added a particular asset or particular item to this library segment, and you can assign a particular member who will be working on this item. Okay, so roles are defined here for these, and these governs the operation you can perform on those items. That person will be keeping track of whatever changes have been made or whatever upgradation has been made to the particular item that has been added to this segment, library segment. So then comes task groups. So task groups are a way to standardize and centrally manage deployment steps for all applications in your projects. So when you include a task group in your definition and then make a change centrally to the task group, the change is automatically reflected in all the definitions. So we can conclude with this that a task group allows you to encapsulate a sequence of tasks already defined in, you can say, build or a release pipelines or into a single task group. So it just encapsulates all those sequences of tasks. So you can choose to extract the parameters from those encapsulated tasks as configured variables and abstract the rest of the task information. So what happens is the new task group is automatically added to the task catalog, and it is ready to be added to other release and build pipelines. So task groups are stored at the project level and are not accessible outside the project group. So the task groups will be only limited to the members who you have assigned in this project, and it won't be accessible to the other people or other team members from different projects, even though they are the member of the same organization. So you can say it's more of a private segment. Now that we have covered task groups, next we have deployment groups. So deployment groups are only available with classic release pipelines, and it is totally different from the deployment jobs. It is basically a collection of deployment related steps defined in a YAML file to accomplish a specific task. So in nutshell, it is a logical set of deployment target machine that have agents installed on each one. The deployment groups represent the physical environment, for example, testing or development or production environment. So a development group is just another grouping of agents, much like an agent pool, you can say. So what you can do with this is you can specify the security context and runtime targets for the agents, or you can let yourself view live logs for each server as a deployment take place. Or you can also enable you to use machine tags to limit deployment to a specific set of servers. So this was about deployment groups. Now that we have covered one more service, let's move on to the next one, that is test plans. So test plans, the first one we have is progress report. So you can analyze with this only. The progress report will be the progress of the project you have been working on, or the deployments you have been doing, or the tasks you have been performing. So basically it lets you analyze and view data for more than one or an individual test plans in a particular project. So data for test plans can be migrated from an on-premises Azure DevOps server that won't show up in this report. Okay. So basically this section lets you drill down by each test plans and give you summary of each test plan in it. So this section also lets you to navigate to a test plan or suite of choice by double clicking on it. Okay. So this was the progress report. Next we have runs. So basically it represents the execution of pipelines. So during a run, the pipeline is processed and agents process one or more jobs. So when you run a pipeline, many things happen under the cover. While you often won't need to know about them, occasionally it's useful to have the bigger picture, right? So Azure pipelines will get processed under this test runs segment. So you'll be able to see what all performance is happening over here. Like while you're running a pipeline, you can see the running state, the date you have started that, or what all that running pipeline includes, like jobs, steps, and tasks. So runs power both continuous integration and continuous delivery pipelines. Next we have load test. So basically Azure load testing is a fully managed Azure service that enables developers and testers to generate high-scale load with custom Apache JMeter scripts and gain actionable insights to catch and fix performance bottlenecks at scale. So basically, application performance and resiliency are more important than ever before. So how you can run an Azure DevOps test? So first you need to click on it and select a test suite that contains all the automated tests, and you can just choose the run test option. And it will start processing it. So this service basically simulates traffic for your application, you can say, regardless of on which platform or where it is actually hosted. So now that we have covered test plans as well, let's move on to the next one, that is artifacts. So this is the last service that is provided to your project by Azure DevOps. So artifacts is a byproduct produced during the software development process. So it mainly consists of the project source code, dependency, or binaries or resources that could be represented in different layout depending on the particular technology. So it's like an extension that makes it easier to discover, install, or publish and Maven packages in Azure DevOps. It's basically deeply integrated with other hubs like Build, so that package management can become a seamless part for your existing workflows. So what is exactly it is used for? So it can be used for both public and private organization with teams of any size. It basically manages your NPM or NuGet packages via feeds, and it allows you to create and share your Maven. So it's a package management solution integrated with your Azure DevOps. So this was all about the services that is provided to your projects. So now that you know what all services do for your project and what are their benefits and how they function, now you can actually plan your project and start creating and working on it and start deploying with the users and what all services you want for your particular project. So what you can do is click here on project setting. Just a second. Yeah, you can just click on project setting. So now what you can do is you can add in description that what your actual project is about. So for say, like I said, if you're creating in a healthcare application, so you can just give it a description that it is for healthcare related issues, queries, and helps needed, and like you're tying that particular application with different hospitals or healthcare organizations. So you can actually add those information in this description. And the process, which basically it is basic for private one, but you do get a range of process for your project when it depending on the visibility of it, like for Agile or Scrum, you can say. So now here you can see that only my ID is attached to it, as I'm the only member here and I'm the administrator. So you can add members here, and scrolling down, you can, now that you know what all services provide you or what they provide to your project, so depending on the need of your project, you can just select the services you want to assign to your particular project. Like, per se, if I don't want boards assigned to it, or you can say if I don't want the services provided by the boards, you can just click on it and select remove boards, and I just need to refresh it. So, yeah, here you can see I have overview, repos, pipelines, artifacts, but I don't have test plans and boards. As you can see, test plan is basically all the collection of whatever you're managing, which is indirectly assigned to boards. So as you remove the boards, the test plans also get removed. Okay, and once like this, you can just select what all services you want specifically, and if you want to delete your project, you can just go ahead and delete it. So this was all about the Azure DevOps services and Azure DevOps Virtual Studio, we can say, and how the demonstration of how a project actually functions in this Virtual Studio.
So guys, let's start with what is Docker. So guys, Docker is a powerful platform that revolutionizes the software development and deployment by simplifying the process of building, shipping, and running applications within lightweight and portable containers. These containers encapsulate everything that an application needs to run, including code, runtime, system tools, libraries, which ensures consistency across different environments. Unlike traditional virtual machines, Docker container shares the host system kernel, making them extremely efficient and fast to start up. Docker enables developers to package their applications and dependencies into easily distributable images, which can be deployed seamlessly across any infrastructure from local development environments to public or private clouds. With Docker, team can accelerate software delivery, improve scalability, and enhance collaboration between development, operations, and quality assurance teams, ultimately leading to a faster innovation and more reliable software releases. Why Docker is important? Docker is important for several reasons. So guys, the first reason that comes up to my mind is portability. Guys, Docker containers are lightweight and portable, which allows applications to run consistently across different environments, such as developer laptops, on-premises servers, and cloud platforms. This portability enables seamless migrations and scaling of applications without compatibility issues. The next one that comes up to my mind is efficiency. Docker containers shares the host system kernel, leading to faster startup times and reduced overhead compared to the traditional virtual machines. This efficiency also enables higher resource utilization and improved application performance. Next that comes up to my mind is isolation. Docker also provides process-level isolation, which allows applications to run independently within their containers without interference from other containers or host system. This isolation enhances security and stability by minimizing the impact of software conflicts and vulnerabilities. The next one is scalability. Docker's lightweight and modular architecture makes it easy to scale applications horizontally by deploying multiple containers across distributed environments. This scalability enables organizations to meet changing workload demands quickly and efficiently. Next is DevOps enablement. Docker facilitates DevOps practices by promoting collaboration between development teams and operations and QA teams. With Docker, developers can package and deploy applications consistently. while operations team can manage infrastructure more efficiently using container orchestration tools like Kubernetes. Now, overall, Docker simplifies the process of building, shipping, and running applications, which leads to a faster delivery, improved reliability, and increased agility for organization across industries. Now, we'll try to understand what is the basic difference between a Docker and a virtual machine. So guys, if I talk about Docker versus virtual machines, Docker and virtual machines serve similar purposes, but they operate kind of differently. If I talk about virtual machine, they emulate the physical hardware to create isolated environments where multiple operating systems can run simultaneously on a single physical machine. Each virtual machine requires its own guest operating system, consuming significant resources and leading to slower startup times. In contrast, Docker uses containerization technology to run applications within lightweight, isolated containers that share the host operating system kernel. This approach eliminates the need for a guest operating system, resulting in faster startup times, lower resource overhead, and greater efficiency. Docker containers are highly portable and can be easily moved between environments, while virtual machines require more complex migration processes. Overall, Docker offers great agility, scalability, and resource efficiency compared to virtual machines, making it an ideal choice for modern microservices-based architectures, DevOps practices, and cloud-native applications. Now, we'll move on and understand about Docker components, where we will discuss about Docker engine, Docker images, containers, and Docker registry. So guys, Docker has 4 important components. The first one is Docker engine, then is Docker images, next comes containers, and there is Docker registry. Now let us discuss each one of them one by one. If I talk about Docker engine. So guys, Docker engine is a core component of the Docker platform. It is a client-server application that consists of a daemon process called Docker running on the host machine and a command line interface client called Docker, which is basically used to interact with the daemon. Docker engine manages Docker objects such as images, containers, volumes, networks, and many more. Now let's move on and discuss about Docker images. Guys, Docker images are lightweight, standalone, executable packages that contains everything needed to run a specific application, including the code, runtime libraries, dependencies, and system tools. Images are created using a Docker file, which specifies the instructions for building the image layer by layer. Images can be shared and distributed via Docker Hub or private Docker registries. Now, let us understand containers. So guys, Docker containers are exactly instances of Docker image that are running as isolated processes on the host machine. Each container has its own file system, networking, and isolated process space, making them lightweight and portable. Containers can be started and stopped, restarted and removed using Docker commands. They provide consistency across different environments and enable efficient application deployment and scaling. Now if you look at this architecture guys, you can see there are application A, application B, and application C. And the overall architecture of a virtual machine includes a hypervisor beneath it, then there is a host operating system kernel, and then there is an infrastructure. The hypervisor typically operates as an intermediary layer between the host operating system and the virtual machine, which facilitates a communication between them. Whereas if I talk about Docker, you can see rather than containing an entire guest operating system within, a container leverages the host operating system through the container runtime while ensuring the isolation. Now we will move on and understand about Docker registry. So guys, Docker registry is a service basically for storing and distributing Docker images. Docker Hub is the official public registry provided by Docker, where users can find and share Docker images for a wide range of application and software stacks. Additionally, organizations can set up private Docker registries to store proprietary or sensitive images internally. Docker registries allows users to push, pull, manage Docker images, facilitating collaboration and deployment workflows. So guys, this was all about the basics of Docker. Now we'll move on and install Docker on our Windows system. So guys, now let's move on to our favorite web browser, that is Google, and from there we will go to Docker Desktop.
download. Okay, so just click on this and you are going to get this Docker desktop. Now what you can do, just here you can just click for download for Windows. You can go for, if you have a supportive version for Mac Intel chip, you can go for this. If you have an Apple chip, you can go for this. If you have wanted to do for Linux, you can do for this. Now just click on this and you can say your Docker desktop is just on the download list. Now few important things I want to tell you. After this, you need a distribution package, okay? So that is WSL for Windows. So you can download that distribution software which is going to enable your Docker desktop. The installation process is very simple. Now let me show you some of the magics of using Docker desktop. Okay, so we will be building this normal folder. Okay, so here I've built a folder called Docker and I'm using VS Code as our text editor. So guys, what I will do, okay, so I will open my VS Code and let me show you how our Docker desktop looks. Okay, so okay guys, you can see all over here, this is our Docker desktop. You will get something like this. Here is containers. Since I am running no containers, so it is showing empty. Here are images. You can download any images from the Docker Hub, which is our registry. And there's a builds, there is a volumes, there is a development environments. Okay, but there are a lot of other features. Okay, so let's move on little by little and let's understand how we can integrate Docker desktop in our development process. So guys, what I've done all over here, so I've created a folder which is kind of empty. Now, simple thing I'm gonna do, I'm gonna go to my VS Code, okay, and I will try to open this folder. So open folder, and on the desktop, I'm going to get a Docker folder. So just right click on this, okay, very nice. Now, let me delete this. So you can see all over here, I have created a file called Docker. So I'll delete it and make it once again. So just right click all over here and type Docker file. Okay, you can see there is a shine of a Docker, okay, all over here. Now, what we are going to do, we are going to type something, okay. We are going to type hello world on Docker. Sounds amazing, okay, because on different programming languages, our first program is hello world. So I thought, like, let me show you how we can type hello world in our Docker. So guys, let me write the code. So I'm going to type from Alpine and latest. Okay. Now I'll explain each code one by one. Now here I'm going to create a directory. Okay. So let's create a directory. Okay. Now I will type run, okay, and mkdir, that will be our /app directory. Okay. Now we are going to write the hello world. Pretty good. Now, so in order to write hello world, I will type run echo hello world. Okay. And let's add some exclamation mark. Okay. So next, what I will do, since I've created a directory all over here, so /app /hello .text. Okay. Now we have typed all over here. Now we are going to set the working directory. So we'll type work dir /app. Then I'm going to specify the command to run the container. So I will specify the command to run our container. CMD Okay, here miss something. That will be cat. Okay, now here let's type the name of our file, which is hello.txt. Okay. Now program is completed. This is a very basic program, and let me explain you what I have written. So guys, from Alpine latest means that it basically specifies the base image to use for the Docker image. In this case, we are using the latest version of Alpine Linux. Next, we can see I am creating a directory mkdir. Okay, so k is missing. So mkdir/app. Then what I'm doing, I'm writing the hello world. So run echo hello world, and I'm creating this app/hello.txt. Basically means it writes hello world to a file name hello.txt inside the /app directory. Then there is work dir. Okay, it actually sets the working directory inside the container to the /app, which is our working directory. Okay, now what is going to happen? This means that subsequent commands will be executed relative to this directory. And finally, we have written cmd cat hello.txt. It specifies the default command to run when a container is started from this image. In this case, it prints the content of the hello.txt using the cat command. So basically, this Docker file can be used to build an image. Running a container from this image will output a hello world. One more thing guys, that there is an extension and you can install the Docker extension in your VS Code. So you can say Docker. You can see I have already installed it. So you can install this extension on your VS Code. Now let us run our application. Okay guys, now the first command that I will be typing, that is docker build t hello world, which basically is going to do what? Is going to build our Docker file. So let's click on this. So you can see it is building our Docker file. Okay, now it has created a directory all over here. Now let's run this file. So I will type docker run hello world, and you can see on our terminal it is printing hello world. We have successfully done this thing. Now there are certain other more important commands, and let me also tell you about it. Now guys, in this we'll be learning about important Docker commands. The first one that comes up to my mind is docker run, which we have already applied it all over here. So guys, the first command is docker run. So basically, this command is going to run a new container. For example, you can type certain like this, docker run hello world. Okay. So this is our first command. Now, in this case, you want to list the containers running. So for that, there's a command called docker ps. Okay. So suppose there are certain options associated with it, like ps a or all. So let me show you this command all over here. And so you can see already this container is running, which is cat hello.txt, and it shows 3 minutes ago. So it is going to list the containers running. For the Docker images, you can type certain like this, Docker images. Okay, so it is basically going to show you the available images on your system. What images you have basically created. Okay, so let me type this. If I type all over here, so you can see hello world is our latest image. So there is an image ID created, okay, and the size of it. Okay, now let us do certain things else, which is Docker build. So guys, Docker build is going to basically build a Docker image from a Docker file. So this syntax for this is like Docker build T and then the name of your image. So in this case, it was hello world. So this was there. So I've already ran this command on the system. I'll show you. So you can see Docker build T hello world. Now, next thing is Docker pull. So guys, if we talk about Docker pull, basically it's going to pull an image from a registry. For example, say Docker pull Nginx. Okay. Next is Docker push. So guys, Docker push is going to do what? It is going to push an image to a registry. So for example, Docker push, then hello world. Next is Docker stop. Okay. So basically Docker stop does what? Docker stop is going to stop a running container. And the same syntax can be used. So it will be Docker stop. Now, next command is Docker start. So basically, this command is going to start a stopped container. So for example, Docker start. Okay, let me copy this. And what is the ID of the container ID you have to give all over here? Okay. Next command is Docker restart. Now, this command is going to do what, guys? This command is basically going to restart a running container. So for example, the same command all over here, and with a particular container ID. Now, final, that is Docker RM. So guys, basically Docker RM is going to remove one or more containers. Okay. So for example, Docker RM, same, and with a particular container ID. Now, next command is Docker RMI. So guys, basically it's going to remove one or more images. So for example, Docker RMI and with a respective image ID. Now our final command, that is Docker X. Okay, so guys, it is basically going to run a command in a running container. For example, Docker XC. Okay, now in this, what you can give, guys, suppose Docker X it container. Okay, we're going to give the container ID. Or we can give /bin and give the bash command. So basically, this is going to run a command in a running container. That is what you have to remember about this command. It is a very useful command. Okay, so whenever you are building any microservices, there you can apply these principles. Now finally, so guys, these are just few basic commands to get started with Docker.
the Docker commands over here. In this topic, we are going to talk about what exactly is the various Docker commands which we can use to interact with the Docker images, Docker containers, and some core components of Docker is what we are going to talk about in this particular topic here. Now let's begin with what exactly is in Docker, because we are trying to explore that what are the different Docker commands we can eventually run to interact with the Docker, because you have the command line interface which is available there, using which you can run some couple of Docker commands, and internally you will be able to have some particular processing which is done at the Docker end. Now Docker is a configuration management tool. It's being used as a configuration management tool just like the other configuration management tools in the industry, in the market. Now it's pretty much used by the developers to make sure that they wrap or they package an application with all its dependency. Now normally in a virtual machine, what we do is that we host or we install the dependencies separately, and then on top of that we host our web applications, or whatever the application we have, we host it on that particular framework or platform. But here in this scenario, we are talking about like how we can wrap an application all together with its dependencies. All the dependencies are getting wrapped, are getting packaged up into a single entity, and that's what we call it as a Docker container. So Docker is a configuration management tool and a containerization tool which is there, which helps us to wrap or package both the dependencies and the source code within a single unit called Docker container. And this is the Docker container which the developers use to do the deployment across multiple environments. So as part of the process, when you are working on the hosting of your application onto your Docker, so ultimately you are looking forward for an entity called Docker container. So if you go through the diagram over here, so in this one, this is in kind of a basic way architecture that how the Docker is being architect and is getting deployed. So initially you have an infrastructure, like a physical infrastructure is there. You have the particular cores, memory, infrastructure, all those things are available there. Now on top of this infrastructure, you are hosting up a host operating system. This host operating system is responsible for taking up all the requests and interacting, providing a particular interface between the particular Docker and the infrastructure, the core hardware. So it acts like a medium over here. So after the host on operating system, on top of that you are going to install the Docker engine, Docker software. It's just like you got a virtual machine on Linux, and on top of that you are installing the Docker software. Once the Docker engine is installed, then Docker engine will take care of management of the Docker containers. You don't really have to do a lot of work. Docker engine is going to take all the internal work, the communication between the operating system and the infrastructure, so that needs to be done by the Docker engine. So Docker engine makes sure that the different container gets up and running, and you can see that in this scenario, in this diagram, we have container 1, container 2 and container 3, and all these containers are actually having its own applications and the dependencies binded up together. So that's the reason why we are saying that with the Docker we are getting a complete package. End-to-end package is being given to us, in which we have both the particular source code and the binaries and the executables embedded inside that. So it's a complete package which is getting created in the form of Docker container, and the developer is responsible for preparing this Docker container so that these containers can be deployed on the Docker host and you can get your application up and running. So this is what we have Docker into a particular and the architecture of the Docker here. Now let's see that what are the different commands we have for the Docker here. Now the very first one is that what are the different images related commands which is available there. The very first one is the command which we typically use to prepare a custom Docker image. Now I can easily go to the Docker Hub and I can pull down a Docker image which is available there. But let's assume that you are working on application source code. So you want to prepare a Docker container for that. Now that Docker container, you will not be able to have it on the Docker Hub. You have to prepare on your own. Right? So in order to prepare your own Docker image, all you have to do is that you have to run docker build command. Now in this case, we have to prepare a Docker file which will act like a Docker, a kind of a Docker build script. Just like in case of Maven we have pom.xml file, and in case of and we have build.xml file. So here we have the Docker file which is available there, and this Docker file makes sure that whatever the steps are mentioned in this Docker file in the build script, it's going to perform a series of steps and the build will be done. So Docker build is the command. -t is the tag that what exactly name whatever the image you are building. So what exactly tag name you are trying to provide over here. So here we are using a tag name called my image, and then after the colon we are providing that what version we want to go here, 1.0, 2.0, 5.0. so whatever the version you feel that you want to refer, you can do that. Now this is the exact way that how in the actual world the Docker images are getting built up by the respective vendors. Let's say that Jenkins wants to prepare a Docker image. So they will be preparing the Docker file in the same manner and prepare these Docker images and publish it to the Docker Hub. So all the Docker images are built up, the custom Docker images are built up with the help of Docker file. So Docker build is the command which will process the Docker file and give you a particular Docker image in the end. Now how to list down all the Docker images. So Docker list ls is something which is there. So this will eventually help you to list down all the Docker images which is listed on or which is available into your system. So that will be listed out over there for you. If you feel that you want to remove a particular image, in that case you can go for Docker image rm command, and whatever the image you want to remove, you can give the respective image name and the tag name there. So Docker image rm command is there, using which you can actually see that how the image can be deleted from the host over here in this one, right? So whatever the ways, whatever the mechanism is there, so we are making sure that how the image can be built up and how we can go for the built up and a particular image can be deployed over here in this case. So in order to delete a Docker image, so you can go for Docker image rm command to remove a Docker image completely from the Docker host. So these are some couple of commands which is available there, using which you can actually interact or manage the Docker image. Because in order to prepare or in order to run a Docker container, we require a source, and that source we are going to get it from the Docker image.
So now we are going to see that how we can execute these commands. So first of all, what we need to do is that we need to see that how Docker build works. For that, we require a Docker file. So I'm going to have a simple Docker file over here, in which we are going to have a basic Docker image selected as an Ubuntu. After that, we are going to go for the one attribute where we are going to do the installation of a specific package, like let's say Git. And accordingly, you can, whatever software you want to prepare, you want to set up, you can do that and put up the commands over here in this Docker file. So I'm going to save this file, and after that what I need to do is that I need to run like Docker images to find out that how many images are there. There is no images present, so I'm going to build a Docker image over here with the name of Simplilearn, or whatever the name you want to give. You can give it over here. In this case, it's not any kind of restricted word, so you can give the actual Docker image name also, that for what purpose you are preparing this image. And with that, what will happen that it will take up the values, whatever attributes you have put up into the Docker file. So that will be processed and that will be picked up. And once that Docker file has been processed, has been prepared, you will be able to see that yes, a final product or a final Docker image is finalized and prepared over here in this one. So we just have to wait for the whole process to complete, and once my Docker image is prepared, I will be able to have a particular setup done or achieved over here. So that's what we require over here in this one to be performed. Now once the installation is done, so you will be able to see like the final Docker image is being prepared over here. So it says successfully built, which means that the Docker image is prepared. Now if you run like Docker images, you will be able to find out that this image is available over here in this one. Now you are seeing like two images, because one is like the basic image which is being pulled down, because we are using a Docker file to do that, to process that one there. Now in case you want to remove it, so all you need to do is that you need to run like Docker image rm and Simplilearn. So if you do that, what will happen that your Docker image which is related to Simplilearn will be wiped off from your system. And in case you want to do like removal of the Ubuntu also, so that also you can do over here with the help of Docker image rm Ubuntu, and that will be removed from your system. So your Docker images will be removed from your system using the particular command called Docker image and then rm command to remove the Docker image from your system, from your
host here. So that's how you deal with the different Docker images commands over here in this one. Now let's go back to the document.
Now the next section over here is the Docker container commands over here. So all the commands related to Docker containers is what we are going to talk about over here. Now the very first one is the particular container. So in order to create a container, so you can run the command called docker create and the image, because for a container you require a Docker image. That's a prerequisite. So once the Docker image is prepared, you can just simply run docker create command, and that will help you to create a container onto your system. Now if you want to run a particular you want to create a container and you want to run it also at the same time, so in that situation you can go for docker run command. The main difference between the docker create and docker run command is that the docker run command is going to run a container, and it's going to give you a response from the command, but the docker create command is going to create only the container. So once the container is up and running, so that's only being done by the docker create command, but the docker run command is going to actually do the preparation of the container also, and at the same time you are being given as a particular response also, like what a command you want to run, so that response also you will be able to get here. And if you feel that you want to rename an existing container, so for that you can go for the docker rename command. So existing container you can rename it with the new container, and that's how the particular rename of an existing container will be done with onto the docker host here. So docker rename is the command using which you can rename an existing container and you can get a new container over here in this case. So these are some of the options, some of the ways that how you can interact with the containers, how you can manage them onto your Docker host over here. So you can run it, you can create it, and you can rename the containers also.
So now what we are going to do is that we are going to see that how we can work on this particular container commands here. So first of all, I'm going to quickly pull down a Jenkins image so that I can create a container out of that. So it's in kind of a 600 around MB Docker image which is available there. Now you can also have a custom Docker image prepared using the Docker file, or you can have a ready-made Docker image pulled down from the Docker Hub also. So this is going to pull the latest version of the Jenkins from the Docker Hub, so that we will be able to proceed further on that and we will be able to continue with the hosting. So we will be converting or running this specific Docker images in the form of Docker containers, so that we will be able to have instance of Docker container over here running in this one. So that's what we are trying to do here. So we will just wait for this pull activity to complete, because it's an heavy Docker image, so it may take some time to download. And once it's download, you will be able to see that Docker images is showing a specific Docker image of Jenkins here. Now you're going to create a container out of that. So you're going to run a command called docker create and Jenkins over here. So that will help us to do the creation of a Docker container. And once that is done, so you will be able to see, like using docker ps command, that if any container is up and running, and if you go for docker ps-a, you will be able to see that yes, a particular Docker container is in created mode. Now this is not in running mode, because you see that when I ran the docker ps command, it was not showing it in the running mode, because I just created a Docker container here, and the created status also shows that yes, the Docker container is created, but it did not run over here. So if you want to run it, so definitely you can say like docker start, and you can give the container name, and that will help me to start my container over here. But of course, if you feel that you want to directly create a container, and you don't want to create the container only, you want to start it also, so in that case you can go for the docker run command. So docker run command is something which can be used instead of doing the execution. So you can say like docker run Jenkins, and what it will do, it will definitely help you to get the container created onto of the Jenkins over here. In this case, it's not like only creating a container, but in fact it's actually starting the container also. So you can see that it started over here into your screen itself. That whole Jenkins gets initialized over here in this one. So this is the way that how you can initialize or you can create a container. Now I can just do a Control-C over here, because it says that Jenkins is up and running. So you can start using this one according to your requirement over there, right? So I'm just doing Control-C so that it can be stopped over there.
right? Now, so this is the way that how typically we can create the containers. Now we got like two containers over here, and one is up and running, and one is something which I just closed just now over here. Now if you feel that you want to rename a container, let's say like this is a container which is available but it's not having a meaningful name. Now I want to convert it into a meaningful name like dev_Jenkins. So that you can easily do with the help of docker rename command, because that will rename the docker container name so that you will be able to connect on to that and you can go for the processing. So that's what we can get over here in this one. So this is how you can do the various management of the resources over here. So let's go back to the main content.
Now, if you feel that you want to remove all the stopped containers, because what happens that sometimes we simply stop the container but we do not remove it from the Docker host because we are not going for the cleanup. Now cleanup is very required because these containers are actually taking up the disk space also. So we need to make sure that we should be having like minimum amount of disk space utilization. So for that, what we really need to do is that we need to run docker container prune command. So this will basically help you to prune or do the cleanup purge of all the containers which is running on the host machine here. And that will definitely help us to remove all the containers which is in stop status. So that will be simply removed over here in this one. So this completely removes all the stopped containers onto the Docker host over here in this scenario. Now second one is that it creates a new image from a containers file changes. Now the way what happens that normally what we follow is that we use the docker build command to do the build process, right? So docker build command is being used in that particular way. Now if you really want to go for preparation of a new image, so all you need to do is that you need to create a new image from a container file. So you can run the command called docker container commit command, and whatever container is there, so that will be saved or preserved as a docker image. Because sometimes we also do some ad hoc changes or modifications on the fly inside the docker container by going inside the docker container and doing the steps. So we really need to preserve those steps, and that is the reason why we are converting a docker container in the form of a docker image here. So that's what we are trying to perform here. So docker container is something which is being done over here in such a way that whatever the steps, whatever the changes we are trying to do, so that needs to be performed over here in this case. So docker container commit command is being used so that we can get a particular final image as part of the container. So the container will be converted in the form of a docker image over here. And the last one is that how we can remove an existing container. So we can go for the docker rm command, which is available there, using which you will be able to go ahead and you can get a particular container removed from your existing system. So docker rm command is pretty much there, using which we can see that how we can remove an existing container from your system as such.
What exactly now we are going to see that how we can perform the various commands on the containers here. So the very first command which we want to do over here is that in order to see that how we can actually remove all the stop containers. But for this one, what we really need to do is that we need to first of all run some couple of containers. So I'm going to quickly run a container called docker run -d httpd. So I'm going to run a particular web server over here, and it should be able to give me a proper container up and running. So I can just double check or validate it as with the help of the docker ps command. So docker ps command should give me the proper confirmation that whether the container is in up and running over here or not. So you can see that it's up and running from last 11 seconds here. Now we got a command where for example we have got some stopped containers, but again you have to manually remove them one by one. Now if you don't want to do that stuff, if you feel that whatever the stopped containers which is available that should be automatically removed from your system, then we have a command called docker container prune. Now for this, what we really need to do is that we need to actually stop this container, because again it will be only picked up like whatever the containers which is available in the stop status, only those will be picked up. So I have copied the container name here in this case, and I need to stop it so that I will be able to remove it with the prune command over here in this one. And then I can run like docker container prune command, which will
basically remove all the containers which is in the stop status. And once that is done, you will be able to see like that is something which is completely gone from your system. So this is a way that how it can not only take care of the stop containers, but it's actually being done so that you can remove the multiple containers with a single command itself over here. So this is not something which will be executed one by one on a different container, but yes, it will definitely take care of doing the changes and performing the activities. Now another thing is that how we can actually do the commit of a particular Docker image. Let's say that we got a Docker container which is running, and there are some changes like some dynamic changes which is available there. So you want to save this particular container as a Docker image, so that whatever the changes, temporary changes are there, so that will be also saved as a Docker image. So all you can do is that, let's say, let again run a particular container of HTTPD here. So this will help me to get a particular container from the HTTP perspective available to us. So docker ps command will give me the option. Now here I have got a container in which it's running. Now if I want to save this container, let's say that I went inside it, did some modification, did some temporary changes. Now I want to refer it, I want to use it. So how you can do that? So for that, what you really need to do is you need to run like docker commit, that's a command, or you can say docker, because you're going to do a docker container commit over here. So the commit of the container is what we are going to do. So docker container commit, and then we are going to say like what is the container. So for container we will be again copying that particular container ID, and we'll say like custom image colon version 1. So we will be giving a custom name or a name of a Docker image and a tag over here in this one. So this will basically save my Docker container which is available in this one in the format of a particular Docker image, in a format of a Docker image over here in this case. So as you can see that almost both of them are having the same change, but the container which we got over here in this one, so this whatever the changes you want to do, you can do that, and you can then put it up into the form of a Docker image, a final Docker image. And at last, if you want to remove it, so docker rm and container ID. Now this again docker rm will come remove only those containers which is in stop status. So if you want to forcefully remove it, so you will be able to use it with the help of -f, which is the forceful remove, which will remove the container completely from your system. And once it's removed from your system, you will be able to see like there is no container running up and running over here in this one. So docker ps -a is not something which is up and running over here in this one. So the completely got wiped out from your system. So that's how you basically work on these commands on this particular container related commands here. So let's go back to the main content. Right, so these are the commands where we can actually do the management, like how to stop the containers, how to remove the containers, and how to get a new Docker image out of the container here. Now let's see that how we can list down all the running containers. If you feel that you want to list down all the running containers, then you can go for the docker containers ls command, and that will eventually help you to list down all the containers which is available there, which is being there into your system. Then docker stop command is there to stop a container. So whatever container which is there in the running status, so that will be stored with the help of the docker stop command. And then the restart command is there, using which you can do a restart of a container into your system. Right, so once the container is restarted, so whatever the application running inside the container, so that will also be restarted over here in this one. So these are the different options which is available, using which we can explore over here in this one. Somewhat more commands about the container. So again, I am going to run a container over here of HTTPD here, so that I can show you some couple of more commands over here. Now we can run like docker ps, or you can say like docker container ls will list down all the containers which is available to you, which is being present in this case. Now if you want to do any kind of operations, like let's say if I want to stop it, now the moment you do the stop over here, so you will be able to stop the container which is up and running for you, and you can come whatever the application is being deployed, that will also not be available to you, because that's simply completely gone for you. Now you can see that Docker container list is not able to show you that particular option, that whether it's being shown or not, because it's in stop status. So in fact, you can do a start, or you can do a restart. So both the operations you can pretty much do over here, so that you will be able to have a complete activity implemented. So restart is also something which is available, which can definitely help you to see that how the things really work, and how you can go for the container the management over here in this case. So you can do docker container ls command to list down what are the containers which is available. Then you can do a restart, you can do a stop also. In fact, start is also there, which can help you to see that how the containers is really available. So this is the way that how you can manage like even the restarts and all, because this really helps you to even do the restart or bounces to the application which is present inside this container. So that also you will be able to see with this particular component here. So that, let's go back to the main content. And then killing a running container. So if you really want to kill a container, so for that we can go for the docker kill, because docker stop is also going to stop the container. But if you want to forcefully kill it, so in that case you can go for the docker kill command to do that particular kill on the containers. And then if you really want to go inside the container and you want to attach your terminal, so for that you can go for the docker attach command, and with this what will happen that you can go inside the container, you can do whatever the changes you want to perform, you can do that, and you can again come back outside that also. So normally typically we use it so that we can see some errors of in the logs which is coming up in the containers, and if any kind of issues are coming up for the applications, we should be able to know that part. Now the last one is the particular wait. Docker wait is there, so that will block a container, and it will go in the wait status. So docker wait and the container ID or the container name you can give. So with that, the particular container will go into the block status. Let's see somewhat more commands over here. So we can run like docker container ls again to find out like what container is available. So you can see that this particular container is available over here in this one. Now if you see, like if I want to get attached to this container, if I want to attach my input and output stream with this container, so you can run like docker attach and the container ID. So your terminal will be stuck over here because it's taking up whatever the progress which is going to be done in the container, that will be in a kind of attached to your terminal over here, and you will be getting the output. But the moment you come out of this, like you say Control C, so you will see that it's basically sending the request to the container that it's getting stopped. So you will be able to see like the docker container list is not going to show you because the container is in stop status. So again you have to do the restart of the container to make sure that the container is up and running. Right, so the attach one will help you to go and attach your standard input and output with your container, with a running container. But when the moment you comes out, you will be able to disconnect or shut down the container. And again I had to restart that container over here in this one. Then again of course we have like docker wait, then container is there. So this will basically put the container into a block status, because all the requests and all will be not sent to the container, and it will be blocked. And if you really want to like consume, or if you want to make use of the container, you will not be able to do that. So docker wait command will kind of block the container, and if you again try to come out of that, so again the requests to the container will be resumed, and they will be able to use on that part. So docker wait command is being used to block the container, and then we have docker attach to the container, the standard input and output, and lastly is the docker kill, which is going to kill the container, and you will be able to see that the container is in simply killed status. So it's it's not like a stopped over here. If it's gracefully stopped, then the exit code definitely will be 0, but in this case, since it's being killed, the particular status is 137 over here in this one. So that's a non-zero status code. So that's how way you will be able to manage the containers on different aspects. Let's go back to the main container. So these were some of the commands which was there from the Docker containers perspective. Let's talk about some of the commands from the share command perspective. So how we can share the Docker images. So we have a typical pull push mechanism which is there, using which we can actually interact with the Docker hub or a Docker registry. So if you really want to pull a Docker image, so in that case you can go for the Docker pull command. If you want to push an image to the registry, so you can use for the docker push command. If you want to execute a command inside a particular running container, or you want to execute a command or a script or something like that, so you can go for the docker exec command, and with that the execution will be done and you will be able to get a response. So that will make sure that yes, whatever the execution you are trying to do, so that will be done over here in this mechanism. Now let's see that how we can do a pull and push activity to a Docker image. So first of all, the pull command is pretty simple. All you need to do is that you need to say that, okay, I want to pull a Docker image. If let's say that our Docker image is already present, then it's just going to say that it's already up to date, it's already available there. But if in some cases you feel that the Docker image is not available and you want to pull it, so all you can do is that you can give that Docker image name, and that you can give the tag also, but in this case we are using the tag as in latest. So that's the reason why even if you provide or you don't provide, it doesn't really matter. So I'm going to give like a Docker pull or MySQL over here, and the moment I hit on this one, what will happen that it says this particular Docker image is not available into my system. It's going to download it, and once it's going to be downloaded, you will be able to see that into your local system. So Docker images is something which is going to help you with the commands, and it will give you the particular ways that how the Docker image is available. So I can run like Docker images over here to see that what are the different Docker images which is available in this manner. Now if you really want to move any of the Docker image, then of course you have to do a Docker login, and you will be doing the the connectivity to the Docker Hub, and then establish the connectivity and all. So what you need to do is that you can run the Docker login command. We will also see this command in the next particular slide, but right now we are just doing it because we want to showcase that how the push really works. So you can actually give your username, that what username you are holding up. So the password does not shows any activity, but yes, still it will let you know that whether the login is successful or not. So in this case it says login is successful. So all you need to do is that, let's say like I got this custom image and I want to push it to the Docker Hub. So you need to rename, or you need to do a tag over here, because the same if you run docker push custom image version 1. So if you do that, it will not be pushed into these particular Docker Hub. So it's going to throw error over here that the access is denied. So all you need to do is that you need to do a tag here. So you have to rename it in such a way that you should be able to add your username over there, because Docker Hub will identify that if it's there with your username, then only it will be pushed. Otherwise it will be simply rejected over there. So that's what you need to do. You need to rename your Docker image, the same Docker image which you have to append your username of the Docker Hub. And once that is done, so all you need to do is that you need to just run like docker, then push is there, then this image name, and then version 1. So the moment you do this, what will happen that it will start transferring those Docker image to the Docker Hub. You see this specifies that yes, this is going to the Docker Hub, docker.io, where my username is there, and this is the custom image which is available there. So if I refresh my page on the Docker Hub, I will be able to see like this public repo which is available there. But again, this one does require the credentials and the login, which we did in just last command, where we ran the Docker login command to do the login to the portal, and after that only we are able to do the setup and the modifications over here. So that's how you do the login, and you are able to connect on that. Now these are some of the pull and push operations. But let's say that if you got a container which is up and running, like this is right now we are not getting any container which is available over here. So you can say like docker run -d httpd, like I'm just running a dummy container over here so that I will be able to show you this command. Now if you for some reason want to go inside the container and want to see some processing and want to see some content, so you can run the command called docker exec -it, and there you can give the container ID. This is nothing but the full format of the container ID which is given to you. So you can use this one also, or you can use the shortened value also you can use. And in the last we can say like bash. The moment you do this, you will be going inside the container. You see that this is the host name which is being shown as the container ID. You can do a like ps-ef command, and it will throw an error that the ps command is not available because you are running this command into the Docker container. So using these kind of commands which is not available in container will help you to identify that yes, you are not on the host machine, you are in fact into the Docker container. So that's the reason why you can do it, because for you the paths and all, everything is same, the terminal is also same, so you may not be able to differentiate in that part. So that's the reason why it's preferred that we use that commands which is going to fail, but that's okay. It will give you that okay, this command is failing because I'm into the Docker container right now. So that's what we are performing over here, right? And you can come out of that, but still the Docker container is going to be still up and running over here in this case. So the container is not going to be down over here in this one. So that's how we manage the container. We can go inside and we can check some informations and get some files there. So these are some of the commands where we can interact. Now in order to log into the Docker Hub, because before doing the Docker push you have to log in, you have to get a credentials and the connectivity with Docker Hub. So you can run the Docker login command where you can see that how the execution can be done. Now using the Docker login command you can interact with the particular Docker Hub. You can set up the credentials. Once the credentials is being set up, so what you can do is that you can go ahead and say that okay, the configurations is done, and we can go ahead and we can perform the execution. So Docker login is the command where you can give the credentials. Docker info is the command using which you can get the information about the Docker tool. So whatever the Docker info is available there, so those things you can actually get it over here in the case of the Docker info. So Docker info is going to give you complete information that what exactly you have the information available over here on this one. And then we have the Docker history. So using the Docker history, you can see history of the Docker image, that what exactly the mechanisms or what are the different image IDs are available there. So this is basically giving you the complete history on how the Docker image is prepared. All the commands is available there, and that will help you to eventually go and understand that how the images can be going on, and you can manage on that part. So these are some of the couple of options which is available there, where we can see that how the executions can be done, and we can go ahead on that particular part. So Docker history is the command again which will help you to see that how you can go for the particular mechanism, and you can listen on the things over there. So Docker login was already done previously when we tried to push the image, but again if you try to run Docker login you will be able to do that. Now Docker info is something which will give some additional information about the Docker, and all the informations about the Docker will be given back to you over here in this one, so the complete clarity. Then let's say that you got a Docker image called HTTPD. Now you want to check the history of this image, that how this image is prepared, what are the different layers which is available, how many layers are there, how much size is being modified in each and every layer. So you can see that we got a layer where we have particular changes of 7.838 MB, but pretty much the from the complete size of this HTTPD, the major portion is actually of the this one, the basic operating system which is being implemented. And then of course there are some packages which got deployed, due to which this 60 MB and 7 MB size is coming up there. So this actually gives you the complete layer wise mechanism, that what are the informations which is available, that how the modifications actually got modified and got changed over here in this one. So this is the additional help which you can get from the Docker to manage the containers here. So these are the ways where you can interact with the Docker Hub. If you really want to create a volumes for the containers, so you can go for the Docker volume create command. So Docker volume create command is there, using which you can create the Docker volumes, and you can pretty much do that setup. So Docker volume create is the command which is available there for that particular part. It will create a volume for you. Now let's see that how we can actually work with the volume. So you can run the command called docker volume ls to find out that what are the different volumes which is available there. Now if you really want to create a volume over here in this one, so you can say like docker volume create, and you can go for the volume name here. Now the moment you do that, what will happen, that a volume will be created, and you can validate it with the help of docker volume ls command, that whether the volume is being created or not over here. So this is the way that how you can manage the volumes onto the Docker host. Now let's talk about some of the Docker swarm commands here. Now Docker swarm commands is there to set up a particular mechanism where you can see that how you can perform a setup. You can actually go here and see that how the setup and modifications can be done. So Docker Swarm is there where we can see that how the execution needs to be done. So you can go for the command called Docker Swarm init command. This will actually go for an initialization of our Docker Swarm cluster, and once the Docker Swarm cluster is initialized, then you can pretty much go there and perform whatever the executions you want to perform. You can do that and you can execute as such over there. So Docker Swarm init is the command using which you can actually see that how the execution needs to be done and how we can perform the mechanism and the changes over here. So Docker Swarm init hyphen advice ADR address is there, which helps you to see that how the executions can be done. Now joins, you have the Docker Swarm join command which is available there. Now if you go for Docker Swarm join command, so you can have a particular host. So Docker Swarm join command is there, which you can run on the node machine, and in that case what will happen, that node will be a part of the Docker Swarm cluster. And then if you want to leave from the Swarm cluster, then you can go for Docker Swarm leave command and it will be simply removed from the Docker Swarm cluster there. Some of the couple of commands using which we can initialize or we can remove from the Docker Swarm cluster here. So Docker Swarm is already being initialized or is being created when the moment you do the installation of Docker. So Docker Swarm init is the command using which you can initialize a Docker container. Now once you initialize over here, so after the initialization you got a command which you want to add it, like you want to run it onto the Docker Swarm cluster. It will act like a worker node so that you will be able to deploy the containers on top of that. Also, if you want to join it as a manager, so you can also get the join token again, so it will give you the proper command. Now if you run like Docker node ls, so you will be able to see like what are the different nodes which is available there. And for any reason, if you're not comfortable with that and you want to reinitialize your Docker Swarm cluster, so all you can do is that you can say like Docker Swarm leave -f, and you will be left out of the Docker Swarm. And now if you want to run like Docker node ls, you will not be able to get that output because it's saying that there is no particular Swarm manager which is available. So you can run Docker Swarm init or you can run the join command to connect to that specific node, but we have already left it and nothing is available over here. So that's a way that how you can manage like what are the different Docker Swarm commands we can typically run to manage the Docker Swarm cluster. Now let's talk about the Docker Compose commands. Now Docker Compose commands is actually there using which we can create multiple containers. It's not only one container which we can go for multiple creations of the containers with the help of Docker Compose file. So Docker Compose -version is the command which we can give you the version of Docker Compose which is being used. So here we use a particular YAML format file which will help us to create the multiple containers. We define the services, that what are the different containers we want to create here, and then with the help of a docker-compose.yaml file we can create or we can have that particular Docker Compose file set up over here in this case. So docker-compose.yaml file is used to do the setup and the modification so that you will be able to have the modifications done and you will be able to find out a particular multiple containers gets created all together. So Docker Compose is the way that how you can do the setup. How you are going to run the Docker Compose file? So in that case you're going to run the docker-compose up command, which will help you to set up like how the compose can be done. And once you are done with the docker-compose up command, so using this the compose will be done and the containers will be up and running. So these are the commands using which we can manage multiple containers using the Docker Compose one. So let's try to run some commands related to Docker Compose. So docker-compose -version will let you know that what exactly version of Docker Compose is installed into your system. So you can run typical apt command to do the installation. So docker-compose is the package name which you can install so that the executables and the package can be installed into your system onto the server. Now all we need to do is that we need to create a Docker Compose file. So what we need to do is that we need to create a docker-compose.yaml file is the default name of the YAML file which we want to create here. That's a standard name. So once you create this, all you need to do is like you need to put some values, attributes. The very first one is the version value, that what version of this particular attribute you want to create here. Let's say that I want to create a version 2. So I will configure here that yes, the version 2 is what I require. I want to set up over here in this one. Now again, if I want to configure that what are the different services we want to run, because services is the main thing which we will be running on this machine, on this server here. So that's what we require. So then we need to put for a particular service called web. So web service we want to search and we want to run. And then again, we need to take care about the spacing, because that's a very important part. And we need to provide the values of the image and all these configurations here, so that you should be able to set up like how the images and how the Docker images can be built up over here. So web is the service which we want to deploy, and then of course the image is the attribute which is there for the web, that yes, Nginx is the one which we are trying to build up. Now you can give the ports configuration also, so you can say like ports, and inside that you can say like what port mapping you want to perform. So you can say like 8080. So, or sorry, 80 is what you can dash for the Nginx, because it runs on 80 port. But now I have to run like 80 port. I want to dash that port over here in this one. So I can specify that 80 port should be available in this one. So I'm going to save this one here, and I'm going to run a command called docker-compose up. Now this will run the containers in the interactive mode, but if you feel that I want to run in the detached mode, so you can say like -d also, which will of course run these ones into the detached mode and it will be executed. So it will process your docker compose file, and since you have used a standard name called docker-compose.yml, so it will automatically pick that docker details and start creating the container.
Hi, and welcome to this session on how to Dockerize an Angular application. My name is Miro Juuso, and in the next few minutes I'll be walking you through building a Docker image for an Angular application and then running the image locally on your workstation. As Angular is a front-end framework, we'll be using a web server called Nginx to serve the application HTML files. After this session, you will understand three things. First, what is Docker and what is it used for? You will understand the basics of Docker and what problem Docker fixes. Next, you'll learn how to write a Docker file, which you can think of as the recipe Docker uses to build your image. In this session, we'll be using a multi-stage Docker file to build our application. Third, you will learn how to use an Nginx server to serve an Angular application inside a Docker container. To follow through the examples in this session, you should have an Angular application ready and the latest version of Docker installed on your workstation. You can install Docker by following instructions on docker.com. First, let's look at what Docker is. Docker is the most popular containerization technology, and it has quickly become the de facto standard when talking about containers. Containerizing an application means packaging it and all its dependencies into a single, easily transportable and isolated container. This container will run in exactly the same fashion regardless of the computer it is run on. By providing this layer of consistency, Docker fixes the traditional "but it works on my machine" problem. Instead of distributing just our application, we're distributing a full runtime environment along with our application. While not exactly correct, it might help you to think of a Docker container as a lightweight virtual machine inside your computer. Your computer can run multiple Docker containers at the same time, stopping and starting them individually as required. A common problem in software delivery is dependency management. When one application is run on multiple development machines and multiple server environments, a small difference in the version of an external library can change the functionality of your application, making it behave differently on different environments. The beauty of Docker is that if you build your application into a container image and transfer the same container image to your colleague's computer, you can be sure that the application will function identically on both computers. This is because the container includes all dependencies for the application inside it. On the other hand, a Docker container should not have any dependencies to the host it's running on, apart from Docker itself. It's important for you to understand what images and containers are, and what's the difference between them. For the purposes of this session, you can think of a Docker image as something that holds a file system and some metadata in it. The metadata includes things like the name or tag of the image, and instructions for Docker like what command to run by default when the image is started. While the official Docker documentation is a bit vague about the meaning of names and tags, you should learn the basics of it. Every Docker image has at least one tag, and in fact, the same Docker image can have multiple tags pointing to it. Every image tag has a name part and a version part, separated by a colon. For example, the Nginx image has multiple tags representing different versions and different flavors of the image. There's a special version tag called latest, which points to the latest version of the image. All Docker commands default to using the latest version tag if no other version tag is explicitly defined. When you build an image on your local machine, or for example a build server, you can upload the image into a Docker registry. When you configure other machines to use the same Docker registry, you can download the same image to as many other machines as you like. There is an official Docker registry called the Docker Hub, and the model is the same as, for example, GitHub. You can store public images free of charge under your account, but you will need to pay to host private images. Having your images public is great for hosting open source projects, but for any commercial proprietary applications, you will most likely want to opt for hosting the images privately. If you don't want to use a third-party service, you can always run your own Docker registry. My advice is that unless you're planning on hosting a very large number of images, it's absolutely worth the cost to spend a few dollars per month on a hosted Docker registry, such as Docker Hub. Once your application ecosystem starts to build around Docker, the registry becomes a critical piece of infrastructure, and keeping it up and running can prove to be a substantial piece of work. When you build or download a Docker image to a computer and run it, it becomes a running container. If you don't tell Docker otherwise, Docker will run a pre-specified command inside the container. As far as this command is concerned, it is running inside a Linux server, and it has access to other commands and resources that are available inside the same container. You can think of a container as a sandbox, where processes running inside the container do not have access to the host system or other containers unless you explicitly specify otherwise. Note that the complete container runs around a single process created by the initial command used to start the container. If this process terminates for any reason, the container will stop. An example for our container would be the Nginx server process. When you start the container, the Nginx server process starts in it, and when the Nginx server process dies or is killed, the container will stop as well. It is possible to run multiple processes inside a single container by, for example, using an init system to spawn the processes you need, but for the purposes of this session, we'll use the concept of just a single process per container. The basic workflow with Docker is as follows. First, you will build a Docker image either on your workstation or on a continuous integration server. Second, you will push this Docker image into a Docker registry to make it available for other computers. Third, you will most likely want to run the image on a server that is accessible via the internet, so clients can access whatever server software is running inside your container. Most often this is an HTTP server, and in this session we'll be using the Nginx HTTP server. In software delivery environments that embrace continuous delivery, this workflow is often part of a fully automated pipeline. A pipeline like this can trigger from committing a piece of code into a version control system and thus automatically deploy a new version of your application into a testing or even production environment whenever you change your application code. As we discussed earlier, a container is isolated from the machine it's running on, as well as any other containers running on the same machine, unless you explicitly define connections between them. This is out of the scope of this session, but I recommend you spend some time after the session to learn about Docker networking and links between containers. In this session, we'll be running a single container that can connect to the internet through the host machine, and expose a single TCP port for the Nginx server process. Building Docker images is done with Docker files. You can think of a Docker file as a text file containing a recipe to tell Docker how to build an image. The basic function of a Docker file is to be a list of instructions that incrementally manipulate an existing Docker image. The word existing here is important. While you can theoretically build a Docker image from scratch, in most use cases you will actually be using another Docker image as the base for your new image. Many frameworks and open source projects publish their own Docker images, which can be used by developers to build images on top of. In this session, we'll be using a new Docker feature called multi-stage builds. This feature is available from Docker version 17.05 forward, and it allows you to use one base image for building our application and another base image for serving it. This works brilliantly for our use case. While Angular is often used as part of the full mean stack, in this session we're only concentrating on Angular. I'm assuming you know Angular and how the Angular command line interface works, and that you have a package.json in your application directory. If you're not quite there yet, check out the excellent Getting Started guide on the Angular website. Please note that the functionality of Angular varies wildly between major versions. However, the fundamental idea behind containerizing an Angular application is the same. Our Docker file is going to have two stages. First, we'll need to build our Angular application using the ng build command. This will output the packaged application in the dist directory under our application root. In the second stage, we will place the files from the dist directory into a directory that's served by a web server, and finally run the web server itself. This is where the multi-stage build feature comes in handy. As you remember, a Docker container only has the software available which we've explicitly added into it. This means that for the ng build command to work, we need to have the Angular command line interface installed inside our Docker container. This is something we wouldn't want on our final Docker image because it's just extra weight. And on the other hand, we wouldn't want the web server inside the image we're building our application in. Because the Angular CLI is distributed as a node package, we can use the official node Docker image as the base of our first builder stage. Because Angular is a front-end framework, it doesn't come with a server-side component, other than the test server shipped with the Angular CLI. Unfortunately, this test server isn't fit to be run on production, so we'll want to use something else to serve the Angular HTML files. In this example, we will use a robust web server called Nginx to serve the Angular application. Please note you could just as well be using a server application like Apache or Lite instead. I'm not going to be diving into the specifics of configuring Nginx. Nginx does come with good documentation, but more importantly, it also comes with an official Docker image. We can use the official Nginx Docker image as the base for our Angular application image. The good thing is that this makes our Docker file very short and simple. Let's have a look. This is the Docker file, and it's divided into two stages. The way the multi-stage build works in Docker is that we're actually creating multiple Docker images with a single Docker file, but we're only keeping the last image we've defined. This allows us to build the application first and then copy the resulting build artifacts into the next Docker image. The idea behind this is that our final Docker image won't have all the build time dependencies in it, which makes the resulting image nice and small. In the first stage, we'll use the from directive to instruct Docker that we want to use the node 8 image as our base image. We're also using the asBuilder keyword, so we'll be able to reference this stage in our second stage later. The next directive is the copy directive. This command is for copying files and directories from our local machine to the Docker image. We're giving this directive two arguments: the location of our application code directory and the target path within the Docker container. In this example, our application code sits in test app, and we want to place it in the directory test app inside the container. The next directive is workdir. This tells Docker that all following commands should be run within the specified directory, which in this example is the application directory within the container. The next directives are the run directives. As you might guess, these directives instruct Docker to run commands inside the container. First, we're running npm install to install all node packages defined in the package.json file of our application. Then we're running ng-build to package our Angular application in the dist directory. Now we'll get to the second stage, which is copying the contents of the dist directory into a directory that's served by default by Nginx. We're using the from directive again. This tells Docker to start building another image. We're defining the from image to be an image called Nginx, which is the official Nginx Docker image. This image is pre-configured to run the Nginx server and serve HTML files that are stored in a predefined directory. Next, we'll use the copy directive, but this time with the from argument. This tells Docker to not look for the source path in our workstation, but instead the previous stage in this Docker file. Essentially, we're copying the contents of the dist directory in the previous Docker image into a directory called user share nginx html inside our new image. The nginx Docker image will then serve the contents of this directory. Finally, we're using a directive called expose to tell Docker that the port 80 has a server running in this image. The port 80 is the default HTTP port, as you might know. Note that the expose directive alone isn't enough to actually expose the port when the image is run. You can merely consider this as a documentation feature, and will still need to explicitly map port 80 from the container into a port on the host machine. This enables you to connect to the mapped port on the host machine, which will then forward the connection into the container. To follow this session for your Angular application, create a file with these contents and place it in the parent directory of your application code. Remember to customize the paths in the file accordingly. Make sure the name of the file is Dockerfile written as one word with a capital D. Now that you've learned what a Docker file is and what one looks like for an Angular application, let's learn how to use it to containerize an example Angular application. For this, we'll be using the Docker command line interface. After you've installed Docker on your workstation, you can use the Docker command line interface to build and run images. To find the command line shell on a Mac, click on the Spotlight search icon on the top right corner of your screen and write terminal followed by enter. While the Docker command line provides many features, in this session we'll concentrate on two, the Docker build and the Docker run commands. First, let's navigate to the directory with our Docker file. The command we'll be using is docker build. We'll be giving the command the -t argument, which defines the tag for the image that will be built. For this, we'll be using the tag test app. The second argument for the docker build command is the build context. This is where Docker expects to find the Docker file. We'll use a single dot to denote the current directory and press enter to start building. You can see Docker runs through every directive in the Docker file as a step, outputting the directive and the output of running it. Finally, you'll see that Docker has successfully built the image and tagged it as test app latest. As you might remember from before, since we didn't define the version tag, the tag latest is used automatically. Great work! Now let's run the image we just built. For this, we'll be using the docker run command. We'll be giving the docker run command a few arguments. First, -i and -t to denote that we want to run the image in an interactive terminal, that is, running the container attached to our current terminal session so we can see the output and interact with the process. We'll also be using the -p argument to map the port 8080 on our workstation to port 80 inside the container. As you remember, the Nginx server is listening on port 80. With this mapping, anyone connecting to port 8080 on our workstation will get forwarded to port 80 inside the container. Finally, the last argument is the tag of the image we want to run. We're using test app latest. Now that the container is running, let's use our web browser to navigate to port 8080 on our local machine. And we can see our Angular application being served. Well done! You can see that Nginx by default outputs all the requests in the standard output of the container. After you've finished testing, press Ctrl+C in your terminal to terminate the Nginx process and thus kill the container you were running. And that's how you Dockerize an Angular application. Before you go, 3 takeaways. 1. Using Docker makes it easy to ensure that your application runs consistently on different workstations and servers. Secondly, Angular is a front-end framework. Angular needs a separate web server software for serving it. Nginx is a fast and robust choice. Finally, using multi-stage Docker files enables you to streamline your build process and create slim Docker images.
Welcome everyone to this tutorial on the Gradle build tool here. In this one we are going to talk about what exactly is a Gradle build tool and how we can use it. And in this one we will be also working on some demos and some hands-on to understand that how we can make use of Gradle for performing the build activity. So let's begin with the first understanding that what exactly is Gradle all about. Now Gradle is a kind of a build tool which can be used for the build automation performance, and it can be used for various programming languages. Primarily it's being used for the Java based applications. It's a kind of build tool which can help you to see that how exactly automatically you can prepare the builds, you can perform the automations. Earlier we used to do the build activity from the Eclipse, and we used to do it manually, right? But with the help of this build tool we are going to do it like automatically without any manual efforts as such here. There are like a lot of activities which we will be doing during the build process. Primarily there are different activities like compilations, linkage, packaging. These are the different tasks which we perform during the build process, so that we can understand that how the build can be done and we can perform the automations. This process also, it's kind of standardized, because again if you want to automate something, standards or a standard process is something which we require for that before being going ahead with that part. So that's the reason why we are getting this build tool, because this build tool helps us to do a standardization process to see that how the standards can be met and how we can proceed further with that part. Also, it's something which can be used for a variety of languages, programming languages. Java is the primary language for which we use the Gradle, but again other languages like Scala, Android, C++, Groovy, these are some of the languages for which we can use the same tool. Now it's actually using, like, it's referring to as a Groovy based domain specific language rather than XML, because Ant and Maven, these are the XML based build tools, but this one is not that dependent on XML. It's using the Groovy based domain specific language. DSL language is being used here. Right now, again, it's something which can be used to do the build. It can further on be used to perform the test cases automations also there, and then further on you can deploy to the Artifactory also, that okay, I want to push the artifacts to the Artifactory, so that part also you can get it done over here. So primarily this tool is known for doing the build automations for the big and large projects, the projects in which the source code, the amount of source code and the efforts is more. So in that case this particular tool makes sense. Now Gradle includes both the pros of Maven and Ant, but it removes the drawbacks or whatever the issues which we face during these two build tools. So it's helping us to remove all the cons which we face during the implementation of Ant and Maven, and again all the pros of Ant and Maven is implemented with this Gradle tool. Now let's see that why exactly this Gradle is used, because that's a very valid question, that what is the activity, like what is the reason why we use the Gradle. Because the first one is that it resolves issues faced on other build tools. That's a primary reason, because we are already having the tools like Maven and Ant which is available there, but primarily this Gradle tool is something which is removing all the issues which we are facing with the implementation of other tools. So these issues are getting removed as such. Second one is that it focuses on maintainability, performance, and flexibility. So it's giving the focus on that how exactly we can manage the big large projects, and we can have flexibility that what different kind of projects I want to build. Today I want to build in different ways, tomorrow the source code modifies, gets added up, so I have the flexibility that I can change this build scripts, I can perform the automations. So a lot of flexibility is available which is being supported by this tool. And then the last one is like it provides a lot of features, a lot of plugins. Now this is one of the benefit which we get in the case of Maven also, that we get a lot of features. But again, when we talk about Gradle, then it provides a lot of plugins. Like let's say that normally in a build process we do the compilation of the source code, but sometimes let's say that we want to build an Angular or a Node.js application. Now in that case we may be involved in running some command line executions, some command line commands, just to make sure that yes, we are running the commands and we are getting the output. So there are a lot of features which we can use, like there are a lot of plugins which is available there, and we will be using those plugins in order to go ahead and in order to execute those build process and doing the automations. Now let's talk about the Gradle and Maven, because again when we talk about Maven, like it was like something which was primarily used for the Java, but again when we are talking about Gradle, so again it's just being used primarily for the Java here. But what is the reason that we prefer Gradle over the Maven? So what are the different reason for that? Let's talk about that part, because this is very important. We need to understand that what is the reason that Gradle is preferred as a better tool for the Java as compared to Maven when we talk about for the build automation here. Now the first one is that the Gradle using the Groovy DSL language, domain specific language, whereas the Maven is considered as a project management tool which is creating the POMs or XML format files. So it's being used for the Java project, but XML format is being used here. And on the other hand, Gradle is something which is not using the XML formats, and whatever the build scripts you're creating, that is something which is there in the Groovy based DSL language. And on the other hand, in the POM we have to create the XMLs, dependencies, whatever the attributes you are putting up in the Maven, that's something which is available there in the format of XML. The overall goal of the Gradle is to add functionality to a project, whereas the goal of the Maven is to to complete a project phase, like to work on different project phase, like compilation, test executions, then packaging, so then deploying to Artifactory. So these are all different phases which is available there into the Maven. But on the other hand, Gradle is all about adding the functionality, that how you want to have some particular features added up into the build scripts. In Gradle there are, like, we usually specify that what are the different tasks we want to manage. So different tasks we can add up into the case of Gradle, and we can override those tasks also. In case of Maven, it's all about the different phases which is being happening over here, and it's in sequence manner. So these phases happens in the sequence order, that how exactly you can build up the sequence there. But in case of Gradle, you can have your own tasks, custom tasks also, and you can disrupt the sequence, and you can see that how the different steps can be executed in a different order. So Maven is something which is a phase mechanism there, but Gradle is something which is according to the features or the flexibilities. Now Gradle works on the tasks, whatever the task you want to perform, it works directly on those tasks there. On the other hand, Maven is something does not have any kind of inbuilt cache, so every time you're running the build, so separate things or the plugins and all this information gets loaded up, which takes definitely a lot of time. On the other hand, Gradle is something which is using its own internal cache, so that it can make the builds a little bit faster, because it's not something which is doing the things from the scratch. Whatever the things is already being available in the cache, so it's just pick that part, and from there it will proceed further on the build automation. And that's the reason why Gradle performance is much faster as compared to Maven, because it uses some kind of a cache in there and then helps to improve the overall performance. Now let's talk about the Gradle installation, because this is a very important aspect to be done, because when we are doing the installation we have to download the Gradle executables, right? So let's see that what are the different steps is involved in the process of the Gradle installation. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the OpenJDK or you can go for the Oracle Java, so you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly use nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of a Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output that whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one, right? Now over here there are different options, like you want to go for 6.7. now they're having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see like we will give this path here. There is 2 environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle_home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these 2 variables I have to configure, then okay, okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd java version to check the version of the Java, and then the Gradle underscore version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it says that 6.7 version is being installed over here in this case. So that's a way that how we are going to have the Gradle installation performed into our particular system. So let's go back to the content. Let's talk about the Gradle core concepts here. Now in this one we are going to talk about what are the different core concepts of Gradle are all about. The very first one is the projects here. Now a project represents an item to be performed over here, to be done, like deploying an application to a staging environment, performing some build. So Gradle is something which is required. The projects, the Gradle project which you prepare is not having multiple tasks which is available there, which is configured, and all these tasks, all these different tasks needs to be executed into a sequence. Now sequence is again is a very important part, because again if the sequence is not met properly, then the execution will not be done in a proper order. So that's the very important aspect here. Tasks is the one in which is a kind of an entity in which we will be performing a series of steps. These tasks may be like compilation of a source code, preparing a jar file, preparing a web application archive file, or a ER file. Also we can have, like in some tasks we can even publish our artifacts to the artifact tree so that we can store those artifacts into a shared location. So there are different ways in which we can have this particular tasks executed. Now build scripts is the one in which we will be storing all this information. What are the dependencies, what are the different tasks we want to refer. It's all going to be present in the build.gradle file there. Build.gradle file will be having the information related to what are the different dependencies you want to download and you want to store there. So all these things will be a part of the build scripts. Now let's talk about the features of Gradle. What are the different features which we can use in case of Gradle here. There are different type of features which is available there. So let's talk about them one by one. So the very first one over here is the high performance. Then high performance is something which we can see that we already discussed, that in case you are using a large projects, so Gradle is something which is in better approach as compared to Maven because of the high performance which we are getting. It uses an internal cache which makes sure that you are using, like you are doing the builds faster, and that can give you a higher performance over there. Second one is the support. It provides the support. So it definitely provides a lot of support on how you can perform the builds, and it's being a latest tool which is available there. So the support is also quite good in terms of how you want to prepare the build, how you want to download the plugins, different plugin supports, and the dependencies information also there. Next one is multi-project build software. So using this one you can have multiple projects. In case in your repository you have multiple projects here, so all of them can be easily built up with the help of this particular tool. So it supports multiple projects to be built up using the same Gradle project and Gradle scripts. So that support is also available with this Gradle build tool. Incremental builds are also something which you can do with the help of Gradle. So if you have done only the incremental changes and you want to perform only the incremental build, so that can also be possible with the help of a Gradle here. The build scans, so we can also perform the build scans. So we can use some integrations with SonarQube and all, where we can have the scans done to the source code on understand on how the build happens or how the source code really happens on there. So that code scan or the build scans can also be performed with this one. And then it's a familiarity with Java. So for Java it's something which is considered as an by default. Not even Java, in fact Android, which is also using the Java programming language, is using the particular Gradle over here, so that the build can be done and it can gain benefits out of that. So in all the manners, in all the different ways, it's basically helping us to see that how we can make sure that this tool can help us in providing a lot of features, and that can help us to make a reliable build tool for our Java based projects or any other programming based project here. Right, now let's see that how we can onboard a Java project with a Gradle here, and for that we have to go back, and Gradle is something which is already installed. We just have to create a directory where we can have like how we can perform some executions, we can prepare some build scripts, and we can have a particular execution of a Gradle build happened over there. So let's go back to the machine. Okay, so we are going to open the terminal here and we'll see that how we can create it. So first of all, I have to create a directory structure. Let's say that we'll say like Gradle -project. Now once the project is created, so we can go inside this directory. So to create some Gradle related projects and preparing the files. Now in this one, let's first create a particular one. So we will be saying like vi build.gradle. So in this one we are going to put like two plugins we are going to use. So we are going to say like apply plugin Java, and then we are going to say like apply plugin application. So these two plugins we are going to use, and when we got this file over here in this one, so it shows like build.gradle, which is available there in this case. So two these files are available. Now if you want to learn like what are the different tasks, so you can run like Gradle tasks command over there. So Gradle task will help you know that what are the different tasks which is available over here by processing the build scripts and all. So this will definitely help you to understand on giving you the output. So here all the different tasks are being given, and it will help you to understand that what are the different tasks you can configure and you can work over here, just like jar files, clean and all that stuff, build, compile, then init is there, then all these different executions, assemble, then Java dog, then build, then check, test, all these different tasks are there. And if you really want to run the Gradle build, so you can run like Gradle clean to perform the clean activity, because right now you are doing like a build, so before that you can have a clean, and then you can run a specific command, or you can run the Gradle clean build, which will perform the cleanup also, and it will at the same time will have the build process also performed over there. So build and cleanup both will be executed over here, and what is the status, whether it's a success or it's a failure, that will be given back to you. Now in this case, in the previous one, if you see that when you ran the Gradle clean, it was only running one task, but when you go for the build process, when you run the Gradle clean build, it's going to give you a much more information. In fact, you can also give me further information, like you can have the -info flag also there, so that if you want to get the details about the different tasks which is being executed over here, so that also you're going to get over here in this one. So you just have to put like -info, and then all these steps will be given back to you, that how these tasks will be executed and the response will be there. So that's a way that how you can create a pretty much simple straightforward project in form of Gradle, which can definitely help you to run some couple of Gradle commands, and then you can understand that what are the basic commands you can run and how the configurations really works on there. Right, let's go back to the main content. Right, now let's move on to the next one. So in the next one, we are going to see that how we can prepare a Gradle build project in case of Eclipse. Now we are not using the local system, we are not directly creating the folders and the files here. We are actually using the Eclipse for performing creating a new Gradle project over here. So let's move on that part. Okay, so now the Eclipse is open, and I have opened in this one. The very first thing is that we have to do the Gradle plugin installation so that we can create new projects on Gradle, and then we have to configure the path, that how the Gradle plugin can be configured on the preferences and all that stuff, and then we will be doing the build process. So the very first thing is that we have to go to the Eclipse marketplace. In there we have to search for Gradle. So once the search is done, it will show us the plugins related to Gradle. So we have to go for build ship Gradle integration. So we'll click on the install. It will proceed with installation. It will download it. In some cases, maybe it's part of the Eclipse as in the ID. So you can go to the installed tab and you can see that also, that if this plugin is already installed or not. But in this case, we are installing it. And once the installation is done, we just have to restart the specific ones. We have to restart this Eclipse so that the changes can be reflected. So it's downloading. it's downloading the Gradle here, and once that is installed, we will be able to use it over here in this case, in this scenario. So we have to just wait for that part. So still downloading the jar files. So once the jar file is done, it's now over the areas and downloaded. So after that, we will be able to proceed further on that download aspect. So it's going to take some time to download it, and once it's done, we will be able to proceed further. Now once the progress is done, so it's asking us for the restart now. So before that, we just have to click on restart now, and then the Eclipse will be restarted altogether again here. So you can do it manually, or you can go for that options. It just require a restart so that the new changes can be reflected over here. So the plugins can be activated and can be referenced here. Now we have to just put up like the the configuration where we can have the system. So we can go for the Gradle configuration. So we can go for Windows and then preferences. Now in this case, we have to go for the ones in which the Gradle option is available there. So Gradle is what we are going to select. Now user home, the Gradle user home is what we need to use, right? So you want to go for the Gradle, you want to go for local installation. So all these options you can use. You can, if you go for the Gradle wrapper, then it will be downloading the Gradle locally, and it is going to use the Gradle W or gradlew.bat file. But if you already have an installation locally, so you can prefer that also, right? Now in the previous demo, we have already got the Gradle extracted, so we just have to go for the downloads. In the downloads already Gradle is available, so we are going to select that part here. So this is what we are going to select, right? So this represents that this is the directory structure in which we are having the mechanism. So you can either go for the build scan, so you can select the build scan also. So once this is enabled, then all the projects will be scanned and will be published, and it's in kind of additional option which is available. If you really want to disable it, you can disable it also, and you can go with this configuration also. So this is where the particular Gradle folder is being put over here in this case, and then we have to just click on apply, and we just have to click on apply and close. So with this one, the particular execution is done. Now we will be going for the project creation. So you can right click over here, or you can go to the file also. So here we are going to go for the job project, and in this we are going to have a Gradle project. So Gradle project is what we are going to create here. And next, so we are going to say like Gradle project, and then next. So once that is done, so finish. So with this one, when you create the project, so what will happen that automatically there will be a folder structure will be available there, right? And there are some Gradle scripts which will also be created there. So we will be doing the modifications to there, and we'll see that how the particular Gradle build script looks like, and how we will be adding some couple of Selenium related dependencies, and we'll see that how we can have more and more dependencies added, and what will be the impact of those dependencies on the overall project. So that also it's very important aspect to be considered. So let this processing be happen over there. It's just creating, and some plugins and binaries are getting installed and getting downloaded. So we'll see that once the project is imported, completely executed over here and got created, we can extract that. Now if you see here, the particular option is available about the Gradle tasks, so you can extract it also, and you will be able to know that what are the different tasks which is available there. Let's see that in the build they are running like build. These are the different tasks which is happening inside the build process. So Gradle executions will be also available over here in this case, and Gradle tasks will be different. It will be represented over here in this one. So you just have to extract on the Gradle build project. Okay, so this is the library which is available. Now what happens that you will be able to have like settings.gradle. In this one you will be able to have like, okay, Gradle -project is something which is available there in this one, so that's what I'm being referring. Then we have over here as in these folder structures which is created like source, main, Java. This is the one. Source test Java is the one which is available as in the folder structure, and source test resources are also available here. So the main source main resources are also available. Now in this case, what happens that these are the dependencies project and external, these are the different dependencies are available there. So let's see, let's add a dependency over here in this one in the build.gradle script and see that how we can do that. If we open build.gradle file, so you can see that these dependencies are there, like test implementation, JUnit is available there, right? And then we have a implementations of this one which is available. Now these jar files, when you put up, it will automatically be added up as in part of this one, as in part of the particular dependencies over here, and which means that you don't have to store them as in within the repository, and automatically they can be happened over there. So let's open a dependency page. So we will be going to MVN repository where we will be opening a dependency link. So this is the dependency link here. So selenium-java is available, and it can give you the dependency for all the different options. Now we have for Maven, this is the one, and for Gradle, this is the one here. So we have to just copy this one, and we have to use it as a dependency. So this is the group, and this is the name and the version which we are using here. Now we have copied this one, so we will go back to the Eclipse. So here we have to just put that dependency, and we have to just save it. So this is something which is providing like Selenium dependencies which is available. So now we have to just refresh the project. So right click over here, then you will be able to see the options in the Gradle saying that refresh Gradle project. Now once the moment you do that, so you will be able to do, like, for the first time maybe it will take some time to download all the dependencies which is related to Selenium, but after that you will be able to see like the dependencies will be simply added up over here in this case. So you can see that all the Selenium related dependencies are added up. For any reason, if you comment these ones and you say like synchronize again, so you will see that all the dependencies which you are adding up from this Selenium from the Selenium perspective will be gone back again. So this is the way that how you can keep on adding the dependencies which is required for preparing your build for your source code, and from there you will be able to proceed further on the execution part. So that's the best part about this Gradle here. So that's a way that how we are going to prepare a Gradle project within the Eclipse, and now you can keep on adding like the source code in this one, and that's the way that how the code base will be added up over here. Right, so that's the way that how the particular executions or this Gradle project is being prepared in case of Eclipse.
In this session, we shall see the differences between the two build tools, Maven and Gradle. We shall begin with seeing the basics of the two, followed by seeing the differences between them on the basis of some very prominent features. But before we begin, make sure you have subscribed to our YouTube channel, and don't forget to click on the bell icon so you never miss an update from Simplilearn. Alright, let's now begin with what is Maven. If you are a Java developer, then this build tool would have helped you every now and then. Maven is a popular open source build tool developed by the Apache group to build, publish, and deploy several projects at once. The tool is written in Java and is used to build projects written in C#, Scala, and Ruby. Maven is based on the project object model and focuses on the simplification and standardization of the building process. In the process, it takes care of the builds, dependencies, reports, distributions, releases, and the mailing list. Maven is chiefly used for Java-based projects. The tool helps build the code and downloading dependencies, and is used to develop and manage any Java-based project. It simplifies the day-to-day work of Java developers and helps them build their projects. Now, when we know about Maven, the next tool to be considered is Gradle. So let's begin with what is Gradle. Gradle is a build automation tool known for its flexibility to build software. Here, a build automation tool is something that is used to automate the creation of applications. The building process includes compiling, linking, and packaging the code. The process becomes more consistent with the help of build automation tools. Gradle is known to build automation in many languages like Java, Scala, Android, C, C++, and Groovy. The tool supports Groovy-based domain-specific language over XML. Gradle provides building, testing, and deploying software on several platforms. The tool is known to build any software and large projects. Before we move forth, we must know that Gradle includes all the pros of ANT and Maven. Along with that, it also curbs all the cons of both of these build tools. Now, let's have a look at the contrast between these two tools. We will have a look at the contrast based on 6 prominent features. The first point of comparison is based on. This answers the question what Maven or Gradle is based on. Maven is based on developing Java-based software and the goal is related to a project phase. Whereas Gradle is based on developing domain-specific language projects. The goal with Gradle is to add functionality to a project. Then comes the second point. The second point is the focus. What do these two tools focus on? Maven simply focuses on developing applications within the time deadlines provided. Whereas in the case of Gradle, there may be new features that might be added to the application while it is being built or developed. Now, the third pointer is configuration. As we know, Maven uses extensible markup language or XML for making the project structure. Maven uses an XML file for declaring the project and its dependencies. Whereas Gradle, on the other hand, doesn't use an XML file for the declaration of project configuration. Gradle uses Groovy-based domain-specific language for making the project structure. Moving forth, the fourth pointer is languages. When we talk about languages, we see that Maven supports software development in languages like Scala, C# and Ruby. Whereas Gradle supports development in languages like Java, C, C++ and Groovy. Now, the next pointer in our list is customization. If we consider customization, then Maven provides a limited number of parameters and resources. It can serve a limited number of developers and is not much customizable. However, this also makes Maven easier to understand and configure. Whereas Gradle is a highly customizable tool and provides a large range of IDE support builds. Gradle can be used for native development with C or C++. The sixth and the last pointer we shall consider is performance. Maven has a slower build time since it does not use build cache, which means it does not create local temporary files during software creation, hence uses extensive time. Whereas Gradle, on the other hand, performs better than Maven as it is optimized for tracking only current running tasks. This means it only works on the tasks that have been changed to give a better performance. Now, when we know the differences between the two build tools, it sometimes becomes critical to decide which tool would be a better fit for our work. So the next topic, how do you choose between the two tools? We know that both Gradle and Maven have their own set of advantages and disadvantages. Gradle is undoubtedly the more powerful tool out of the two. Still, it has many functionalities that are not always needed, and dealing with so many functionalities is slightly a difficult task. If we consider the tools together, we can conclude that Maven is great for small projects. It should be used when dependency management, modularization, consistency, lots of plugins and conventions are preferred. At the same time, Gradle, on the other hand, is fantastic when it comes to big projects and should be used when flexibility, ease of use, speed, and incremental builds are of importance. And also, if you have started with Maven and now your project has overgrown, you can switch or migrate from Maven to Gradle at any point of time. I hope this will help you when it comes to choosing between the two build tools in the near future.
And today we'll dive into a tutorial on the configuration management tool Chef. So if you look at the DevOps approach or the DevOps lifecycle, you will see that Chef falls under operations and deployment. So before we begin, let's have a brief look at all that you'll learn today. First, we'll get to know why should we use Chef and what exactly is the Chef. Two of the most common terms used with Chef, configuration management and infrastructure as code. We'll have a brief look at these. We'll also have a look at the components of Chef and the Chef architecture, quickly go through the various flavors of Chef, and finally we'll wrap it up with a demo on the installation of Apache on our nodes. So let's begin, guys. Why should we use Chef? Well, consider a large company. Now this company caters to a large number of clients and provides n number of services or solutions. Of course, to get all of this done, they need a huge number of servers and a huge number of systems. Basically, they will have a huge infrastructure. Now, this infrastructure needs to be continuously configured and maintained. In fact, when you're dealing with an infrastructure that size, there's a good chance systems may be failing. And in the long run, as your company expands, new systems may even get added. So what do? Well, you could say the company has the best system administrator out there, but all by himself, could he possibly take care of an infrastructure that size? No, he can't. And that's where Chef comes in, because Chef automates this entire process. So what does Chef provide? Chef provides continuous deployment. So when you look at the market space today, you see how products and their updates are coming out in a matter of days. So it's very important that a company is able to deploy the product the minute it's ready, so that once it's out, it's not already obsolete. Chef also provides increased system robustness. As we saw, Chef can automate the infrastructure, but in spite of this automation, there's a good possibility that errors do creep in. Chef can detect all these bugs and remove them before deploying them into the real environment. Not only this, Chef also adapts to the cloud. We all know how today the services, tools, solutions, everything's revolving around the cloud. So Chef does really play along by making itself easily integratable with the cloud platform. So now that you know why to use Chef, let's look at what exactly is Chef. Chef is an open source tool developed by Opscode. Of course, there are paid versions of Chef, such as Chef Enterprise, but other than that, most of it is freely accessible. Chef is written in Ruby and Erlang. If you would have gone through any previous material on Chef, I'm sure you would have come across Ruby being related to Chef, but not Erlang. So this is why, because Ruby and Erlang are both used to build Chef, but when it comes to actually writing the codes in Chef, it's just Ruby. And these are the codes that's deployed onto your multiple servers and does the automatic configuration and maintenance. And this is why Chef is a configuration management tool. So I've used this term configuration management a couple of times. What exactly does this mean? Let's start with the definition of configuration management. Configuration management is a collection of engineering practices that provides a systematic way to manage entities for efficient deployment. So let's break this down. Configuration management basically is a collection of practices. And what are these practices for? These practices are for managing your entities, the entities which are required for efficient deployment. So what are these entities that you need for efficient deployment? They are code, infrastructure, and people. Code is basically the code the system administrators write for configuring your various systems. Infrastructure is the collection of your systems and your servers. And then finally, you have the teams that take care of this infrastructure. So codes need to be updated whenever your infrastructure needs a new configuration or some sort of updation in the operating system or the software versions. Your code needs to be updated at first. And as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D, and so on need to be well aware when the change is made as to why it was made, what was the change made, and where exactly this change was made. So there are two types of configuration management. On our left, we have the push configuration. Here, the server that holds the files with instructions to configure your nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems, Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. We don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something and at his 10th command he realized the very first command he wrote, there was something not right there. Well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. A second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And our final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine and two nodes. You can have any number of nodes. First things first, the system administrator must create a recipe. So the recipes that are mentioned in our Chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have one recipe, two recipes, three recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have Simplilearn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the OHI service. The OHI service will collect all information regarding the current state of your nodes and send it over to the Chef client. When you run the Chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then fetched from the server and executed at the node. This sets the node to the right state. There are various flavors of Chef. We'll quickly go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now, this kind of configuration is used only when you have just a single node to take care of. The next flavor is the Hosted Chef. With Hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical Chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional Chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these three machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using two virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have two machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK installation. Go to the first link, which is your Chef's official page, and under Red Hat Enterprise, because our system's a Red Hat system, select the link of the version that you're using. So I'm using CentOS 7, so my operating system version is 7, so I'll take this link. Now this is the link for downloading your Chef DK. You copy this link and go to your terminal. Guys, notice I'm in the home directory of my root user. So let's install our Chef DK. And it's getting installed. Now this will take some time because it's quite a large file. And Chef DK is downloaded. Next step, we need to install it. And this is the version of the Chef DK that we have downloaded. So type the same. Okay, so that's done. So now we need to make our recipes, and the recipes will exist within cookbooks. So first let's make a Chef repository. So within that, we'll have a folder for holding all our cookbooks, and within our cookbook, we'll write our recipe. So we start with the directory for chef repository. Move into it. Create a folder called cookbooks, within which we'll store each of our cookbooks. Move into this folder. Okay, so we'll just check the contents here right now. So we have our chef DK, we have a chef repo folder here, and let's check the contents of the chef repo. And this has cookbooks. Okay, so our first cookbook that we'll be making will be under this folder cookbooks. So let's move into cookbooks. We are in. Now we need to create our first cookbook. So the instruction for creating your first cookbook is chef generate cookbook and the name of your cookbook. So I'm just giving the name as sample. Yeah, so our cookbook sample is created. Now when you create your cookbook, you'll notice that a hierarchy is also automatically created. So let's just check the hierarchy of our cookbook. Let's move into sample. And tree is the command for checking the hierarchy. So here, as you can see, we have recipes, and under recipes, we have default.rb. So we'll be editing this default.rb to create our recipe. Okay, so let's begin with that. Let's move into our recipes folder and open your default.rb. And here we are. So now we'll type in our code. So what's our recipe for? Our recipe is for installing the HTTPD package on our node, and then we'll also create a small index file where we'll just have a simple content such as welcome or something like that, just to check if our HTTPD is working fine. So let's begin typing the code here. Package HTTPD service HTTPD do. And what must be done with this package is that once it's installed, it needs to be enabled and it needs to be started. And so that's our first task. Our next task is creating our HTML file. So as you know, all your HTML files will follow this path name. And this is the content of your file. You have successfully configured your node. And that's it. That's our simple code. So our recipe is now ready. Save it and exit back to your terminal. Now what we need to do is that we need to configure our server. So go to your browser. On the search engine, type manage.chef.io. So as I mentioned earlier, we'll be using a server as a service on the cloud. So you'll enter your login page for the Chef server. Most of you may not have a profile already, so you go to click here to get started and fill in the details. It's just like creating an account on Facebook. So I already have my account. I've put in the credentials here. I'll just sign in. Now the first thing once you sign in is you'll get an option to create an organization. So all you have to do there is you gotta enter the name of your organization, and just below that there's another box for entering a short form of your organization. Now my organization name was Simplilearn and the short form was SLP123. So when you come to the administration tab under organization, you can see this organization name. Next step, click on this arrow and you gotta download your starter kit. Okay, so once you click on starter kit, you'll come to this page where there's a button for download starter kit. So do download it. Save the file. So now come back to your terminal. So you come back to your terminal, and next what you need to do is you need to unzip your chef starter.zip. So for that, first we'll move our chef starter to the root. So it's currently present under the downloads folder. Let's move it. So we have moved our chef starter.zip. Now let's unzip it. First, let's just check the contents of our root directory right now. So we have our chef repository, chef repo folder that we created, the chef starter zip that we just moved, and of course the chef DK. So now we can unzip our chef starter kit. And that's done. So our next step, we got to move the chef starters.zip file into our cookbooks, which lies inside the chef repository. This is done because we'll be executing our further commands to connect our workstation with the server from the cookbooks, because that is where our sample cookbook is. And that's moved. So now we'll run a knife command. So what knife does is that it uploads your recipes or your cookbooks onto the server. So here's the command for running your knife. Samples the name of the cookbook that you're uploading, and uploading sample 0.1.0 and uploading sample. Yeah, so our cookbook is uploaded. Now let's just check this at our server. How we do that is, go back to your browser where you have opened your server. So there's no node here yet because we have not configured our node with the server, but we have configured our workstation with the server. And you see here our cookbooks uploaded, sample. So our workstation and our server are connected. So now we need to connect our node with the server. So first we move on to our node machine. We need to take the IP address of our node machine. So for the IP address, we'll just type ifconfig. Right, so this is your IP address. 192.168.2.190. Note this down somewhere, guys. Now that's done, go back to your workstation. I'll just keep it this way so I can see both. Okay. Go back to your workstation's terminal, but this time to connect our server with the node. So we have taken the IP of our node, and this is where we'll be using it. 192.168.2. The username, which is root in our case, and then enter the password, and then finally you enter your node name. So this is the name that will appear for this particular node on our server. I'm just giving it chef node. You can give it whatever you like. We'll just check the command knife bootstrap, the IP address, SSH user, our user, which is root, SSH password, the password for the root, and finally the node name. And the node's getting created. So once the node is connected to your server, we'll go back to our browser, open our server service on the cloud, and we'll check the node tab. So ideally, your node name should appear there. Great. So our node is added. Also, if you notice here, our chef client service on the node has started running. So let's just check this with the server. Go to your nodes. And here we go. So chef node, a CentOS 7 platform. This is our IP. So it's all done. So now we need to add a cookbook to the run list of this node. So come here, click on this arrow, edit run list. Here's sample. This is the cookbook that we want to run on our node. Put on the current run list. And here we have the run button. Just click on that. So this should have transferred our cookbook onto the node. Let's check that. Go to your node machine. Clear this. We need to be the root. Let's run the chef client service. So we are running it once again because after it was started, we did add something to our run list. The changes in the run list is updated. So in 1 minute 56 seconds, our cookbook has run on our node. So the configuration changes should have been made. Let's check that. It's pretty simple. Just go to your browser On the search engine, just type localhost. And here's our HTML page that we created on our workstation. Congrats, you configured your first node. And I really hope you did. So that is the end of our demo. We have successfully installed the HTTPD package on our node, and we have also executed a HTML file. So with that, we come to an end to our video. Now let's have a quick look at everything you learned today. First, you saw why you should probably use Chef. Then what exactly is the Chef? We looked into the two most important terms often used with Chef: configuration management and infrastructure as code. We also saw the various components of Chef and how these components work together to provide the capabilities that Chef does. We looked into the 4 flavors of Chef, and finally we wrapped it up with the demo on installing HTTPD package on our node and also writing a simple HTML file.
And today we're going to delve into Git and what it actually is and how it fits within your DevOps stack. So a little scenario before using Git. One of the challenges that a lot of developers and development teams would have had is developers would be working on different types of code, whether it was database code, whether it was Python, or whether it was Java or .NET, and they would have a central server that they would be pushing all of their source code in. But there was little or no communication that was actually going on in between all the developers. You know, the challenge you had with that scenario is that when people would be checking in code, you could be like, there'd be conflicts and you'd have to roll back different code versions. And this is really kind of the challenge that Git addresses. Git is a tool that allows all of the developers, no matter what stack they're working in, to have access to all of the code. And it makes it much more effective at being able to have development teams work on small, medium, or even massive applications. And some of the biggest applications out there are managed through a Git distributed server environment. So let's jump into what we'll be covering so you have a clear understanding of the value that you're going to get out of watching this presentation. So we're going to go through DevOps and the tools we have available for DevOps. We'll talk about what version control means within a DevOps environment and cover the 2 different types of version control, centralized and distributed. And then we're going to zero in on Git, which is a really fantastic distributed version control system. And we're going to go through and understand the features, workflow, branches, and commands in Git. We're going to give you a demo and then summarize all of the activities at the end of the presentation. So, what is DevOps? Well, this is one of my favorite questions. I love the idea of what DevOps is. So DevOps really is a culture of being able to deliver solutions faster, where your development teams and your operation teams work effectively together. The idea is to be able to continuously build out solutions and have testing codes that's built into your solutions, so that no matter where they are in the stage of the integration and deployment lifecycle, they're always being tested, and you can always have code getting ready to be released out. The idea is that instead of having big releases that you would have maybe once every 2 weeks or once a month, that you would actually have a continuous stream of releases, because you always have code that is being tested, you have your network that's being tested, you have your environment being tested, and you'll be able to provide feedback directly to the appropriate person, whether they're in devs or whether they're in ops, to be able to be successful at being able to deliver solutions faster. The bottom line, your dev team thinks like operations, and your operations team begin to think like developers. It's really a fantastic way of being able to speed up delivery and have your team just think and feel and act in a different cultural environment. So let's have a look at some of the tools that are available to you in DevOps environment. If we look at DevOps, it's really kind of split into 2 areas. The dev side, you have building, code, planning, and testing. And then on your ops side, you have release, deployment, operating, and monitoring. But the tools really all interact with each other. And what's really great is that the tools are either open source or very, very low in cost. And in fact, most of the tools that you're seeing in front of you right now are open source tools, which means there's no licensing to you, and you can actually effectively manage them and implement them within your team right now. So let's have a look at some of the dev tools that you have for doing code versioning. And so Some of the tools that you may have used in the past include Subversion, Team Foundation Service, and Git. These are all different types of version control software that you have out there. One of the oldest ones is Subversion. It's a centralized version control system. It's one of the tools I used years ago. It really is good at doing what it's supposed to do, which is just a very simple version controlled solution. It's open source, so it's free. There's no licensing. There are challenges with working with it because it is a centralized tool rather than a distributed tool, and we'll get into that in a little bit. But for a very basic version control system, it does what you want it to do. Team Foundation Service Solutions, something that many of you in Microsoft world may have been using for a long time. And the thing that's great about TFS is that it's built right into the Microsoft environment. It's the server side, the services side of building out your solutions with Microsoft. Just recently, in the last couple of weeks, at the beginning of September 2018, Microsoft actually just rebranded TFS as Azure DevOps, and so you have Azure Pipelines, and there are 5 now Azure tools that actually replace TFS. But these are all tools that are very similar in concept. The old TFS tools are very similar to the centralized SVN tools, whereas the new tools that are part of Azure are actually much more aligned with Git. So what you're seeing is Microsoft moving from the centralized server to a distributed server with their new Azure DevOps tools, which is fantastic news for every developer listening to this. And then we have Git, and Git is a distributed version control system. It is, again, open source, which means that you can start using it right now without fear of having to have any costs or any penalties. And the thing that's really good about it is that you can use it for almost any kind of digital project. And what it's good at is being able to create that historical record and versioning of your source code, whether you're doing a web application, a mobile application, or you're actually building a Python script for a machine learning solution. So let's dig into what version control systems are and how they can be of value to you. So the role of a version control system is to allow developers to be able to check in their files into a repository. And here you can actually see how we can check in 3 files into a repository, and that repository then becomes a snapshot or a historical record of the files that we're working on. And you want to be able to have it so that the repository is flexible enough so that as you want to be able to scale and add in new files or new versions of a file, that you can actually do that easily within your VCS environment. And the goal is to be able to constantly have each of these versions available so that anybody that wants to be able to check out the file can actually have the latest version or see a history of how that file became what it is today. Let's look at centralized version control systems, and then we'll compare it against distributed version control systems. So a centralized version control system has a central server where all the files are stored, and everybody has to check in and check out from that centralized server, and all of the versions are managed within that server environment. The problem is that if that central server crashes, which doesn't happen but very often, but it can happen, you end up losing all of your files. And I was actually on a project where that actually happened to us, and we lost 6 months of history of how the application was created. Fortunately for us, we actually had a backup, but it didn't have all the historical data. So we were able to at least continue working, but we just lost a lot of files and it took a while to get back into place. So let's now look at and compare this to a distributed version control system. With a distributed version control system, you still have a centralized server that manages the files. But the difference is that as a developer, you check out all of the files for a project. So you can actually manage the whole project locally on your development machine and make your changes. And then you can just check in and out the changes that you've made to the centralized server. The opportunity you have here is that the server itself, if it goes down, you're not going to be in a situation where you lose all of the history, because everybody that's working on the actual application has all of the versions of the code locally on their machine. Now, one of the more popular distributed version control systems that out there is Git. I mean, it really is probably the most popular by a margin compared to a system out there. So, let's dig into, what actually is Git. So Git is a version control system for managing files, and as a developer, you have a Git client on your machine and you're able to make changes and create local repositories of a program on your computer, and then you can sync up with a remote service such as GitHub or GitLab or the new Azure Labs environment, where you can actually store files remotely and then allow remote teams to have access to those changes in the actual application you made. So you can track your changes easily. The tool is inherently distributed, so it makes it very easy to manage the code for large teams. And you can bring people in very quickly, and you can have people come in as specialists and spin them up quickly and have them work on a piece of the code and then drop them out of the project. If you want to have a check on how this works, go and start contributing to any of the many thousands of open source projects like GitHub, where you can go in with your Git tools and just contribute to those projects. And then finally, one of the things that I really like with Git is that it's not a linear development approach. It's not starting from A and going to Z. It's a non-linear approach, which allows you to have branches that people are working on in parallel to your master branch, where people are actually doing the delivery of the production code. So let's step through some of these features. So Git, as you can imagine, the first thing it does is track history. That's probably the most important part of having a version control system. It's free open source. You can actually go and use it right now. There are no costs for actually using it. It is a non-linear environment that allows people to be able to build out new features in parallel to the master branch, so that you can be constantly having the master code out there and adding in new features without breaking the code. And you can automatically create backups because each developer has a version of the code remotely. It's incredibly scalable. Some of the biggest projects out there now are being managed through Git. And because of this scale, the collaboration becomes a byproduct of teams working together. And branching just is so much easier within Git. So as you can see, this whole thing leads to a very effective distributed environment. So let's step through some of the workflow that we have available for Git. So the way that Git works is that you, as an operator, as a developer, you have the Git client on your local development machine, whether it's a Linux machine, a Mac, or a PC, and you connect to a remote server and you pull down the latest working copy, and then you're able to make all of your changes locally, and you can modify the codes, you can review changes, and you can commit those codes to your Git repository that you have locally, and then you can push those changes back up to the remote server. And as soon as you push them into the remote server, those changes then become available to everybody else working on the project. So they can be constantly keeping everybody updated on all the work that is happening. So, typically the way that it would work is, you would start off with having the working file, the working directory that you have locally, and then you would stage those files into a staging area, and then you get those files ready to be committed to your Git repository. And these are all actions that you would do locally and then connect to a remote server. And then later, when you go back into work on your project, the first thing you should always do is check out that code, so that you always have the latest version of the code and everybody's kept in sync. So let's talk about branching in Git. So the way that branches work is that if you imagine you're working on a project, and projects always have a tendency of getting bigger than you imagine. And what you want to be able to do is keep that main product working and keeping it working effectively. But if you want to be able to add a feature to that product, you may have 2 or 3 different groups that are working on multiple features simultaneously. And what you want to be able to do is give them the freedom to work on those individual features. And the way you do it in Git is that you can create branches off the master, and while you're off the main branch, which is called the master. And so each person could be working on their own separate branch, and then when they want to, they can then later merge those branches back into the main master. And all this time, the main master still works and still able to produce the right code for the customer, but at the same time, it allows the developers the freedom to be able to write in their new features. And so we can look at this in a little bit more visually with the master branch. And we can put in small features and large features, and we can then merge them back as we need to. So this kind of covers some of the commands that we have in Git. So the first command you'd want to use is called git init, and that's allowing you to go into a folder on your local PC or your local Mac and convert that folder into a local Git repository, and that creates that repository. Then you want to be able to make changes to that repository, and the commands you'd be using in this instance would be add, commit, or status. You want to be able to sync your repositories with the remote server. So be able to put the code that you have on your computer on the remote server, you use push. You want to get the code from the remote server, you'd use pull and then add origin. And then if you want to do parallel development from the master branch, the main branch, you would use branch, merge, or rebase as ways to be able to do parallel development. And now we're going to go through and do a demo on Git. So we're going to do a demo on Git so you can feel comfortable running the commands in the interface and you're able to get Git running correctly in your environment. So the first thing we're going to do is we're going to set up which version of Git that you have, and then we're going to see if we can establish some global configurations within your Git environment. And we're going to do sandeep.dash as the name, the email address is sandeep.simplylearn, and then we're going to do a list of the different configuration settings we have. So to check the version of Git that we have, we do git -- version in our terminal or command line window. You can also use PowerShell. That'll actually get you running in the same environment as well. All of these tools are going to be command line tools. And then the next thing we're going to do is we're going to assign some global usernames and a global email address so that we can actually access the Git account itself locally on the device. And so we're going to put in config -- global user.name Sandeep, and then git config -- global user.email and sandeep.d@simplylearn.net. And now we're going to check the list of usernames and email IDs in our configuration environment with -list, and you'll see that we have everything in there correctly. Here is our username right here, and our name and our email ID. So if you need any help when you're actually doing any of your work in Git, all you have to do is do git help config or git config -- help, and this will allow you to actually get access to the help screens. So let's just go and type that in, git help config, return, and this takes us to the help page that's running locally on your device. And here we have a breakdown of all the different commands and what those commands actually do within a Git configuration. And we can go ahead and we can do git config -- help, and that will actually take us to the same page. So two ways of doing the same thing. So we're going to go ahead and we're going to create a test repository on our local system, and we're going to do that with make directory called test, and then we're going to move our cursor within command window, terminal window, to the test folder, and then we're going to initialize that folder to become a Git repository. So let's go ahead and do that. So we're going to make a new directory and we're going to call it test, and we're going to move the cursor so it's actually in the test folder. We do cd change directory to test, and you can see now we're actually in the test folder. And now what we have to do is initialize this folder as a Git repository. And so we're going to do this as git init, and it's now a new Git instance that we can actually now use for managing our Git environment. So we're going to create a new file and we're going to call it info.txt, and we're going to put some content in it, and we're actually going to put it in the folder that we've just created so you can actually see what it's like to test out the Git environment with a file that hasn't been checked into it yet. So let's go ahead and do that. So we open up our folder directory, and here you can see we have the test folder, and we're just going to go ahead and create a default test file. So right click, text, new document, info.txt, open that, and you can put really whatever you want in here. We're just going to put in this information right now, name equals Sam, registration number 12479, and save that file, close it out. Now if we actually go ahead and run a git status command, you'll see that the info.txt file is in red. That's because that file has not actually been checked into the project. It's a new file that we've added, but it hasn't been committed yet into the Git repository. So let's go ahead and see what it takes to actually add the file to the Git repository that we just created. So we're going to do that by doing git add info.txt, and then we're going to commit that into the history of that Git repository. So it now has version control, and we can start doing forking and other kind of similar activities when we connect later to our GitHub Git environment. So we do git add info.txt, and remember we're actually still in the test folder, so it's going to look for that file in that folder and just add it in. And now if we go ahead and do git status, we'll actually be able to see that the info.txt file is in an active color. First of all, we have to commit it, so we go git commit -m, and then we're going to commit, and we add in some quick text here. You can write whatever you want. Committing the text file is now actually committed into the Git repository, and it's still running locally on your PC. So we're going to go make some changes to the file, and we're going to save it, and we want to be able to see how we can use Git to compare the differences between the two files. So let's go over, and we're going to make some changes to the info.txt file. Here we are. Here's info.txt. We're just going to add in a new line. We're going to add in the line address, and we're going to save that file. And now when we go over to Git, we're going to be able to review the difference. So we're going to do git diff, and here you actually see that we've added in a new address file. So now you can actually see this is the difference, the difference between the two documents. Now, as you can imagine, when you have code, this would become more elaborate, where actually will show you code that's been pulled out if you've reduced any of eliminated any code, or if you added in new code. Really useful. So we're going to go ahead and add our Git username to a remote location, so we can actually start testing out the file that we've created into a remote repository. In this case, we're going to use GitHub, and you'll be able to see how we can actually then save that file into a Git repository that somebody else could then access and be able to make edits to. So let's just go ahead and make those changes. So git config -global user.username, and we're going to do Simplilearn, and that will associate it with this Git repository that we've just created locally. So Simplilearn-GitHub. So Simplilearn GitHub is the username that we use on GitHub. So we're going to go over to GitHub. Here we are in GitHub, and then correct new repository. And then, as you can see, we're in Simplilearn-GitHub, and we're going to call the new repository test. We're going to make it public so anybody can access it. And you'll see that it automatically adds a README file, and we have our test environment set up correctly. So we'll go ahead and copy the URL link, which is github.com simplilearn-github/test.git. Copy that, and we'll go back over to our command line window. And so now we're going to add the username to the GitHub configuration. So what we're doing is we're connecting the local repository to the remote repository. So we type git remote add origin, and then we'll paste in the address. And this then allows us to connect the local repository that we created in the test folder with the remote repository. And now we're connected. So now that we've connected, we can actually push the file that we have in the local repository on your PC or Mac to the remote repository in the GitHub server environment. So let's go ahead and do that. So we're going to do git push, and push is the command to push the documents from the origin, which is the local file, to master, and master is a remote file. Hey, and there we are. Success. So what we have now is the file that we just created in our local Git repository is actually now in the remote repository as well, so that anybody can access it. So let's go have a look at that. So we're going to refresh the GitHub page, and hey, there we are. There's info.txt has been uploaded, and we're ready to go. That's great. That's what you should be seeing. So refreshing your web page on the remote GitHub folder, and it could be any Git service, but just happen to be using GitHub because it's free to use. You'll be able to see that the local file has been installed and is now part of the Git repository in the remote server. So what we're going to do now is we're going to create 3 more files, and we're just going to call them info.txt, info2, and info3, and then we're going to push them out to the remote server, and we're going to merge everything together into a single environment. So let's go ahead and create those 3 files, and we're just going to add those into the folder. So let's go ahead, create new text document, info1, and then we're going to create info2, and then info3. I'll get my typing right here. Okay, here we go. There we are. Okay, I'm opening info3, and I'm just going to enter some text in here. And what we're going to do is illustrate how we can do branching. And each of these files I'm going to save and then close out. And now I can go over and... So let's create a new branch. And we're going to call this one first_branch. And we go git branch first underscore branch, and this will be a new branch of the code environment that we're creating. And so hit return, and that allows us to create a new branch. And so what we do is we're going to move to the new branch. So we're going to do git checkout first underscore branch, and that allows us to move into that branch. And you see that info.txt is already there, which is good. That's what we want to see. Now what we need to do is add in the new documents. So here we have the different steps we've taken. We created a branch, we moved to the new branch, and now we're going to go ahead and add the info3txt to that branch so you can actually see everything coming together. And we're going to go with git add info3.txt. So we're just adding a file like we were previously with our initialization, our first initial Git folder, and that file has now been added to the first branch. So we're going to go ahead and commit the file to the first branch, and then we're going to merge the documents into the master branch so we have everything together. So let's go ahead and do those steps. We're going to do the commit first, and then we're going to merge everything together. All right, so we do git commit -m, and we'll just put in, we're just going to say made changes to first branch, and that's just documentation so that we know what we've done. And there we are, we've committed the file. So we had that file info3txt committed, and now we're going to go ahead and merge the files into the main master, and so we can actually have everything together as one consistent environment. And we do that by typing in, so this lists out what we have in our master file. So we just do ls, and that shows everything in the folder. And we have info.txt, info1txt, info2txt, and info3txt are now all in the first branch. So let's go ahead and we're going to merge. Okay, so actually before we merge, we have to check out the master branch. So we do git checkout master. So it gets us into the master branch, and you'll see that we have just one file there, info.txt. So we're going to list out the files in the master branch. And so what you'll see is info.txt, info1text, and info2text are there. But info3text isn't there because that was created in a separate branch. So let's go ahead and merge the first branch into the master branch. So we do git merge, and we do first underscore branch, and there we are, we've merged it in, and excellent, that looks good. So let's go ahead and list out the files that we have in the master branch, and we do ls, and then you'll see that we have 4 files, including the info3.txt that we had in a separate branch, now all in the master branch. So there we are. We've gone through and we've looked at the different commands and controls that you have for working with Git. And as we've established in this presentation, we talked about version control systems, why they're important, but why distributed version control systems differ from your traditional version control systems, particularly when you have global and remote teams. We've covered what Git is and the architecture of Git and the various concepts you have with Git, such as forking and cloning, being able to add collaborators to be able to work in your projects, branching and being able to pull and push code from a remote service. And then finally, we did a full demo on how to use each of those commands within a normal environment running on your local computer. Hello, and this is Matthew from Simplilearn, and we're going to be covering Ansible today as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam, and like yourselves, Sam is a system administrator, and he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache, they could be database servers running MySQL. And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases, for the simple reason that we're all human. As if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really allows you to create and control 3 key areas that you would have within your operations environment. First of all, there's IT automation. So you can actually write instructions that automate the IT setup that you would typically do manually in the past. The second is the configuration and having consistent configuration. Imagine setting up hundreds of Apache servers and being able to guarantee with precision that each of those Apache servers is set up identically. And then finally, you want to be able to automate the deployment so that as you scale up your server environment, you can just push out instructions that can deploy automatically different servers. The bottom line is you want to be able to speed up and make your operations team more efficient. So let's talk a little bit about pull configuration and how it works with Ansible. So there are 2 different ways of being able to set up different environments for server farms. One is to have a key server that has all the instructions on, and then on each of the servers that connect to that main master server, you would have a piece of software known as a client installed on each of those servers that would communicate to the main master server and then would periodically either update or change the configuration of the slave server. This is known as a pull configuration. An alternative is a push configuration, and the push configuration is slightly different. The main difference is, as with a pull configuration, you have a master server where you actually put up the instructions. But unlike the pull configuration where you have a client installed on each of the services, with a push configuration, you actually have no client installed on the remote servers. You simply are pushing out the configuration to those servers and forcing a restructure or a fresh clean installation in that environment. So Ansible is one of those second environments where it's a push configuration server. And this contrasts with other popular products like Chef and Puppet, which have a master-slave architecture with a master server connecting with a client on a remote slave environment where you would then be pushing out the updates. With Ansible, you're pushing out the service and the structure of the server to remote hardware, and you are just putting it onto the hardware irrelevant of the structure that's out there. And there are some significant advantages that you have in that you're not having to have the extra overhead weight of a client installed on those remote servers, having to constantly communicate back to the master environment. So let's step through the architecture that you would have for an Ansible environment. So when you're setting up an Ansible environment, the first thing you want to do is have a local machine. And the local machine is where you're going to have all of your instruction and really the power of the control that you'd be pushing out to the remote server. So the local machine is where you're going to be starting and doing all of your work. Connected from the local machine are all the different nodes pushing out the different configurations that you would set up on the local machine. The configurations that you would write, and you would write those in code, are within a module. So you do this on your local machine for creating these modules, and each of these modules is actually consistent playbooks. The local machine also has a second job, and that job is to manage the inventory of the nodes that you have in your environment. The local machine is able to connect to each of the different nodes that you would have in your hardware network through SSH clients, so a secure client. Let's dig into some of the different elements within that architecture. And we're going to take a first look at playbooks that you would write and create for the Ansible environments. So the core of Ansible is the playbook. This is where you create the instructions that you write to define the architecture of your hardware. So the playbook is really just a set of instructions that configure the different nodes that you have, and each of those set of instructions is written in a language called YAML. And this is a standard language used for configuration server environments. Did you know that YAML actually stands for YAML Ain't Markup Language? That's just a little tidbit to hide behind your ear. So let's have a look at one of these playbooks it looks like. And here we have a sample YAML script that we've written. So you start off your YAML script with 3 dashes, and that indicates the start of a script. And then the script itself is actually consistent of 2 distinct plays. At the top we have play 1, and below that we have play 2. Within each of those plays we define which nodes are we targeting. So here we have a web server in the top play, and in the second play we have a database server that we're targeting. And then within each of those server environments, we have the specific tasks that we're looking to execute. So let's step through some of these tasks. We have an install Apache task, we have a start Apache task, and we have an install MySQL task. And when we do that, we're going to actually execute a specific set of instructions. And those instructions can include installing Apache and then setting the state of the Apache environment, or starting the Apache environment and setting up and running the MySQL environment. So this really isn't too complicated, and that's the really good thing about working with YAML, is that it's really designed to make it easy for you as an operations lead to be able to configure the environments that you want to consistently create. So let's take a step back though. We have 2 hosts, we have web server and database server. Where do these names come from? Well, this takes us into our next stage and the second part of working with Ansible, which is the inventory management part of Ansible. So the inventory part of Ansible is where we maintain the structure of our network environment. So what we do here is part of the structure in creating different nodes is we've had to create 2 different nodes here. We have a web server node and a database server node. And under web server node, we actually have the names that we're actually pointing to specific machines within that environment. So now when we actually write our scripts, all we have to do is refer to either web server or database server, and the different servers will have the instructions from the YAML script executed on them. This makes it really easy for you to be able to just point to new services without having to write out complex instructions. So let's have a look at how Ansible actually works in real world. So the real world environment is that you'd have the Ansible software installed on a local machine, and then it connects to different nodes within your network. On the local machine, you'll have your playbook, which is the set of instructions for how to set up the remote nodes. And then to identify how you're going to connect to those nodes, you'll have an inventory. We use secure SSH connections to each of the servers, so we are encrypting the communication to those servers. We're able to grab some basic facts on each server, so we understand how we can then push out the playbook to each server and configure that server remotely. The end goal is to have an environment that is consistent. So let's ask you a simple question. What are the major opportunities that Ansible has over Chef and Puppet? Really like to hear your answers in the comments below. Pop them in there and we'll get back to you, and really want to hear how you feel that Ansible is a stronger product, or maybe you think it's a weaker product as it compares to other similar products in the market. Here's the bonus. We're going to talk a little bit about Ansible Tower. So Ansible Tower is an extra product that Red Hat created that really kind of puts the cherry on the top of the ice cream, or is the icing on your cake. Ansible by itself is a command line tool. However, Ansible Tower is a framework that was designed to access Ansible. And through the Ansible Tower framework, we now have an easy to use GUI. This really makes it easy for non-developers to be able to create the environment that they want to be able to manage in their DevOps plan without having to constantly work with the command prompt window. So instead of opening up terminal window or a command window and writing out complex instructions only in text, you can now use drag and drop and mouse click actions to be able to create your appropriate playbooks, inventories, and pushes for your nodes. All right, so we've talked a lot about Ansible. Let's take a look at a specific company that's using Ansible today. And in this example, we're going to look at Hootsuite. Now, Hootsuite, if you've not already used their products, and they have a great product, Hootsuite is a social media management system. They are able to help with you managing your pushes of social media content across all of the popular social media platforms. They're able to provide the analytics, they're able to provide the tools that marketing and sales teams can use to be able to assess a sentiment analysis of the messages that are being pushed out. Really great tool and very popular. But part of their popularity drove a specific problem straight to Hootsuite. The challenge they had at Hootsuite is that they had to constantly go back and rebuild their server environment, and they couldn't do this continuously and be consistent. There was no standard documentation, and they had to rely on your memory to be able to do this consistently. Imagine how complex this could get as you're scaling up with a popular product that now has tens of thousands to hundreds of thousands of users. This is where Ansible came in and really helped the folks over at Hootsuite. Today, the DevOps team at Hootsuite write out playbooks that have specific instructions that define the architecture and structure of their hardware nodes and environments, and are able to do that as a standard product. Instead of it being a problem in scaling up their environment, they now are able to rebuild and create new servers in a matter of seconds. The bottom line is Ansible has been able to provide Hootsuite with IT automation, consistent configuration, and free up time from the operations team so that instead of managing servers, they're able to provide additional new value to the company. So here are some key takeaways. We've gone through why you'd want to have a product such as Ansible to be able to manage the growing environment that you'd have within your network. We've looked specifically at the 3 key areas of success for Ansible around IT automation, consistent configuration management, and the ability to be able to automatically deploy new software to new servers or even rebuild existing servers. We compared Ansible from a pull and push configuration environment, how it compares with other products such as Chef and Puppet that are also popular and used for providing a consistent and similar service. We broke down the architecture of Ansible and looked at how the local machine really is critical at pushing out the instructions that you have within your playbook that are managed within your modules, and how you use the inventory to be able to manage the actual physical hardware available on your network. Finally, we looked at how you would set up a physical Ansible environment within your network and looked at the additional tools that are being developed by Red Hat for Ansible, including the new Ansible Tower GUI interface to make it so much easier for you to be able to build the instructions and playbooks needed to be able to create consistent Ansible environments. And finally, we looked at a use case from Hootsuite and how Ansible really help them out tremendously to improve the efficiency of their DevOps team. And today we're going to continue our education in DevOps, and we're going to focus specifically on Puppet. So in this session, what we're going to do is we're going to cover what and why you would use Puppet, what are the different elements and components of Puppet, and how does it actually work, and then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that will be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifest templates and files. You would apply a certificate of authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifest templates and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, that the current state of the client, that is used and communicated back to through the agent. So let's step through the workings of Puppet. So the Puppet environment is a master-slave architecture. The clients themselves are distributed across your network, and they are constantly communicating back to a master server environment where you have your Puppet modules. The client agent sends a certificate with the ID of that server back to the master. And then the master will then sign that certificate and send it back to the client. And this authentication allows for a secure and verifiable communication between client and master. The factor then collects the state of the client and sends that to the master. Based on the facts sent back, the master then compiles manifests into the catalogs, and those catalogs are sent back to the clients, and an agent on the client will then initiate the catalog. A report is generated by the client that describes any changes that have been made and sends that back to the master, with the goal here of ensuring that the master has full understanding of the hardware running software in your network. This process is repeated at regular intervals, ensuring all client systems are up to date. So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are: 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines. So why Puppet? Puppet is a tool to help manage your infrastructure for your hardware and the software installed on those servers. Puppet is a tool that makes it very easy through code to implement consistent experiences across your network. The components of Puppet are really broken into 2 distinct areas, where you have a server where you would write the manifests, templates, and files, and that server is a master server. And then you would have a client installed on all the individual servers within your network, so you can then push out instructions to those networks. The number of companies that are using Puppet is significant. They include companies such as Spotify, AT&T, Staples, and Google. And finally, the process for actually writing a manifest is fairly easy. You'll be able to pick this up really quickly. And this is truly going to help you better manage your infrastructure through using code and infrastructure as a code principles.
Hello, this is Matthew with Simplilearn, and today we're going to go through a real tough battle. We're going to decide which is better for your operations environment. Is it Chef, Puppet, Ansible, or SaltStack? All 4 are going to go head to head. So let's go through the scenario of why you'd want to use these tools. So let's meet Tim. He's our system administrator, and Tim is a happy camper putting and working on all of the systems in his network. But what happens if a system fails? If there's a fire, a server goes down? Well, Tim knows exactly what to do. He can fix that fire really easily. The problems become really difficult for Tim, however, if multiple servers start failing, particularly when you have large and expanding networks. So this is why Tim really needs to have a configuration management tool, and we need to now decide what would be the best tool for him.
because configuration management tools can help make Tim look like a superstar. All he has to do is configure the right codes that allows him to push out the instructions on how to set up each of the servers quickly, effectively, and at scale. All right, let's go through the tools and see which ones we can use. The tools that we're going to go through are Chef, Puppet, Ansible, and SaltStacks. And we have videos on most of these software and services that you can go and view to get an overview or a deep dive in how those products work. So let's go and get to know our contestants. So our first contestant is Chef. And Chef is a tool that allows you to configure very large environments. It allows you to scale very effectively across your entire ecosystem and infrastructure. Chef is by default an open source code. And one of the things that you find is a consistent metaphor for the tools that we recommend on Simplilearn is to use open source code. The code itself is actually written in language of Ruby and Erlang. And it's really designed for heterogeneous infrastructures that are looking for a mature solution. The way that Chef works is that you write recipes that are compiled into cookbooks, and those cookbooks are the definition of how you would set up a node. And a node is a selection of servers that you have configured in a specific way. So for instance, you may have Apache Linux servers running, or you may have a MySQL server running, or you may have a Python server running. And Chef is able to communicate back and forth between the nodes to understand what nodes are being impacted and need to have instructions sent out to them to correct that impact. You can also send instructions from the server to the nodes to make a significant update or a minor update. So there's great communication going back and forth. If we look at the pros and cons, the pros for Chef is that there is a significant following for Chef, and that has resulted in a very large collection of recipes that allow you to be able to quickly stand up environments. There's no need for you to have to learn complex recipes. The first thing you should do is go out and find the recipes that are available. It integrates with Git really well and provides for really good, strong version control. Some of the cons, though, are really around the learning speed it takes to go from a beginner user with Chef to being an expert. There is a considerable amount of learning that has to take place, and it's compounded by having to learn Ruby as the programming language. And the main server itself doesn't really have a whole lot of control. It's really dependent on the communication throughout the whole network. All right, let's look at our second contender, Puppet. And Puppet is actually in many ways very similar to Chef. There are some differences, but again, Puppet is designed to be able to support very large heterogeneous organization. It is also built with Ruby and uses DSL for writing manifests. So there are some strong similarities here to Chef. As with a Chef, there is a master-slave infrastructure with Puppet, and you have a master server that has the manifests that you put together in a single catalog, and those catalogs are then pushed out to the clients over an SSL connection. Some of the pros with Puppet is that, as with Chef, there is a really strong community around Puppet, and there's just a great amount of information and support that you can get right out of the gate. It is a very well developed reporting mechanism that makes it easier for you as an administrator to be able to understand your infrastructure. One of the cons is that you have to really be good at learning Ruby again, as with Chef. You know, the more advanced tasks really need to have those Ruby skills. And as with Chef, the server also doesn't have much control. So let's look at our third contender here, Ansible. And so Ansible is slightly different. It is, the way that Ansible works is that it actually just pushes out the instructions to the server environment. There isn't a client server or master slave environment where Ansible would be communicating backwards and forwards with its infrastructure. It is merely going to push that instructions out. The good news is that the instructions are written in YAML, and YAML stands for YAML Ain't Markup Language. YAML is actually pretty easy to learn. If you know XML, and XML is pretty easy, if you know XML, you're going to get YAML really well. Ansible does work very well on environments where the focus is getting servers up and running really fast. It's very, very responsive and can allow you to move quickly to get your infrastructure up very fast. And we're talking seconds and minutes here, really, really quick. So again, the way that Ansible works is that you put together a playbook and an inventory, or you have a playbook. So the way that Ansible works is that you have a playbook, and the playbook, it then goes against the inventory of servers and will push out the instructions for that playbook to those servers. So some of the pros that we have for Ansible: we don't need to have an agent installed on the remote nodes and servers. It makes it easier for the configuration. YAML is really easy to learn. You can get up to speed and get very proficient with YAML quickly. The actual performance, once you actually have your infrastructure up and running, is less than other tools that we have on our list. Now, I do have to add a proviso. This is a relative less. It's still very fast. It's going to be a lot faster than individuals manually standing up servers, but it's just not as fast as some of the other tools that we have on this list. And YAML itself as a language, while it's easy to learn, it's not as powerful as Ruby. Ruby will allow you to do things that at an advanced level that you can't do easily with YAML. So let's look at our final contender here, SaltStack. So SaltStack is a CLI-based tool. It means that you will have to get your command line tools out or your terminal window out so you can actually manage the entire environment via SaltStack. The instructions themselves are based on Python, but you can actually write them in YAML or DSL, which is really convenient. And as a product, it's really designed for environments that want to scale quickly and be very resilient. The way that SaltStack works is that you have a master environment that pushes out the instructions to what they call grains, which is your network. And so let's step through some of the pros and cons that we have here with SaltStack. So SaltStack is very easy to use once it's up and running. It has a really good reporting mechanism that makes your job as an operator in your DevOps environment much, much easier. The actual setup, though, is a little bit tougher than some of the other tools, and it's getting easier with the newer releases, but it's just a little bit tougher. And related to that is that SaltStack is fairly late in the game when it comes to actually having a graphical user interface for being able to create and manage your environment. Other tools such as Ansible have actually had a UI environment for quite some time. All right, so we've gone through all 4 tools. Let's see how they all stack up next to each other. So let the race begin. Let's start with the first stage, architecture. So the architecture for most of our environments is a server-client environment. So for Chef, Puppet, and SaltStack. So very similar architecture there. The one exception is Ansible, which is a client-only solution. So you're pushing out the instructions from a server and pushing them out into your network, and there isn't a client environment. There isn't a two-way communication back to that main client for what's actually happening in your network. So let's talk about the next stage, ease of setup. So if we look at the 4 tools, there is one tool that really stands out for ease of setup, and that is Ansible. It is going to be the easiest tool for you to set up. And if you're new to having these types of tools in your environment, you may want to start with Ansible just to try out and see how easy it is to create automated configuration before looking at other tools. Now, and so with that said, Chef, Puppet, and SaltStack aren't that hard to set up either. And you'll find there's actually some great instructions on how to do that setup in the online community. Let's talk about the languages that you can use in your configuration. So we have 2 different types of language, with both Chef and Ansible being procedural in that they actually specify at how you're actually supposed to do the task in your instructions. With Puppet and SaltStack, it's decorative, where you specify only what to do in the instructions. Let's talk about scalability. Which tools scale the most effectively? And as you can imagine, all of these tools are designed for scalability. That is the driver for these kind of tools. You want them to be able to scale to massive organizations. What do the management tools look like for our 4 contenders? So again, we have a 2-way split. With Ansible and SaltStack, the management tools are really easy to use. You're going to love using them. They're just fantastic to use. With Puppet and Chef, the management tools are much harder to learn, and they do require that you learn some either the Puppet DSL or the Ruby DSL to be able to be a true master in that environment. But what does interoperability look like? Again, as you'd imagine, with the similar to scalability, interoperability with these products is very high in all 4 cases. Now, let's talk about cloud availability. This is increasingly becoming more important for organizations as they move rapidly onto cloud services. Well, both Ansible and SaltStack have a big fail here. Neither of them are available in the most popular cloud environments. And Puppet and Chef are actually available in both Amazon and Azure. We've actually just haven't had a chance to update our Chef link here, but Chef is now available on Azure as well as Amazon. So what does communication look like with all of our 4 tools? So the communication is slightly different with them. Chef has its own knife tool, whereas Puppet uses SSL, so Secure Sockets Layer, and Ansible and SaltStack use Secure Socket Hashing, SSH, as their communication tool. Bottom line, all 4 tools are very secure in their communication. So who wins? Well, here's the reality. All 4 tools are very good, and it's really dependent on your capabilities and the type of environment that you're looking to manage that will determine which of these 4 tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is. Please post in the comments below which tool you have decided to go with and what are the challenges that you're coming up with, because we'll help answer those challenges for you.
And welcome to this session on how to Dockerize an Angular application. My name is Miro Juuso, and in the next few minutes I'll be walking you through building a Docker image for an Angular application and then running the image locally on your workstation. As Angular is a front-end framework, we'll be using a web server called Nginx to serve the application HTML files. After this session, you will understand 3 things. First, what is Docker and what is it used for? You will understand the basics of Docker and what problem Docker fixes. Next, you'll learn how to write a Docker file, which you can think of as the recipe Docker uses to build your image. In this session, we'll be using a multi-stage Docker file to build our application. Third, you will learn how to use an Nginx server to serve an Angular application inside a Docker container. To follow through the examples in this session, you should have an Angular application ready and the latest version of Docker installed on your workstation. You can install Docker by following instructions on docker.com. First, let's look at what Docker is. Docker is the most popular containerization technology, and it has quickly become the de facto standard when talking about containers. Containerizing an application means packaging it and all its dependencies into a single, easily transportable and isolated container. This container will run in exactly the same fashion regardless of the computer it is run on. By providing this layer of consistency, Docker fixes the traditional "but it works on my machine" problem. Instead of distributing just our application, we're distributing a full runtime environment along with our application. While not exactly correct, it might help you to think of a Docker container as a lightweight virtual machine inside your computer. Your computer can run multiple Docker containers at the same time, stopping and starting them individually as required. A common problem in software delivery is dependency management. When one application is run on multiple development machines and multiple server environments, a small difference in the version of an external library can change the functionality of your application, making it behave differently on different environments. The beauty of Docker is that if you build your application into a container image and transfer the same container image to your colleague's computer, you can be sure that the application will function identically on both computers. This is because the container includes all dependencies for the application inside it. On the other hand, a Docker container should not have any dependencies to the host it's running on, apart from Docker itself. It's important for you to understand what images and containers are, and what's the difference between them. For the purposes of this session, you can think of a Docker image as something that holds a file system and some metadata in it. The metadata includes things like the name or tag of the image, and instructions for Docker like what command to run by default when the image is started. While the official Docker documentation is a bit vague about the meaning of names and tags, you should learn the basics of it. Every Docker image has at least one tag, and in fact, the same Docker image can have multiple tags pointing to it. Every image tag has a name part and a version part, separated by a colon. For example, the Nginx image has multiple tags representing different versions and different flavors of the image. There's a special version tag called latest, which points to the latest version of the image. All Docker commands default to using the latest version tag if no other version tag is explicitly defined. When you build an image on your local machine, or for example a build server, you can upload the image into a Docker registry. When you configure other machines to use the same Docker registry, you can download the same image to as many other machines as you like. There is an official Docker registry called the Docker Hub, and the model is the same as, for example, GitHub. You can store public images free of charge under your account, but you will need to pay to host private images. Having your images public is great for hosting open source projects, but for any commercial proprietary applications, you will most likely want to opt for hosting the images privately. If you don't want to use a third-party service, you can always run your own Docker registry. My advice is that unless you're planning on hosting a very large number of images, it's absolutely worth the cost to spend a few dollars per month on a hosted Docker registry, such as Docker Hub. Once your application ecosystem starts to build around Docker, the registry becomes a critical piece of infrastructure, and keeping it up and running can prove to be a substantial piece of work. When you build or download a Docker image to a computer and run it, it becomes a running container. If you don't tell Docker otherwise, Docker will run a pre-specified command inside the container. As far as this command is concerned, it is running inside a Linux server, and it has access to other commands and resources that are available inside the same container. You can think of a container as a sandbox, where processes running inside the container do not have access to the host system or other containers unless you explicitly specify otherwise. Note that the complete container runs around a single process created by the initial command used to start the container. If this process terminates for any reason, the container will stop. An example for our container would be the Nginx server process. When you start the container, the Nginx server process starts in it, and when the Nginx server process dies or is killed, the container will stop as well. It is possible to run multiple processes inside a single container by, for example, using an init system to spawn the processes you need, but for the purposes of this session, we'll use the concept of just a single process per container. The basic workflow with Docker is as follows. First, you will build a Docker image either on your workstation or on a continuous integration server. Second, you will push this Docker image into a Docker registry to make it available for other computers. Third, you will most likely want to run the image on a server that is accessible via the internet, so clients can access whatever server software is running inside your container. Most often this is an HTTP server, and in this session we'll be using the Nginx HTTP server. In software delivery environments that embrace continuous delivery, this workflow is often part of a fully automated pipeline. A pipeline like this can trigger from committing a piece of code into a version control system and thus automatically deploy a new version of your application into a testing or even production environment whenever you change your application code. As we discussed earlier, a container is isolated from the machine it's running on, as well as any other containers running on the same machine, unless you explicitly define connections between them. This is out of the scope of this session, but I recommend you spend some time after the session to learn about Docker networking and links between containers. In this session, we'll be running a single container that can connect to the internet through the host machine and expose a single TCP port for the Nginx server process. Building Docker images is done with Docker files. You can think of a Docker file as a text file containing a recipe to tell Docker how to build an image. The basic function of a Docker file is to be a list of instructions that incrementally manipulate an existing Docker image. The word existing here is important. While you can theoretically build a Docker image from scratch, in most use cases you will actually be using another Docker image as the base for your new image. Many frameworks and open source projects publish their own Docker images, which can be used by developers to build images on top of. In this session, we'll be using a new Docker feature called multi-stage builds. This feature is available from Docker version 17.05 forward, and it allows you to use one base image for building our application and another base image for serving it. This works brilliantly for our use case. While Angular is often used as part of the full mean stack, in this session we're only concentrating on Angular. I'm assuming you know Angular and how the Angular command line interface works, and that you have a package.json in your application directory. If you're not quite there yet, check out the excellent Getting Started guide on the Angular website. Please note that the functionality of Angular varies wildly between major versions. However, the fundamental idea behind containerizing an Angular application is the same. Our Docker file is going to have two stages. First, we'll need to build our Angular application using the ng build command. This will output the packaged application in the dist directory under our application root. In the second stage, we will place the files from the dist directory into a directory that's served by a web server, and finally run the web server itself. This is where the multi-stage build feature comes in handy. As you remember, a Docker container only has the software available which we've explicitly added into it. This means that for the ng build command to work, we need to have the Angular command line interface installed inside our Docker container. This is something we wouldn't want on our final Docker image because it's just extra weight. And on the other hand, we wouldn't want the web server inside the image we're building our application in. Because the Angular CLI is distributed as a node package, we can use the official node Docker image as the base of our first builder stage. Because Angular is a front-end framework, it doesn't come with a server-side component, other than the test server shipped with the Angular CLI. Unfortunately, this test server isn't fit to be run on production, so we'll want to use something else to serve the Angular HTML files. In this example, we will use a robust web server called Nginx to serve the Angular application. Please note you could just as well be using a server application like Apache or Lite instead. I'm not going to be diving into the specifics of configuring Nginx. Nginx does come with good documentation, but more importantly, it also comes with an official Docker image. We can use the official Nginx Docker image as the base for our Angular application image. The good thing is that this makes our Docker file very short and simple. Let's have a look. This is the Docker file, and it's divided into two stages. The way the multi-stage build works in Docker is that we're actually creating multiple Docker images with a single Docker file, but we're only keeping the last image we've defined. This allows us to build the application first and then copy the resulting build artifacts into the next Docker image. The idea behind this is that our final Docker image won't have all the build time dependencies in it, which makes the resulting image nice and small. In the first stage, we'll use the from directive to instruct Docker that we want to use the Node 8 image as our base image. We're also using the asBuilder keyword, so we'll be able to reference this stage in our second stage later. The next directive is the copy directive. This command is for copying files and directories from our local machine to the Docker image. We're giving this directive two arguments: the location of our application code directory and the target path within the Docker container. In this example, our application code sits in test app, and we want to place it in the directory test app inside the container. The next directive is workdir. This tells Docker that all following commands should be run within the specified directory, which in this example is the application directory within the container. The next directives are the run directives. As you might guess, these directives instruct Docker to run commands inside the container. First, we're running npm install to install all node packages defined in the package.json file of our application. Then we're running ng-build to package our Angular application in the dist directory. Now we'll get to the second stage, which is copying the contents of the dist directory into a directory that's served by default by Nginx. We're using the from directive again. This tells Docker to start building another image. We're defining the from image to be an image called nginx, which is the official Nginx Docker image. This image is pre-configured to run the Nginx server and serve HTML files that are stored in a predefined directory. Next, we'll use the copy directive, but this time with the from argument. This tells Docker to not look for the source path in our workstation, but instead the previous stage in this Docker file. Essentially, we're copying the contents of the dist directory in the previous Docker image into a directory called user share nginx html inside our new image. The nginx Docker image will then serve the contents of this directory. Finally, we're using a directive called expose to tell Docker that the port 80 has a server running in this image. The port 80 is the default HTTP port, as you might know. Note that the expose directive alone isn't enough to actually expose the port when the image is run. You can merely consider this as a documentation feature, and will still need to explicitly map port 80 from the container into a port on the host machine. This enables you to connect to the mapped port on the host machine, which will then forward the connection into the container. To follow this session for your Angular application, create a file with these contents and place it in the parent directory of your application code. Remember to customize the paths in the file accordingly. Make sure the name of the file is Dockerfile written as one word with a capital D. Now that you've learned what a Dockerfile is and what one looks like for an Angular application, let's learn how to use it to containerize an example Angular application. For this, we'll be using the Docker command line interface. After you've installed Docker on your workstation, you can use the Docker command line interface to build and run images. To find the command line shell on a Mac, click on the Spotlight search icon on the top right corner of your screen and write Terminal followed by Enter. While the Docker command line provides many features, in this session we'll concentrate on two, the Docker build and the Docker run commands. First, let's navigate to the directory with our Docker file. The command we'll be using is docker build.
we'll be giving the command the -t argument, which defines the tag for the image that will be built. For this, we'll be using the tag test app. The second argument for the Docker build command is the build context. This is where Docker expects to find the Docker file. We'll use a single dot to denote the current directory and press enter to start building. You can see Docker runs through every directive in the Docker file as a step, outputting the directive and the output of running it. Finally, you'll see that Docker has successfully built the image and tagged it as test app latest. As you might remember from before, since we didn't define the version tag, the tag latest is used automatically. Great work! Now, let's run the image we just built. For this, we'll be using the docker run command. We'll be giving the docker run command a few arguments. First, -i and -t to denote that we want to run the image in an interactive terminal, that is, running the container attached to our current terminal session so we can see the output and interact with the process. We'll also be using the -p argument to map the port 8080 on our workstation to port 80 inside the container. As you remember, the Nginx server is listening on port 80. With this mapping, anyone connecting to port 8080 on our workstation will get forwarded to port 80 inside the container. Finally, the last argument is the tag of the image we want to run. We're using test app :latest. Now that the container is running, let's use our web browser to navigate to port 8080 on our local machine. And we can see our Angular application being served. Well done! You can see that Nginx by default outputs all the requests in the standard output of the container. After you've finished testing, press Ctrl+C in your terminal to terminate the Nginx process and thus kill the container you were running. And that's how you Dockerize an Angular application. Before you go, 3 takeaways. 1. Using Docker makes it easy to ensure that your application runs consistently on different workstations and servers. Secondly, Angular is a front-end framework. Angular needs a separate web server software for serving it. Nginx is a fast and robust choice. Finally, using multi-stage Docker files enables you to streamline your build process and create slim Docker images.
Hello and welcome everyone. This session will make you understand how machine learning is being implemented into the DevOps culture. So, in this video, we will cover the following topics. What is machine learning? The difference between machine learning and artificial intelligence? What do you mean by DevOps? What are the benefits of machine learning in DevOps? The disadvantages of machine learning? How to apply machine learning in DevOps? And finally, applications of machine learning in DevOps. So let's start by understanding what machine learning actually is. Machine learning is a part of computer science that provides the computers with the ability to learn without being programmed. It uses pattern recognition and computational learning theory to build an algorithm and predict future data. Presently, machine learning is being used widely all over the world, and it has become a part of our lives. Effective web search, voice recognition, automated cars, games are some of the fields that have applied machine learning to improve user experience. Now you may feel that machine learning sounds a lot like artificial intelligence. Let's find out if they are actually similar. Although machine learning and artificial intelligence are two terms used reciprocally, they are not similar. Putting it simply, AI is the extensive concept of computers being able to complete a task in a way that humans regard as smart. On the other hand, machine learning is an application of AI which allows us to provide the computers with access to the data and adapt on their own. Imagine working in a silo in a company that has a wide range of products that are being used by customers from all over the world. In order to keep up with the customers' needs and issues, it is imperative that the development and the operations team work together. DevOps thus ensures fast and short release cycles that can get new applications and features to customers quickly and reliably. DevOps is also about team coordination and having feedback loops for continuous improvement. This helps in capturing the release bugs as early as possible, thus reducing the testing time. Let's have a look at the benefits of introducing machine learning into the DevOps culture. In DevOps, it's absolutely necessary that the IT operations is able to keep up with the pace and depth of the product an organization is working on. There should be professionals who are familiar with the product flow, analytics, troubleshooting, and must be able to figure out the errors in the process and report accordingly. Now, this is where machine learning comes in. Its aim is to eliminate human efforts at troubleshooting or finding issues. What it will do is analyze the previous and current data and plan and predict the future of the workflow, thus eliminating any unwanted circumstances. Let's now get deeper into the topic and find out how machine learning can be implemented to DevOps. DevOps and machine learning share a powerful alliance with the related capabilities like predictive analytics, algorithmic IT operations, operations analytics, and AI. Introduction of machine learning into DevOps has gifted its team with the abilities to proof-check highly complex data sets, detect patterns and anti-patterns, uncover new ideas, repeat and refine queries, all at the same speed as the computer operates with. Large and variable data generated by new delivery processes and the next-gen applications can be exclusively handled by machine learning with ease. Let's now look into some key examples of how machine learning can help optimize the functions of a DevOps environment. Delivery process can be tracked with various DevOps tools. Now, these tools produce a lot of data, and any kind of error in this data can be detected by the application of machine learning. Large code volumes, slow release rate, long build times, etc. are some of the issues that are put in check using machine learning. Machine learning can also review the QA results and figure out errors and present a better testing pattern based on its findings. It can track the behavior patterns of the development and operations user and detect irregularities, indicating malicious activities like stealing intellectual property, deploying authorized code, etc. Management of the code is where machine learning can be the most handy. Large data volumes and transaction records and the number of users is something that can be analyzed by machine learning, and it can point out the errors with respect to the normal values. Machine learning can also be used to manage the high number of alerts that occur in the production system, reducing alert storm and alert fatigue. It can also detect errors in the normal proceedings and wisely analyze previously released logs to find out the issues with the new release. Machine learning can read through previously known good patterns of utilization and plan out the best kind of configuration to maximize performance. It analyzes through user matrices to detect good and bad patterns and lets the business and development team know if the product is going to have a problem prior to its release. Now, if at all there are any disadvantages of machine learning, they are these. It still can't be guaranteed that every algorithm used in machine learning would work fine in every case. Sometimes it might fail, and thus, it demands a proper understanding of the problems so that the right machine learning algorithm is used. Machine learning requires a large amount of deep learning data. Collection of such huge amount of data makes it really difficult to work with. And machine learning is not a self-maintaining software application. As a result, the technical faults keep accumulating, and it's called technical debt. Technical debt can be of many types, like hidden feedback loops, underutilized data dependencies, brittleness, etc.
Hello and welcome to this video on DevOps orchestration. In this video, we will cover the following. What is automation and orchestration? Why does the industry need DevOps orchestration? How to relate DevOps with orchestration? The key benefits of DevOps orchestration, the investments and technology stack required for orchestration, and an example of a success story. DevOps teams would like to move fast and would want to ship faster. But most organizations would want to build up tools to allow sharing across teams and to gain an understanding of scale. This is where automation and orchestration play a key role. It ensures that they orchestrate
all of these tools in an efficient and easy to review way. So what is automation and orchestration? To repeatedly perform a task or combine several processes to complete performing a task is what automation does. Though automation is a complex process in scope, it works on accomplishing a single task, like deploying a server. On the other hand, orchestration is more than just combining the little task and performing a larger script. The small tasks are put together into a workflow by orchestration services that includes many of the automation tasks. Keeping in mind the steps that might streamline the workflow, task automation is perfect for improving numerous steps in one area and does not comply once you move beyond that particular area. This process of the movement of the product through multiple departments from the beginning to completion state is called a workflow. IT and applications make use of the same logic, as not everything that is related to technology can be put under IT. Now, why does the industry need DevOps orchestration? The industry will be able to gain the following using DevOps orchestration: manage and enforce the coding standards, guidelines, and conventions. Identify, build, and deploy release tools for quicker or faster releases, to improve the release process and have error-free releases, to define, control, and maintain third-party software and its versions across environments, define and enforce performance and load at customer or service level. The IT culture has changed after the introduction of DevOps, as it combines the work of the developers, operations, and quality assurance testers to improve the quality of the end result. Traditionally, the barrier that existed among these groups has restricted automation efforts. Therefore, in a DevOps environment, service orchestration has proved to be the most beneficial to an organization. Orchestration has been built in a way that allows it to work within the barriers and above them. DevOps team has to coordinate among themselves as well as employ various tools. This is precisely where orchestration comes in, extracting the portions of automation from the various DevOps toolkits. This means that the internal change in a DevOps team can be a gradual process, while orchestration services can take advantage of the interfaces that are already available. Teams can set long-term goals that include taking up the original toolsets that the orchestration provides. This ensures that the team can prevent the rip and replace method that prevails in IT service delivery. This also removes the added effort of having to stop and recreate everything from scratch by allowing the team to quickly create automation tasks and integrate them into an orchestration platform. Applying orchestration in DevOps makes it smooth to shift the focus to the tasks that are critical. When the developer requests for a resource and gets it approved, the resources are made available through automation. After deploying the resource, it is networked and deployed again with the required software through automation that the orchestration controls. Then, via automation, the virtualized resource is added to the monitoring toolkit, which is again under the orchestration's control. In this way, it is very clear that orchestration controls the work of automation. Some of the key benefits of DevOps orchestration are: problems are resolved faster, complexities are easily managed, software delivery is more continuous, there is a higher engagement among employees, more opportunities are available for professional development, there will be more productive teams. Separate tools performing different functions are joined together by orchestration. It sets up security checkpoints and safeguards to remove the steps that are missing and issues in configuration in the process from product creation to deployment. Helps to target critical goals and approvals. Human element gets removed, thus making the process less viable to human errors. Investments required for orchestration workflow are: people. There must be a confidence and trust in the team members' capabilities to perform the tasks on their own. Culture. Aligned to a common goal are high-performing, cross-functional teams. And finally, process. There must be a move to a more automation adaptive and collaborative structure from a more siloed and manual approach. Some of the technologies used here are Chef, Jenkins, Salt, Puppet, Ansible, and others. Amazon, after moving into a more DevOps-oriented approach, increased its revenue and allowed its engineers to scale capacity up and down, keeping the number and duration of outages reduced. It also transitioned into a more continuous deployment process.
Hello everyone and welcome to this video on DevOps Value Stream Mapping.
In this video, we will cover the following. What is value stream mapping, that is VSM? What role does value stream mapping play in DevOps? How is value stream mapping being implemented in DevOps? And finally, how is value stream mapping useful? Before we dig deep into value stream mapping, that is VSM, let's ask the million-dollar question. How does software change lives? Software is transforming the priorities of business in every industry. Consider how Tesla has disrupted the automotive industry, how Airbnb has changed the world of hotel bookings and vacation rentals, and how Uber has turned the taxi business upside down. Each of these companies led with a software that created an entirely new experience for the customer. Now, Agile and DevOps practices increase the speed of delivery and the quality of the product. There are many ways that software changes the industry for the better. Organizations which use DevOps tools in various stages of the software development lifecycle often find themselves in a struggle to gather an overall understanding of the lifecycle, right from planning to operations. Feedback is also something that is necessary to be collected at every step of the process to constantly improve the product. The faster these feedbacks are received, the better will be the value of the product created. And this is the core where value stream mapping brings value to the DevOps lifecycle. Now that we've understood why we need VSM, let's find out what it really is. In today's market, organizations don't compete on the basis of their product or service they provide. It is done on the basis of how fast it is able to provide quality products and results. VSM in general can be defined as a representation of all the steps followed by a product from its raw material stage to its final product form. It is one of the important lean principles that organizations use. Lean principles usually ensure that the customer is able to obtain more value and eliminate waste while utilizing lesser resources. It graphically represents each stage in the process from product development to deployment. It helps recognize areas where value isn't created and then ensures that these are taken care of. So now let's try to understand what role VSM plays in DevOps. The VSM process enables IT organizations to identify areas for improvement. VSM usually starts with the product person or the team as they are the direct line to the customer. Now the process moves through the development lifecycle, QA testing, release and operations, and how the IT team monitors and manages this product or feature after release. Now the value stream doesn't end there. It looks down through deployment and up at the customer to see if the project achieves its goals. It exposes wastes and inaccuracies in the critical activities involved in software development and operations. It helps identify the delays, the constraints, and other issues that may arise in the process. It also integrates multiple tools, analyzes events, and provides accurate, usable data to the managers. VSM helps companies realize the value that they are receiving from DevOps tools. Now, how is VSM implemented in DevOps? VSM involves creating a value stream map which represents the current state of an organization's software development and operations. This helps in realizing what development needs to be done in an ideal value stream map. Some of the key metrics collected are percentage current or accurate. Now, for a given VSM step, this is the percent of complete or accurate work items received from the previous step in the VSM. Next one, lead time. Lead time for a given VSM step, that is, from the instant a work item leaves the previous step to the instant it leaves the current step towards the next step. Lead time includes both idle time as well as time during which the item is being productively processed. And last, value added. Value added time, which is the only time during which the item is being productively processed. A VSM based on the previously created VSM helps create an improved and realistic representation of the activities without the bottlenecks and issues that plague it in its current stage. A VSM is successful when an organization realizes all its issues as quickly as possible to move into a more efficient form. Now let's understand how VSM is of use in DevOps. These metrics, spanning the entire DevOps lifecycle, are of great use when it comes to solving online scaling issues, affecting the speed of delivery, guiding business decisions, and reducing operational costs. Although VSM supports significantly in finding bottlenecks and pain points, it's not the only thing it's useful for. Analyzing value streams can greatly improve the confidence of the department regarding its choice of projects and ventures. With the data that can be obtained from the key performance indicators, which is the value of how effectively a company is achieving its business objectives and the metrics across the tool chain, important business decisions can be taken effortlessly with the data to back it up. VSM allows greater visibility from the time to value of the development to the delivery lifecycle significantly. It helps in eliminating the redundant processes, faster integrated feedback, and expanding successful strategies. This also leads to greater traceability, helping trace errors to their origins, correcting issues, and better work quality. Each tool in the DevOps tool chain creates its own set of data and events. It's a matter of great importance that the data is correlated and integrated intelligently. It allows DevOps users to obtain an insight into all the stages of the software lifecycle. It greatly increases the speed and quality of the process from its production to its delivery. We will have a look into DevOps team structure in this session. In this video, we will go through what is DevOps, why do we need DevOps, what is DevOps team structure and the resources to build it, the various benefits of building a DevOps team, and the best team structure for DevOps. So what do you mean by DevOps? Imagine working in a silo in a company that has a wide range of products that are being used by customers from all over the world. In order to keep up with the customer's needs and issues, it is imperative that the development and the operations team work together. DevOps thus ensures fast and short release cycles that can get new applications and features to customers quickly and reliably. DevOps is also about team coordination and having feedback loops for continuous improvement. This helps in capturing the release bugs as early as possible, thus reducing the testing time. DevOps carries out the following activities in an organization. 1. Engineering and compliance. DevOps helps in managing and enforcing the coding standards, guidelines, and conventions. It also helps in keeping a tab on the tools for developer productivity, code manageability, compliance enforcement, certification, etc. 2. Build and deploy tools. DevOps identifies, builds, and deploys release tools for quicker and faster releases and improves release process and error-free releases. 3. Third-party software management. DevOps helps in defining, controlling, and maintaining third-party software and its versions across the environments. It constantly evaluates and certifies the software upgrades released by third-party software vendors. Now, the whole idea of implementing DevOps in an IT organization is to have frequent releases while increasing the quality of the products. This cannot be achieved if the organization has a number of silos working in separation, even though they all have the same objective. Hence, a DevOps team structure is required to facilitate the ideals of the DevOps culture. A typical DevOps team structure can comprise of the following roles. The DevOps evangelist or automation architect. This person should be the front runner for the organization and be able to lead a team that is passionate about DevOps and the company as a whole and should be able to determine key value that IT can provide to the business. The evangelist takes care of the end-to-end processes involved in product building and should be experienced in using the tools also. This role also involves making sure that the product is highly available in the production and the pre-production system and is being released frequently. Senior DevOps Engineer. Senior DevOps engineers should possess the following skills. Software testing. Although it's similar to software developing, the role is a little different as the responsibilities increase. Along with coding new requirements, they have to test, deploy, and monitor the entire process as well. Experience assurance. Over and above to quality assurance, this role involves making sure that the end product is released, keeping user experience in mind. Security engineering. During the development phase, the security engineering skills are to be used to to embed the security requirements into the product itself. The timely deployment of the product is ensured. The engineer also makes sure that the functions are up and running most of the time. Junior DevOps Engineer or System Administrator. Traditional IT operations or system administration professionals focus on keeping the servers running. DevOps needs people who are open source pros, passionate towards technology, and effectively hands-on with the development platform, tools, networks, servers, and database, and even support. With a team structure formed, certain actions are to be followed. The goals of the company must be aligned with the DevOps team. This means that the business requirements and the company vision of the organization must be at par with the objectives of the DevOps team. This approach allows the team members to focus on the business target rather than the individual projects or goals assigned to them. This will create a DevOps team structure based on a specific objective or goal, increasing visibility among team members and also giving them a sense of purpose when they are at their workplace. Coming to the part where it's time to implement DevOps, there are tools segregated in terms of building, testing, and deployment of products. Jenkins, Puppet, Ansible, Chef are some of the tools used in DevOps. The final step is to figure out how well the DevOps team is performing, and that can be done by tracking some key performance indicators like deployment frequency, security and quality, volume of errors, etc. Several researchers have made it evident that both business and customers stand high chances of benefiting from DevOps development. The following are some of these benefits. As the IT professionals no longer have to pay attention to the end goal, but the process, it increases job satisfaction. Once DevOps is introduced into the administration, the teams acquire a clear roadmap on how to proceed and complete a goal, thus saving a lot of time on operational activities. Some of the traits that a best team structure can have are close-knit collaboration. This structure changes the once siloed development and operations team and redeploys them as a tightly woven, highly collaborative parts of a company working side by side. This approach maximizes the blend of software engineering skills and deep systems knowledge. This way, everyone is aware of the various aspects of a particular project. Dedicated DevOps team. Dedicated DevOps team comprises of people who are experienced with skills like vision control, writing infrastructure as code, and continuous delivery. Its main job is to address the problems that are most painful, such as automated deployment. Once they are done with it, they move on to providing shared services for the organization. Cross-functional team. It consists of professionals working together from different disciplines for developing and deploying a product or service. The team should be empowered and self-sufficient. They write it, test it, and deploy it. Technology has always been something that has helped us find order in chaos. It has helped us put together the best of our works and achieve more in the field of overall development. Similarly, DevOps has opened up newer ways for the upcoming and established companies to attain order, reliability, and stability within themselves.
So in today's video, we are going to talk about what is DevOps, why DevOps is needed, and why it is gaining so much popularity in recent times. Then we will try and understand where does cloud fit in here. And then finally, we will take a look at Microsoft Azure stack for DevOps, which is also known as Visual Studio Team Services. So let's first try and understand what exactly DevOps is. As per the definition given on the internet, it is a combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. Now, high velocity is the keyword here. If you remember a couple of months back, or maybe a couple of years back, it was quite normal to deliver an application in 3 months' time or 6 months' time. A typical deployment frequency was at least a quarter. But today, if you talk about the top performing companies who are right at the top, their frequency is a couple of times deployments every single day, right? So they're doing multiple deployments in a single day in 24 hours time on their production machines. That is how fast they have become. So it's really important to
implement DevOps practices in order to do that. Without DevOps, that would not be possible at all. You cannot even think about multiple deployments in a single day if you don't have DevOps practices implemented in your company. So essentially, you try to get this pipeline wherein you have a build, test, and release pipeline, and which actually then you monitor your customers, their behavior, and then plan accordingly for the next set of enhancements and bug fixes and things like that. So this is a continuous process. It goes on and on and on. So now we understand what exactly DevOps is all about. Then let's try and understand why it has become so popular in recent times with the IT companies. The first and the foremost important benefit of DevOps is that it makes your developers and operations folks to collaborate in a much better way with a lot less friction. They have a common goal, and what they want to do is essentially to make sure that the application is up and running, which is the primary task. And what happens is they collaborate in a much better way. They understand each other's problems and they understand each other's way of working, and which actually helps productivity increment for both of them. DevOps practices such as continuous integration, continuous delivery, infrastructure as code, etc. They make it possible to release the code way faster than before with almost no errors, which results in faster time to market and minimized failed deployments. Now, faster time to market or time to market is a concept of an idea which has been first thought about, and then it went through the process of designing and implementing and coding, and then finally testing, and finally you have an end result which goes to the end users. So that process, the whole time taken, is known as time to market, which becomes increasingly faster if you are implementing DevOps in your projects. Now, because of all these combination of practices and cultural changes and all those things, you have a shared responsibility model, which actually helps in increased collaboration, as we have seen before, and faster releases. So these two, what happens in turn, increases overall productivity of every individual and the team. And overall, you become much more productive than what you have been in the past. Now, Puppet Labs and DORA, which is a DevOps research organization, they publish every year one report, which is known as State of DevOps Report, which they compile after doing a lot of surveys of the IT individuals and the companies. They have been publishing this report for the past 5-6 years now already. And if you go and take a look at all these past reports, which are available on the internet, free of cost, you don't have to pay anything for it. You can just type in State of DevOps Report and the year for which you want it, and you can get the report in a PDF format. This report basically compiles a lot of information about the people who are trying to implement or who have implemented DevOps in the past, and what are the benefits they have been able to see after implementing DevOps. And some of the most important benefits are, first of all, it is frequent deployments, as we have seen before. The rate of deployment becomes very fast, and it gets reduced from months to quarters, to becomes weeks and days and hours. You can actually do deployments in an hourly fashion instead of in a monthly or quarterly fashion. Then we have a faster MTTR. MTTR stands for mean time to recovery. So let's say if there's a failed deployment, how long it takes for you to make your application normal up and running again. So that whole time is typically calculated in the form of MTTR. And that's actually, if you see on screen, it is 24 times faster than previous, or 24 times faster than a non-DevOps project compared to a DevOps project. Then, of course, we have a very less number of failed deployments if you are on a DevOps framework. And finally, we have a very shorter lead times. Now, lead times actually indicates the time given to the deployment team to get ready for the deployments. So let's say you told your deployment team that today you are telling that the deployment has to be done 2 days afterwards. So that gives you basically 48 hours to the deployment teams, right? So that gets reduced to from weeks to days, and then from days to hours. As per Gene Kim, who is one of the chief evangelists for DevOps, one of the way how you measure DevOps implementation is if you say your deployment team that you have to deploy a software right now, and if their answer is anything but yes, that would mean that they still need to work on their DevOps framework. So if you are completely on DevOps, you should be able to deploy anytime and anywhere. So now we have understood what is DevOps and why DevOps has become so popular. Now let's try and understand the relationship between DevOps and cloud, which are two of the most happening technologies at the moment. So the first and the most important relationship is that they're complementary to each other. What happens is there are a lot of principles and a lot of technologies which are common to DevOps and cloud. And what happens is if you implement DevOps, you are helping your cloud infrastructure. And if you have a cloud infrastructure, it actually helps you to get on a DevOps framework much quicker. What happens is a combination of DevOps and cloud provides you a definite advantage over your competition. And cloud actually makes it easy to implement DevOps services because of inherent abstraction of complexities. So what happens is you don't need to bother about whether your tools are going to be integrated or not, whether you have written the glue code or not, things like that. You have all the framework ready in front of you, and you just need to get up and rolling with your DevOps implementation if you are working on cloud. Whereas if you're working on some on-premise solution, let's say you have a traditional data center in which you're trying to implement DevOps, it will always be more complex than if you're doing the same thing on the cloud. And finally, cloud, as you're aware, it gives you this added advantage of agility, scalability, and on-demand availability. These are some of the things which are inherent to cloud. The moment you talk about cloud, the moment you implement cloud, all these things come naturally to it. These are the things which you get by default if you are on cloud. So these things actually help in your DevOps implementation. So Microsoft has given their DevOps services a name which is known as a Visual Studio Team Services, and all the DevOps related services have been compiled over here. So let's take a look at what exactly those are and how they have been divided, and what do they offer you. So as the name, as you can see, is Visual Studio Team Services, and whatever, if you want to, make a full-fledged DevOps pipeline, starting from plan to code to build to test and release, you are supposed to work with Visual Studio Team Services. And you can actually, it is very fast and easy for you to plan, build, and ship software across a variety of platforms. You can actually get up and running in minutes on Azure Cloud without having to install or configure a single server. You can access your projects, your code, and work items through an integrated experience within Visual Studio. Or you can use free plugins which are already available for you. And for example, you have support for Git client, you have support for Xcode, you have modern web browser interface, and you can use your favorite development tool to tailor Visual Studio Team Services to your team's needs. And you get free private code repositories. You can track your bugs, work items, feedback. You have inbuilt Agile planning tools. If you're on Agile framework, you get all the tools inbuilt with the Visual Studio Team Services. You have continuous integration builds, which are already inbuilt into the platform. You can develop and work in any language. All the major languages such as .NET and Java and Python and Ruby, all of them are supported by Visual Studio Team Services. You get this infrastructure as code ability with the help of Azure Resource Manager, which is, you can think of it as a counterpart for Chef or Puppet. And for monitoring, we have something called Application Insights, which is the inbuilt monitoring tool which is provided to you within Visual Studio Team Services. So let's take a look at one by one some of the most important services which are given by Visual Studio Team Services, or also known as Microsoft Azure Team Services. And the first one in the list is, of course, source code management. Now, in Microsoft Azure, you have actually two options. If you want to use distributed version control system, you have an option of Git. And if you are a big fan of centralized version control systems, then you have this option of TFS, Team Foundation Version Control, as you are aware of it already. And Visual Studio Team Services actually lets you connect directly to any Git repository or service provider, including Git, or let's say TFS, or maybe GitHub, Bitbucket, your private repository, or even Subversion. You can automatically trigger your pipeline from changes to your code And authentication part is taken care by typically Git Credential Manager or SSH. So Visual Studio Team Services lets you perform most common Git tasks you will need for your day-to-day work right from Visual Studio. And you have Team Explorer and you have Git command line, which work great together. And when you make updates and perform commands through one interface, you'll be able to see those changes reflected in the other. You can limit who can contribute to specific branches and automatically include the right reviewers for every code change. So you get all the capabilities which you would like to have in your source code management suite. So next in the line, we have continuous integration, and Visual Studio Team Services lets you integrate with any of the application stack of your choice for testing and integration in order to achieve continuous integration. Now, high-performing teams practice continuous integration and continuous delivery. Now, Visual Studio Team Services not only automates the build and testing and deployment of your app, it actually gives you complete traceability to see everything in the build, including changes to your code, reviews, and test results. It actually lets you integrate with any application stack of your choice, as we have seen before. And you can actually work on all major platforms such as Windows, Linux, and iOS, and with suites like Maven, NUnit, JUnit, etc. When you talk about continuous delivery or build and release related services, again, you have a host of services at your disposal. Actually, Visual Studio Team Services and Team Foundation Server, which actually helps you implement a highly customizable continuous integration and deployment pipeline. And as we have seen before, you can use any of the application stack for your purpose. You can develop your code in .NET, in Java, in Node.js, PHP, Python, anything of your choice, right? And similarly, you have multiple ways to deploy it and multiple locations you can deploy your application. Right. Visual Studio Team Services actually supports deploying your application to virtual machines, to containers, if you have an on-premise data center, or if you have any of the cloud platforms or PaaS services, you can deploy anywhere you like. If your goal is to produce packages which can be consumed by others, so even that has been given as a capability in Visual Studio Team Services. You have a built-in package management repository, and you can package and publish your application bits as, let's say, NuGet, NPM, or Maven packages into the built-in repository or into any other package management repository of your choice. Now, when it comes to monitoring, we have Application Insights. Now, Application Insights is an extensible application performance management service for web developers who are building and managing apps on multiple platforms. With Application Insights, you can actually quickly find out how your app is performing and being used when it is live. Let's say if there's a problem, it lets you know about it. You can help. It actually helps you assess the impact and helps you determine the cause. It actually lets you increase your visibility over application and brings your operation and application data together in one place. So you have all the capabilities of a modern continuous monitoring application in the form of Application Insights, which is an inbuilt application in Azure stack. So when we talk about infrastructure as code, we again have an inbuilt tool within your Azure stack, which is known as Azure Resource Manager. And when you talk about infrastructure, when you think about your application infrastructure, you think of many components, right? You think of a virtual machine, you think of storage account, you think of network components, a web app, database, third-party services. You don't see these components as separate entities, right? Instead, you see them as related and interdependent parts of a single entity. You want to deploy, manage, and monitor them as a group. And that's what Azure Resource Manager lets you do it. You can actually deploy, update, or delete all the resources for your solution in a single coordinated operation. You use a template for deployment, and that template can work for different environments, such as testing, staging, and production. Resource Manager provides security, auditing, tagging features to help you manage your resources even after deployments. Now, agile tools actually they help you. You can track everything in a single place with the help of agile tools, and they kind of give you all the management related capabilities when you want to have a bird's eye view of your overall DevOps infrastructure. So you have this dashboard availability in which you can actually see in a nutshell, at a glance, you can take a look at what exactly is going on with your infrastructure. Now, let's say you are working on a if you're working on a Scrum or Kanban, if you're working on that model, then let's say you have Kanban boards at your disposal and you have even a Scrum boards at your disposal. You can actually capture new features and bugs or any other work item into your backlogs. You can actually customize your task boards as per your needs, so that you can track your team progress, or you can use agile portfolio management for larger groups to track work across all of the teams. Now, apart from all these, whatever we have discussed so far, we have something called a Visual Studio Marketplace. Now, this is a place, it is an online store that offers applications and services either built in or designed to integrate with Azure Cloud Platform. Now, let's say we have discussed all of the tools beforehand, right? We have been discussing for the last 5 minutes or so. But let's say you need a tool which is not there in the list. So you need to come to the marketplace, and this will give you whatever tools you need for your DevOps pipeline. You will have those tools available here. Right. The products and services which are sold through the Azure Marketplace, actually they come either from Microsoft directly or the technology partners. So with Marketplace, actually, you can integrate Azure Cloud with a host of technologies. As you can see on the screen, you have Jenkins, Docker, Redgate, we have Elasticsearch, MongoDB, Cassandra, NetScaler, F5 Big IP, and a lot more, actually. Now, Azure Marketplace also supports various pricing models. Let's say bring your own license model, or pay-as-you-go model, or even free software extensions. So all these extensions are available on Marketplace, and they are certified by Microsoft to ensure compatibility with the Azure Cloud Platform. And as of mid-2016, Azure Marketplace has more than 3,500 products organized into several categories. Hello everyone, and welcome to this video in which we are going to talk about DevOps on AWS. So first we'll try and understand what exactly DevOps is all about. Then we will see why it is gaining so much popularity and what are the benefits of implementing DevOps in your projects and in your company. Then we will take a look at where exactly cloud fits in here. And finally, we will see what AWS has to offer when we talk about DevOps on cloud. So first of all, what exactly is DevOps? As per the definition given by Amazon, it's a combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. Now, high velocity is the keyword here because gone are the days when it was okay to release a software upgrade or an enhancement or a bug fix once in a quarter. Today, you have companies who are doing that on a weekly basis and in some cases on a daily basis. So this speed actually enables organizations to better serve their customers and compete more effectively in the market. And once you have DevOps implemented properly, this is how it looks like. You have a delivery pipeline wherein you are building, testing, and releasing your software to the customers, and then you are monitoring their behavior and planning for the next release accordingly. So what are the key benefits of implementing a DevOps in your projects? The first and foremost benefit is better collaboration among the devs and ops of your organization. So your development department and your operations department, they work like a single cohesive unit with little or no friction, which definitely increases overall productivity of the organization. DevOps practices such as continuous integration, continuous delivery, infrastructure as code, etc., make it possible to release the code way faster than before with almost no errors, resulting in faster time to market and minimized failed deployments. And overall, once you have this shared responsibility model, as they call it, it actually increases the collaboration. Release happens faster, which in turn increases overall productivity of every individual and the team. Now, State of DevOps report, it's a report published by Puppet Labs and DORA, which is a DevOps research organization, on an annual basis. Every year they release this report. after doing a lot of extensive survey of individuals and companies. And based on that, they give you the outcome or the trends which are going on in the market with regards to DevOps. And some of the key findings of the last couple of years is if you implement DevOps, you actually gain frequent deployments. You have a faster MTTR, which stands for mean time to recovery, which essentially means that how much time it takes for you to roll back if you have any problem coming up during your deployments, in case of a failed deployment rather. And yes, you have less number of failed deployments if you have DevOps implemented properly. You design it in such a way that it fails less and less. You make your deployment boring, in one word. And finally, shorter lead times. Now, lead time is typically a time given to the deployment team before you tell them when it has to be released. So let's say it can be 48 hours, it can be 72 hours. You have to tell them, let's say, in 1 week in advance. So that time gets shorter and shorter and shorter, which means you can tell your deployment team maybe even only 1 hour in advance when you are going to deploy your software, and they should be able to do it. That's how it works. So these are some of the key benefits of implementing DevOps in your company. Now let's see how DevOps and cloud, how they are interrelated. First of all, DevOps and cloud, they are complementary to each other. Now, most importantly, DevOps and cloud, both of these technologies are comparatively new in IT industry. Cloud, not so new, but DevOps, definitely it's comparatively new. And important thing to remember is that both of these technologies are the ones which are currently being embraced by most of the companies. They are trying to move towards DevOps, and they're trying to implement cloud in their projects. So what happens is cloud makes it easy to implement DevOps services because of inherent abstraction of complexities. Now, you need not worry about the integration aspect of your tools and technologies in particular. You don't need to write a lot of glue codes. You just have the tools and you just have the services. You just implement them, and it works absolutely fine. And yes, you do get the added advantage of agility, scalability, and on-demand availability to DevOps services. All these things are inherent when you have a cloud provider, right? You need not worry about all these aspects. You don't worry about the scalability factor of your servers. You don't worry about the on-demand availability. Whenever you want a service, you have it available if you're working on a cloud. And yes, a combination of DevOps and cloud provides a definite advantage over the competition. No doubt about that. So now let's take a look what exactly AWS has to offer when it comes to DevOps on AWS. Now, what happens is AWS happens to call them deployment services. They have a specific services with regards to DevOps practices. They call them deployment services. And the first one is Code Commit. It's a fully managed source control service that makes it easy for companies to host, secure, and highly scalable private Git repositories. It also eliminates the need for you to manage your own source control system or worry about scaling its infrastructure. You can use AWS Code Commit to store anything from code to binaries. It also supports the standard functionality of Git, so it works seamlessly with your existing Git-based tools. You can actually think of Code Commit as Amazon's version of GitLab or GitHub. AWS Code Pipeline, it's a continuous integration and continuous delivery service for fast and reliable application and infrastructure updates. Code Pipeline builds, tests, and deploys your code every time there is a code change based on the release process models you define. You can easily build out an end-to-end solution by using pre-built plugins for popular third-party services like GitHub or integrating your own custom plugins into any stage of your release process. With AWS Code Pipeline, you only pay for what you use. There is no upfront fees or any kind of long-term commitments. And some of the key benefits of Code Pipeline is, for example, rapid delivery. You have improved quality of the overall pipeline. You can actually automate your build and test and release process, which actually allows you to easily test each code change and catch bugs while they are small and simple to fix. You can assure the quality of your application or infrastructure code by running each change through your standardized release process. And you can easily integrate Code Pipeline into any other services within AWS or outside. For example, you can pull your source code from GitHub, use your on-premises Jenkins build server, run load tests using a third-party service, or pass on deployment information to your, let's say, custom operations dashboard. Next is AWS Code Build. Now, AWS Code Build actually eliminates the need to provision, manage, and scale your own build servers. It provides pre-packaged build environments for the most popular programming languages and build tools such as Apache Maven, Gradle, and more. You can also customize build environments in AWS Code Build to use your own build tools. AWS Code Build scales automatically to meet peak build requests. And some of the major benefits of code builds, first of all, it is a fully managed service. So it eliminates the need to set up, patch, update, and manage your own build servers. It is an on-demand service, so you can use it anytime you want, and you pay only for the number of builds minutes you consume. And definitely it is out of the box, so you don't need to have any kind of configurations done. It is a pre-configured build environments for the most popular programming languages. All you need is to point to your builder scripts to start your first build. Now, Code Deploy is a service that automates code deployments to any instance, including Amazon EC2 instances and instances running on premises. If you need to deploy applications frequently or to multiple environments or both, it automates the process, allowing you to deploy reliably and rapidly by eliminating the need for error-prone manual operations. Now, AWS Code Deploy helps minimize downtime by performing rolling updates across your Amazon EC2 instances, and it also tracks your application health. Now, CloudFormation actually gives developers and system administrators an easy way to create and manage a collection of related AWS resources, provisioning and updating them in an orderly and predictable fashion. It simplifies provisioning and managing resources on AWS. You can create templates for the services and applications you want to build on AWS. It then uses those templates to quickly and reliably provision the services or applications, which are known as stacks, right? And you can use various resources such as EC2, VPC, RDS, etc. as part of your CloudFormation stacks. You can provision from a single EC2 instance to a multi-tiered application spanning across multiple availability zones with very complex routing rules. And all this with a click of a button. Once you have everything defined properly in the form of templates in CloudFormation. AWS OpsWorks. Now, this is something you can think of as Chef on AWS. It's basically a flexible application management solution with automation tools that enable you to model and control your application and their supporting infrastructure. You can manage the complete application lifecycle, including resource provisioning, configuration management, application deployment, software updates, monitoring, and access control. You can define the application's architecture and the specification of each component, including package installation, software configuration, and resources.
In this video, we will define release management and discuss what this means from a DevOps point of view. Additionally, we will examine various tools that can be used to set up a DevOps release management workflow. What is release management? Release management is the process of managing, planning, scheduling, and controlling a software build through different stages and environments, including testing and deploying software releases. DevOps release management. DevOps as a culture emphasizes that the collaboration and communication of software development team members and IT professionals is a dependency of the release cycle, and accordingly, we see the importance of release management as an increasing discipline in this world. In the modern iterative world, where feedback and performance metrics are incorporated directly into the development cycle, the process of overseeing the development cycle requires dedicated resources and personnel. What are the goals of DevOps release management? The DevOps release cycle should deploy releases into operation and establish effective use of services in order to deliver value to the customer. Release and deployment management also ensures handover to service operations takes place and that suitable training and documentation exists to ensure ongoing support of the new service. Release management strategies. There are basically four main release strategies used in DevOps. The first of these are slow cadence release windows. A release window is a period of time when new software may be released.
For example, your organization may determine that, based on low server demand, that the period between 1 a.m. and 5 a.m. on Saturday morning will be the weekly release window. Within this window, there may be various subsets of the release window. These are known as release slots. Release slots can serve as roll-up points within the release window. The period of slow cadence release windows tends to be less frequent, occurring weekly, monthly, or even longer. However, in terms of modern high availability application services, this paradigm has all but disappeared. The advantages of this approach are a consistent cadence to business stakeholders and predictable release date targets for delivery teams. A major disadvantage of the slow cadence release window is that it tends to bottleneck a release management process that must support multiple teams. There are only so many slots available within the release window, and this may force some teams' releases to be delayed to the next release window. This problem may be exacerbated further if the team is attempting to adopt a continuous delivery model. Release train. The idea of a release train is that every team associated with the train has the same release cadence. The train may release once a quarter, once a month, or even once a week. This approach is commonly used on larger programs where there are many teams contributing features or subsystems to the release. The predictable schedule of the train is very attractive to business stakeholders. Just as with a real-life train, if you miss the train, the release point, your feature or update must wait until the next train. This model also takes dependencies into account. If there are dependent modules, these must be coordinated on the same train. The major disadvantage of the train model is because development teams are constrained to a fixed cadence, lean or continuous deployment paradigms are difficult to implement. The fixed cadence can also introduce bottlenecks, just as in the slow cadence window release model. The quick cadence release model addresses some of the requirements of continuous deployment. Here there are many release windows and many release slots. The increased slots allow for finer control over dependencies, and the increased windows allow for more frequent releases. This makes the quick cadence release window less prone to the bottlenecks of the slow cadence and train models. Continuous release availability. Of the strategies discussed here, continuous release availability is the only model that allows an implementation of continuous delivery. With this model, teams may release solutions into production whenever required. In order to support this paradigm, several modern DevOps practices must be implemented. Some of these are fully automated deployment, fully automated regression tests, feature toggles, and self-recovering components. There are other methodologies besides these that allow continuous delivery in a release management framework. Let's look at some of these. DevOps techniques for release management are: use infrastructure as code, destroy all your servers all the time, zero in on zero downtime deployments. Let's drill down on each of these components. Infrastructure as code. The days of manual configuring of infrastructure are long gone. There are two main reasons for this. The first is that manual configuration is error-prone. Humans make mistakes. For instance, in a manually maintained environment, how many times has it occurred that someone forgot to properly reconfigure the environment before a new payload was deployed? This was a common occurrence and often resulted in countless wasted hours in debugging the new configuration. Secondly, tracking a manual process through documentation is cumbersome. Written documents are also subject to omissions, misinterpretations, and are frequently out of date with respect to a dynamic environment. Infrastructure as code is the process of managing and provisioning server infrastructure through machine-readable definition files. Just as the software development team provides you with the source code for your application, your infrastructure development team provides you with the machine definition scripts for your infrastructure. Just like software source code, these can be maintained through a version control system and become part of the Git repository, and can also be automatically propagated through a continuous delivery system like any other piece of software. There are many configuration management tools that support this concept. A few of these are Chef, Puppet, Ansible, and Saltbox. These tools allow you to define in code exactly what your environment looks like. This view is then automatically applied to all servers. Infrastructure as code has three main advantages. It leads to more reliable releases. When you automate the process of installing and configuring software, you reduce the room for error. It allows a more repeatable release process. You can run your scripts over and over in your testing environment, in your UAT environment, your staging and production environments, and know that what you are getting is the same result each time. The release cycle becomes a well-tested and well-rehearsed process. Disaster recovery becomes simpler because the requirements of the recovery server are clearly documented and reliably reproduced in the code. The recovery server and the original server both share the same code set. And since the script files are preserved as living documentation, they improve audits. The script not only tells exactly how a server is configured, but since they are version controlled, you can see how it has changed over time. Additionally, with a continuous delivery system, you can see when the scripts were applied and who initiated the deployment. So we can see how infrastructure as code allows both the development and the operations side of teams to coordinate their releases and deploy continuously to physical, cloud, and virtual environments. Destroy your servers. What do we do when our server crashes and we lose our environment? Do we have the confidence that we can recover from this scenario in an accurate and timely manner? If we have a manually configured environment, then the answer is likely no. We may be putting our confidence into the fact that we do operating system backups. However, is that path actually tested as part of the backup and restore cycle? There is a common problem associated with server administration known as configuration drift. This is where the actual configuration of the server evolves over time due to the compounding effect of making changes on top of changes. This is a given with manual configuration, but it can even happen when using an automation tool. How can we be confident that a single run of our current configuration scripts will put our server into a known state? The only way to eliminate configuration drift is to destroy our servers on purpose as part of our regular maintenance cycle. We should also deploy our servers as virtual machines so that they are easy to redeploy. Part of every deployment should be the destruction and restoration of the environment. These are commonly referred to as Phoenix servers. This process will force us to ensure that our infrastructure code is an accurate representation of our desired server configuration. Since our normal deployment process is to restore our services from the point of destruction, disaster recovery becomes part of our normal operating procedure. Zero downtime. In a modern DevOps environment, service outage announcements for routine maintenance are an embarrassment. Also, scheduling downtime at off-peak hours when our staff is not likely to be at their best is an accident waiting to happen. We need to find ways to deploy software without affecting our user base. This is particularly important when we are using Phoenix servers, as their downtime can be unacceptably long. Although there are a few common strategies for managing maintenance and downtime, we will focus here on blue-green deployment as an example. In this strategy, we actually have two identical server environments. Set up routing using a load balancer such as HAProxy or Nginx so that all of the traffic is routed to the active server environment. Now you can direct your configuration management to update the passive server environment. When you are confident that the passive environment is working as desired, You can simply use the load balancer to redirect the network traffic to the new environment with the latest changes. This way, the user base will experience no disruption in service. Release management tools. Let's take a look at some of the release management tools that are in the marketplace. Electric Flow is a single DevOps platform that supports the entire end-to-end software development and delivery process. Electric Flow Deploy is built on top of this powerful platform to automate deployments and accelerate time to market, reduce delivery costs, and increase quality, reliability, and traceability. BMC Release Process Management is a release management tool that allows you to deploy changes to your business-critical applications with lightweight, web-based task coordination and execution. IBM Urban Code Release, formerly called uRelease, is a collaborative release management tool that helps you handle the growing number and complexity of releases. You can plan, execute, and track a release through every stage of the delivery cycle. Octopus Deploy is an automated deployment and release management server. It is designed to simplify deployment of ASP.NET applications, Windows services, and databases. CA Release Automation is an enterprise-class continuous delivery solution that automates complex multi-tier release deployments through orchestration and promotion of applications from development through production.
Hello and welcome to DevOps Test Automation. Today we will see what test automation is and where test automation fits into the overall DevOps automation continuous integration, continuous delivery. We will also see various test automation frameworks that are available. In DevOps, we do talk about a lot of automation, using a lot of tools to automate the non-human steps that are part of your entire SDLC lifecycle. Automation can be achieved using various tools at different steps of your software development and delivery, like to create your build, to trigger your test cases, to deploy your build, to run various other automation scripts. Build tools like Maven, Ant can help automate your build creation. You can use tools like Puppet and Ansible that can automate the configuration management for your entire environment setup. Continuous integration tools like Jenkins and TeamCity can automate various steps of your delivery pipeline execution. Then there are tools like Octopus, Deploy, and Kubernetes that can automate the code deployment steps of your continuous deployment. Lastly, you have continuous monitoring tools like Nagios to automate the server monitoring. In other words, monitoring the different applications you have running on your server. Let's look at what DevOps test automation is. Similarly, where all the steps of your software development and delivery process can be automated, the testing that comes at the different stages of your software development, like your unit testing, your integration testing, performance testing, stress testing, penetration testing, can also be automated. These tests are done at different stages of your software development project, and test automation also includes continuous quality tools that help manage and maintain the code quality aspects of software development tools that help you automatically check the code coverage of your software code and do automated code reviews for your software code. The importance of software testing and quality control cannot be stressed upon enough in an automated SDLC process. When the underlying code written does not meet certain code quality criteria, all the tools that you use for automation from your coding stage onward to your deployment stage could become a huge maintenance nightmare very quickly, because you'll be struggling to correct your code, to fix your code, and automatically run the tools that help you do an automated build, automated testing, automated deployment. Because these tools are like triggers, and once you run the trigger, if the underlying code does not meet a certain quality criteria, your automated code, your automated steps are still going to run every time, and unfortunately fail or raise a lot of unnecessary issues because your underlying code doesn't meet a certain quality criteria. And very soon, you could be caught up in maintaining your automated pipeline and also trying to maintain and fix your code issues. And things can get out of hand very quickly. Automated process workflow is a series or set of interconnected steps that run in a particular order to achieve the desired end results. If made run on a less than desirable quality code, the automated workflow will keep pushing the same code quality into the production environment, or worse, fail at each and every step of your automation workflow, requiring someone in the team to manually monitor the automated workflow, thus completely negating the purpose of automation in the first place. There are different testing frameworks available in the market for various technologies that can be used at the different stages of the SDLC process. These frameworks allow you to write scripts or test scripts that can be written for every use case that you are deploying, every functionality that you are writing the code for that has to be implemented in your software project. There are frameworks and tools that can automate all the test steps of your entire software project. These are some of the test automation frameworks available for unit testing. ASP Unit for unit testing of ASP-based websites and pages, API Sanity Checker for unit test generator for C, C++ libraries. This can also automatically generate reasonable input data for every API function. CUnit for OS independent Windows, Linux, Mac, OS X, and probably others. CPP Unit for C++, set by design to keep usage easy and allow it to work on embedded platforms. C++ is buried in macros, so the learning curve for a C programmer is minimal on this, and it is ported to Symbian and has a mocking support library, CPP UMock. XUnit supports running tests concurrently. Macros are only used for test setup, not for test assertions. XUnit for testing native XML programs, individual XSLT templates, and Java programs that equal XML data. HTML Unit for Java hit list browser emulators. JUnit for Java-based project unit testing. TestNG can include unit test, functional test, integration test, and can create even non-functional tests like your load test, time test, unit testing framework for JavaScript and Node.js. It works with any unit testing framework and assertion libraries. Visual Studio is the unit testing framework that was first included in Visual Studio Team System in 2005 when it integrated with the IDE, but was not available in the most used Standard Edition. From Visual Studio 2008, it is also available in the Professional Edition. Starting with Visual Studio Express 2013, it is included with Visual Studio Express editions. PHP Unit, it produces XML, HTML reports with code coverage. PyTest, distributed testing tool for Python. SQL Unit for SQL statements and queries, and Spock is a testing and specification framework for Java and Groovy applications. Spock supports specifications by example and BDD style testing as well. Then you have various system integration frameworks like your TestNG. This can include unit test, functional test, integration test. Your Jasmine, which is a BDD framework independent, easily integration with the Ruby projects and continuous builds, allows for both DOM-less testing and asynchronous testing. You have JS Test Runner, which is a JUnit test runner that runs JavaScript tests. The goal of the JS Test Runner is to be able to test JavaScript code using an approach that test-driven programmers will feel comfortable with, particularly in the context of continuous integration. Then you have Quality Gate 1 Studio, which is a commercial freeware test framework for United Integration testing that analyzes dependencies between test cases to flow that data between them. It supports combinational testing, multi-threading, and time dependencies. You have TSQL-LT, which includes mocking frameworks, continuous integration support, and uses SQL Test SGY. You have Juxi, a library for unit testing SLT style sheets for Java. MoX Unit works for both MATLAB and Octave and uses all style object-oriented programming features and is compatible with MATLAB XUnit test framework. It can also be used with Travis CI and shippable continuous integration services and integrates with Mocov to provide code coverage reports either offline or through coveralls.io. NMate is NUnit and part cover code generation and integration add-in for Microsoft Visual Studio 2005-2008. Then you have a few BDD frameworks, behavior-driven testing. libcBDD is block-based behavioral-driven development library that allows for very readable tests. Tests are written inside main functions, and this allows for great flexibility on how to run these tests. You have cgreen, which is unit testing framework, including strict and loose mocks, reflective runner discovering tests automatically, suites, BDD style, concept under test notation, test protected against exceptions, natural language out, and extensible reporter, learning mocks. Then you have catch, which is header only, no external dependencies, auto registration, TDD, and BDD features. You have Igloo, which is BDD style unit testing in C++, Easy B BDD testing in Groovy, Spock BDD with built-in mocking and spy capabilities, HSpec, which is RSpec style BDD framework for Haskell that integrates with QuickCheck and HUnit. You have JSpec, which is highly readable BDD 50-plus matchers, DOM framework, independent, async, Rhino, Node.js support, and more. You have Chai, which is BDD/TDD assertion library for Node and the browser that can be delightfully paired with any JavaScript testing framework. Buster.js, which is BDD/XUnit assertion, expectation, browser/server, extendable with tools like linting and other QA measures, highly configurable, well documented, and actively adopted. A PHP spec, which is a BDD style testing framework. Scala-Test, which is scalable test framework, supports different styles of testing, TDD, BDD, and more. And you have XSpec, a behavior-driven development framework for XSLT and XQuery, and is based on the spec framework of RSpec, which is a BDD framework for Ruby. These are a few mocking frameworks that can be used for different kinds of testings. You have cgreen, which allows you to do unit testing framework, including strict and loose mocks, reflective runner discovering tests automatically, suites, BDD style, concept under test notation, test protection against concepts, natural language out, extensible reporter, and learning mocks. You have CMocka, which is a test framework for C, which support for mock objects. It's easy to use and set up. CMocka is a successor of CMockery, which was developed by Google, where it has been unmaintained for quite some time. So CMocka was forked and will be maintained in the future. Then you have OpMock, which is stubbing and mocking framework for C and C++ based on code generation from headers. It can check call parameters, call sequence, and handle multiple implementations of a mock and much more. Includes as well a small unit testing framework with JUnit compatible XML output, but works also with any unit testing framework. Then you have CXS tests, uses a C++ parser and code generator. Of course, it requires Python for testing registration and has a framework for generating mocks of global functions, but not for generating mocks of objects. Header-only mock object library and Eclipse plugin to create test doubles in a simple yet powerful way. It leverages the new C++ 11 language facilities while still being compatible with the C++ 03 and has a built-in support for Qt. EasyMock is a mock framework for Java. JMock is a mock framework for Java. JMockit is an open source framework. Tests can be easily written that will mock final class, static methods, constructors, and so on. There are no limitations. Mockito is a mock framework. PowerMock is an extension to both Mockito and EasyMock that allows mocking of static methods, constructors, final classes, and methods, provides private methods, removal of static initializers. Then you have Enhanced PHP, which is unit testing framework with mocks and stubs built in. It runs in the command line or gets HTML5, TAP, or XML output via a web browser. Then we have a few continuous testing tools. Appium is a freely distributed open-source mobile application UI testing framework that allows hybrid, native, and web app testing. It also supports automation testing on physical servers, emulators, and simulators. A big advantage that Appium offers is cross-platform app testing by using the single API for both Android and iOS platform test scripts. Because Appium uses vendor-provided automation frameworks, there is no need to additionally compile any Appium authored by the code framework as you are testing the app that is being shipped. Bamboo is a continuous integration server from Atlassian, the makers of Jira, Confluence, and Cloud. Bamboo ties automated tests, automated builds, and releases in a single workflow, and this helps in implementing continuous integration, deployment, and delivery all within Bamboo. Bamboo can help run tests in parallel batches as it supports up to 100 remote build agents, and this helps to keep the queue flowing and to provide quick feedback to developers. Cruise Control is a Java-based framework that helps implement a continuous build process and allowing performing continuous integration of software development process. CruiseControl.net, however, comprises of two executable components, ccservice.exe, which is the Windows service, and ccnet.exe, which is a console app included for testing purposes. As it is easier to debug a console application rather than a service, it is recommended to perform initial tests with ccnet.exe and then to read the console output to understand the ccnet exception and behavior. Then you have Cucumber, which is behavior-driven development, is a practice that tests systems rather than test code. Cucumber is a Groovy-based test tool for BDD framework and is used to write and run automated acceptance tests in simple plain English that can be understood by your business analysts, by developers, and by testers. While Git is version control system, GitHub is a staging platform that lets developers edit and build upon each other's codes, share prototypes, and collaborate on projects. By sending a link to GitHub, clients can test drive the website in progress for functionality. TestRail, a web-based test case management software been integrated with GitHub, can provide developers, testers, and team leads to centrally manage and coordinate software testing efforts. Jenkins is an extensive automation server, is a continuous integration server that automatically involves creating and testing and continuous delivery application that can distribute, build, test loads to multiple computers with different operating systems. This speeds up the integration process and the users can get a fresh build as required. Jenkins also helps in continuous delivery of applications by guiding the definition of build pipeline and integrating with the large number of technologies related to testing and deployment. Jenkins can be used as a simple CI server to build and test Android apps, to support the Git version control system, and to provide unit testing for other technologies using a host of plugins. JUnit is a simple unit and regression testing framework used by Java developers to write readable tests that increase programming speed and improve the quality of code. JUnit test framework can be easily integrated with Eclipse and or Maven and provides features such as your fixtures, test suites, JUnit classes, and test runners. JUnit has played a critical role in the development of test-driven development and belongs to the family of unit testing frameworks, collectively called as XUnit, which was originated with Sonnet. Maven is a tool for automating build lifecycles using Java, C#, Ruby, Scala, and other languages. Automation ensures that for building a project, only a small set of commands need to be executed. Maven uses an XML file to explain the software project that is being built, along with its dependencies on required plugins, external, and components. The Apache Software Foundation hosts the Maven project. Selenium Automation Framework is a customized, open-source, portable software testing framework for web applications that has been developed using Selenium by using a scriptless test automation framework. Selenium reduces coding efforts, test cycle times, and related costs, which improves the test automation efficiency of apps developed on .NET, Ajax, or Java J2EE. Selenium was developed by a team of developers and testers at ThoughtWorks. It was released under the Apache 2.0 license and can be downloaded and used without charge. Selenium IDE is a full-fledged integrated development environment for authoring tests and using a test domain-specific language to write tests in a number of popular programming languages like Java, C#, Groovy, Perl, PHP, Python, and Ruby. It also is a record playback tool for authoring tests. TestNG is a testing framework that has been designed to cover multiple test categories such as end-to-end functionality integration and unit tests. Taking inspiration from JUnit and NUnit, TestNG has been built to provide some additional advanced new functionalities to the testing framework. These advanced functionalities provide a lot of benefits to both developers and testers. To be used properly, TestNG requires JDK 5 or higher installed on the machine. SonarQube provides the capability to not only show the health of an application, but also to highlight issues in newly introduced with a quality gate in place so you can fix the leak and therefore improve quality systematically.
We will see one of the various DevOps metrics that need to be monitored and measured, and one of the various dashboard tools to do the same. Let us begin by understanding what software metrics are. While we develop software products, we need some mechanism, some way of measuring or validating that what we are doing meets our customers' expectations. Not only of the functionality that we are developing as part of that software development, but also of cost, budget, of various resources, the spend, and the return on investments on all that cost, all that money that is being spent. Metrics can be defined as quantitative measures that allow the software engineers to identify the efficiency and improve the quality of software processes, software projects, and the outcome product. This enables software engineers or project managers or your stakeholders to adjust software processes and improve software products if needed. There are various metrics that can be measured for software projects. You have balanced scorecards that are a performance management tool, a semi-standard structured report supported by design methods and automation tools that can be used by managers to keep track of execution of activities by the different team members within their reporting structure, and to monitor the consequences arising from any of these actions. You can have a software bug which can be measured or a line of code. So, a bug is an error or a flaw or a failure or some kind of fault in the computer program or system that causes it to produce an incorrect or unexpected result, or to behave in unintended ways. Then you have code coverage. So, in computer science, code coverage is a measure used to describe the degree to which the source code of the program is executed when a particular gas width runs. A program with high code coverage, measured as a percentage, has more of its source code executed during testing, which suggests that it has a lower chance of containing undetected software bugs compared to a program with low code coverage. There are many different metrics that can be used to calculate the code coverage. Some of the most basic ones are the percentage of subroutines, programs, and the percentage of program statements that are called during execution of the software code. Then you have something called cyclomatic complexity, which is a software metric that is used to indicate the complexity of a software program. It is a quantitative measure of the number of linearly independent paths through a program's source code. You can have function points and automated function points. So, function points is a unit of measure to express the amount of business functionality and information a system or a product provides to a user. Function points are used to compute functional size measurement of software, the cost in dollars or number of hours of a single unit discalculated from previous project data. In engineering, maintainability is the ease with which a project can be maintained in order to correct effects or the causes, repair or replace faulty components without having to replace the parts that are working fine, prevent unexpected working conditions, maximize the products used for life, maximize efficiency, reliability, and safety, meet any new requirements that you receive from your customer to implement, make future maintenance easier or able to cope with a more changed environment. Then you can have something called number of classes and interfaces. So number of classes and interfaces are measured to check for code complexity or even your function point complexity. Source line of code, SLOC, also known as line of code, is a software metric that is used to measure the size of a computer program, accounting the number of lines in the text of the program's source code. Source line of code is typically used to predict the amount of effort that would be required to develop a program, as well as to estimate programming productivity or maintainability once a software is produced. In computing, a loader is part of an operating system that is essentially responsible for loading programs and libraries in the memory of your computer. It is one of the essential stages in the process of starting a program, as it places programs into memory and prepares them for execution. Loading a program involves reading the content of the executable file containing the program instructions into memory and then carrying out the required preparatory steps to prepare the executable front-running. Once loading is complete, the operating system starts the program by passing control to the loaded program code. In computer science, the runtime or execution time is the time during which the program is running or executing, in contrast to other programs like cycle phases such as compilation time, length time, load time. A runtime error is detected after or during the execution state of a program, whereas a compile time error is detected by the compile time before the program is ever executed. Type checking, register allocation, code generation, code optimization are typically done at compile time, but may be done at runtime either, depending on the particular language and compiler. Weighted microfunction points is a modern software sizing algorithm invented by Logical Solutions in the year 2009, which is a successor to the solid ancestors scientific method such as COCOMO, COSISMO, Maintainability Index, Cyclomatic Complexity Function Points, and Ousted Complexity. It produces more accurate results than traditional software sizing methodologies, while requiring less configuration and knowledge from the end user, as most of the estimation is based on automatic measurement of an existing source code. Dashboards often provide at-a-glance view of various key performance indicators, also called KPIs, relevant for a particular objective or business process like sales, marketing, human resources, or production. In real-world terms, dashboard is another name for a progress report or a report. The underlying virtues of implementing DevOps are continued improvement and development. The development and IT operation teams are expected to collaborate and be active participants in this collaboration and innovative process. The objective overall is to ensure smooth functioning of the application with the least interruptions, build distinct dashboards for distinct software. Ultimately, a dashboard is a common platform or a framework that enables you to manage issues, so more than the technicalities, it is important to nurture a culture that encourages the adoption of DevOps approach. The idea here is to enable self-learning and self-improvement among software developers, operations engineers on a regular basis. Change is difficult, and while on a transformation journey, it is important to realize the objectives of the project or task at hand. The objective helps structure the metrics, for tracking the overall development process for the respective teams. DevOps dashboards enable system admins and developers to remain updated with software applications, key performance metrics like uptime, load time, API calls, CPU processes, memory usage, and various other components that ensure that your production environment is stable and your customer and user experience is stable. Software development lifecycle is a journey of various ups and downs. Things get broken and fixed throughout the cycle. DevOps Dashboards monitors the process and helps you to spot bugs before you get flooded with user issues, user feedback, and tickets. As mentioned earlier, building metrics on the DevOps dashboard totally depends on the project objectives. Creating a DevOps dashboard totally depends on and is highly influenced by your own requirements and challenges. It is a reflection of your project's need at the overall approach of the team. So, it is recommended to create, edit, repeat, and build focused dashboard metrics that enhance the visibility of the project process and issues. Additionally, it incorporates response time, usage of resources, issues and errors, any user feedback, any other aspect that you feel is important for a speedy delivery. For example, tracking CPU usage for individual internal APIs helps the operations team to evaluate the issues with performance and accordingly to take necessary actions during the course of the project. You need dashboard for tracking the application, for assessing the team's progress, for tracking the core performance APIs and making them visible for all. The objective is to get the process going collaboratively and deliver it at the same speed with the necessary quality. Quality and speed are at the core of DevOps approach, a key reason why leading enterprises across the globe leverage the synergy between development and operations teams with an indicated DevOps model. DevOps culture is majorly driven not just by this synergy, but also by the underlying need for continuous collaboration and delivery. There are various DevOps metrics on which you can create dashboards, frequency of deployments, which is basically a metrics that will keep a tab on the frequency of deploying the new code. It will help track the deployment process by team members, which is a very critical activity for any project. Moreover, it is all-pervasive and is applicable across projects. You can measure tracking change, and it is absolutely critical to track the user stories associated with the project, and most importantly, setting the parameters to track the complexity of the changes occurring in the project. You can track the lead time, which is software application development, follows a process of development to deployment when new code is developed and successfully deployed into production. Cycle time is a key indicator to determine efficiency in the process where it helps the team to understand the areas of improvements. Ultimately, the metrics helps the team to get a better hold of the project's development. Track percentage of deployments fail, so you need to track the percentage of deployments that had led to outage or any negative feedback from your customer from your user. By the nature of DevOps approach, it is expected to build quality right from the beginning rather than post-development as an afterthought. Experts suggest to review this metrics as a team to effectively keep track of negative sentiment in the project. Mean time to recovery is another useful metric. Recovery and resilience is critical in any project, as it will help build market readiness of your software application. Mean time to recovery is an ideal process of tracking complex issues and failures, assessing the ability of the team to handle fundamental change and be able to bounce back. Various performance metrics can be incorporated. This metrics has to remain stable, irrespective of any changes in user feedback or your deployment indicators. It is a key indicator that the software application is operational within the defined limits. There are various DevOps dashboards tools available, like Elk Stack, Graphite, Keen.io, Librado, Datadog, and Hygiea. The Elk Stack is essentially a combination of 3 open-source products from Elastic: Elasticsearch and analytics capability, Logstacks as the logs aggregator, and Kibana for the fancy dashboard visualization. Today, Elasticsearch is pretty much built in with Logstash and Kibana as an Elastic's product as well, making integration and setup very simple. But a new deployment rolls out. The dashboard follows custom indicators that you can set up using your app's help. These indicators update in real time, allowing close monitoring and freshly delivered code, taking its first steps after being uploaded to production. It is free, but there are Elastic paid plans that include different levels of professional support for the tool. Graphite is an open source tool written in Python for storing data and providing graphs and visualizations of it on demand. It does not collect any data itself, but instead works with other tools for the purpose. Grafana is an open source tool that provides a metrics dashboard and graph editor for Graphite. It essentially enhances what you can get from Graphite and provides more features. Graphite and Grafana are designed to be language agnostic. Also worth noting is the hosted Graphite, which essentially offers Graphite and Grafana as paid software as a service model. Keen.io is a software-as-service analytics infrastructure platform. It collects the data you specify from a wide range of possibilities, and its APIs perform analytics and visualization tasks at your request. It's designed around providing flexibility and choice to users from whom other visualization and metrics aren't satisfied. If you can't get the exact data you want from other tools, but can't or don't want to build your own custom analytics infrastructure, if analytics is a primary focus or concern for you, and you want more than what an out-of-the-box solution provides, then DevOps Keen.io is a good tool for you. Liberato is a hosted service for monitoring and managing cloud applications. Liberato can create custom dashboards in seconds without the need to set up or deploy any software. It focuses on graphics and visuals to create a very smooth look and feel compared to other dashboards. It recently became part of SolarWinds. If you want to be able to work with highly customized metrics and reports, if you want beautiful visualizations and better learning for the data that you send in, Liberato is the tool that will answer all of this for you. Datadog is again a software service monitoring tool targeted for DevOps teams that take data from your app and wide range of other tools and provides metrics and visualizations. It unifies data produced from your infrastructure and software into one location. They are currently built around aggregating and presenting data rather than performing analytics. If you want a DevOps-focused tool that works with an extensive ecosystem of other tools, if you want a tool that presents you with a unified view of data generated across your hardware and software, Datadog is a good choice. Hygiea gives developers a visual way to track progress across the development pipeline. The dashboard automatically refreshes every minute after tracking a project's progress across 6 different areas, features code repository, build quality monitoring, and also deployment. For example, the code repo window displays information regarding coding activities, number of commits per day, number of committers, and other current coding trends. Hygiea dashboard only supports the following tools to plug in. Those plugins can be written to integrate with other tools and solutions. Features like Jira, version 1, code repositories like GitHub, Subversion, build tools like Jenkins, Hudson, for quality, SonarQube, Cucumber, Selenium, and for deployment, IBM Urban Code Deploy.
DevOps has helped businesses of all types, whether startups
or Fortune 500 companies, all of them have started moving towards DevOps, as all of them are interested in improving the speed and quality of software development. And to name a few organizations, we have NASA, Amazon, Netflix, Walmart, and Facebook. DevOps have helped these companies in fixing several issues and overcoming several challenges. Here in this video, we shall have a look at some real-time problems that DevOps helped in solving. Let's have a look at all the topics we will be covering today. First, we shall learn the basics of DevOps. Then, we shall have a look at some advantages of DevOps, followed by some real-time scenarios. In our main topic, that is real-time scenarios, we shall have a look at 4 significant parts: continuous integration scenarios, continuous testing scenarios, continuous delivery scenarios, and DevOps scenarios. So without any further ado, let's get started. But before we begin, make sure you're subscribed to our YouTube channel and don't forget to click on the bell icon so you never miss an update from Simplilearn. Now, the first topic we have is, what is DevOps? DevOps is a software engineering culture that unifies the development and operations team under an umbrella of tools to automate every stage. There are several phases in the DevOps lifecycle, beginning from the planning phase and going up to the monitoring phase. The stages of DevOps begin with planning and coding. In these phases, tools like Git and Jira software are used to provide a repository for managing and storing various code versions. Then comes the build phase. In this phase, the tools like Gradle and Maven are used to automatically fetch the source code from the repositories and package them into executable applications. After the build phase comes the test phase. Testing in DevOps is automated within the build pipeline to ensure that the applications are deployable. The most common tool in this phase is Selenium. Next comes the deploy and operate phase, where tools like Puppet and Chef are used to push the ready applications to the deployment phase and continuously configure them to the right state. Moving forth comes the monitor phase, where the released products are continuously monitored. The most common tool used here is Negios. DevOps stages will be incomplete if we don't talk about the integration phase. The integration phase is the heart of DevOps, continuously automating the integration of all the different stages. The most popular tool that makes the process possible is Jenkins. Now, when we know the basics of DevOps and the stages in DevOps, let's have a look at some benefits of DevOps. Benefits of DevOps may be categorized under the following categories. The first category is adaptability. DevOps makes it possible for organizations to adapt better to market trends and yield the maximum outputs. Then another benefit of DevOps is fast delivery. DevOps makes it possible to increase the pace of releases, bug fixing, and response to customers. The third category here is reliability. DevOps ensures the quality of infrastructure and application updates. Moving forward, another critical category is improved collaboration. DevOps makes it possible to have effective team building that has core values like ownership and accountability. The last category we shall see is security. Automation increases consistency and predictability that reduces human errors. Now, let's have a look at our main topic, that is real-time scenarios. Before diving deep into the subject, let's understand what does real-time scenarios mean. Real-time scenarios refer to the problems, issues, or challenges that happen in our daily lives. In this section, we shall have a look at the ways how we can overcome such issues. We have divided the real-time scenarios into 4 subsections. First being the continuous integration scenarios, second is the continuous testing scenarios, then third comes the continuous delivery scenarios, and finally we have the DevOps scenarios. So let's begin with continuous integration scenarios. The first scenario in this section is continuous integration may decrease productivity. The problem here is that the product is made live as soon as the first working model is created. The project managers pay most of their attention to launching new features and ensuring that deadlines are met. There may be conditions that developer has to pause everything else and fix the bugs first. Now, let's have a look at the key points that could be done to solve this. There may be daily stand-ups with all the team members. Then, project managers must understand all the team members. It is really of great importance to have a proper roadmap for developers. And lastly, having continuous integration in the entire process is of utmost necessity. The second scenario in the continuous integration section is adopting a new way of testing. The challenge here is that the development process is slowed down when the project is tested at each and every step. There have to be more tests, which means in order to write more test cases, it will take more time. Then developers need to create the test cases that can be used in the testing process. Now, let's have a look at some key points about what could be done to curb this challenge. There must be a habit of writing test cases from the beginning of the test case. The team must know and understand that development along with testing makes a project robust. Then the third and the last scenario in this category is ignoring of error messages. The challenge here is that developers must not ignore error messages. These error messages must be read as they provide hints to developers to solve problems and challenges. If such messages are ignored, they may result in the wastage of money and resources. Now, let's have a look at some key points that could be taken to face this real-time problem. The first simple step is to send only crucial messages. Then, the developers in charge should only receive the relevant alerts, which means that it is not necessary for all the developers to receive messages for all the problems. The developers must receive messages for errors that particularly concern them. After the continuous integration scenarios, let's have a look at the continuous testing scenarios. If you are enjoying this video, don't forget to like the video and subscribe to our YouTube channel so you never miss an update from Simplilearn. In this section, the first real-time scenario we have is write requirement specifications. This scenario talks about the teams spending a lot of time and efforts on clarifying the requirement specifications. If a team is able to set the right requirements, then almost half of the project is already successful. So it is very important to have specific and accurate understanding of requirements, which helps in designing the test plans better. The scenario further states that the teams must adopt model-based testing and behavior-driven development techniques, and the adoption of such techniques will help generate the right test cases from the initial steps of each stage and help resolve the gaps more quickly. Then, the second scenario here is making of feedback loops. The scenario concerns the feedback loops at every stage. If there is no feedback at every stage of the development cycle, how will the testing be possible? The process of continuous testing is not possible without frequent feedback loops at every stage of the development cycle. For the automation of the testing process, visibility of test execution and results are of great importance. The next scenario in this continuous testing scenarios is the management of complexity. It states that continuous testing becomes more complex as it moves towards the production environment. The number of tests grow along with the complexity of the code. The tests are to be updated every time the phases are updated. This increases the overall time to run these tests, eventually delaying the release process. The solution of the problem is improved test orchestration. It provides the right amount of test coverage in shorter sprint cycles and enables teams to deliver confidently. The fourth and the last scenario that we shall see in this section is integration of pipeline. The most important and the basic thing needed for the implementation of continuous testing is the automated pipeline. To enable automation, it is necessary to integrate a pipeline. Then there is a term called pipeline orchestration that is based on understanding when to scale, how to analyze results, how to scale, why it works, and how it works.
Moving forth, let's have a look at our third subsection of real-time scenarios, that is the continuous delivery scenarios. The first scenario in this section is slow deployments and no standalone product. At times, the complexity increases to such a level where having uncertainty in terms of what to deploy, where and how is a normal thing. The old development process was time consuming, which led to slower deployment and delivery as well. But now, this is not the case. Continuous development is backed up by continuous integration followed by continuous delivery. Continuous integration with new features makes sure that a standalone product is delivered at completion. The second scenario here is monitoring of the product. Here, the challenge is to know what to monitor. As to know what to monitor is a difficult task. Sometimes, irrelevant data is produced. There may be times when the amount of messages received as a result of monitoring may be so much that it is difficult to analyze by the developer. Or sometimes they might be very less for the developer to figure out the bugs. So to know how much to monitor may be a challenge in itself. We must understand that monitoring the product after delivery is an essential process of development. And then also the process of bug fixing and product maintenance requires the right amount of monitor log. The third and the last scenario in this continuous delivery section is the missing of some dependencies. There might be cases when a build is out of date and some dependencies are missing. These missing dependencies can lead to the failure of the product. This may be costlier as maintenance is the more significant part of the development lifecycle. Hence, while deploying, it is important to make sure that the software is well tested and packed. Now, when we have covered our three subsections, let's have a look at our last section, that is DevOps scenarios. The first scenario is resolving problems. DevOps promotes transparency among different teams in an organization. The entire DevOps scenario brings the development team, operations team, and security team together and makes them collaborate with each other efficiently and effectively. Successful implementation of DevOps increases the speed of tracing problems, in turn increasing the chances of problems being fixed at an early stage. The second DevOps scenario is the simplification of business process. As DevOps brings the teams closer and there is a better definition to all the segments of the project, this makes the process simplified by reducing complex tasks into simpler processes. Therefore, the time taken to complete the process reduces extensively. Moving forth, the next real-time scenario is faster release cycles. DevOps drive development teams in the direction of continuous improvement and faster release cycles. This is how DevOps promotes faster release cycles along with continuous improvement. This process in turn provides more time to focus on some other factors that really matter. The reduced time plays an important role in providing better user experience. Here, the last DevOps scenario we shall see is deliver value to the customers. DevOps teams can focus on business activities as the deployment pipelines are automated. The culture reduces the time to deliver the value to the customers. One of the biggest focuses of the team is to create more customer value. DevOps activities increase the sustainable competitive advantage of a company and create better business outcomes.
Learning objectives. By the end of this lesson, you will be able to describe the importance of continuous integration and continuous deployment, list the features of Jenkins and demonstrate their uses, list the features of TeamCity and demonstrate their uses, and select a suitable tool for your organization. The overview and importance of continuous integration and continuous deployment. Overview of continuous integration. Continuous integration is a development practice of combining code from a number of different developers into a common code base intended for deployment. Each integration event is verified by automated build and automated tests. There are many aspects to a continuous integration, also known as CI, process. Continuous integration is a development practice of combining code from a number of different developers into a common code base intended for deployment. Each integration event is verified by automated build and automated tests. There are many aspects to a continuous integration, also known as CI, process. These are develop and compile code, perform unit tests, integrate code with various types of databases, perform pre-production deployment activities, for example, moving code to various types of computing environments, such as testing and staging. Also, part of a continuous integration process is to perform functional testing and apply labels against release points in the code repository. Additional activities in CI are to generate reports and analyze the code. Continuous integration is about combining code from each developer into a common deployment path automatically with a high degree of accuracy. Continuous integration is more than a developer just creating some code and committing it to a feature branch he or she is working on for automation to pick up and deploy. Instead, the developer needs to make sure that he or she writes unit tests that exercise each line of code written. The purpose of unit testing is to prove that the code that's written works to expectation. A standard feature of most shops that practice continuous integration is to have the process run all the unit tests in a developer's work branch before merging the code into a common code base. If the unit tests don't pass in the automated process, the developer's code is not merged into the common branch. Then, the developer is typically notified, either by email or by another communication channel, that there's a problem that needs to be corrected. Overview of continuous deployment. Continuous deployment is an extension of continuous integration. Its purpose is to reduce the time between a development team writing code and then using it in production. The benefits of continuous deployment are not only that it provides faster feedback from end users as each new feature is released to production, but it also realizes a faster return on investment for each feature as it gets developed. For the most part, continuous deployment is a highly automated process that reduces the need for human interaction in the deployment process. Scripts take over most of the work that used to be done by humans previously involved in the physical deployment of code. Not only does automation copy code from one computing environment to another, the scripts will actually create the computing environments that need to be in place before you can move the code along. Automation reduces the time it takes to get code from developer to end user and increases the accuracy of the code that's being produced. Continuous deployment makes sure that the right code is in the right place at the right time. Popular tools in continuous integration and continuous deployment. The more common CI/CD tools used in IT shops practicing DevOps are Jenkins, Travis CI, Bamboo, TeamCity, and Git Lab. Continuous integration with Jenkins. Jenkins is one of the more popular tools in the DevOps landscape. It's a powerful framework that supports a broad plugin ecosystem. Instead of having to write code on a line-by-line basis to extend the power of Jenkins, developers write custom plugins to add new functionality. These plugins are highly reusable, so much so that a whole marketplace has evolved around the product. There are now over 1,000 plugins available, and most of these are free. Also, Jenkins integrates with over 100 other DevOps tools such as GitHub and testing tools from a variety of vendors. Jenkins allows DevOps personnel to reliably orchestrate the release tool chain, and it's designed to be an end-to-end solution. In order to get full benefit from using Jenkins, aspiring DevOps personnel need to understand the standard phases in the CI/CD pipeline. These phases are code and commit, build and configure, scan and test, release, and deploy. You're going to incorporate a variety of tools with Jenkins during each phase of the process. During code and commit, developers use an integrated development environment, also known as an IDE, to create code. The popular ones are Visual Studio, Visual Studio Code, and Eclipse. And then they'll check the code into a version control system such as Git, GitHub, Perforce, or Mercurial. Some code might require binary dependencies that are stored in an artifact repository, such as Artifactory. After code is created and committed, it needs to be built. If the code requires compilation into a binary file such as a DLL, exe, or jar file, Jenkins will use a build system such as MS-Build, a C compiler, Maven for Java, or Ant for more general purposes. If the code needs to be containerized, you'll use Docker. Some IT shops will automatically create computing environments during build and configure in anticipation of impending code deployments. Tools such as Puppet, Chef, and Ansible can provision virtual machines automatically according to predefined configurations. During the scan and testing phase, you'll integrate Jenkins with testing tools such as JUnit, JMeter, Cucumber, or MS Test. Front-end testing can be conducted using Selenium, Appium, Sauce Lab, or Hewlett-Packard products. The purpose of scan and test is to make sure the code meets quality standards and is safe to move forward in the CI/CD process. The release phase is the last stage before code is released to users. You might integrate Jenkins with tools such as udeploy, Serena, Midvision, or XL Release. Finally, for deploy, you'll go on-premises to a cloud service or a hybrid combination of both a private on-premises cloud and a public cloud. For public cloud deployments, you'll target Amazon Web Services, Google Cloud, Azure, or IBM Cloud. Also, we're seeing cloud orchestration technologies such as Kubernetes take an increased presence as a release platform. For a private cloud, there's OpenStack. If you're working directly with virtual machines, you'll integrate Jenkins with VMware products or Docker. At a high level, in terms of application runtimes, you'll need something like the JBoss Java Virtual Machine or the WebSphere Application Server. Jenkins provides operational consistency in the various stages of release, regardless of the particular products you plan to use. Thus, you'll do well to keep these phases of deployment in mind as you continue on your journey to DevOps mastery. Continuous deployment with Jenkins. As you can see in the slide, continuous deployment, which we abbreviate as CD, consists of 5 operational stages. The first stage is coding, which is typically done on the developer's local workstation. The next stage is storage. During the storage phase, a developer commits his or her code to a source control management system such as Git, moving the code into a separate test computing environment, ensuring that the code is implemented in the best way possible, in addition to ensuring that the code works according to expectation so that it can be released to production, is done in the quality assurance and testing stages. Production is the final stage in the release process. Production is where the code is made available to end users. The value that Jenkins brings to the software development lifecycle is that it can be configured to automate every stage of the entire process. This is very important because it not only speeds up the software development process overall, but also increases the accuracy and reliability of the code under development. Companies such as LinkedIn, Google, and Facebook have made continuous deployment a fundamental part of the way they make software. It's only by using an automation tool such as Jenkins that effective continuous deployment is possible. Doing deployment manually is time-consuming and costly. Those who adhere to the principles of DevOps understand that continuous deployment is an essential part of the practice of software development in the modern enterprise, and automation is key to the practice. Continuous integration with TeamCity. TeamCity is a free continuous integration tool from JetBrains. The company is best known for its integrated development environments for writing software. The abbreviation for integrated development environment is IDE. TeamCity is a complete continuous deployment, continuous integration system designed to automatically manage all aspects of the software development lifecycle. TeamCity is designed to integrate with all the popular products used in modern software development. It integrates well with the standard web browsers. As we've learned previously, communication among and between teams is important. Thus, TeamCity can be configured to send out notifications using email, RSS, chat tools, and social media platforms such as Slack. It supports version control by integrating with source control management systems such as Git, Subversion, Perforce, as well as many others. TeamCity supports all the build tools and development frameworks commonly found in the enterprise, such as Ant, Maven, MS Build, and Grunt. Also, TeamCity can be integrated with popular IDEs such as Eclipse, the various JetBrains tools such as IntelliJ, WebStorm, and PyCharm. TeamCity also integrates easily with the industry standard for developing Microsoft technologies, Visual Studio and Visual Studio Code. Continuous deployment with TeamCity. A good way to understand the workflow that TeamCity is designed to manage by way of automation is to conceptualize the software development process as having three areas of activity: artifact, deployment, and operations. Let's take a look at each area in detail. Artifact activity is about managing the various code components that make up a software system. Some shops use the term deployment unit to describe the distinct component of code that needs to be released into production. Other shops use the term deployment artifact. Some of these components might be a binary file such as Java or a jar file, or in .NET shops the artifacts can be an exe or a DLL file. Linux doesn't have the concept of file extension-based executables. Thus, any file can be an executable. You just need to have the right permission set. The important thing to understand about the artifact area is that it's about creating and managing deployment units that will be released to production. Deployment. Once an artifact or a collection of artifacts are ready for release, they need to go through a company's deployment process. There are a number of tools and processes associated with deployment activity. The ultimate goal of the deployment activity is to make sure that working, valuable software gets to the customer as quickly as possible. Typically, companies will use a ticketing system to control and monitor the work that needs to be done in deployment. Artifacts will be prepared for deployment. Computing instances will be provisioned. Sometimes the provisioning might involve creating virtual computing instances, such as a virtual machine or a container. Other times it might require installing physical hardware, such as computers and networking devices. Then, after provisioning is complete, the deployment artifacts are configured and pushed into relevant computing environments. And finally, we get to operations. It's important to understand that a comprehensive CI/CD system such as TeamCity goes beyond just deployment activity. TeamCity will also automate a lot of operations activity. Release personnel can use TeamCity features to orchestrate computing environments and monitor activity in those environments. Also, it coordinates important aspects of enterprise-level DevOps, such as logging and aggregating security alerts. Security is a critical aspect of any enterprise's operation and is of particular concern to any DevOps practitioner working within the enterprise. Overview and features of Jenkins. Jenkins as a continuous integration tool. Jenkins is a Java-based open-source automation tool. It functions as a server and is a software development and cross-platform tool used for continuous integration and continuous deployment. Let's look at what Jenkins can do. As a continuous integration server, it can be used as a CI server or a continuous delivery hub for a project. In terms of distribution, it can easily distribute work across different machines and help trigger builds, tests, and deployments to multiple machines and platforms quickly. Jenkins is designed to work cross-platform. It allows programming in software development environments such as iOS, .NET, Android, Ruby, and Java. Architecture of Jenkins. Jenkins is a comprehensive CI/CD framework that is designed to be flexible and extensible. It has a distinct object model that has classes like project and build. These classes describe the various components of the framework. It uses Jelly as the view technology. It uses the file system to store its data. Directories are created at the location on disk defined by the environmental variable Jenkins_home. It supports plugins which are plugged into those extension points and extend the capabilities of Jenkins. Popular features of Jenkins. Let's take a look at the features. 1. Jenkins is platform independent. 2. It has a rich plugin system. 3. It has the support of a large community of third-party developers and expert users. 4. It's designed to scale to meet the needs of the large enterprise. 5. Its automation capabilities enable immediate detection and resolution of issues. 6. It's open source and user-friendly. And 7. It's easy to configure, modify, and extend. Build status and job health. Every time a Jenkins job runs, the status of the build gets reported. The figure on the left side of the slide shows the results of a few runs of a build project. Notice that the result of each build is reported. Sometimes the build succeeds. Other times it fails. If an administrator aborts or disables the build, that gets reported too. The figure on the right side of the slide provides a description of the overall health of the project according to many builds. Assisted practice. Set up Jenkins. Let's take a look at the assisted practice. You are given a project to install and configure Jenkins on the Ubuntu operating system of your Learning Lab virtual machine. Lab 3.1. Installing and configuring Jenkins. In this demo, we're going to describe 3 steps to install and configure Jenkins. First, we're going to modify the file sources.list. Then we're going to use apt-get to install the Jenkins package. And then finally, we're going to run Jenkins in the browser. So let's get started. First, at the command line, we type make_dir lab 3.1. Then, at the command line, we type cd lab 3.1 to navigate into the directory we've just created. Now, we need to add the key from the Jenkins package repository into our local environment. At the command line, we type wget-q-o https://package.jenkins.io/debian-stable/jenkins.io-key pipe sudo apt-key add dash, and this will add the key directly into the apt-get file system. Now we need to update the file sources.list. We'll use the Vi editor that's already installed in your classroom virtual machine. At the command line, we type sudo space vi space /etc/apt/sources.list. Sources.list is the file that apt-get uses to locate package repositories on the internet. We strike the I key on the keyboard to put vi into insert mode. We scroll down to an empty space in vi and type deb https://pkg.jenkins.io/debian-stable space binary /. Then we hit the escape key to get out of insert mode and type :W for write, Q to quit vi. Now we have to update the package manager. At the command line, we type sudo apt-get space update. Update executes. Once we see the line reading package lists ... done, the update is complete. Now we need to see if Java is installed, and if not, we need to install it. At the command line, we type java space -version. As you can see, Java and the Java Development Kit is already installed. If Java was not installed, you would type sudo space apt-get space install space openjdk-7-jre. This command will execute apt-get to install the OpenJDK package. Now we install Jenkins. Type sudo space apt-get space install space Jenkins. Strike the Y key to confirm installation. The installation process will take a few seconds. Now we're going to open the initial installation of Jenkins in a browser. We go back to the virtual machine desktop. In this case, we'll load the Firefox browser. We're going to enter the IP address of the Jenkins installation. The IP address was assigned to the virtual machine earlier. In the address bar of the Firefox browser, we enter the IP address 172.31.26.234:8080. 8080 is the port where the Jenkins server is running. Please be advised, the IP address of your virtual machine will be different, and the way you can discover the IP address is at the command line, type ifconfig. The IP address of your virtual machine will be in the information displayed. The first screen we're shown is the Unlock Jenkins screen. We're going to need to enter the administrator password in order to continue. As you can see in the red type, the location of the password is a file /var/lib/jenkins/secrets/initial-admin-password, where initial-admin-password is the name of the file that contains the password. We return to the terminal. We type clear to clear the screen. At the command line, we type sudo space cat space /var/lib/jenkins/secrets/initial-admin-password. We strike the Enter key to display the password. We highlight the password in the terminal and then copy it by right-clicking on the mouse and selecting Copy. We return to the browser and paste the password into the administrator password text box. Then we click the Continue button. Firefox will offer to save the password, but we'll click Don't Save. We have the option to install suggested plugins, or we can select specific plugins to install. We're going to go with the Install Suggested Plugins method. We click the box labeled Install Suggested Plugins. The Getting Started page appears and the plugin installation continues. Once downloading and installing the plugins is complete, you'll be presented with the Create First Admin User page. At this point, we've successfully installed Jenkins. Now, the next steps will be to create the admin user by putting in a username, password, confirmation of password, a full name for the user, and the user's email address. Let's recap the important steps. Assisted practice, guidelines to install and configure Jenkins. Log in to your Ubuntu Lab provided with the course. Open the terminal and execute the command available in the lab document 3.1 to add the key to the system. Edit the sources.list file and add the command to the file and then save it. Update the apt-get package. Install JDK 8+ version. Install Jenkins using apt-get package. Navigate to the IP address of the machine denoted as x.x.x.x:8080 in the browser of your virtual machine. Get the password and enter it into the Jenkins window. Create a new role job in Jenkins. Explore the Freestyle project and build section. Overview and the features of TeamCity. TeamCity as a continuous integration tool. TeamCity is a Java-based management and continuous integration server. It's licensed commercial software that's used for continuous integration and continuous deployment. TeamCity supports a number of features that are important to the continuous integration process. For example, gated commits ensure only working code is committed to deployment branches in source control. TeamCity supports integration with various integrated development environments, such as Eclipse and IntelliJ. It has a build grid that describes build activity. Also, it has cross-platform support for a variety of operating systems and programming languages. Also, TeamCity has seamless code integration. TeamCity Workflow. TeamCity supports the CI/CD process that has become the standard workflow for many companies and software development shops. Let's take a look at the overall workflow. As you can see in the slide at point 1, the first step is that a developer or tester checks code in to the source control management system. Upon commit at point 2, a build trigger message is sent to the TeamCity server. Then, at point 3, TeamCity works with system unit testing to start the system unit testing automation process. If the code passes the test, artifact building, archiving, and deployment tasks are performed in an automated manner at point 4. TeamCity reports the status of all the activities at point 5. Popular features of TeamCity. TeamCity has many features that make the CI/CD process more efficient. Let's take a look at the features. TeamCity has pre-tested commit, instant notifications, it has code coverage and monitoring capabilities, it provides a comprehensive build infrastructure, and it has enhanced version control system integration. TeamCity makes it easy to verify code, and it offers configurable test reports. And finally, TeamCity supports managing users and roles. Assisted practice. Set up TeamCity. Now it's time to do an assisted practice to set up TeamCity. You're going to be given a project to install and configure TeamCity on the Ubuntu operating system in your Learning Lab virtual machine. So let's get started with Lab 3.2, Install and Configure TeamCity. First, we create a directory for the work. We type mkdir lab 3.2. Then we navigate to that directory by typing cd space lab 3.2. First, we're going to download the compressed GZ file for TeamCity. Then we're going to extract the files from the compressed file. We're going to move the extracted directory that contains the files into another location. We're going to start up TeamCity. And then we're going to go to the browser and register a user with TeamCity. Let's download TeamCity. We go to the desktop of our classroom virtual machine, and then we click on the icon for Google Chrome. Chrome appears. In the Chrome address bar, we type www.jetbrains.com/teamcity/download. We click the download button. The GZ file downloads and the thank you page appears. We return to the terminal. At the command line, we type cd space /home/Ubuntu/capital downloads/. We strike the enter key. This takes us to the directory where the GZ file has been downloaded. At the command line, we type ls to confirm that the GZ file is indeed in the directory. Notice the file teamcity-2018.2.1.tar.gz is listed. Now we need to extract the files. At the command line, we type tar space zxvf space teamcity-2018.2.1.tar.gz, and we hit the enter key. This will extract all the files into a directory named TeamCity. Now we need to move the directory TeamCity into the directory /opt/JetBrains. We create a directory by typing sudo space mkdir space /opt/JetBrains. Now we need to move the directory TeamCity into the directory /opt/JetBrains. At the command line, we type sudo space mv space teamcity space /opt/JetBrains/teamcity. We strike the enter key. Now we need to give full read, write, and execute permissions to the files in the newly created directory TeamCity. At the command line, we type cd space /opt/JetBrains. We strike the enter key. Then we type chmod space --R777 teamcity /. This says to give all rights to the directory and the contents of the directory TeamCity. We type ls just to make sure the directory TeamCity is indeed there. We type cd space teamcity / and hit the Enter key to enter the directory teamcity. Then we type ls to take a look at the contents of the directory teamcity. Notice there is a bin directory. We navigate into the bin directory by typing cd space bin and hit the Enter key. Let's clear the screen to make things easier to see. To invoke teamcity, we will execute the bash file /teamcity-server.sh space start. It's very important that you use the / characters. We hit the Enter key and teamcity starts up, spawning teamcity and then teamcity restarter running with PID 11618. And the PID, the process identifier, will vary according to systems. Now teamcity is running. We go back to the browser, but before we do, take notice of the IP address of the virtual machine, which is shown on the command line on the left-hand side. The IP address of this virtual machine is 172.31.26.234. In the address bar of the Chrome browser, we type 172.31.26.234:8111, which is the port on the IP address where teamcity is running. The teamcity first start web page appears. We click the Proceed button. The teamcity is starting page appears. Then we see the database connection setup page. teamcity allows you to choose from a variety of databases. We can use Postgres, MySQL, Oracle, or MS SQL Server. We're going to use the internal database. teamcity creates the database and initializes its server components. This phase of the setup can take a few minutes. The page will reload automatically once teamcity is through installing its server components. We're almost done with teamcity's installation process. Then all we'll need to do is to create an account in teamcity. When the installation process is complete, we'll be presented with the licensing agreement that we have to agree to. We scroll to the end of the terms and conditions. We click the checkbox for Accept License Agreement. We're going to uncheck Send Anonymous Usage Statistics. Then we'll click the Continue button. The web page Create Administrator Account appears. We enter the username Simplilearn. Then we add a password and confirm the password. Finally, we click the button Create Account. We'll also save the username and password information in Google Chrome. Upon successfully entering a username and password, we'll be presented with the My Settings and Tools web page in teamcity. The page allows us to access projects and changes and agents, as well as build queues. In the next demo, we'll look at more details. Let's recap the important steps. Guidelines to install and configure TeamCity. Number 1, log in to your Ubuntu lab provided with the course. Number 2, download TeamCity from the official site. 3, unzip the folder and install TeamCity. 4, provide the read, write, and execute mode access to TeamCity. Number 5, run TeamCity at x.x.x.x:8111, where x.x.x.x is the IP address of your local machine, or the machine where the server is running. 6, create an account in TeamCity and add the basic details to complete the setup process. 7, explore options such as projects, changes, agents, and build queue. Build tools and their uses. Build tools. Build tools are programs that automate the creation of applications from source code. Automation tools allow the build process to be more consistent. Some common build tools are Make, Bash, which ships with Linux, Ant, Apache Maven for Java, Grunt, and Gulp. Popular features of build tools. Well, we can start with compiling to binary code for languages such as C# and Java. Build tools will package a compiled program for deployment. Also, it will run automated test cases against the code. The build tool will deploy artifacts to production and will also generate documents for developers to use for later reference. And finally, a build tool will generate release notes. An overview of Apache Ant. Apache Ant is a Java library and command line tool. Its aim is to provide processes described in build files as targets and extension points dependent on each other. Let's take a look at some of the distinct features. Apache Ant supplies a number of built-in tasks that allow it to compile, test, and run code. It's flexible and does not impose coding conventions. It builds solutions by combining build tools and dependencies with Apache Ivy. It solves Make's portability problem. And users can develop custom Ant libs using Java. And finally, you can use Ant to pilot any type of process. The limitations of Apache Ant. In Apache Ant, there are a few limitations. Some of the limitations are, number 1, configuration error checking is limited. Undefined properties are not raised as errors, but are left as unexpanded references. Number 2, Ant has limited fault handling rules. Lazy property evaluation is not supported. Thus, you need to be very exact when configuring Ant. It is not a forgiving environment. Number 3, older tasks use default values, which are not consistent and can cause problems. You need to pay attention. Changing defaults can break existing Ant scripts. And finally, number 4, Ant build files are complex and verbose, as they are hierarchical and partly ordered. An overview of Maven. Apache Maven is a comprehensive software project management tool. Based on the project object model, also known as the POM, Maven can manage a project's build, reporting, and documentation from a central XML file. Let's take a look at the key points of Maven. Number 1 is backward compatibility and auto-parent versioning. The hierarchical structure of the POM XML file reduces the burden on version control and reconciliation of dependencies. Number 2, Maven supports model-based builds. Number 3, Maven supports parallel builds and better error integrity reporting. You can kick off a number of project builds that run asynchronously. Number 4, release management and distribution publication is built into Maven. The project object model is comprehensive and covers all aspects of the software development lifecycle, from development through testing and on to release. Number 5, instant access to the latest features with less or no additional configuration. Maven allows artifact version control that can be set to get the latest release of a dependency. Thus, you can make sure the code is always up to date. 6. Large and growing repositories. There is a complete ecosystem of Maven artifact repositories that make it so you have access to popular components automatically. The Maven repository, found at https://mavenrepository.com, is a popular one. Also, a company can set up its own private repository. The drawbacks of Maven. Maven does have some drawbacks. Number 1, unable to depend on outcome status. Maven builds can fail, leaving nothing behind other than error messages that can be very hard to understand. Number 2, Maven is verbose and complex. It does take a while to master the details of the platform. Number 3, slow and partial black box. Maven does a lot of things automatically, and sometimes these black box activities can be very opaque. And finally, number 4, Maven can be unreliable when integrated for use within the Eclipse IDE. Comparing Maven over Ant. Well, Maven has better dependency management. It provides more powerful builds. There's better collaboration, and the debugging capabilities are a bit better than Ant. There's more componentization in the builds, and there's reduced duplication. And finally, the POM provides a more consistent project structure. The Project Object Model, also known as the POM. The Project Object Model is an XML representation of a Maven project. It provides general configuration information, such as a project's name, its owner, and its dependencies on other projects. The XML excerpt in the slide shows a rudimentary implementation of Maven's Project Object Model. The POM XML needs to define the group ID, the artifact ID, and version. The packaging needs to be declared too. The default deployment package is a jar. The project described in the XML file in the slide has an artifact ID of calculator. You can think of the artifact ID as the name of the artifact that's going to be created. The POM shows a version of 1.0 and it belongs to the group with the identifier EU.TotalEclipse. You can think of the group ID as a way a company organizes a number of artifacts under a common name. Overview of Grunt. Grunt is a JavaScript-based task runner which is used to automate repetitive tasks in a workflow. It can be used as a command line tool for JavaScript objects. Let's take a look at some of the key points to understand about Grunt. In Grunt, developers write Grunt setup files to ease workflow. Thus, Grunt speeds up the development flow and enhances performance. It helps with the automation of repetitive tasks with less effort. It supports a small infrastructure which is a best fit for new code bases. Grunt minifies files such as HTML and CSS, thus reducing the potential problems with network latency. Grunt aims at reducing the chances of errors during repetitive tasks, and it includes built-in tasks to extend functionality of plugins. Currently, Grunt has over 4,000 plugins and can be used in large production sites. An overview of Gulp. Gulp is an open-source JavaScript toolkit used as a build system in front-end web development. It automates time-consuming and repetitive tasks involved in development. Some of the key features of Grunt are code minification and concatenation, usage of pure JavaScript code. Grunt converts files created under less or SAS in a CSS compilation process. Less, which stands for Linear Style Sheets, is a dynamic preprocessor style sheet language that can be compiled into cascading style sheets, also known as CSS. And these style sheets are run on the client side or the server side. Sass is a preprocessor scripting language that is interpreted or compiled into cascading style sheets. Grunt also manages file manipulation in memory. Some of the advantages of Grunt are that it's easy to code, it's easy to test with web apps, and the plugins are simple to use. Some of the disadvantages of Grunt are there's more than the usual number of dependencies, multiple tasks cannot be performed in parallel, and configuration can become tedious. Assisted practice, continuous integration with Jenkins and Maven. You are given a project to configure in Jenkins. You need to make Jenkins poll get commits and build the project code using Maven on the Ubuntu operating system on your practice lab VM. Okay, so let's get started with Lab 3.3, continuous integration with Jenkins, Git, and Maven. In this lab, we're going to configure Jenkins to support Git and Maven. Then we're going to configure a Maven project. And then finally, we're going to build the Maven project using source code from Git. So in a web browser, we open Jenkins, and what we do in our classroom virtual machine is we go to the IP address, and in this case it's 172.31.206.234:8080, and Jenkins typically runs by default installation. We click the new item link, which is on the upper left of the Jenkins web page. The new item web page appears. In the new project text box, we enter the project name, in this case, Java Maven. Then we select Freestyle Project, then scroll down the web page and click the OK button on the left-hand side. The web page for the newly created project loads. We add text to the description text box. This is a simple project to test Jenkins. We go to the menu bar at the top of the project's web page and we click the Build tab. We're taken to the Build section of the web page. We click the Add Build Step button to display a drop-down of options. From that drop-down list, we select the item Execute Shell. In the command text box, we enter the Linux command echo space quotation mark hello space from space Jenkins quotation. We click the Save button on the lower left. Now we'll do a test build to make sure everything's working all right. On the left-hand side of the project web page, we click the link Build Now. The build starts, and when it completes, you'll see a blue circular icon in the Build History section of the project web page on the left side. And you can see there's a build there, and it's labeled number 1. To the right of build number 1 is a drop-down arrow, which we click to get a list of options, and we select Console Output. Selecting Console Output will display in the web page the build log activity. Notice there's a line that says Hello Jenkins. This is from the echo command we entered in the Jenkins build configuration. Let's develop the project a little more. What we need to do is to add Git integration and get the project to work with Maven. We go to the Simplilearn site on GitHub, and that's Simplilearn DevOps Official. And we go to the repository Java Maven App. On the GitHub site, we click the green Clone or Download button to display the URL that we can use to access the Java Maven App repository on GitHub. So we highlight the URL and copy it. We go back to the Jenkins web page. In the Jenkins web page, on the menu bar, we click the tab for the Java Maven project. the Java Maven project appears. On the left side of the project's web page, we click the Configure hyperlink. This loads the project's configuration page, in which we click the Source Code Management tab. We're navigated to the Source Code Management section of the configuration page. There, we click the option Git. We paste the URL of our Simplilearn Java Maven app repository into the text box Repository URL. Entering a valid URL will make the error message, "Please enter Get Repository," disappear. We're going to select some predefined credentials from the Credentials dropdown. We added those earlier, but if you need to add credentials in the future, simply click the Add button and then select Jenkins. Now, if you're using your own GitHub repository, you'll be presented with the Jenkins Credentials Provider dialog. You're going to need to enter your username and also your password. Once we configure access to the Get repository, we click the Save button. Now, what we've done is we've effectively given Jenkins the right to access our GitHub account using our credentials. In other words, Jenkins is impersonating us. After we save the Git configuration, we'll be brought back to the projects page. We need to go back to Jenkins Home. We click the Jenkins tab on the upper left of the project page. This takes us back to the main Jenkins dashboard page, which we can think of as Home. Now, we click Manage Jenkins on the left side of the Jenkins home page. On the Manage Jenkins page, we select Global Tool Configuration. The Global Tool Configuration page appears. We scroll down to the Maven section of the Global Tool Configuration page. We click on the button Add Maven to add a Maven configuration. We're going to give this installation a name, and we're going to call it Local Maven. Then Maven needs to know where its home is on the classroom virtual machine. In the text box labeled Maven_home, we enter the value /usr/share/maven. An alternative method is to again click on Add Maven, add a name, this time Maven, and then from the Install from Apache dropdown, select the version of Maven that's on the machine. We've now let Jenkins know about Maven, so we can click the Save button. We return to the Manage Jenkins page. We need to return to the project. In the upper left-hand corner of the Manage Jenkins page, we click the Jenkins button. We're brought back to the Jenkins main dashboard. You can see Java Maven in the list of projects on the main dashboard. When we hover over Java Maven, we'll see a down arrow. We click that down arrow and some options appear. We select Configure from the Options dropdown. The Java Maven project's configuration page appears. We click the Build tab in the menu bar. You can see the echo command that we created previously in the Build section. We want to get rid of it. So what we're going to do is we're going to go to the right side of the Execute Shell section and click the red button with the X label. Clicking the red button deletes the Execute Shell command, echo, from the Build section. Now we want to add a new build step. We click the Add Build Step button and we notice that another dropdown appears. From that dropdown we select Invoke Top-Level Maven Targets. After we add the Maven build task, we'll be presented with a Maven version dropdown. This will contain the Maven configurations we created previously. we select one of the configurations. In this case, we'll select Maven. Let's recap the important steps. Assisted practice, guidelines to configure Jenkins and Maven. Number 1, log in to Ubuntu Lab provided with the course. Number 2, log into Jenkins and create the first Jenkins job. Number 3, install and configure Maven. Number 4, configure Jenkins with Java, Git, and Maven. Number 5, create a Jenkins job for your Maven build project and run the project. Number 6, poll Git for commits and automatically trigger the build. Number 7, build a trigger using the push mechanism instead of pull. Number 8, repeat steps 6 and 7 multiple times to observe the results in the console output section.
Welcome everyone to another topic on CI/CD pipeline using Jenkins. Now in this one we are going to talk about that how exactly we can go for a CI/CD implementation with a pipeline concept, and that too with the help of Jenkins tool. So let's talk about what exactly we are going to talk about. Now first of all, we are going to talk about like what exactly is the DevOps process, and then we are going to talk about like what is the importance of CI/CD pipeline. Then we are going to take care of a kind of a sample pipeline which is there, a kind of a building a CI/CD pipeline with the help of Jenkins here. And in the end we are going to see a small demo on how we can do this setup so that we can have some particular pipeline processed and executed and processed all together. So let's talk about the different things one by one. Now the first one is that what exactly is in DevOps here. Now DevOps is basically a combination of two practices, like that is the development and operations. So development is having their own task of doing the development and preparing the source code, and operation is responsible for deploying the source code to a specific environment, whether it's a production or any other environment. So they take care of all those tasks, creating the virtual machines, managing, performing the patching, and number of tasks is there from the operations perspective. Now development is something which keeps on working on the source code there on the development, and they are responsible for keeping a particular product up and running. So they do the performance, they they do the coding, they do the particular interaction with the testing to validate their source code. A huge number of activities is actually done by the development team, and they eventually uses a number of tools like scripting tools, coding tools, development tools. A lot of tools they basically use to support their development, because they are performing different kind of programming. It could be a possibility that more than one programming language is being used for your project. So that's kind of wider scope is present as such over here when we talk about the DevOps here. Now from the operations perspective, it's basically a team which is responsible for managing the workforce, right? And it's something which we can use to see that all the daily activities and operations should be managed effectively and efficient. So that's the main important point over here, that whenever we are working with the operations, whenever we are working on that, we should be able to get a kind of a decent amount of work and decent amount of activities managed with the help of operations teams here. So operation teams is pretty much responsible for keeping the environment up and running, and whatever the activities and maintenance work we want to do, we will be able to do on that. Now DevOps really helps us to achieve a lot of milestones over here. Now let's talk about that one by one. So very first one of that is that it helps us to get a frequent release of deliveries here. Now we were doing the releases prior to DevOps also, but that was not that much frequent. Probably people were doing like every quarter, every 3 months, 4 months. That kind of time duration was being used by the team to deliver the source code or deliver into a specific environment. But the moment the specific DevOps comes into the picture, the frequency of this release really increased a lot. So some organization in fact trying to do like every month release, twice a month. So that's the kind of frequency which we are getting when we move on to the DevOps. So that really helped and got efficient with the introduction of DevOps here. Now second one is the team collaboration. Now that is also improved drastically, because earlier the operations and the development teams were not working in that collaboration. They were like working involved in their own task, but with the help of DevOps, they really come along and had a very good team collaborations, which really helps them to increase the overall productivity and the performance of the product. So these are the prime milestones which we achieve with the implementation of DevOps as such into our project. Another one is that it helps to get a kind of a better management here. So effective and efficient management is what we get with the help of DevOps, because ultimately you have redefined your processes, you have implemented certain development tools, certain automations, and that really helps you to increase the overall management of all your unplanned work. So the planning is something which got really improved with the help of DevOps. And faster resolution of issues, because the way you are delivering your source code to the production environment, you are pretty much doing it into a less duration of time. And when that is happening, definitely there is a kind of a increase in the number of bugs which is getting resolved. And there is another benefit that ultimately the number of bugs which you are getting in production, that drastically reduced in case of DevOps. So since we are getting less number of issues and bugs, it's very easy for us to do the resolutions quite quickly and implement into a specific production environment. Right? So DevOps today is being implemented by most of the major organizations, whether it's a financial organization, whether it's a kind of a service organization. Every organization is somehow looking forward for the implementation and the adaptation of DevOps, because it totally redefines and automate the whole development process altogether, and whatever the manual efforts you were putting earlier, that is simply or gets automated with the help of these tools here. So this is something which get really implemented because of some of the important feature like a CI/CD pipeline, because CI/CD pipeline is responsible for delivering your source code into the production environment in less duration of time. So CI/CD pipeline is ultimately the goal, which really helps us to deliver more into the production environment when we talk about from this perspective. Now let's talk about that. What exactly is a CI/CD pipeline? Now, when we go into that part, when we go into that understanding, so CI/CD pipeline is basically continuous integration and continuous delivery concept, which is used or which is considered as a backbone of the overall DevOps approach. Now, it's one of the prime approach which we implement when we are going for a DevOps implementation for our project. So if I have to go for a DevOps implementation, the very first and the minimum implementation and the automation which I'm looking forward is actually from the particular CI/CD pipelines here. So CI/CD pipelines is really a wonderful option when we talk about the DevOps here. So what exactly is the pipeline term all about? So pipeline is a series of events that are connected together with each other. It's kind of a sequence of the various steps, like typically when we talk about any kind of deployment, so we have like build process, like we compile the source code, we generate the artifacts, we do the testing, and then we deploy to a specific environment. All these various steps which we used to do it like manually, that is something which we can do it into a pipeline. So pipeline is nothing but a sequence of all these steps interconnected with each other, executed one by one into a particular sequence. Now, the pipelines is responsible for performing a variety of tasks, like building up the source code, running the test cases. Probably the deployment can also be added up when we go for the continuous integration and continuous delivery there. So all these steps are being done into a sequence, definitely, because sequence is very important when we talk about the pipeline. So you need to talk about the sequence the same way in which you are working on the development, and in a typical world, the same thing you will be putting up into a specific pipeline. So that's a very important aspect to be considered. Now let's talk about what is the continuous integration here. Now continuous integration is also known as the CI. Pretty much you can see that a lot of tools are actually named as CI, but they are referring to the continuous integration only. So continuous integration is a practice that integrates the source code into a shared repository, and it used to automate the verification of the source code. So it involves the build automations, test cases automation. So it also helps us to detect the issues and the bugs quite easily and quite faster. That's a very early mechanism which we can do as such if we want to resolve all these problems. Now continuous integrations does not eliminate the bugs, but yes, it definitely helps them easily to find out, because we are talking about the automated process, we are talking about the automated test cases. So definitely that is something which can help us to find out the bugs and then the development can help on that, and they can proceed with those bugs, and they can try to resolve those things one by one. So it's not a kind of automated process which will eventually remove the bugs is something which you have to recode and you have to fix it by following the development practice. But yes, it can really help us to find those bugs quite easy and help them to remove. Now, what is the continuous delivery here? So continuous delivery, also known as CD, is a kind of a phase in which the changes are made into the code before the deployment. Now, in this case, what happens that it's something which we are discussing, or we are validating that what exactly we want to deliver it to the customer. So what exactly we are going ahead, or we are moving to the customer. So that's what we typically do in case of continuous delivery. And the ultimate goal of the pipeline is to make the deployments. That's the end result, because coding is not the only thing. You code the programs, you do the development. After that, it's all about the deployments, like how you're going to perform the deployment. So that is a very important aspect. You want to go ahead with the deployments, that's it, you can go there. And that's a real beauty about this, because it's in kind of a way in which we can identify that how the deployments can be done or can be executed as such here. Right. So the ultimate goal for the pipeline is nothing but to do the deployments and to proceed further on that. Right. So when both these practices are placed in together in an order, so all the steps could be referred as a complete automated process, and this process is known as CI/CD. So when we are talking about, like, when we are working on this automation, so in that case, what happens that we are looking forward that how the automation needs to be done. And since it's in kind of a CI/CD automation which we are talking about, so it's nothing but the end result would be like build and deployment automation. So you will be taking care of both the build and the test case executions and the deployments as such when we talk about as such the CI/CD here. The implementation of CI/CD also enables the team to do the build and deploys quite quickly and efficiently, because these are things which is happening automatically, so there is no manual efforts involved, and there is no scope of human error also. So we have frequently seen that while doing the deployments we may miss some binaries or some miss can be there. So that is something which is completely removed as such when we talk about this. The process makes the teams more agile, productive, and the confident here, because the automations definitely gives a kind of a boost to the confidence that yes, things are going to work perfectly fine and there is no issues as such present. Now, why exactly Jenkins? Like, Jenkins is what we typically understand, or we here and there, that it's a CI tool, it's a CD tool. So what exactly is Jenkins all about? So Jenkins is also known as a kind of orchestration tool. It's an automated tool which is there, and the best part is that it's completely open source. Yes, there are some particular paid or the enterprise tools are there, like CloudBees and all, but there is no as such offering difference between the CloudBees and the Jenkins here. So Jenkins is a kind of open source tool which a lot of organizations pretty much implement as it is itself. So even if they don't want to go, we have seen in a lot of big organizations where they are not going for the enterprise tool like CloudBees and all, and they are going for the pretty much core Jenkins software as such here. So this tool makes it easy for the developers to integrate the changes to the project. That is something which is very important, because it can really help the teams to say that how the things can be done and how it can be performed over there. So the tools is very easy for the developers to integrate, and that's the biggest benefit which we are getting when we talk about these tools as such. So Jenkins is a very important tool to be considered when we talk about all these automations. Now, Jenkins achieves continuous integration with the help of plugins. That is also a kind of another feature or benefit which we get, because there are so many plugins which is available there as such, which is being used. And for example, you want to have an integration with Kubernetes, Docker and all. Maybe by default those plugins are not installed, but yes, you have the provisioning that you can go for the installation of those plugins, and yes, those features will start embedded up and integrated within your Jenkins. So this is the reason, this is the main benefit which we get when we talk about the Jenkins implementation. So Jenkins is one of the best fit which is there for building a CI/CD pipeline, because of its flexibility, open source nature, plugin capabilities, the support for plugins, and it's quite easy to use, and it's very simple, straightforward GUI which is there, which can definitely helps us. You can easily understand and go through the Jenkins, and you can grab the understanding, and as an end result you will be able to have a very robust tool using which pretty much any kind of source code or any kind of programming language you can implement CI/CD. Whether it's an Android, it's a .NET, it's a Java, it's a Node.js, all the languages are having the support for the Jenkins. So let's talk about the CI/CD pipeline with the Jenkins here. Now, to automate the entire development process, a CI/CD pipeline is the ultimate Jenkins all about. So Jenkins is also known as a kind of orchestration tool. It's an automated tool which is there, and the best part is that it's completely open source. Yes, there are some particular paid or the enterprise tools are there like CloudBees and all, but there is no as such offering difference between the CloudBees and the Jenkins here. So Jenkins is a kind of open source tool which a lot of organizations pretty much implement as it is itself. So even if they don't want to go, we have seen in a lot of big organizations where they are not going for the enterprise tool like CloudBees and all, and they are going for the pretty much core Jenkins software as such here. So this tool makes it easy for the developers to integrate the changes to the project. That is something which is very important because it can really help the teams to say that how the things can be done and how it can be performed over there. So the tools is very easy for the developers to integrate, and that's the biggest benefit which we are getting when we talk about these tools as such. So Jenkins is a very important tool to be considered when we talk about all these automations. Now, Jenkins achieves continuous integration with the help of plugins. That is also a kind of another feature or benefit which we get, because there are so many plugins which is available there as such, which is being used. And for example, you want to have an integration with Kubernetes, Docker and all. Maybe by default those plugins are not installed, but yes, you have the provisioning that you can go for the installation of those plugins, and yes, those features will start embedded up and integrated within your Jenkins. So this is the reason, this is the main benefit which we get when we talk about the Jenkins implementation. So Jenkins is one of the best fit which is there for building a CI/CD pipeline because of its flexibility, open source nature, plugin capabilities, the support for plugins, and it's quite easy to use, and it's very simple, straightforward GUI which is there, which can definitely helps us. You can easily understand and go through the Jenkins, and you can grab the understanding, and as an end result you will be able to have a very robust tool using which pretty much any kind of source code or any kind of programming language you can implement CI/CD. Whether it's an Android, it's a .NET, it's a Java, it's a Node.js, all the languages are having the support for the Jenkins. So let's talk about the CI/CD pipeline with the Jenkins here. Now, to automate the entire development process, a CI/CD pipeline is the ultimate solution which we are looking forward. To build such a pipeline, Jenkins is our best solution and best fit which is available here. So there are pretty much 6 steps which is involved when we look forward for any kind of pipeline. It's a generic pipeline which we are looking forward. Now it may have like another steps which is available there, probably some additional steps you're doing, like some other plugins you are installing, but these are the basic steps which is there, like a minimum pipeline if you want to design. These are the steps which is available there. Now let's see. The first one is that we have to require a Java JDK, like a JDK to be available on the system. Now most of the operating systems are already available with a GRE, like a Java GRE. But the problem with the GRE is that it's only for the build process. It will not be doing the compilation. You can run the artifacts, you can run the jar files, you can run the application, run the code base, but the compilation requires the Java C or the Java JDK kit to be installed onto the system. And that's the reason why for this one we also require the JDK. And certain Linux commands execution understanding we need to have, because we are going to run some kind of steps, some installation steps and process, so that's pretty much required. Now let's talk about how to CI/CD pipeline with Jenkins. Now first of all, you have to download the JDK, and that is something which is installed. So after that you can go for the Jenkins download. Now jenkins.io/download is the official websites of Jenkins. Now the best part is that there you have the support for different operating systems and platforms. From there you can easily say that if you want to go for a Java package like a WAR file, Docker, Ubuntu, Debian, CentOS, Fedora, Red Hat, Windows, OpenSUSE, FreeBSD, Ganto, Mac operating system. In fact, whatever the different kind of artifacts or different environment or different application you want to download, you will be able to do that. So that's the very first thing to start upon. You download the generic Java package like a WAR file. Then you have to execute it. You have to download that into a specific folder structure. Let's say that you have created a folder called Jenkins. Now you have to go into that Jenkins folder with the help of cd command, and there you have to run the command called java-jar and the Jenkins.var there. So these are the executables artifacts. So var files can be easily executable. Jar files, var files can be easily deployed. So just because with the Java command you can run them, you don't require any kind of web container or application container as such. So here also you can see that we are running the Java command and it runs the applications as such. And once that is done, so you can open the web browser and you can open like localhost colon 880. So Jenkins uses the 880 port just like a Tomcat Apache. So if once the deployment is done, installation is done, so you can just open the localhost colon 880. Now if you want to get the Jenkins up and running in the browser, probably you can go through the public IP address also there. So you can put the public IP address colon 880, and that can also help you to start accessing the Jenkins application. Now in there you will be having an option called create new jobs, so you need to click on that. Now once the particular new job, new item, new job, that's a different naming conventions which is available there. Now all you are going to do is that you're going to do like you are proceeding with creating the pipeline job. So you will be having an option called pipeline job over there. Just select that and provide your custom name, what pipeline name or job name you want to refer or you want to process there. Now once that is available, so what happens that it will be an easy task for us to see that how exactly we can go ahead and we can perform on that part. So this can really help us to see that how a pipeline job can be created and performed on these modifications as such. Now when the pipeline is selected, and we can give a particular name, that is, this is the name which is available, and then we can say okay as such over there. Now you can scroll down and find the pipeline section. So there what happens that when you go over there and say that okay, this is the way that how the pipelines are managed and those kind of things. So you will scroll down and find the pipeline section and go with that pipeline script. Now when you select that option, there are different options which is available, like how you want to manage these pipelines. Now you are have the direct access also, like if you want to directly create a pipeline script, you can do that. If you feel that you want to manage, like you want to retrieve the Jenkins files, also a code management tool also can be used there, so you can work on that also. So like this, there are so many a variety of things which is available, like which you can use to work around that how exactly the pipeline job can be created. So either you can fetch it from the source code management tool like Git version or something like that, or you can directly put the pipeline code as such over there. Right now, so next thing is that we can configure and execute a pipeline job with the direct script. So we can, once the pipeline is selected, so you can put the particular script like Jenkins file into your particular GitHub link. So you may be having like already a GitHub link, so that where the Jenkins file is there, so you can make use of that. Now once you process the GitHub link, so what we can do is that we can proceed with that, and once the processing is done, so you can do the save, and you can keep the changes, and it will be picking up the pipelines. The pipeline script is added up into the GitHub, and you have already specified that let's just go ahead with this Jenkins file pipeline script from the GitHub repository and proceed further. Now once that is done, so what next you can do is that you can go with the build now process. You click on the build now, and once that is done, so what will happen that you will be able to see that how the build process will be done and how the build will be performed over there. So these are pretty much a kind of a way. So you can click on the console output, you will get all the logs that is happening inside that. Whatever the pipeline steps are getting executed, all of them you will be able to get, or you will be able to get on that part there. So these are the different steps which is involved as such. And the sixth one is that yes, whatever the particular when you run the build now, you will be able to see that source code will be will be checked out and will be downloaded before the build, and you can proceed with that part. Now later on, if you want to change the URL of this GitHub, you can configure the job again, the existing job, and you can change that URL, GitHub link URL, whenever you require. You can also clone this job whenever you go ahead and you work on that, and that's also kind of the best part which is available as such, right? And then you can have the advanced settings over there. So in there you can put like your GitHub repository. You can say like okay, the GitHub repository is there, so I'm just going to put this URL, and with that what will happen that the settings will be available there, and the Jenkins file will be downloaded as such. And when you run the build now, you will be able to have a lot of steps, like a lot of configurations going on. So then the checkout SCM. So we can have a declaration like checkout SCM, which is there. So when the checkout SCM is there, so it will check out a specific source code. After that, you go to the log and you will be able to see that each and every stage which is being built up and executed as such. Okay, so now we are going to talk about a demo here. So on the pipeline here, so this is a Jenkins portal. Now you can see here that there is an option called create a job. You can either click on the new item or you can click on the new job, create a job here. Now here I'm going to say like a pipeline, and then you can select the pipeline job type here. Now you have the freestyle pipeline, GitHub organization, multi-branch pipeline. These are the different options which is available there, but I'm going to continue with the pipeline here as such. So when I selected the pipeline and say okay, so what will happen that I will be able to see a configuration page which is related to the pipeline. Now here the very important part is that you have all the general build trigger options which is similar to the freestyle, but the build step and the post build step is completely removed because of the pipeline introduction. Now here you either have the option to put the pipeline script all together. You can also have some particular example. For example, let's talk about some GitHub Maven particular tool here. So you can see that we have got some steps as such over here, and it's pretty much running over there. Now you run it, it will work smoothly, it will check out some source code. But how we are going to integrate like the Jenkins file into the version control system, because that's the ideal approach we should be following when we create a pipeline of a CI/CD. Now I'm going to select a particular pipeline from SCM here, then go with the Git here. Now in there, the Jenkins file is the name of the file of the pipeline script, and I'm going to put my repository over here in this one. Now this repository is of my Git, which is like having a Maven build pipeline which is available there. It's having some steps related to CI for the build and deployments, and that's what we can follow as such over here. Now in this one, the if it is a private repository, definitely you can add on your credentials, but this is a public repository, a personal repository, so I don't have to put any kind of credentials. But you can always add the credentials with the help of add here, and that can help you to set up whatever the credentials, the private repositories you want to configure. Now once you save the configuration here, now what it's going to do is that it's going to give you a particular page related to build now. If you want to run, if you want to delete the pipeline, if you want to reconfigure the pipeline, all these different options are available there. So we are going to click on the build now here, and when I do that, immediately the pipeline will be downloaded and will be processed. Now you may not be able to get the complete stage view as of now because it's still running. So yeah, you can see that the checkout code is done, then it's going on to the build. Okay, that's one of the steps which is there. Now once the build will be done, so it will continue with the next steps, with the next further steps there. So you can also go to the console output log here, like you can click on this, or you can click on the console output to check the complete log which is happening there. Or in fact, you can also see the stage wise logs also, because that is also very important. When you go for the complete logs, it may have a lot of steps involved, and a lot of logs will be available there. But if you want to see a specific log of a specific stage, that's where this comes into the picture. And as you can see that all the different steps like test cases executions, the sonar cube analysis, the archive artifacts, deployment, and in fact the notification, so all this is a part of a complete pipeline. This whole pipeline is done here, and you get a kind of a stage view, its success over here, and the artifacts is also available to download. So you can download this WAR file is a web applications as such over here. So this is what a typical pipeline looks like, that how the automation, the complete automations really looks like as such over here.
DevOps has emerged as a transformative approach fusing development and operations to streamline workflows, enhance collaboration, and boost efficiency. This dynamic fusion has given rise to a multitude of groundbreaking projects that are reshaping the industry. So in this explanation of the top 10 DevOps projects, we'll delve into the innovative solutions and tools that are catalyzing progress from automation and containerization to continuous integration and deployment. These projects not only facilitate agility but also drive excellence in software delivery, ensuring that DevOps remains at the forefront of modern technology. So join us as we embark on a journey through the most influential DevOps initiatives of our time. With that said, if these are the types of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified.
And if you are a professional with minimum 1 year of experience and an aspiring DevOps engineer looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in DevOps from Caltech University in collaboration with the IBM should be your right choice. For more details, use the link mentioned in the description box below. So let's start with why are DevOps skills crucial. Understanding DevOps is vital for optimizing the software development lifecycle. DevOps engineers need to master several key skills. Linux proficiency. Many firms prefer Linux for hosting apps and managing configuration systems. It's essential for DevOps engineers to be well-versed in Linux as it's the foundation of tools like Chef, Ansible, and Puppet. Continuous integration and continuous delivery. CI ensures teams collaborate using a single version control system, while CD automates design, testing, and release, improving efficiency and reducing errors. Number 3. Infrastructure as code. Automation scripts provide swift access to necessary infrastructure, a critical aspect with containerization and cloud technologies. IAC manages configuration, executes commands, and swiftly deploys application infrastructure. Configuration management. Tracking software and operating system configurations ensures consistency across servers. Tools like Ansible, Chef, and Puppet simplify this process, making it efficient. At number 5, we have automation. DevOps aims for minimal human intervention, maximizing efficiency. Familiarity with automation tools like Gradle, Git, Jenkins, and Docker is essential for DevOps engineers. So these tools streamline development processes and enhance productivity. Moving on to the first project of the day, we have unlocking efficiency of Java application with Gradle. Meet Gradle, the versatile build automation tool transcending platforms and languages. This project helps you start on a journey of Java application creation, breaking it into modular subprojects and more. The main aim of this project is to help you master project initiation as a Java application, adeptly build it, and generate meticulous test reports. You will be well-versed in running Java applications, crafting archives, and elevating your Java development pros. So dive in to transform your coding skills with Gradle. The source code for this project is linked in the description box below. Moving on to project number 2, unlock robust applications with Docker for web servers. Docker, the go-to container technology, revolutionizes services and app hosting by virtualizing operating systems and crafting nimble containers. This project focuses on creating a universal base image and helping you collaborate with fellow developers in diverse production landscapes. You will be dealing with taking web apps foundations in Python, Ruby, and Meteor. So master this project and you will yield Docker file efficiency like a pro, slashing build times and simplifying setups. So say goodbye to lengthy Docker file creation and resource-heavy downloads. The source code for this project is also mentioned in the description box below, so don't forget to check out. Moving on to project number 3, we have master CI/CD pipelines using Azure. In this Azure project, we harness Azure DevOps to create efficient CI/CD pipelines. This project mainly focuses on leveraging Azure DevOps project. We deploy applications seamlessly across Azure services like App Service, Virtual Machines, and Azure Kubernetes Service or AKS. Utilizing Azure's DevOps Starter, we set up ASP.NET sample code, explore pre-configured CI/CD pipelines, commit code changes, and initiate CI/CD workflows. Additionally, we fine-tune monitoring with Azure Application Insights for enhanced performance insights. The source code for this project is also mentioned in the description box below. Moving on to the next project, elevating Jenkins communication, the remoting project. The Jenkins remoting project is all about enhancing Jenkins communication capabilities. It's an endeavor to bolster the Jenkins remoting library, creating a robust communication layer. This project incorporates a spectrum of features from TCP protocols to efficient data streaming and procedure calls. As a part of this project, you will start on the exciting journey of making Jenkins remoting compatible with bus technologies like ActiveMQ and RabbitMQ. To succeed in this project, a strong grasp of networking fundamentals, Java, and message queues is your arsenal. Dive in and join us in elevating the way Jenkins communicates with the world. Check out the link mentioned in the description box below for the source code. Moving on to project number 5, automated web application deployment with AWS, your CD pipeline project. In this project, you will create a seamless continuous delivery pipeline for a compact web application. Your journey begins with the source code management through a version control system. Next, discover the art of configuring a CI/CD pipeline enabling automatic web application deployment whenever your source code undergoes changes. Embracing the power of GitHub, AWS Elastic Beanstalk, AWS Code Build, and AWS Code Pipeline. This project is your gateway to streamlined, efficient software delivery. The source code for this project is linked in the description box below. Moving on to the next project, Containerized Web App Deployment on GKE, Scaling with Docker. This project will help you discover the power of containerization with this project. You will learn how to package a web application as a Docker container image and deploy it on a Google Kubernetes engine or GKE cluster. You can watch your app scale effortlessly to meet user demands. These hands-on projects cover packaging your web app into a Docker image, uploading it to artifact registry, creating a GKE cluster, managing auto-scaling, exposing your app to the world, and seamlessly deploying newer versions. You get to unlock the world of efficient, scalable web app deployment on GKE. The source code for this project is linked in the description box below. Moving on to project number 7, Mastering Version Control with Git. In a world of software development, mastering a version control system is paramount. Version controlling enables you for code tracking, version comparison, seamless switching between versions, and collaborating among developers. Your journey in this project will begin with the fundamental art of saving code in a VCS, taking the scenic route to set up a repository. You can then start on a quest through code history, unraveling the mysteries of version navigation. Navigating through branching, a deceptively intricate task, is next on your path. By the end of this project, you will be fully equipped to conquer Git, one of the most powerful version control system tools in the developer's arsenal. The source code for this project is mentioned in the description box below. Moving on to the next project, Effortless Deployment, running applications with Kubernetes. The major focus of this project is to help you harness a straightforward web service that handles user messages, akin to a voicemail system for leaving messages. Your mission, you ask. You get to deploy this application seamlessly with Kubernetes, then Dockerize it. By mastering this fundamental step, you will unlock the power to run your application in Docker containers, simplifying the deployment process. The source code for this project is mentioned in the description box below, so don't forget to check it out. Moving on to the project number 9, Mastering Terraform Project Structure. This project will help you maintain and extend the efficiency of Terraform projects in everyday operations. A well-structured approach is essential. This project unveils the art of organizing Terraform projects based on their purpose and complexity. So harness the power of key Terraform features, including variables, data sources, provisioners, and locals, to craft a streamlined project structure. By the end, your project will effortlessly deploy an Ubuntu 20.04 server on DigitalOcean. Configure an Apache web server and seamlessly point your domain to it. Level up your Terraform game with proper project structuring and practical application. Check out the link mentioned in the description box below for the source code. Moving on to the last project of the day, we have efficient Selenium project development and execution. In the world of test automation, Selenium projects play a pivotal role. They enable seamless test execution, report analysis, and bug reporting. This proficiency not only accelerates product delivery but also elevates client satisfaction. By the end of this project, you will master the art of building Selenium projects, whether through a Java project or a Maven project, showcasing your ability to deliver high-quality results efficiently. Check out the link mentioned in the description box below for the source code through this project.
Learning objectives. By the end of this lesson, you will be able to describe the benefits of traditional and agile approaches to software testing, describe the levels and approaches of software testing, demonstrate a test-driven development framework with JUnit, and demonstrate a behavior-driven development framework with Cucumber. Software testing overview. Software testing. Software testing is an investigation conducted to share information about the quality of the product and the service under test to the organization. The software testing checklist is as follows. Is the test meeting the requirements that guided its design and development? If not, there's really no value using the test. The most important thing about testing is that it ensures that the behavior of the software under development meets the requirements of the business. Next, is the test responding correctly to the inputs?
If not, either there is a problem in the test or the system under test, and this needs to be figured out and remedied. Is the test functioning within an acceptable span of time, or is it running too long and making the test framework time out? Is the test working properly in its intended environments? Be careful. It's not unusual for a test to pass in one environment, yet fail in another. In order for a test to be valid, it must run reliably in a way that's appropriate to the environment in which it is operating. Is the test achieving the desired results? In order to make sure that the test is indeed meeting the desired results, the requirements which the software is intended to satisfy must be well known, both in terms of documentation and common knowledge among the development team. Tests must be created according to verifiable specification, not developers' assumptions. Otherwise, a company runs the risk of spending money developing tests that have marginal use. Traditional versus agile testing. Let's take a look at traditional testing first. It follows a predictive model with a step-by-step phased approach. It certifies the quality of the product, and traditional testing produces the final system with all the required features. Unit testing for each module is followed by integration and system testing. No feedback is provided until testing is completed, and modifications are implemented in the next release. Agile testing is different. Agile testing follows an adaptive model with an iterative approach. It certifies the quality and fast delivery of the product, even with minimal functionality. Each sprint produces a working version that has a subset of features of the final system. Continuous testing and regression tests are conducted across all iterations. And at the end of every sprint, a short, ongoing feedback cycle is produced. And finally, modifications are implemented in the next sprint of the test cycle. The important thing to understand about traditional testing versus agile testing is that in agile, continuous testing is a driving principle. Testing is conducted throughout the entire software development process, from development onto system testing, and even after the code is released. Many shops take a test-driven development approach, which is abbreviated as TDD. Under TDD, all activity emanates from predefined tests. The rule of thumb is a requirement really is a requirement once its behavior can be described as a test. For example, just saying that a requirement of the application is that it's easy to use has marginal value in the TDD world. We need to be able to test for easy to use. Designing software under TDD means that requirements will read something like, the save document feature will be easy to use. This means that a user will be able to figure out how to save a new document without prior knowledge in under 3 seconds. You see how exact that is? Taking an agile approach means that requirements are defined in a way that is quantifiable and verifiable. And tests written to these requirements can prove with little or no ambiguity that the conditions of requirements have been met. Agile testing advantages. Let's take a look at some of the advantages of agile testing. First, there's reduced risks. A basic practice of agile is to develop code iteratively over many sprints. Typically, a sprint will not last longer than 4 weeks. The benefit of the iterative approach is that issues are uncovered quickly and thus resolved quickly. In other words, problems appear early and are fixed early. This reduces software development risks significantly. When a development team is following the waterfall approach, one in which problems keep accumulating until they are revealed downstream in the QA phase after development is complete, the time it takes to solve all the problems presented can become overwhelming. So too can the risks. Agile's iterative approach breaks development periods into smaller pieces and thus makes the risks more manageable. Also, an advantage is faster time to market. Agile's iterative approach not only reduces risks, it also allows features to be released more quickly from the product backlog. Users are being given features in an iterative manner. Thus, time to market is faster. Product testing as a method is a definite advantage. Product testing is a part of all and any activity in the Agile process. Testing becomes a methodical discipline that is always performed. Because QA personnel are equal members of the software development team, testing is not a special event delegated to a special group outside of the development effort. Testing becomes a method in the process overall and is conducted by many people on the development team. Easy adaptation to evolving requirements. Agile assumes that change is ever present. In fact, change is welcome. Thus, the practices that emerge within the Agile process are designed to adapt to change quickly. For example, sprints are intended to occur over a short period of time. Thus, should change need to be made, businesses don't need to wait for months to implement a change. It can be done as soon as the next sprint is scheduled to start. And the final advantage is improved quality of products. Short sprints, development processes that are designed to accommodate a change quickly, and continuous testing throughout the entire software development lifecycle have the results of increasing the quality of products overall. Implementing small feature sets means that they can be tested as the code is created, and they can be fixed quickly should the need arise. This increases code quality dramatically. Advantages of using Agile with DevOps testing. Let's continue examining the advantages of using Agile with DevOps testing. Cohesion of teams. Small teams that work closely together day in and day out create a synergy that significantly increases productivity. As team members work together closely during the intensive activity in a sprint, the strengths and weaknesses of each member become apparent. Thus, efficient workload allocation starts to take place naturally. A team member commits to performing tasks in his or her area of expertise. Also, he or she will offer to help others when problems arise. No one person can know it all. The team understands this. It's through a willingness to not only admit one's weaknesses, but also to offer help when one's expertise is needed that genuine team cohesion evolves. Easy scalability. As we've mentioned earlier, Agile processes are intended to be flexible. This flexibility makes scaling easier. Remember, under Agile, testing is a continuous activity conducted throughout all stages of the software development lifecycle. Also, automation is key to Agile. Continuous automated testing is easier to scale than a testing process that's run manually only at release time. Flexibility in process combined with automation makes scaling easy. Improved quality of products, continuous integration and testing, and process automation are Agile features that provide significant advantages in DevOps testing. As we've mentioned many times, Agile's iterative development process, along with the use of continuous automated testing, improves the quality of the software created significantly. Testing levels, approaches, and automation tools. Software testing approaches. When it comes to software testing, the important thing to remember is that the role of the software development test engineer goes well beyond manual testing. In fact, in the practice of DevOps, the role of the software development test engineer is anything but that of a manual tester. In DevOps, manual testing is frowned upon except in very special circumstances, such as complex performance testing that requires a very detailed, time-sensitive approach to test preparation. The job of the software test engineer, also known as an SDET, is to design the automated tests that will be executed within a continuous integration, continuous deployment framework such as Jenkins, TeamCity, or Travis CI. Test engineers approach testing in a variety of ways depending on the situation. In terms of determining the quality of source code, the engineer will conduct a static test. A static test is a review of the code and the associated documentation in order to make sure it complies with industry standards, regulations, and best practices. During static testing, the code is not run. When it comes time to run the code, dynamic testing processes are used. This might be a unit test or a more comprehensive integration test or a system test. The important thing to understand is that the code is exercised by a test runner application, such as JUnit. The test runner executes runtime testing on the code and reports the results accordingly. There are also the exploratory and box approaches to testing, which are very closely related. Exploratory testing is a term created by Kem Kainer in 1984. According to Kainer, exploratory testing is a style of software testing that emphasizes the personal freedom and responsibility of the individual tester to continually optimize the quality of his or her work by treating test-related learning, test design, test execution, and test result interpretation as mutually supportive activities that run in parallel throughout the project. It's a learn-by-doing approach. The more time a test engineer spends with the testing, the more he or she sees opportunities for improvements and adjusts accordingly. Box testing is about defining the degree of visibility that the tester has to the code and then determining the scope of testing that can and should be conducted. There's white box testing, in which the code is visible to the testing instrument. Since the code is visible, it should be observed and its behavior under test needs to be reported. In a black box situation, the internal code is opaque. The testing instrument has no access to the lines of code being executed. The only information available is the response from the component under test. A good example of a black box test is testing the server-side logic of a website or API. Unless accommodations are made otherwise, the test instrument has no visibility as to how the logic of the website or API is implemented. All that is known is the input and the output. Thus, testing is conducted according to these criteria. Software testing levels. There are 4 levels of software testing. Let's take a look at each. Unit testing is a dynamic test that exercises a unit of code, typically a function. The current trend in testing is that developers write the unit tests for their code. They are the ones that know the code best and are responsible for making sure that the code they write meets the defined requirements. Integration testing is the practice of ensuring that all the components that the various developers are writing work together according to requirements and cause no side effects. Typically, integration testing is performed upon the code base in the common repository branch into which the code from all developers is merged. System testing ensures that the code overall meets the business's requirements. System testing has a very broad scope. This includes not only ensuring that the code meets the predefined logical requirements, but also that the code interacts properly with the other systems it's intended to service. During system testing, engineers observe code performance in terms of CPU, memory, and storage behavior. Also, system testing observes network operations as well. Remember, in system testing, computing environment is just as important as the software itself. Finally, operational acceptance testing is conducted just before the code is about to be released to end users. This testing is also known as UAT, User Acceptance Testing. In this phase of testing, non-technical personnel, internal, and many times customers, use the software to make sure that it meets the expectations at hand. Popular software testing techniques. There are many techniques used to test software. Some of the more popular are A/B testing, usability and security testing, continuous testing, functional versus non-functional testing, alpha testing, beta testing, regression testing, and smoke and sanity testing. Let's take a look at each. A/B testing is the technique of releasing a feature to a small audience of users and then increasing the number of users over time. For example, a company will create a clone of the product code, including a new feature, and release it to a set of servers bound to a specific load balancer IP address. The website will be configured to route every 10th request to the servers with the new feature. If the feature proves successful, traffic is increased to every 5th request, and then to every other request. However, if something goes wrong, the routing to the new feature is terminated. A/B testing is intended to let users perform some degree of real-world testing without putting the whole site at risk. Usability and security testing. Usability testing is intended to determine how easy the code is to use. The scope of usability testing is typically for those features that require direct human interaction. Usability testing goes beyond just testing the graphical user interface of a product. In fact, usability testing APIs is becoming a growing concern in testing circles. For example, human factors and usability test engineers want to know how long it takes for an engineer to figure out how to use a given API. Is the documentation clear? Are the error messages informative? Do the API responses make sense? These are all questions that are answered quantifiably when usability testing. Security testing is concerned that the code is safe to use and that it does not cause critical harm to the system when running. This means that it's not taking on permissions beyond the scope that's needed. It means that the code is not behaving like a bad actor. Also, security testing is about making sure that bad actors cannot get to the overall system and do harm. Penetration tests, also known as pen tests, are a type of test that is usually performed when doing security testing. Pen tests make sure that no IP addresses or ports are left open unintentionally to the outside world. It also means that sites and services can withstand denial of service attacks. Continuous testing is the practice of testing at regular, short intervals throughout the software development lifecycle. Typically, tests are conducted automatically in response to an event in the software development lifecycle. For example, when a developer commits code to a release branch or when a merge is conducted into the overall code base. Also, testing is done automatically on new environments as they are provisioned. The overall intention of continuous testing is to test early and test often. Functional versus non-functional testing. Functional testing is intended to make sure that code logic works as expected, that no side effects are incurred. Functional testing is about ensuring that code behaves according to requirements. Non-functional testing occurs at the system level. Non-functional testing is concerned about how the entire system works. For example, non-functional testing is concerned with network latency, disk I/O, and fail safety. Alpha testing is the practice of releasing code that is considered just good enough for the end users to exercise. It's expected to be buggy. The hope is that by releasing code to a lot of users performing a variety of use cases, that issues not picked up in internal testing will be uncovered. Beta testing is the phase after alpha testing when, having fixed issues uncovered by users previously in alpha testing, the code is considered to be a release candidate. If all goes well in beta testing, the code will be given a release version number, deployed, and supported accordingly. In beta testing, the code is expected to have a minimal amount of bugs that need to be remedied. Regression testing is the practice of making sure that code that is about to be released is operational and does not break code in other parts of the system. A regression test is system-wide. Regression testing is important because otherwise it's quite possible to introduce intended fixes into a system that actually create more problems than they solve. Smoke insanity testing is a testing regimen that's intended to check that the most obvious parts of the system work. Typically in smoke testing, a tester, or the automated equivalent, will log into the system, perform a few tasks, and then make sure all is well. Smoke insanity tests are intended to be fast and just good enough to make sure that there's nothing dramatically wrong with the system. Automation testing frameworks. Test-driven development teams rely on automated testing. A testing framework is used to write test cases, and continuous integration software will run these test cases automatically. A well-developed testing framework or an integrated development environment, also known as an IDE, can be used to run the test scripts. Some examples of automation testing frameworks are LoadRunner, Selenium, and TestNG, which is supported by Maven. Jenkins has a number of plugins that support automated testing. Appium supports automated testing for mobile devices, and there's the tried and true automated testing tool for Java, JUnit. Automation testing frameworks. There are a number of types of automation testing frameworks. For example, number one, a linear scripting framework, which is also known as record and playback. You use the framework to create test steps that get executed in sequence. For example, having the test tool fill in data in a form on a web page and then verify the results. A typical linear scripting framework is Selenium. Number two, hybrid test automation framework. That's one where you use a combination of two or more frameworks. Number three, keyword-driven testing. Keyword-driven testing is a software testing methodology that uses keywords or action words to symbolize a functionality to be tested. For example, consider the keywords login and logout. These keywords will be associated with tasks to execute. The keyword to task association is usually stored in an Excel spreadsheet or a database. Automated tests will do a lookup on the keyword and then do the associated tasks. Keyword-driven testing frameworks separate the test creation process into two distinct stages, a design and development stage and an execution stage. Number four, data-driven testing frameworks. Data-driven testing frameworks is one in which test scripts run dynamically using predefined data sets from some sort of data store, such as a database or an Excel spreadsheet. For example, a data-driven test is designed to enter and validate name and address information into a form and will use data that's stored in the database automatically. The testing framework is connected directly to the database, and data entry and validation occurs automatically within the test. No human intervention is required. Number five, a modular testing framework is one in which tests are organized into distinct modules. The benefit of a modular testing framework is that the encapsulation it provides makes updating and extending a given module easier, and that the risk of incurring side effects is reduced. You can think of a modular testing framework as one that supports the concept of test suites, where each suite contains one or many tests, as well as common setup and teardown processes that can be applied to all tests in the suite. JUnit is an example of a modular testing framework. Number six, behavior-driven development. Behavior-driven development, also known as BDD, focuses more on making sure the software does what it's supposed to do as opposed to worrying about how it does it. BDD tools tend to use natural language constructs that are similar to English-like sentences. For example, in BDD, a common way to express an assertion is to write, expect checkbox 1 to be true, or the variable x should equal 4. BDD is particularly effective when business personnel are part of the development team. BDD allows more people, even those without a programming background, to participate in test design. Popular testing tools. SOAP UI is an open source web service testing application for service-oriented architectures and RESTful APIs. Robot Framework is a keyword-driven test automation framework that uses tabular test data syntax. Popular testing tools. RSpec is a domain-specific testing tool to test Ruby code. It's a behavior-driven development framework that's used in the production of applications. Eggplant Functional is a black box GUI testing automation tool which uses intelligent image recognition algorithms to monitor the display being tested. It's used for mobile testing, cross-platform testing, and performance testing. Popular testing tools. Mocha is a JavaScript test framework for Node.js programs. Its features are browser support, asynchronous testing, test coverage reports, and use of any assertion library. Jasmine is also an open source testing framework for JavaScript. It supports asynchronous testing, the use of spies for implementing test doubles, and testing of front-end code through a front-end extension. Test-driven development approaches and JUnit 5. Overview of test-driven development. Test-driven development is a software development process that depends on the repetition of testing within short development cycles. Requirements are converted into test cases, and then the software is improved to pass new tests. Developers apply the concept to improve and debug legacy code developed in older techniques. Test-driven development, also known as TDD, is based on a simple principle. Their principle is that the test that describes the behavior of the software to be developed is written before creating the code itself. Operationally, this means that if I am to write a function, imagine getWinner, I write the test for that function before actually writing the code for the function. The developer starts with a failing test and then gets it to pass. Test-driven development cycle. 1. Add the test, or you can also say create the test. 2. Check that the new test fails. 3. Write the code that gets the test to pass. 4. Run the test. 5. Refactor the code if necessary. And then 6. Repeat the process again. Test-driven development advantages. There are many advantages to taking a test-driven development approach to the software development lifecycle. The biggest advantages are fast feedback. Developers are always running tests against the code, even before commits are made to source control. Thus, the feedback loop is immediate. Creation of detailed specification. Developers need a detailed understanding of how the code being written is supposed to behave in order to write the test that's the starting point of the development process. Thus, detailed specification is critical. Less rework. When the tests actually reflect the behavior under development, less rework is required downstream in the software development process. Less debugging. Desired behavior has already been established in the tests that need to pass. Thus, developers do most of the initial debugging in the development stage, not later on in downstream processes. Fast identification of errors. The initial tests reveal errors in code as the code is being written. Testing first makes the errors appear at development time, not later on. Creation of solid code. The tests that the code must satisfy exist first. Thus, the code being written is by nature more accurate. However, in order to maintain a high degree of accuracy, developers must write not only test cases that ensure the code works in what is called a happy path execution, that's when things are going the way expected, but also developers need to write unhappy path tests that ensure that the code errors out in a way that is expected and graceful. Clear interface. In order for the test to be accurate, the interfaces that the code exposes must be clear, maintainable, and flexible. Tests written before coding takes place serve as a continuing reference to determine code integrity. Developers that follow TDD tend to run all the tests in the code base upon initial checkout from the source control management system. Running all the tests first informs the developer that the code base is sound and that he or she can add new code in a way that does not create side effects. Failing tests indicate that the code base is out of sync. Being able to determine the health of the code on checkout by running the tests associated with the code first makes it a lot easier to maintain the code overall. Faster time to market. The practice of test first reduces all development time. Having a developer fix code that he or she knows is a faster process than having someone further down the line in the development process address issues. Fast resolution of issues means faster time to market. Less development cost. A rule of thumb is the most cost-effective place to conduct testing is to push testing activity as close to the developer as possible. Test-driven development is all about having developers do more testing and addressing issues raised when testing. Hence, the cost of development is reduced provided the test coverage of the code is comprehensive. Improved quality is by nature built into the TDD process. Increase in programmers' productivity. Having developers ensure the code as it is being written takes a lot less time than sending the code through the software development process untested, only to have it returned to the developer for remedy when the code is found faulty. Fewer bugs. As mentioned earlier, improved quality is, by nature, built into the TDD process, hence fewer bugs. Simplification of code. Developers only write the code that's needed to get the test to pass. Nothing more, nothing less. As a result, the code tends to be simpler yet more elegant. Adaptability. Test-driven development can be applied to any development environment, from COBOL to Java to more modern languages such as Golang. TDD is about the practice, not about a particular programming language. In TDD, the motto is test first, test often, and write only as much code as is needed to get the test to pass. Overview of JUnit. JUnit is a unit testing framework for the Java programming language. Over 10,000 Java projects have used JUnit as an external library. It's the first option that many developers use for testing Java applications. Advantages of JUnit. There are many advantages for using JUnit as the go-to tool in a test-driven development process. Let's take a look at some of the advantages. In JUnit, the server requirement is eliminated for testing web applications. It's a simple framework for writing automated tests. JUnit has a hierarchical structure. Program code can be tested as a single unit or multiple units. JUnit provides a text-based command line and graphical test reporting mechanism. And finally, JUnit supports test assertions and immediate test reporting. Java, a programming language. The building blocks of Java are standard to any object-oriented programming language. Let's take a look at the building blocks. Abstraction. Java allows programmers to create interfaces and abstract classes that serve as templates from which other classes can be derived. Encapsulation. A class is the key building block of Java. Behavior that is of concern only to the class is encapsulated as private code. Code that's to be used by consumers of the class is made public. Encapsulation promotes reuse in that changes can be made to private code without affecting consumers of the class. Polymorphism. Java supports polymorphism. This means that parameters can be added to a function and thus extend new behavior to the function. In other words, a function can behave in many different ways based on the number and type of parameters passed to it. Inheritance. Java supports inheritance. Developers can create new classes that are derived from other classes. A new class will get all the properties and functions of the parent class automatically. Inheritance promotes code reuse significantly. JUnit 5 with Java. JUnit 5 plus Java requires that certain software be available to design and to run tests. The software required is Java SE, Java 8 or higher, Eclipse IDE, and the JUnit library. Assisted practice. Test-driven development approach with JUnit 5. You are given a project to demonstrate the test-driven development approach using JUnit 5 and Java as a programming language. Alright, so let's get started with Lab 4.1, Test-driven development with JUnit 5. The objective of this lab is to show you how to create a set of unit tests in the Eclipse integrated development environment and run those unit tests under JUnit 5. Eclipse is already installed in your classroom virtual machine. However, if you want to run the labs on your own computer, you can easily download Eclipse from eclipse.org. Now, the first thing we need to do is to create a working directory for this lab. In the terminal window of your classroom virtual machine, go to the command line and type make dir space lab.4.1. Hit the enter key. This creates the directory. Next, let's navigate into the directory by typing cd space lab.4.1 and strike the enter key. We type the Linux command clear to clear the screen so that we can have an uncluttered view of the work we're going to do. The code we're going to test is already out on the Simplilearn GitHub repository. So all we need to do is to clone that code down into the classroom virtual machine. At the command line of the classroom virtual machine terminal window, we type get space clone space https://github.com/Simplilearn DevOps official /lesson-04-JUnit TDD.git. This is the get file for the Simplilearn GitHub repository dedicated to this lab. We strike the enter key and the cloning process begins. Let's confirm that the cloning process worked. At the command line, we type the Linux command ls, and notice there is a directory lesson-04-JUnit TDD. This directory was created by the get cloning process. The directory contains the source code we're going to use in Eclipse in this lab. Before we go on, let's enter the Linux command pwd, present working directory. Take note that we are in the /home/ubuntu/lab.4.1 directory. This is the directory we're going to use once we're in Eclipse. We go over to the running instance of Eclipse in our classroom virtual machine. You can see that Eclipse has no projects loaded into it. Now we're going to load in the code we downloaded from GitHub. We click on the File menu in Eclipse, and from the File drop-down we select Open Projects from File System. Eclipse displays the Import Projects dialog. We click the Directory button on the upper right-hand side of the dialog. We are presented with the file system for the classroom virtual machine. We select the folder lab.4.1, and inside of that folder you'll see another folder marked lesson-04-JUnit TDD. That's the code we downloaded from GitHub. We click on the OK button on the lower right of the File System dialog. Then we're back to the Import Projects dialog. Notice that the import source is now the JUnit TDD folder. We click the Finish button on the lower right of the Import Projects dialog. The project appears in the Eclipse IDE. Notice on the left in the Project Explorer, we can see the file system for the project. We click on the down arrow and we see that there is indeed a package com.tddjunit.java. We click the down arrow and we can see all the files in that package. The files are add.java, maths.java, and subtract.java. We double-click on the file maths.java to open it up in the Eclipse text editor. Notice the class maths has two methods, add and subtract. The method add implements the add interface defined in add.java, and the method subtract implements the subtract interface defined in subtract.java. Now we're going to create a JUnit 5 test case that exercises the method add and the method subtract. We right-click on maths.java. From the drop-down, we select New, and from that drop-down, we select JUnit Test Case. Eclipse displays the dialog New JUnit Test Case. Notice that by default, Eclipse wants to store the unit test file into the same folder as the source code. This really isn't good business. What we're going to do instead is to create a separate directory for our tests. We close the JUnit Test Case dialog. We return to the Project Explorer on the left side of Eclipse, and then we right-click on the root of the project tree, TDD without JUnit. We right-click on New in the drop-down that appears, and then select Source Folder from the next drop-down that appears. Eclipse displays the new source folder. In the folder name text box, we enter test src. Then we click the Finish button on the lower right of the dialog. Take a look in the Eclipse IDE on the left side. Notice the Package Explorer now displays the folder test source. Now it's time to create a JUnit test case for Maths Java. We right-click on the file, Maths Java, and select New from the drop-down, and then from that drop-down, select JUnit Test Case. The new JUnit Test Case dialog appears. Start editorial comment. Editor, please notice that at timestamp 4:14 that the new JUnit Test Case dialog appears. Please put a freeze frame here as I need to explain the various fields in the dialog. End editorial comment. Notice there are three text boxes we want to pay attention to. There's the source folder at the top, package, and name. The directory in the source folder text box is pointing to the source code directory for the project. This isn't what we want. We want the source folder to be the directory test source that we just created. Also, notice going down to the name text box that Eclipse has assigned a default name to the test file, and that default name is maths test. That's okay. The important thing to understand here is that we need to change the source folder to the directory test source. To change the directory, we click the Browse button to the right of the source folder text box. the source folder selection dialog appears. We select Test Source from the dialog and then click the OK button. Then, in the Test Case dialog, we click the checkboxes for Setup and Teardown. Clicking these checkboxes will insert Setup and Teardown methods into the test case. Start editorial comment. Editor, we might have to put a freeze frame in timestamp 4:23 because I need to describe what setup and teardown behaviors are. End editorial comment. Now, what the setup method does is it provides preliminary behavior that gets run before the test happens. Teardown is the behavior that gets run after the test happens. So for example, if you had to do a database setup, you would put the database setup in the setup method, and then if you wanted to disconnect from the database, you would put the disconnection behavior in the teardown method. Begin editorial comment. Editor, we're going to need a freeze frame at timestamp 4:29 so that I can explain why we're skipping adding the JUnit 5 library temporarily. End editorial comment. Next, Eclipse will want us to add the JUnit 5 library. But before we do that, we have to do some other things with the test configuration. We click the Cancel button to skip adding the JUnit 5 library temporarily. We're going to get back to that. We're presented with a dialog that asks us to select the methods we want to test. And we're going to select Maths, Add, and Subtract. We click the Finish button. The dialog asking us to add the JUnit 5 library reappears. So we're going to select Add JUnit 5, and then we're going to click the OK button. Take a look at the Project Explorer pane on the left side of the Eclipse IDE. Notice that the JUnit 5 library is indeed installed now. Also, when we double-click on the file mathstest.java, you can see that the file appears in the Eclipse code editor. Notice that there's a setup method, a teardown method, and also a test add and a test subtract method. Test add and test subtract are the tests we're going to run. To run the test, we right-click on the file mathstest.java, and from the drop-down select Run As, and then select JUnit Test. The JUnit tests run, but they fail. Take a look at the left side of the Eclipse IDE. Notice the red bar. This indicates that tests have failed. And then if you look in the failures text box, you'll see that indeed 2 tests have failed. Take a look at the test add and test subtract methods in the Eclipse code editor. Notice that by default they're given a fail state. You can see it says fail, not yet implemented. Our work now is to get the test to pass. Now we're going to write some code. In the file mathstest.java, we create a private member variable. And we type private maths space class under test semicolon. Okay, so our private member variable is class under test. In the setup method, we type class under test equal new maths. What we've done is created an instance of the maths class that is visible throughout the test case. Next, we'll put test behavior in the method testAdd. Let's recap the important steps. Assisted practice, guidelines to demonstrate the usage of JUnit 5 with Java. Number 1, download Java 8 or a newer version and set up the environment variables required. Number 2, download Eclipse from the official Eclipse site. Number 3, create a new Java project in Eclipse. Number 4, create 2 classes, one to add and another to subtract numbers. Number 5, generate the JUnit test files for each class. Add the files in a different source directory for better indentation. Number 6, confirm that Eclipse has added the JUnit 5 library to the build path. Number 7, confirm that the test cases have failed and the error logs are available in the failure trace section in Eclipse. Number 8, rerun the test cases and confirm that the tests have run successfully without any error or warning logs in the failure trace. Behavior-driven development principles, Cucumber, and its applications. Overview of behavior-driven development. Behavior-driven development is an extension of test-driven development. Behavior-driven development, also known as BDD, focuses on where to start in the process, what to test and what not to test, how much to test in one go, what to name the tests, and also how to understand test failures. Behavior-driven development principles. The first principle is to define a test set for the first unit. Second, make the tests fail. Third, implement the unit. And fourth, verify the implementation of the unit that makes the test succeed. In addition to the guiding principles of BDD, a key concept of behavior-driven development is that software development needs to be managed from both business and technical perspectives. Thus, key to BDD is the domain-specific language, also known as the DSL. The DSL describes those entities and processes that are specific to the domain for which the software is being developed. For example, software being developed for the medical industry will have a DSL that contains the terms and, by association, the software abstractions that describe the medical domain. If the software is being developed for the financial industry, the terms and software entities will describe those entities and processes associated with finance. All development takes place with the DSL as the main means of expression. BDD is intended to take advantage of the DSL to make mappings of business requirements to test assertions a direct association. Thus, many BDD tools provide test expressions that appear as assertions made in natural language. For example, the assertion, expect variable s to be a string. The focus of BDD is to make it so that all members of the development team, business and technical personnel alike, can serve as active, empowered contributors. Overview of Cucumber. Cucumber is a software tool for testing other software by running automated acceptance tests written using a behavior-driven development approach. The tool allows the execution of feature documentation written in business-facing text. Cucumber uses the Gherkin language to define test cases. It's designed to be non-technical and human-readable. Cucumber collectively describes use cases related to the software system. Gherkin, a language for Cucumber. Gherkin is a set of grammar rules that structures the plain text for Cucumber to understand. It serves multiple purposes. Gherkin provides unambiguous executable specification, automated testing, and documentation about the system's actual behavior. Gherkin keywords. Each line of the script must start with a Gherkin keyword followed by any relevant text. The primary keywords are feature, scenario, given, when, then, and, but, that means steps, background, scenario outline, and examples. The secondary keywords are defined using the following symbols along with text. Quotation marks surrounding text for docstring, the pipe symbol for data tables, the @ sign for tags, and the hash or pound sign which indicates comments. Tools for Cucumber. Cucumber is supported by a number of code editors, IDEs, and development frameworks. For example, for supported code editors, there's Atom, TextMate, which is a macOS product, and Visual Studio Code, which is available in Windows, Mac OS, and Linux. Supported IDEs are IntelliJ and Eclipse, and supported build tools are Apache Maven, Gradle, and Rake. Cucumber with Java. In order to run Cucumber and Java, there are certain software requirements that need to be satisfied. These are Java SE up to Java 8. Be careful, Java 9 and higher versions are not supported yet. Maven, version 3.3.1 or higher, the IntelliJ IDE with the Cucumber for Java plugin installed, and Cucumber Eclipse, which is an alternative for IntelliJ. Cucumber with JavaScript. In order to use Cucumber with JavaScript, there's certain software that's required. The software is Node.js, which is a JavaScript runtime engine, a text editor such as Atom, or Visual Studio Code, or TextMate, which is only available for Mac users. Cucumber with Ruby. In order to run Cucumber with Ruby, you're going to need certain software. The required software is Ruby, Bundler, and a text editor. Cucumber with Kotlin. In order to run Cucumber with Kotlin, you're going to need to make sure that required software is installed. The required software is Java SE version 8. Again, be careful, Java 9 and higher versions are not yet supported for Cucumber. Maven, version 3.3.1 or higher. The IntelliJ IDE with the Cucumber for Java plugin installed. Also, you need to make sure that the IntelliJ IDE has the Kotlin plugin installed. And also, you can use Cucumber Eclipse with Kotlin Eclipse, which is an alternative to IntelliJ. Assisted practice. Behavior-driven development approach with Cucumber. Problem statement. You are given a project to demonstrate the behavior-driven development approach using Cucumber and JavaScript as a language. Welcome to Lab 4.2, Installing Cucumber. In this lesson, we're going to install Node.js, NPM, the Node Package Manager, Visual Studio Code. Then we're going to take a brief introductory overview of Cucumber. The first step is to install Node.js. One way to install Node.js is to go to the website at nodejs.org and download it directly using the download page. Another way to install Node.js is at the command line in a terminal window. We go to a terminal window in your classroom virtual machine. Then, at the command line, we type sudo space apt-get space update. This will do a package update before we install Node.js. Once the update completes, we use the Linux command clear at the command line to clear the screen. Now we'll install Node.js using apt-get. At the command line, we type sudo space apt-get apt-get space install space node.js, and then we hit the enter key. The installation process will start. Then we strike the Y key on the keyboard to continue the installation. To confirm that Node is installed, we type at the command line no space -v. That's strange. At the command line, we're getting a message saying the program Node is currently not installed. You can install it by typing, and there's the command. So let's type that command. We'll type at the command line sudo space apt space install space node.js -legacy. Okay, that works. So let's check the version of Node. At the command line, we type node space -v. And the version v4.2.6 is displayed. Now, be advised, when you install Node, you'll probably get a higher version number. And that's okay because we want to stay up to date with the current version. But in this case, we're going to go with the version of this installation. Now let's check to see if the Node Package Manager NPM is installed. At the command line, we type npm space -v. Notice the output. The program npm is currently not installed. you can install it by typing, and there's the command. So that's what we'll do. At the command line, we type sudo space apt space install space npm. The installation process starts. Then we strike the Y key on the keyboard to continue with the installation. Let's check the version of npm. At the command line, we type npm space -v, and notice we get version 3.5.2. Now, again, when you install npm, you're probably going to get a higher version number, because by default, apt-get or apt-install will always find the latest version of a piece of software to install. We type the Linux command clear to clear the screen. Now we need to go to the website for Visual Studio Code, or what's also called VS Code. So in the browser we type code.visualstudio.com/download. We click on the button .deb to download the Debian Ubuntu package of Visual Studio Code. Remember, your classroom virtual machine is running the Ubuntu operating system. The reason we're downloading Visual Studio Code is that we need the VS Code integrated development environment in order to run Cucumber. We type ls to find the location of the downloads directory. Then we type cd downloads. We type ls to see if the code download has completed yet. Well, it hasn't. Let's wait a moment. Again, we type ls to see if the VS Code is downloaded. Notice on the left-hand side of the screen, there is a file, code_1-30.2-15 and a whole lot of numbers, .deb. This is the VS Code download. Now remember, when you do this process, you might get a higher version number because the download's going to get the latest version. Now we need to extract the VS Code application files from the .deb file. At the command line, we type sudo space dpkg space -i space and the file name of the VS Code.deb file. Then we hit enter. The unpacking process begins. Once the download is complete, we go to the Applications tab in our Classroom virtual machine on the upper left of our screen. We click the Applications tab and a drop-down appears. We go to the Development menu item in the drop-down. We click the item Development in the drop-down list. You'll notice that a sub-item Visual Studio Code appears. We click the Visual Studio Code menu item. If indeed you don't see the Visual Studio Code menu item in the drop-down list, you might have to go back and try to reinstall Visual Studio again. Anyway, if indeed the program is installed successfully, when you click the menu item Visual Studio Code, the application will start up. Great, so Visual Studio is successfully running. Now we need to go back to the terminal window in our Classroom virtual machine and make a directory for our Cucumber work. At the command line, we type mkdir space lab4.2 and then we hit the enter key. Now we navigate to the folder we just created. So we type cd space lab4.2 and hit the enter key. Next, we need to create a working directory for our Cucumber work. So, at the command line, we type mkdir space hello Cucumber, HELLOCUCUMBR. Then we strike the enter key. Now, we navigate to the working directory by typing cd space hello Cucumber. We go back to the Visual Studio Code application. We go to the File menu and click on the menu item Open Folder. The Open Folder dialog appears. In the Open Folder dialog, we click on Lab 4.2 and then the folder Hello Cucumber. We click the OK button in the lower right-hand corner of the Open Folder dialog. The IDE displays the Hello Cucumber directory. We click the Maximize button in the upper right side of the Visual Studio Code window to get a better view. We're going to open the Terminal window in Visual Studio Code. In the Visual Studio menu bar, we click the View tab and you'll see a drop-down appear. We scroll down and click the menu item Terminal. The Terminal pane appears in the Visual Studio Code IDE in the lower part of the main window. We're going to create a Node.js project using the Terminal window in Visual Studio Code. In the lower pane, we type npm init -yes. This creates a Node.js project with a default package.json file. Now we need to make an entry in the package.json file for Cucumber and also install the Cucumber Node.js modules. To do this, at the command line in the Visual Studio Code window, we type npm install cucumber --save -dev and we strike the enter key. --save -dev tells the npm package installer to make an entry for Cucumber in the development node of package.json. Also, npm will install the node package for Cucumber. Now, what's interesting is once Cucumber is in package.json, the only thing another developer needs to do to install the project is to type npm install at the command line. Then the npm package manager is smart enough to inspect package.json and install all the node modules listed. You can see npm starting to install the node modules for Cucumber. Upon completion of the installation of the node modules for Cucumber, you'll see a listing of the modules dependencies in a tree in the terminal window of VS Code. Cucumber requires that we create a folder named Features. We're going to use the terminal window in Visual Studio Code to create that directory. In the terminal window of Visual Studio Code, we type the command line instructions mkdir features. We navigate to the Features folder by typing cd features and then striking the enter key. Next, we need to create another folder named Steps. In the terminal window of Visual Studio Code, we type mkdir steps and strike the enter key on our keyboard. When you look at the vertical Explorer pane on the left-hand side of the Visual Studio Code window, you'll notice that there's a folder named Features and a subfolder named Steps. Now we need to create a file, cucumber.js, to store default configuration settings. We navigate to the root of the project folder, so we type cd lab 4.2 and we strike the enter key. Then, in the Visual Studio Code terminal, we type at the command line cd hello cucumber. We're in the root directory of the Hello Cucumber project. Now we need to create the file cucumber.js. At the command line in the terminal window of Visual Studio Code, we type touch space cucumber.js. This creates an empty file named cucumber.js. Now we need to export the default settings. In the Vertical Explorer panel on the left side of the Visual Studio Code window, we select the file cucumber.js. This will open cucumber.js in the Visual Studio Code text editor. We type the Node.js module export statement, module.exports, space and equal sign, open and close curly brackets. Within the curly brackets, we type default colon and a pair of tick quotes. Tick quotes on a US keyboard can be found to the left of the numeral 1 key. Within the tick quotes, we type -- format - options space single quote left curly bracket double quote snippet capital I lowercase nterface double quotes colon space double quotes synchronous double quotes right curly bracket single quote tick right curly bracket. Now I know that's a lot, so pay close attention to the screen and make sure you enter exactly what you see. Now save the file. We're going to create a file named stepdef.js and we're going to put it in the steps directory. So in Visual Studio Code, on the left side Explorer pane, we select the steps folder with our mouse, right click and select New File. We name the file stepdef.js. Now, click on the file step.js to bring it up in the Visual Studio Code text editor. Once you see the file, click in the file and enter const space assert equals space require a paren pair single quote assert single quote semicolon. This tells Node that we want to create an instance of the assert object which ships with the assert library, which ships with Node, in the file stepdef.js. Next, we want to tell Node to use the given, when, and then objects from within Cucumber. In the editor, we type const left bracket capital given comma capital when comma then right curly bracket equals require paren single quote cucumber single quote. And using the brackets to extract variable names is special to ES6. If you're using ES5, this probably won't work. But under ES6, you can pull out a number of objects from one given library using the multiple declaration within the curly bracket technique. Okay, don't forget to save the file. Next, we need to go and tell Node how to run a Cucumber test. So we go back to package.json, and then in the package.json file, which you'll see in the Visual Studio Code Editor, you'll see a scripts node and beneath that a test node. We delete the default entry that npm init made in the test node of the package.json file. You can see it says echo/error no test specified and exit. We're going to delete that, so we do. And in its place, we type cucumber-js. This is telling Node to run the command cucumber.js when it comes time to run the test from the command line. So at the terminal window in Visual Studio Code, on the lower part of the pane, we type npm space test. you can see that Cucumber responds with 0 scenarios and 0 steps. And this is okay because we haven't written any tests in Cucumber yet. We're going to write tests in the next lesson. Hi, in this lab we're going to create a Cucumber test by first writing a feature and scenario with steps in a .feature file using the Gherkin language. Gherkin is a declarative language similar to YAML. We use Gherkin to describe a feature and then a scenario and then the given, when, and then steps that need to be executed within the Cucumber test. Now remember, we're going to write the feature, the scenario, and the test steps in Gherkin. But what we're not going to write is the JavaScript that implements the steps defined in the feature file. Thus, the scenario and the steps are undefined and the test will fail. So, to make a long story short, in Cucumber we're going to write an undefined test. We're going to write our Cucumber scenario in the Visual Studio Code IDE. We open the Visual Studio Code IDE by going to the Applications tab in our Classroom Virtual Machine. We click the Applications tab and a menu drops down. From that menu, we select the development item and then the Visual Studio Code context item appears. We click Visual Studio Code. This will open up the VS Code IDE. Visual Studio Code opens. We go to the File menu and select the Open Folder item. The Open Folder dialog appears. We navigate to the folder Lab 4.2, which is a project we made in the last video. Then, once in the folder Lab 4.2, we select the folder Hello Cucumber. We click the OK button to open Hello Cucumber in the Visual Studio Code IDE. The Open Cucumber project opens in Visual Studio Code. When you take a look at the Project Explorer on the left side of the Visual Studio Code IDE, you'll notice that the Cucumber node module is installed. When we select the file index.js, you can see that it appears in the VS Code text editor. In this case, index.js is the entry point for the Cucumber node module's CLI library. Cucumber ships with a number of options, CLI, which is the command line interface, and also other libraries that you can use directly as part of the testing process. The important thing to understand about index.js, again, is that it is the entry point for a module, and this is how we know we have Cucumber installed. Now let's see if we can get a test running. In the terminal window of the VS Code IDE, which is in the lower part of the screen, we type npm test. And notice that Cucumber tries to run, but it reports that there are 0 scenarios and 0 steps. This makes sense because we haven't written any scenario for the test yet, nor have we written the implementation code behind it. So let's start at the beginning and write the scenario. We collapse the Node Modules folder and navigate up to the Features folder in the Hello Cucumber project. Now, as you might remember from earlier, Cucumber requires that we have a Features folder and that in the Features folder there is a .feature file and also a folder step_definitions. The feature file we're going to create is named is_it_capital_Friday_yet.feature. So, in the Explorer window of the VS Code IDE on the left-hand side, we click on the Features folder, and then we click on the New File icon, which is to the right of the Hello Cucumber listing in the Project Explorer of Visual Studio Code. A text box appears in the Project Explorer for the file, and we type is_it_F Friday_yet.feature. This feature file will describe the scenario that Cucumber is going to support. Now it's time to write the feature. In the first line of the text editor, we type feature: is it Friday yet with a question mark. This is the feature definition. In the second line, we put an indent and then we write a description. The description is everybody wants to know when it's Friday. Now, be advised, this description is arbitrary. We can put anything in there we want. Its purpose is to provide descriptive text so that people who are running the test know what it's about. We skip a line, and at line 4, we enter the scenario. So, we indent, and then we type the word scenario followed by a colon, space, and then Sunday isn't Friday. This is our scenario. We want to test in a behavior-driven manner that we can prove that Sunday isn't Friday. Next, we need to enter 3 steps: given, when, and then. And these are fundamental to Cucumber. In other words, we're going to say, given a certain condition, when this is enforced, then this needs to happen. So, let's write these steps. First, we write the given step. So, we indent, and we're at the same indent level as scenario. We type given space today is Sunday. We enter another line, number 6, and at the same indent level as given, we type when space I ask whether it's Friday yet. That's the when step. Then we enter another line, and then at line 7, at the same indent level as when, we type then space I should be told quotation nope quotation. So let's review. We've set up our feature, then we've defined the scenario, we've written the given step, the when step, and the then step. Now let's run the test. At the terminal window in the VS Code IDE, we type npm space test. This command runs the test instruction we defined in the last video in the package.json file. The test runs. Notice that the response is that one scenario is undefined and that 3 steps are undefined. And this makes sense because we've written the scenario in the feature file, but we haven't implemented the actual test behavior in JavaScript. And that's to come in the next video. Okay, so let's do the lab that's concerned with a scenario that's going to fail and then pass in Cucumber. The objective of this lab is to write a Cucumber test that supports a scenario defined in a feature file. Begin editor note. Editor, we need a freeze frame at timestamp 05. End editor note. The Cucumber test we're going to implement is based on the file isitfridayyet.feature as shown on your screen. The way that Cucumber works is that it will use the feature file to define certain aspects of the behavior test we're going to implement. In the feature file, there's a scenario described, Sunday isn't Friday, and it's given a given clause, today is Sunday, and there's a when clause, I ask whether it's Friday. Finally, there's a then clause, I should be told nope. So let's take a look at how to turn this feature into a Cucumber test. In the Visual Studio Code IDE, we go over to the left to the Explorer pane and we click on the file stepdefs.js. The file appears in the Visual Studio Code Editor in the main page. Notice please that the file declares a constant assert equals require assert, and the assert library is built into Node.js. Also, the file declares 3 variables, given, when, then, and those come from the Cucumber module which we installed previously. In the code editor, we write a function, is it Friday? We add the parameter today to the function. We add the comment, we'll leave the implementation blank for now. Now, the given object takes a constructor, so we'll add one. In the Visual Studio Code Editor, we add the constructor given, paren, single quote, today is Sunday, single quote, comma, function, paren set, curly brackets. In the function body, we add the statement, this.today equals, single quote, Sunday, single quote. Sunday is a string that we're assigning to the member variable this.today. When is also an object that takes a constructor. The constructor takes 2 parameters, the condition string and a function. So we enter, single quote, I ask whether it's Friday yet, single quote, comma, function, parens, curly brackets. In the function body, we add the statement, this.actualAnswer equals is it Friday, where is it Friday is the function we've defined previously. We pass the parameter this.today into the function is it Friday. Next, we implement the then object, which is also a constructor. We type, single quote, I should be told, curly bracket string, curly bracket single quote, where string is a format parameter. Then we add the function parameter. We type function, paren, expected answer, paren, curly brackets. In the body of the function, we type the statement, assert.equal, paren, this.actualAnswer, comma, expected answer, paren, semicolon. This statement asserts that the condition we're testing for is actually enforced, that the actual answer equals the expected answer. Now, let's execute the test. In the Visual Studio Code IDE, the terminal is in the lower pane. At the command line in the terminal, we type npm space test, where test is defined in the package.json file. The Cucumber test runs, and you can see it fails. Let's review the test in the terminal. Given today is Sunday, when I ask whether it's Friday yet, I should be told nope, but I'm not told nope. Nothing happens. Thus, the test fails. We clear the console in Visual Studio Code by typing the Linux command clear at the command line. We edit the function is it Friday yet. We go to the function and we remove the comment we placed there previously. Then we type return space single quote nope single quote semicolon. Thus, whenever we call the function is it Friday, it will return the string nope. Now we run the test again in the terminal of Visual Studio Code. This time the test passes. Let's recap the important steps. Assistant practice. Guidelines to demonstrate the usage of Cucumber. Number 1. Install Node.js and NPM from the Node.js official website. Number 2. Open Visual Studio Code and check the version of Node and NPM. Number 3. Create an empty Cucumber project folder. Number 4. Add Cucumber as a development dependency to Visual Studio Code. Number 5. Create a folder feature and in it create another subfolder, steps. Number 6. Add the code to the respective files. 7. verify Cucumber installation. And 8, confirm that all the scenarios and steps have passed. Key takeaways. You are now able to describe the benefits of traditional and agile approaches to software testing. You can describe the levels and approaches of software testing. You can demonstrate a test-driven development framework with JUnit. And finally, you can demonstrate a behavior-driven development framework with Cucumber.
Hi guys, welcome to this video on Git interview questions and answers. Git is the most popular distributed version control system used for source code management. It helps coders to coordinate and track their code. We have compiled the most important Git interview questions that you might face in a Git or DevOps interview. So without further ado, let's get started with Git interview questions and answers.
So let's just get into those source code management, and we're going to focus specifically on Git. The reason being is that Git is really the most popular source code management solution right now. There are other technologies out there, but for the types of distributed environments that we have, source code management with Git is probably the most effective. So the first question you'll be asked when it comes to Git is to talk about the difference between centralized and distributed version control. And if we look at the way that the two are set up, older technologies such as older versions of Team Foundation Server, though the current version does actually have Git in it, but older versions required a centralized server for you to check in and check out of code. The developer in the centralized system does not have all the files for the application, and if the centralized server crashes, then you actually lose all of the history of your code. Now, in contrast, a distributed model, actually we do check in our code to a server. However, for you to be effective and building out your solution, you actually check out all of the code for the solution directly onto your local development machine. So you can actually have a copy of the entire solution running on your local machine. This allows you to be able to work effectively offline. It really allows for scalability when it comes to building out your team. So if you have a team that may be in Europe, you can actually then scale that team with people from Asia, from North America or South America very easily, and not have to worry about whether or not they have the right code or the wrong code. And in addition to that, if the actual main server where you're checking in your code does crash, it's not a big deal because you actually have, each person has a copy of the code. So as soon as the server comes back up, you're able to check back in and everybody's running back as if there was nothing had happened at all. So one of the questions you'll be asked is to give the answer to some of the commands you use for working with Git. So if you were to be asked a question is, what is the Git command that downloads any repository from GitHub to your computer? On the screen we have 4 options. We have Git push, Git fork, Git clone, and Git commit. The answer in this instance would be Git clone. Now, if you want to be able to push code from your local system to a GitHub repository using Git, then first of all, you want to be able to do is connect the local repository to a remote repository. And in the example, you may want to talk about using the command git remote add origin and then the actual path to a GitHub repository. You could, if you wanted to, actually at this point also talk about other repositories such as Git Lab that you can also work with, or a private Git repository that would be used just for the development team. Once you've actually then added the local repository into your local computer, then the second action you want to use is a push, which is to actually push your local files out to the master environment. So you use the command git push origin master. So one question you may be asked is, what is the difference between a bare repository and a standard way of initializing a Git repository? So let's look through what is the standard way. So the standard way using git init allows you to create a working directory using the command git init. And then the folder that creates is the folder that creates all the revision history related to the work that you're doing. In contrast, using the bare way, you have a different commands for setting that up. So it would be git init --bare, and it does not contain any working or checked out source files locally on your machine. In addition, the revision history is actually stored in the root folder versus a subfolder that you would have with the normal git init initialization. So which of the following CLI commands would you be used to rename a file? So we have git rm, git mv, git rm-r, or none of the above. Well, in this instance, it would be git mv. A question that you'll be asked around commit is going to be, what is the process to revert a commit that has already been pushed and made public? And there are two ways you can address this. The first is to actually address the bad file in the new commit, and you can use the command git commit -m and then put in a comment for why that file is being removed. The second is to actually create a new commit that actually undoes all the changes that were made with the bad commit. And then to do that, you would use git revert and then the commit ID, and the commit ID could be something such as 560E0938F, but you'd have to find that from the commit that you had made, but that would allow you to revert any bad files that you had submitted. So there are two ways of being able to get files from a Git repository, and you're going to be asked to explain the difference between git fetch and git pull. So git fetch allows you to fetch and download only new data from a new repository. It does not integrate any of the new data into your working files, and it can be undone at any time if you want to break out the remote tracking branches. In contrast, git pull updates the current head branch with the latest changes from the remote server. So you get all of the files downloaded. It downloads new data and integrates it with the current working files you have on your system, and it tries to merge remote changes with your local ones. So one of the questions you'll get asked about Git is, what is a Git stash? So as a developer, you will be working on the current branch within a solution. But what happens if you come up with an idea where it's something that will take a different amount of time for you to be able to complete, but you don't want to interrupt the mainline branch? So what you can actually do is you can actually create a branch that allows you to start working on your own work outside of the mainline branch. And this is called Git stash. It allows you to be able to modify your files without interrupting the mainline branch. So once you start talking about branching in Git, be prepared to answer and explain the concept of branching. So essentially what it allows you to do is have a mainline master branch that has all the code that the team is checking in and checking out against, but allows you to have an indefinite number of branches that allows for new features to be built in parallel to the mainline branch, and then at some point be reintroduced to the mainline branch to allow the team to add in new features. And so if we look through the merge and git rebase, these are the two features that you'd be using continuously to be able to talk about how you take a branch and merge it back into the mainline branch. So on the left hand side we have git merge, which allows you to take the code that you're creating and merge it back into the master. On the right hand side what you have is a slightly different approach. This is for projects where you reach a point in a project where you go, okay, we're going to effectively restart the project at this point in time, and we want to ignore the complete history that's happened before that, and that's called git rebase, and that would allow you to rewrite the project history by creating a brand new mainline branch that ignores all other previous branches that have happened before it. You can, if you want to, very quickly and easily find out all the files that have been used to make a particular commit. So when somebody asks you the question, how do you find a list of files that has been changed in a particular commit, you can actually say that all you have to go is find the command git diff-tree-r and then the hash that you would use for the commit, and that would actually then give you a breakdown of all the files that have been made with that particular commit. A question that you'll be asked when you're talking about merging files is, what is a merge conflict in Git and how can it be resolved? So essentially a merge conflict is when you have two or more branches that are competing with commits in Git, and you have to be able to determine which is the appropriate files that need to be submitted. And this is where you would go in and to actually help resolve this issue, you'd actually go in and manually edit the conflicted files to select the changes you want to keep in the final merge. So let me go through the steps that you would take to be able to illustrate this when you're talking about this particular question in your interview. There are essentially 4 stages. The first would be under the repository name, you want to select a pull request, and you want to be able to show how that pull request would be demonstrated inside of GitHub. So within the pull request, there's going to be a highlight of conflict markers, and you'll be able to select which conflicts you want to keep and which you want to merge and which ones you want to change. So it's a step through how you would actually resolve a merge conflict. The first step would be under GitHub. You want to be able to pull the repository name and then the pull request around that repository. In the pull request list, click the pull request with a merge conflict and that you'd like to be able to resolve. That will pull up a file that will list out all of the conflicts for you. Near the bottom of that file will be a list of the requests that need to be resolved. And then if you need to make a decision on which branches you want to keep or which ones you want to change, that will have to be something you have to put in instructions inside of the file. You'll actually see that there are conflict markers within the instructions which are going to ask you which files you want to change and which ones you want to keep. If you have more than one merge conflict in your file, scroll down to the next set of conflict markers and repeat steps 4 and 5 until you resolve all of the conflicts. You will want to mark your file as resolved in GitHub so that the repository knows that you are having everything resolved. If you have more than one file with a conflict, then you want to go then onto the next file and start working on those files and just keep repeating the steps we've done up to this point until you have all of the conflicts resolved. And then once you have all of the resolutions created, then you want to select the button which is commit merge and then merge all your files back into GitHub, and this will take care and manage the resolution of the merge conflict within GitHub. So you can also do this through command line, and with the command line you want to use git bash, and so you want to, as a first step, open up git bash and then navigate to the local git repository in command line using the cd change directory and then list out the actual folder where you actually are putting all of your code, and then you want to be able to generate a list of the files that are affected with the merge conflict. And in this instance here, you can actually see the file styleguide.md has a merge conflict in it. And as before, with working with GitHub, you actually go through and use a text editor, and you can use any text editor. But as you go through and edit out what you want to keep and what you want to manage in your conflict, so you actually have a resolution that's being created, so that you'll be able to then, once you're using the conflict markers, you can actually merge your files together so that the solution itself will allow you to incorporate your commits effectively into the resolution. Once you've gone through and applied your changes, you're able to then merge the conflicted commits into a single commit and able to push that up to your remote repository.
Hi guys, welcome to this video on Jenkins interview questions and answers. Jenkins is a popular DevOps open source automation server. It is used to automate the non-human part of software development and supports continuous integration and continuous delivery. Jenkins is a server-based system that runs in servlet containers such as Apache Tomcat. We have compiled the most important Jenkins interview questions that you might face in a Jenkins or DevOps interview. So without further ado, let us get started with Jenkins interview questions and answers.
So the first question you'll be asked about with Jenkins is explain a master-slave architecture of Jenkins. So the way that Jenkins is set up is that the Jenkins master will pull code from your remote Git repository such as GitHub and will check that repository every time there is a code commit. It will distribute the workload of that code and the tests that need to be applied to that code to all of the Jenkins slaves. And then on request, the Jenkins master and the slaves will then carry out all the builds and tests to be able to produce test reports. The next question you'll be asked is, what is a Jenkins file? And simply put, a Jenkins file is a text file that has a definition of the Jenkins pipeline and is checked into a source code repository. And this really allows for three distinct things to happen. One, it allows for a code review and iteration of the pipeline. It permits an audit trail for that pipeline, and also provides a single source of truth for the pipeline, which can be viewed and edited. So which of the following commands runs Jenkins from the command line? Is it java-jar jenkins.war, java-war jenkins.jar, java-jar jenkins.jar, java-war jenkins.war? And the answer is A, java-jar jenkins.war. So when working with Jenkins, you're going to be asked what are the key concepts and aspects of working with a Jenkins pipeline. And you want to really hold out your fingers here and go through 4 key areas, and that is pipeline, node, step, and stage. So pipeline refers to the user-defined model of a CD continuous delivery pipeline. Node are the machines which are part of that Jenkins environment within the pipeline. Step is a single task that tells Jenkins what to do at that particular point in time. And then finally, stage defines a conceptually distinct subset of tasks performed through the entire pipeline. And tasks could be build, test, and deploy. So which of the following file is used to define dependency in Maven? And do we have A, build.xml, B, pom.xml, C, dependency.xml, or D, version.xml? And the answer is pom.xml. Working with Jenkins, you're going to be asked to explain the 2 types of pipeline used in Jenkins along with the syntax. And so a scripted pipeline is based on GroovyScript as their domain-specific language for Jenkins. And there are 1 or more node blocks that are used throughout the entire pipeline. On the left-hand side, you can actually see what the actual script would look like, and the right-hand side shows what the actual declaration for each section of that script would be. The second type of Jenkins pipeline is a declarative pipeline. And a declarative pipeline provides a simple and a friendly syntax to define what the pipeline should look like. And then you can actually, at this point, use an example to actually break out how blocks are used to define the work completed in a declarative pipeline. So how do you create a copy and backup of Jenkins? Well, to create a backup, periodically back up Jenkins to your Jenkins home directory, and then create a copy of that directory. It's really as simple as that. A question you'll be asked as well is how can you copy Jenkins from one server to another? Well, there are 3 ways to do that. One is you can move a job from one installation of Jenkins to another by copying the corresponding job directory. The second would be to create a copy of an existing job directory and making a clone of that job directory but with a different name. And the third is to rename an existing job by renaming a directory. So security is fundamental to all the work that we do within DevOps, and Jenkins provides the center core to all the work that gets completed within a DevOps environment. There are 3 ways in which you can apply security to authenticate users effectively. And when you are asked about this question of security within Jenkins, the 3 responses you want to be able to provide is A, Jenkins has its own internal database that uses secured user data and user credentials. B is you can use a LDAP or lightweight directory access protocol server to be able to authenticate Jenkins users. Or C, you can actually configure Jenkins to authenticate by using such as OAuth, which is a more modern method of being able to authenticate users. You're going to be asked how to deploy a custom build of a core plugin within Jenkins. And essentially, the 4 steps that you want to go through are, first of all, copying the .hpi plugin file into the Jenkins home plugins subdirectory. You want to remove the plugin's development directory if there is one. You want to create an empty file called plugin.hpi.pinned. And once you've completed these 3 steps, restart Jenkins and your custom build plugin should be available. How can you temporarily turn off Jenkins security if the administrative user has locked themselves out of the admin console? Well, this doesn't happen very often, but when it does, it's good to know how you can actually get into Jenkins and be able to resolve the problems of authenticating effectively into the system as an administrator. So when you want to be able to get into a Jenkins environment, what you want to be able to do is locate the config file. You should see that it's set to true, which allows for security to be enabled. If you then change the user security setting to false, security will be disabled, allowing you to make your administrative changes, and will not be re-enabled until the next time Jenkins is restarted. So what are the ways in which a build can be scheduled and run in Jenkins? Well, there are 4 ways in which you can identify the way a build can be scheduled or run in Jenkins. The first is when source code management commits new code into the repository. You can run Jenkins at that point. The second can be after the completion of other builds. So maybe you have multiple builds in your project that are dependent on each other, and when so many other builds have been executed, then you can have Jenkins run. You can schedule builds to run at a specified time. So you may have nightly builds of your code that illustrate the changes in the solution you're building. And then finally, you also can manually build an environment on request. Occasionally, you will want to also restart Jenkins. And so it's good that when a question around how do you restart Jenkins manually comes up, that you have the answers. And there are 2 ways in which you can do it. One is you can force a restart without waiting for builds to complete by using the Jenkins URL that you have for your environment /restart, or you can allow all running builds to complete before restart are required, and in which case you would use the command of the URL for your Jenkins environment /safe restart.
Hi guys, welcome to this video on Nagios interview questions and answers. Nagios or Nagios Core is a free open source computer software that is used to monitor systems, networks and infrastructure. Nagios was initially released in 2002 and since then has become the go-to solution for monitoring in the DevOps lifecycle. In this video, we have compiled the most important Nagios interview questions that you might face in a Nagios or DevOps interview. So without further ado, let's get started.
So let's look at continuous monitoring. So with continuous monitoring, how does Nagios help in continuous monitoring of systems, applications, and servers? And so this is really just a high-level question of using Nagios within your environment. And you should be able to just come back very quickly and say, Nagios allows you to help manage the servers and check if they're being sufficiently utilized and if there are any task failures that need to be addressed. And so there are 3 areas of utilization and risk that you want to be able to manage. This is being able to verify the status and services of the entire network, the health of your infrastructure as a whole, and if applications are working properly together with web services and APIs that are reachable. So the second question you'll be asked is, how does Nagios help in continuous monitoring of systems, applications, and services? So it's able to do this by having the initial Nagios process and scheduler and the additional plugins that you would use for your network connect with the remote resources and the Nagios web interface to be able to run status checks on a predefined schedule. So what do you mean by Nagios Remote Plugin Executor, or the NPRE of Nagios? So NPRE allows you to execute plugins on Linux Unix machines that allow you to do additional monitoring and machine metrics such as disk usage, CPU load, etc. What are the ports used by Nagios for monitoring purposes? In this example, there are 3, and they're easy to remember, so I would memorize these 3, but they're essentially ports 5666, 5667, and 5668. So there are 2 types of checks within Nagios. So you will be asked for what is an active and passive check in Nagios. So an active check is initiated by the Nagios process and is run on a regular schedule. A passive check is initiated and formed by an external application or process. So this may be where a system is failing. And results are submitted to Nagios for processing. And to continue with this, for what is an active and passive check, active checks are initiated by the check logic within the Nagios daemon. Nagios will execute a plugin and pass information about what needs to be checked. Plugin will then check the operational state of the host or service and then process the results of the host or service check and send out notifications. In contrast with the passive check, it is an external application that initiates the check. It writes the results of the check to an external command line file. Nagios reads the external command file and places the results of all passive checks in a queue for later processing, so you can go back and revalidate. And then Nagios may send out notifications, log alerts, etc., depending on the results that they get from checking the information. So you're going to be asked to explain the main configuration file and its location in Nagios. So the main configuration file consists of a number of directives that affect how Nagios operates. So consider this as the configuration file that is read by both Nagios processor and the CGIs. So this will allow you to be able to manage the main configuration file that's placed into your settings directory. So what is the Nagios Network Analyzer? And again, hold out your 4 fingers because there are 4 options here. So the Nagios Network Analyzer 1, provides an in-depth look at all your network traffic source and security threats. 2, allows system admins to gather high-level information on the health of your network. 3, provides a central view of your network traffic and bandwidth data. And then 4, allows you to proactive in resolving outages, abnormal behavior, and threats before they affect critical business processes. So what are the benefits of HTTP and SSL certificate monitoring with Nagios? So with HTTP certificate monitoring, it allows you to have increased server and services and application availability, obviously very important, fast detection of network outages and protocol failures, and allows web transaction and web service performance monitoring. The SSL certificate monitoring allows you for increased website availability, frequent application availability, and provides increased security. So explain virtualization with Nagios. So in response to this, the first thing you should be able to talk about is how Nagios itself can run on many different virtualization platforms, including Microsoft Visual PC, VMware, Xen, Amazon EC2, etc., etc. So just make sure you get that right off the bat. Nagios was able to provide capabilities to monitor an assortment of metrics on different platforms. It allows for quick detection of service and application failures, and has the ability to be able to monitor against many metrics, including CPU usage, memory, networking, and VM status. So name the 3 variables that affect recursion inheritance in Nagios, and it is name, use, and register. So name is a template name that can be referenced in other object definitions. Use specifies the name of the template object that you want to inherit its properties and variables from. And register indicates whether or not the object definition should be registered to Nagios. And on the right-hand side of the screen, we have an example of what that script would look like. Again, you may want to be able to memorize this, as it's something that you can actually write down and show someone if you're going through a technical interview. So why is Nagios said to be object-oriented? And fundamentally it comes down to the object configuration format that you can use in your object definitions. It allows you to inherit properties from other object definitions, and this is typical of object-oriented development and is now applied for the Nagios environment. So some of the objects that you can inherit are services, hosts, commands, and time periods. So finally, explain what is state talking in Nagios. And so there are really 4 options here when you're talking about state stalking. So state stalking is used for logging purposes in Nagios. It allows you to enable for a particular host or service that Nagios will watch over very carefully. It will log any changes it sees in the output of the check results. And then finally, helps the analysis of log files.
Hi guys, welcome to this video on the interview questions of configuration management tools, Chef, Ansible, and Puppet. Chef is a configuration management tool written in Ruby and Erlang, which provides continuous deployment, increases system robustness, and provides cloud integration. Ansible is another open source software tool for provisioning configuration management and application deployment. And Puppet is a configuration management tool that can also be used as a deployment tool and implements infrastructure as a code. In this video, we have compiled the most important interview questions of configuration management tools, Chef, Ansible, and Puppet that you might face in a DevOps interview. So without further ado, let's get started.
So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following: which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be #systemctl disable httpd.service, or is it system disable http.service, system disable httpd, or the final option, which is systemctl disable httpd.service. Your answer should be the first one, which is #systemctl disable http.service. So Chef comes with a series of tools that allow it to function effectively, and one of the tools that you're going to be asked about is, what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef Apply differ from Chef Client? So fundamentally, the difference between them is that Chef Apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do what is the command to sign a requested certificate, the top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the 3 options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's being done with Puppet. Version control can be extended with Git. And then the changes should be passed through Jenkins. So the 3 tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are 4. The resources are a basic unit of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just one or two roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often two different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to two things. One is that it makes it easier to distinguish strings and undefined variables. And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially three. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is, provide a differences between Ansible and Puppets. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So we dig deeper into the actual architecture. Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture.
So guys, let's start with Docker interview questions and answers. So guys, let's start with our first question. That is, what is Docker? So guys, Docker is a containerization platform that allows developers to package applications and their dependencies into standardized units called as containers. Very basic question, and I hope so you would be aware of this one. Now let's move on to our second question. That is, how does Docker differs from virtual machines? Kind of tricky, but still you should have an idea of this. And the answer to the same question is, like, what happens unlike virtual machines, which require a hypervisor to run multiple operating systems into a single physical machine? The Docker containers shares the host of its operating system kernel and only contain the application and its dependencies. And that's how it differs from virtual machine. I hope so you would have got an idea regarding the same. Now let us move to our third question. The third question is, explain the difference between Docker image and Docker container. So guys, very basic question, and the answer to the same is, a Docker image is a template for creating Docker containers. It's a read-only template with instructions for creating Docker container. Docker container is a runnable instance of Docker image. So guys, our next question is, how do you create a Docker image? So guys, Docker images are typically created using a Docker file which contains a set of instructions for building the image. The Docker build command is then used to build the image from Docker file. So in this way, you create a Docker image. So we'll move to the next question, which is related to the next one. And that is, what is a Docker file? So guys, a Docker file is a text file that contains instructions for building a Docker image. It includes commands such as from, run, copy, expose, and cmd. I hope so you would have got an idea regarding the same. Now let us move on to the next question. That is, explain the Docker run command and what it is. So guys, if we talk about the Docker run command, it is basically used to create and start a Docker container based on the Docker image. It can also be used to specify runtime options such as environment variables, network settings, and volume mounts. I hope so. You would have got an idea regarding it. Now let us move to the next question. That is, what is Docker Hub? So guys, if we talk about Docker Hub is a cloud-based registry service that basically allows users to store and share Docker images. It provides public and private repositories for storing images as well as an integration with other services such as GitHub and Bitbucket. Very basic question. Now let us move on to the next question. That is, how do you publish a Docker image from Docker Hub? So guys, if we talk about it, to publish a Docker image to a Docker Hub, you first need to tag that image with your Docker Hub username and the repository name using the docker tag command. It's very important, and remember this. And then you have to push the image to the Docker Hub using the docker push command. So it was pretty simple. Now let us move on to the next question. That is, what are Docker volumes? So guys, if we talk about what are Docker volumes, so Docker volumes are a way to persist data generated and used by Docker containers. They basically allow data to be stored outside the container's writable layer, making it possible to share the data between containers and persist data even if the container is stopped or deleted. Very simple. These are some of the basic concepts that you will find on Docker documentation. So whenever you are preparing for your interview, I'll advise you to go thoroughly to the official documentation with Docker. It really helps. Most of the questions, like scenario-based questions, coding-based questions, are generally asked from there. Now let us move to the next question. It's a pretty interesting one. So it is basically asked from the architecture, and the question is, what is Docker daemon? So guys, Docker daemon, often referred to as Dockered, is a background service that manages Docker objects such as images, containers, networks, and volumes. It runs on the host operating systems and handles requests from Docker Engine CLI or the other Docker client via Docker API. That is, so in this command, can you explain the significance of I flag, T flag, and docker run it ubuntu/bin/bash? So this is our command, and the interviewer is asking you to explain the significance of I and T flag. Okay, so basically the I flag stands for interactive. So whenever you use these flags, it keeps the standard input open even if not attached, essentially. It allows you to interact with the containers process, enables you to provide input to the commands running inside the container. And with respect to the T flag, if we talk about, then T stands for sudo TTY. T flag stands for sudo TTY. It basically allocates a sudo terminal for the container, allowing you to see the command prompt and providing a more shell-like interface for interaction. So without a T flag, you basically wouldn't get a nicely formatted terminal prompt, and your interaction with the container might also not feel as natural. So this is the significance of I flag and T flag. Now let us move on to the next question. What is the difference between add and copy in a Docker file? Very basic question. So guys, if we talk about add and copy, they basically both are used to copy files into the Docker image, but add additional functionality. Okay, so what does add do? It can basically copy files from remote URLs, decompress the files, and automatically set the file permissions. Very easy. Now let us move on to the next question. That is, what is the difference between CMD and entry point in a Docker file? So guys, if we talk about CMD, CMD specifies the default command to run when a container is started, while entry point specifies the command to run when the container is started and also additional arguments to be passed to the commands. So this was all about CMD and entry point. So guys, our next question is, what is Docker Compose? So guys, Docker Compose is basically a tool for defining and running multi-container Docker applications. It allows basically developers to use the YAML file to define the services and also networks and volumes. So that's a very basic definition of Docker Compose. So let us move to our next question. That is, so when a container exists, is it possible for you to lose the data? Like, very basic question. But the answer to the same is no, it's not possible to lose any data as long as the container exists. Like if you delete, then all the data will be lost. So that's the overall scenario for this question. It's a very kind of a tricky question, so just remember it. Now let us move to the next question. So next question is, what is the difference between logging and daemon logging? So very frequently asked question, guys. So container logging and daemon logging refer to the different aspects of logging within the Docker ecosystem. If I talk about the container logging refers to the logging performed by applications running inside Docker containers. Whereas each container has its own isolated environment and it can generate its own logs just like any other applications. Whereas container logging captures the output, which is SDE out, standard output, and std dir of the process running inside the container. By default, this output is captured by Docker and can be accessed using commands like docker logs. So this was related to container logging. Now if we talk about daemon logging, guys. So guys, daemon logging refers to the login performed by Docker daemon itself. The Docker daemon is responsible for managing containers, images, networks, and volumes on the host system. Daemon logging captures the events related to Docker's operations, such as container creation, container start-stop, image pull-push, network creation, and so on and so forth. So that's what's the basic difference between container logging and daemon logging. Now let us move to the next question. Does Docker provide support for IPv6? Very interesting question, guys. So if you are aware with the documentation, you will definitely answer this question. Yes, Docker does have some support for IPv6, but like as per as my knowledge, it has become quite comprehensive and it's maturing as its support for IPv4. So that's what in the process right now. Let us move to the next question, and this is related to scaling. So the question is, how do you scale Docker horizontally? So guys, horizontally scaling in Docker involves running multiple instances of a service across multiple Docker containers to distribute the workload and improve performance, availability, and fault tolerance. And here's you can basically scale it. So first one is using Docker Swarm and Kubernetes. So what happens using Docker Swarm and Kubernetes? It happens a process of container orchestration. So these platforms provide a built-in support for horizontal scaling. They allow you to define desired replica counts for the services. And also the orchestration platform manages the deployment and scaling of the containers automatically, like what Kubernetes does in this scenario. So this is one way, there can be multiple ways. So have an open eye regarding this question. It can be asked in the interview. So guys, our next question is, how does CMD and entry point differs in a Docker file? So guys, it's a very interesting question and kind of frequently asked. So guys, use entry point instructions when building an executable Docker image using commands that always need to be executed. And you are going to use CMD instructions when you need an additional set of arguments that can act as a default instructions until there is explicit command line usage when Docker containers run. So that's what the basic difference between entry point and CMD is. Now let us move to the next question. That is, what is the purpose of volumes in Docker? Very theoretical question. So guys, in Docker, volumes provide a way to persist and share data between containers and the Docker host. They have several purposes. Like if I talk about first is a persistent data storage, then sharing data between the containers, performing optimization, performance optimization, integration with external storage systems, and many more. So this is the purpose of volumes in Docker. Now let us move to the next question. That is, what is the difference between Docker restart policies, no, on failure, and always? Very interesting question. So guys, if I talk about no means no automatic restart. Containers remain stopped after exit. Like if I talk about on failure, here automatically restarts a container if it exists with a non-zero exit status, like there will be a specified number of attempts. And in the case of always, it automatically restarts a container regardless of the exit status. So that's what the difference between all of these policies are. No, on failure, and always. Please take a note of this question. This is kind of very important. Now let us move to the next question. That is, what is the difference between Docker container and Kubernetes pod? So guys, Docker Container is a lightweight, standalone and executable package that contains everything needed to run a piece of software, including code, runtime system, tools and libraries. It runs a single Docker host in a managed using Docker engine. If I talk about Kubernetes pods, it is a higher level abstraction that can contain one or more Docker containers along with shared storage, network resources, and configuration settings. It represents the smallest deployable unit in the Kubernetes, and it also provides an environment for running containers. So that's what the difference between the Docker container and Kubernetes pod is. Now, let us move to the next question. That is, how do you secure Docker containers? Very interesting question and kind of a practical question. So guys, securing a Docker containers involves several steps. So it's a combination of best practices and security measures to protect the containerized applications and the underlying infrastructure. Here are some of the key strategies. First, use the official images. Utilize official Docker images from trusted sources, as they are regularly updated and maintained within the security patches. The next one is container image scanning. Employ container image scanning tools to identify vulnerabilities and malware in Docker image before deployment. Third one, you can reduce attack surface. Minimize the attack surface by removing unnecessary components, limiting privileges, and using minimal base images. Next one is container isolation. You're going to utilize container isolation mechanisms like namespaces, C groups to restrict container access to the host system. You can also use secure configuration like configure Docker daemon and containers with the best security practices, such as using least privilege, disabling unnecessary features, and also enabling security options like SecOmp and AppArmor/SE-Linux. So these were some of the ways in which you can secure Docker containers. Now let us move to the next one. That is, can you tell me some of the best practices for using Docker in the production environment? So this is one of the practical questions that has been asked most frequently. So guys, the answer for this question is like using Docker in a production environment requires careful planning and adherence to the best practices to ensure reliability, scalability, and security. The first practice would be use official images. Utilize official Docker images from trusted sources as they are regularly updated and maintained with security patches. Next one is optimize container images. Minimize image size by removing unnecessary dependencies using multi-stage builds, optimize layer caching to improve deployment speed and reduce resource consumption. Third one is implement container orchestration. Use container orchestration platforms like Kubernetes or Docker Swarm to manage containerized applications, automate deployments, and achieve high availability and scalability. Fourth one, you can automate builds and deployments. Implement CI/CD pipelines to automate the build, testing, and deployment of Docker images, ensuring consistency and reliability in production environment. And finally, you can monitor containerized applications. So these were some of the best practices that you can follow while using Docker in a production environment. Now let us move to the next question. That is, how do you automate deployments of Docker containers? So guys, automating the deployment of Docker container involves using CI/CD, means continuous integration, and continuous deployment pipelines to streamline the process of building, testing, and deploying containerized applications. So first one is you can use version control. Store the application code and Docker configuration in version control systems like Git. Have a CI/CD pipeline setup. Set up a CI/CD pipeline using platforms like Jenkins, GitLab, GitHub Actions. Configure the pipelines to trigger on code commits or pull request to the version control repository. Third one is build Docker images. Use Docker files to define the container images for your application. Configure the CI/CD pipelines to build Docker images automatically whenever changes are pushed to the repository. Use tools like Docker, BuildKit, or Canico for building Docker images in a CI/CD environment. So in this way, you can automate the deployment of Docker containers. Now let us move to the next question. That is, how do you perform rolling updates in Docker Swarm? So guys, performing rolling updates in Docker Swarm involves updating services in a Swarm cluster without causing downtime or service disruption. The first one is you have to update service definition. Modify the service definition to specify the updated Docker image version or any other configuration changes which you are going through. You can update the service definition using the Docker service update command or by modifying the Docker compose file used to deploy the service. Second one is rolling update strategy. Specify the rolling update strategy to control how Swarm performs and the update. The rolling update strategy defines parameters such as number of parallel tasks and the delay between the updates. Common rolling update strategies include parallelism, delay, and failure action. For example, guys, you can specify a rolling update strategy within parallelism of 2 and delay of 10 seconds using the update parallelism and update delay flags. Very easy. So this was all about how you can perform rolling updates. Now let us move to the next question. So guys, our next question is, what is Docker Content Trust? So guys, Docker Content Trust is a security feature of Docker that provides cryptographic verification of image integrity and authenticity. It ensures that only verified and signed Docker images are pulled and run on Docker host. So guys, let's move to the next question. That is, how do you configure automatic container restarts in Docker? So guys, answer to the same is, to configure automatic container, it starts in Docker, use the double start flag when running the container. Specifying the desired restart policy. Your option can include no for automatic starts, on failure to restart container, and that exit with a non-zero status. And you can also use always to restart the containers regardless of the exit status. For example, there is a command like docker run // restart equals to always and your container name, which can be my container. So in this command, it sets a container to automatically and it restarts always. So this was the answer to this question. Now let us move on to the next question. That is, how do you configure custom logging driver in Docker? Very, very good question. So guys, to configure a custom logging driver in Docker, you can follow these steps. First one is choose a logging driver. Select the custom logging driver compatible with Docker, like you can use Splunk and syslog. Next one is update Docker daemon configuration. Edit or create the Docker daemon configuration file. Then add a log driver key with the value set to the name of the custom logging driver. You can optionally configure the additional logging driver options under the log ops key. So in this way you can do it. Now let us move on to the next question. That is, how do you manage secrets in Dockerized application? So guys, to manage secrets in Dockerized applications, use Docker built-in secret management or external tools like HashiCorp Vault. So in this way, you can basically manage secrets in Dockerized applications. These were some of the theoretical questions that I've asked you guys. Mostly were kind of basic. And now we'll move to the second part of the question. Now in this series, what we are going to see, mostly we are going to figure out some of the scenario and some of the file-based questions. So guys, as you can see, I am using VS Code as my text editor. So let us see what we have all over here. Okay. So guys, as you can see in this question, it says there is a certain code written all over here. This is basically a Docker file. So it says use the official Node.js image as a base image from Node 14. Then you are setting up your directory all over here. You are copying the JSON and you are installing the npm package. Then you are copying the rest of the application. You are exposing the port 3000. And in order to run the Node.js application, this command is written. Now some of the basic question I'm going to start with this Docker file. So your interviewer can ask you questions like explain each line of the Docker file and its purpose. So you can see I have added the comments all over here and it defines the purpose. So like from Node 14, this means that I'm using the official Node 14 version, this image. And similarly, all the other lines, I have added the code. Okay. Now let us move to the second question. What is the purpose of workdir/user/src/app? So basically, as you can see all over here, it is setting up the directory in this folder. Now, let us move to the third question, which says, why do we copy .json files separately from the rest of the application code? Now, this is a pretty interesting question. And your interviewer can ask you something like this based on your Docker file. So guys, the answer for this question is, we copy package star.json files separately to take advantage of the Docker layer's caching mechanism. So this basically ensures that all the dependencies are only reinstalled when the dependencies change rather than on every code change. So that's why we are copying package star.json files. So this is one of the interesting question and it can be asked. So now it's a very basic question, run npm install. Why do we expose port 3000 in the Docker file? Now let us see this question. So guys, exposing 3000 informs Docker that a container listens on the port 3000, which allows Docker basically to map that port to the host machine when we are running the container. And finally, it says what is the significance of command node app.js. So as I've told you, it basically is a command to run the Node.js application. So these are some of the basic questions that can be asked with respect to your Docker file. So you can have a check on these one. Now let us move to the next question. Now you can get an assignment certain like this, that write a Docker file for a simple Python Flask application. And you have to ensure that Docker file installs Python, copies the application code into the container, installs dependencies using pip, and exposes the port for Flask application to run on, say, port 3000. So basically you have just seen a template Docker file. Now we want to write a Python Flask application. So guys, let me show you the answer for the same. So similarly, you're going to start. So from Python 3.9, this is your latest Python which you want to use. Next process would be setting up your directory. So work.dir/app. Then you need to copy the current directory, copy./app. Install the Flask and other dependencies. So you're going to install it using pip. So run pip install /no cache directory Flask. Okay, and then you are going to expose your port like to 5000 to allow this communication to the Flask app. And finally, you are going to run this application. It is very simple, just a template I have used earlier. And in this way, your interviewer can give you some hands-on task to code a Docker file. Now let us move to the next question. I hope so you would have got a brief idea regarding this. Now, similarly, it says, write a Docker file that builds a custom Nginx image with SSL support. Now, okay, let me do this. Now it says, ensure that Docker file copies custom Nginx configuration files and SSL certificates into the image and exposes ports 80 and 443. So what is this, guys? If I talk about this, basically it is asking for you to build a custom Nginx image, okay, and it should have an SSL support. Now it should copy the custom Nginx configuration files and also the SSL certificates into the image, and it has given the specified ports to expose. Now, how would you tackle this? So the answer to the same is very basic. Start from Nginx, the latest version. Now you have to copy the Nginx configuration files. So say copy nginx.conf/etc nginx nginx.conf. Okay. Then you would do copy default conf, etc. nginx confd and default conf. So basically you are writing this code to copy the custom Nginx configuration files. Okay. But these are the two-step process. And next was to copy the SSL certificates. So copy the SSL certificate in the same fashion. So there will be a key and certificate. Now you have to expose the port 80 and 443. So for the HTTP, this would be an HTTP traffic, and this would be for HTTPS traffic. So this is how you are going to use it. It's a little bit tricky and complicated, but it's a template for you. Like if you are getting certain question regarding to use an Nginx or to expose two ports, you can use this template. It works perfectly well. Now let us move to the next question. That is implementing a multi-stage Docker build for Java application. So guys, it says you have to write a Docker file that compiles the Java application using Maven in the first stage and then copies the compiled jar file into a lightweight runtime image in the second stage. So this is a two-stage process. And so let's start with the first one. Let's figure out what is there in stage one. So it says that in stage one, you have to write a Docker file, okay, where it copies the compiled jar file into the lightweight image. This is in the second. And in the first one, it compiles a Java application using the Maven. Okay, very basic. So let me show you the template for this one. So there's a comment for stage one. So you have to use Maven. So I have selected from Maven 3. This is a current version, and for OpenJDK 11 AS Builder. So I'm building a Java application using the Maven. I'm setting up the directory all over here. Then I'm copying the Maven project descriptor file, so that will be a pom.xml file involved here. You're going to copy the source code finally, and you're going to build the Java application. So there is an ambient command for the same, run ambient package. So this is your stage 1 process. It's very important for you to see this. It's also kind of a little bit tempting question. Now, in the second stage, you have to build the Java application with Maven run ambient package. So here you have to create a lightweight runtime image. So I have used from OpenJDK 11 JRE Slim. Set up the working directory, copy / from builder / app target myapplications.jar. So you have to copy the jar files. Then you have to expose the given port. So 8080 is a port for the server. And finally run it, the cmd java jar and myapplication.jar file. So this is how we approach to a problem in a multi-stage process that are told to write in a Docker file. So as you practice more and more questions like this, guys, I am definitely sure that it will boost your confidence to tackle questions like these. Now, let us move to the next question, which are scenario-based questions. So guys, first scenario-based question is, like, suppose there is a Docker container which is unable to communicate with another container on the same Docker network. But how would you diagnose and troubleshoot network connectivity issues between the containers? It's a very practical question, and there is a high probability that your interviewer can ask this. So guys, to troubleshoot and resolve a Docker container, start a failure related to containers entry point script, you should follow these steps. First one is check the container logs. Okay, so start checking by container logs to see if there are any error messages or any exceptions related to the entry point script. You can use commands such as docker logs commands to view the containers logs. Next one is inspect the container configuration. Use docker inspect command to inspect the container's configuration and verify the entry point script specified in the Docker file. Third one is you can verify the entry point script permissions. Here you have to ensure that the entry point script has the correct permissions to set the executable within the container. Fourth one is to test the entry point script locally. You have to copy the entry point script from the container to your local machine and test it to see if it executes successfully outside the container environment. So this basically can help to isolate any issues with the script itself. So these are some of the process in which you can follow up to check if one of the containers is not able to communicate with the other on the same network. Now let us move to the next question. That is, it says you are trying to build a Docker image for a Python application using a Docker file. Okay. However, the build process fails with an error indicating that a required Python package cannot be installed. How would you modify the Docker file to ensure the package is installed successfully? Wow, what a great question. Let us try to tackle this question. So guys, any issues related to diagnosing and troubleshooting network connectivity involves like between Docker containers. There can be a varying steps that one can go, but I'll approach this problem something like this. First of all, I would check the Docker network configuration. Okay, I'll start by verifying both of the containers. Are they connected to the same Docker network? Okay, and for this, I can use Docker network inspect command. Next one is I can verify the containers IP addresses. Check for the IP addresses assigned to the containers within the Docker network. For this purpose also, you can use a Docker inspect command. Third one is you can test the connectivity using ping. You can use a ping command to test the connectivity between the containers by pinging one container from other using its IP address. Next one is check the firewall rules. Ensure that there are no firewall rules blocking the traffic between two containers within the network. Then inspect the containers processes and ports. Check if the required services or processes are running inside the containers and listing on the correct ports. And finally, check for Docker logs for errors. Inspect the Docker container logs for any errors or warning related to network connectivity. For this purpose, you can use Docker logs command. So in this way, you can troubleshoot your program. So guys, here's the next question. And it's a pretty interesting one. And it says something like this. Suppose you have a Docker Compose file that defines multiple services for a microservice architecture. Okay, and then each service runs a different application component such as front end, back end, and a database. However, you notice that the front end service intermittently loses connectivity to the back end service. How would you troubleshoot and fix this issue? This is a very practical problem, and when you are deploying your application on Docker, you might face these issues. So your interviewer can ask you this type of question also. So how would you approach this question? So the answer to the same is so guys, whenever you have a problem related to troubleshooting the intermittent connectivity issues between services in a Docker Compose setup, so it can be a little bit of complex issue. But if you go through a systematic approach, like which I'm going to tell you, you might find an easy way to resolve this issue. So first of all, what I would like you to do is you have to check your Docker Compose configuration, where you have to ensure that your Docker Compose configuration in the docker compose.yml file is correctly defined the network settings for the services. You have to pay attention to the services names like the ports, network mode, and minimum. Then you have to inspect the logs. Check for the logs of both front-end and back-end services for any error messages or warnings that might indicate the network-related issues. For this purpose, use Docker Compose logs to view logs for specific services. Third one is you have to check for the container health check. You have to verify that the health of the containers running in the front-end and the back-end services. Use Docker PS to list all the running containers and check their status. If any container is restarting frequently or has exited unexpectedly, investigate the cause. Fourth one is network connectivity. Check if the front-end service can be resolved the host name of the back-end service. You can do this by executing a command within the front-end container, or ping resolve the host name of the back-end service. For example, you can type this command like docker compose, then exec. Then suppose your front end is a given directory, so write front end and try to look up nslookup backend. So you can type this command all over here and it's going to check a given issue. So guys, you can type this command to troubleshoot this issue. Next thing is you can also try for service dependencies. So you have to also ensure that the front-end service waits for the back-end service to be fully initialized before attempting to connect. Sometimes intermittent connectivity issues occur because of the front-end service starts before the back-end service. So you can add a delay or retry mechanism in the front-end service initialization script. Now, finally, you have to check also the Docker networking, where you have to review the Docker's networking modes like bridge, host, overlay, etc. And you have to ensure that the chosen mode is appropriate for your setup. Please make it sure that this is a very important point. And also you have to look for Docker built-in networking features like user-defined networks for better isolation and control over communication between the services. So this is one thing. Now, let us move to the next part. That is the next question. So it says you are attempting to optimize a Docker build process for large Java application. But however, you are encountering a challenge where the final image size is larger than expected. So how would you prefer to refactor the Docker file to reduce the size of the final Docker image without sacrificing the functionality? Very practical question, guys. So how would you approach this question? Take a time as you have read the documentation or did some projects. So you can pause this video for a while and try to think of an approach which can resolve this issue. So I would approach this question something like this. So in order to reduce the final Docker image size for the Java application using multi-stage builds, first I would check the base image selection. You have to choose a minimal base image for the final stage, such as an Alpine Linux or distroless Java, to reduce the size of the image. Next one, you have to minimize the dependencies in the final image, excluding unnecessary packages and libraries. Utilize tools like Maven or Gradle to exclude dependencies which are not required for the runtime. Third one is optimize copy operations. You have to optimize copy operations by copying only necessary files and directories from the build stage to the final stage. Utilize Docker ignore to exclude all the irrelevant files and directories from the build context. Next one is layer optimization. Guys, combine multiple run commands into single run instruction to reduce the number of layers in the final image. You have to utilize Docker build cache efficiently by ordering commands from the least frequently changed to the most frequently changed. And finally, you have to look for static content compression. Compress static content like HTML, CSS, JavaScript file using techniques like Brotli or gzip before copying them into the final image. So this is how I would try to do it. And one more point I can add it, that I can also review the container configuration optimization. I would review and optimize JVM and application server configurations to reduce the memory footprint and also improve the performance. I'll adjust JVM heap size, garbage collection settings, and thread pool configurations based on application requirements. So in this way, if you approach this question, I think so your interviewer will be very, very impressed. Now, let's move to the next question, which is the question, when you are deploying a Dockerized application to a Kubernetes clusters using Helm charts, however, when you attempt to deploy the application, you would encounter an error indicating that the container is unable to mount a volume. And how would you debug and resolve this issue within the Helm charts and Kubernetes deployment configuration? Quite an interesting question. Now, let us see the approach to solve this problem. So guys, whenever you want to debug and resolve the issue of a container which is unable to mount a volume in a Kubernetes cluster deployed using Helm charts, you can follow these steps. First of all, inspect the Helm chart configuration. Review the Helm chart templates and value files to ensure that the volume configuration is correctly defined. Then you have to verify that the volume type name, mount path, and other properties are accurately specified in the Helm chart. Check for Kubernetes resources. Use kubectl get pods, kubectl describe pods, or kubectl logs command to inspect the status and logs of the pods affected by the volume mounting issues. So guys, you can use these codes. Okay, these are the certain commands. So, okay, this is one, or same, and here you could just type describe pods, or you can go for kubectl logs. Okay, and you can make the k as small. Okay. So this makes one of the answers for this question. Next thing is, what you can do guys, you can verify the volume configuration. Check for persistent volume and persistent volume claim, PV and PVC. Use these resources and check that they are correctly configured and available in the Kubernetes cluster. Ensure that the PV and the PVC have matching names, storage class, access mode, and other properties required for volume provisioning and mounting. Next one is troubleshooting the volume provisioning. If dynamic volume provisioning is used, you have to verify that the storage class is specified in the PVC available and capable for provisioning the volumes. You have to check the status of the storage provider, like the cloud storage service, to ensure that it is operational and accessible from the Kubernetes cluster. Then fifth one is permission and access. You have to ensure that the Kubernetes service account used by the pod has the necessary permissions to access and mount the volume. If using secrets or config maps as volumes, you can verify that they are correctly configured and accessible by the pods. So these were some of the points which you can mention, and in this way, you will completely answer this question. Now, let us move to the next question. That is, suppose you have a complex microservice architecture, okay, which is deployed on a Docker Swarm cluster. Now, one of the microservices which handles critical financial transactions experiences intermittent performance issues, causing delays and potential financial losses. You need to diagnose and resolve the issue promptly to ensure the stability and reliability of the application. So, how would you approach this question, guys? So guys, diagnosing and resolving intermittent performance issues in a critical microservice handling financial transactions on Docker Swarm cluster requires kind of bit systematic approach. So first of all, I would like you to look for monitoring and logging. You have to utilize Docker Swarm's built-in monitoring capabilities or the third-party monitoring tools to gather metrics on CPU usage, memory utilization, network traffic, and container health. Analyze container logs for any error messages, warnings, or patterns indicating performance bottlenecks. Check resource utilization metrics to identify if there are any spikes or anomalies in CPU or memory usage that coincides with the performance issues. Ensure that the microservice has sufficient CPU, memory, and network bandwidth allocated to handle peak loads. Third one is network latency. Investigate network latency between the microservice and other components in the Docker Swarm clusters, including databases, external services, and other microservices. Check out for network congestions, packet loss, or communication issues that could impact performance. Fourth one is you have to look for database performance. Examine the performance of database assessed by the microservice. Monitor query execution times, database logs, and indexes to identify potential database-related bottlenecks. You can also go for optimizing the database queries, indexes, and configuration settings to improve query performance and reduce latency. Now, next thing what you can do is you can go for scaling and load testing. Consider scaling the microservice horizontally by adding more replicas to distribute the workload across multiple containers. You can perform load testing to simulate real-world transaction volumes and identify performance limits and scalability issues. Next thing, you can go for continuous monitoring and alerting. Implement continuous monitoring and alerting systems to proactively detect performance issues and notify stakeholders in real time. Set up alerts based on predefined thresholds for CPU, memory, latency matrix to trigger investigation and remedial actions. Now, what you have to do next is do incremental changes and testing. Make incremental changes to the microservice configurations, code base, or infrastructure settings based on diagnostic findings. Test changes in staging environment before applying them to the production to ensure they do not introduce regression or new issues. So guys, by following these steps, leveraging monitoring, diagnostic, optimization techniques, you can diagnose and resolve intermittent performance issues in a critical microservice, ensuring stability and reliability of the financial transactions which you have applied running on the Docker Swarm cluster. So guys, let us start with our first question. And the question is, what is DevOps? So guys, DevOps is a set of practices that combine software development and IT operations to shorten the systems and also deployment lifecycle to provide continuous delivery with high software quality. Basically, what DevOps does is it actually emphasizes collaboration, automation, and monitoring throughout the entire software development. And you have to do coding to deployment, and also you have to do the maintenance. So this is the entire thing about DevOps. Now let us move on to the next question. Next question is, what are the key benefits of DevOps? See, for someone who is actually adopting DevOps thing in their software development process, the first and the foremost thing is you're going to get faster time to market. By automating the process and fostering collaboration, DevOps is going to allow teams to deliver applications and features more quickly and reliably. There is improved collaboration. DevOps actually breaks down silos between development, operations, and other stakeholders, promoting a culture of collaboration and shared responsibility. And finally, if I have to say, the quality of softwares that you deliver has an enhanced quality. There is automation in testing and deployment, which is ensuring better consistency and fewer errors, leading to higher quality software. So these were some of the benefits of using, let's say, DevOps. Now let us move on to our next question. The next question is, what are the key components of DevOps? So guys, the key components of DevOps are, first of all, collaboration, because collaboration promotes different teams coming up together to collaborate on developments, operations, and this happens throughout the organization. Next thing is automation. When you are automating repetitive tasks like testing, deployment, and infrastructure provisioning, it improves efficiency and reduces human error. Then you have something called as continuous integration. Developers frequently integrate code changes into a shared repository to detect issues early. Then you have continuous deployment. This practice actually automates the release of software, pushes update to production as soon as they are verified. And finally, you deal with monitoring. Continuous monitoring ensures the health and performance of applications in real time, enabling rapid response to issues. So guys, these were some of the key components of DevOps. Now let us move on to the next part. And the next question is, what is continuous integration? So guys, continuous integration is a practice where developers frequently commit code changes to a shared repository. You have automated builds, and tests are triggered upon each commit to detect errors early, which ensures that the software is always in a deployable state. I hope so, guys, you would have got a brief idea regarding this question. This was a pretty basic one. Now, similarly, we have another question. Let's say the question is, what is continuous deployment? So continuous deployment extends continuous integration by automating the release process. And once the code passes the automation test, it automatically gets deployed to production without manual intervention. And it ensures quick and consistent delivery of new features and bug fixes. Now, let us talk about the next question. And the next question is pretty interesting. Name some popular DevOps tools. So first of all, you have Jenkins, which is an open source automation server for CI and CD. Then you have Docker, which is a tool for automating deployment of application inside a lightweight portable containers. Then you have Kubernetes, which is an open source platform for automating the deployment, scaling, and management of containerized applications. After that, you have something called as Terraform, which is an open source infrastructure as a code tool to provision, manage infrastructure across multiple cloud providers. Then you can talk about Git, which is a version control system for managing code changes and also collaborating on development. Then we can talk about Ansible, which is a configuration management tool for automating infrastructure tasks. And finally, we have Prometheus for monitoring and alerting, let's say if any microservice fails. So this is a toolkit which is actually designed for reliability and scalability in the modern cloud native environments. So these were some of the popular DevOps tools. Now let us talk a bit about the next question, which is what is version control and why it is important. So see guys, version control is a system basically that tracks changes to files, especially source code, over the time. It allows multiple developers to collaborate efficiently, track changes, and revert to previous versions of code. For example, like when you use Git all over here. So Git is the most widely used version control system in DevOps. Similarly, you can find Bitbucket. Most of the people use it. So these are some of the important things. Now let us move on to our next question. The next question is, what is the difference between Git and GitHub? So guys, Git is a distributed version control system for tracking changes in the source code. It allows developers to work locally and manage version control. Whereas GitHub is a cloud-based platform that hosts Git repositories and provide additional features like collaborative tools, pull request, and project management capabilities. Next question is, what is infrastructure as a code? If I have to say, guys, infrastructure as a code is the practice of managing and provisioning computing infrastructure using machine-readable configuration files rather than manual hardware-based configurations. And this is a pretty interesting process because IAC enables automation, consistency, and scalability in managing infrastructure. Next question is, what is a pipeline in DevOps? So guys, a pipeline in DevOps is a series of automated processes that allows software to be built, tested, and deployed in stages. It includes, you have something called as build pipeline, you have something called as test pipeline, then you have deployment pipeline, and these are some of the most important pipelines that you will come across in DevOps process. Now guys, let us move on to the next part, which is intermediate level questions. So the first question is, what is Docker and why it is used? So see guys, Docker is a tool that allows developers to package application and their dependencies into containers. So guys, containers are something where which basically stores the images of the technology which you are using. Let's say if you are using Node.js, so you might have the Node.js image all over here in the containers, which is very much important for your given microservice or let's say any project which you are doing to hold it up. So containers are basically lightweight, they are consistent across different environments, and that makes it easier to deploy applications anywhere. Now let us move on to the next question. The next question is, what is the difference between containers and virtual machines? See, containers share host operating systems, kernel, and are more lightweight and faster to start. But virtual machines include entire operating system, which makes them more resource intensive but can run different operating systems on the same hardware. Next question is, what is Kubernetes? So see guys, Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It helps manage complex systems that consist of many containers by automating scheduling, scaling, and load balancing. Now, the next question is, what are the CI/CD tools that are commonly used in DevOps? So see guys, the tools, you can name it like Jenkins, GitLab CI, Travis CLI, Circle CI, TeamCity is there, then you have Bamboo. These are some of the important CI/CD tools. So if you are in, let's say, talking about any of these tools, so make sure you have a good idea, because interviewer might go in depth with that tool and ask you some of the production practices or any important concept that is aligned with that tool. Now let us move on to the next question. Next question is, what is configuration management? So see guys, configuration management is the practice of systematically managing and maintaining a computer system's configuration. So use tools like Ansible, Chef, and Puppet, which automate the process of configuring servers, applications, and other infrastructure. Next question we have is, this is a pretty interesting question, and the question is, what is shift left testing? So see guys, shift left testing is a practice of testing kind of very early in the software development process, starting from requirement phase, to ensure that defects are caught earlier. Thus, it reduces cost and improves product quality. Let's move on to the next question. Next question is, what is the role of monitoring in DevOps? This is a very important question. So monitoring actually in DevOps ensures that systems are running as expected, and it involves tracking the performance and health of the applications in real time. You have tools like Prometheus, Grafana, Nagios, with which teams can detect failures, monitor KPIs, and respond to incidents quickly. Next question we have is, what is a microservice architecture? So see guys, microservice is an architectural style where application is built as collection of loosely coupled, independently deployable services. Each microservice handles a specific business function which can be developed, deployed, and scaled independently. Now let's discuss a bit about the next question. The next question is commonly asked question in the interviews, and that is, what is a blue-green deployment? So see guys, blue-green deployment is a strategy for reducing downtime and risk by running two identical production environments, which are called as blue and green. The new version of the application is deployed to the green environment, where blue environment remains live. Once the green environment is tested and verified, then traffic is switched over to it. So guys, next question is, what are some of the best practices for CI/CD pipelines? See, if I just talk about the best practices for the CI/CD pipelines, the first thing is automation testing. You have to make sure that all the tests are running automatically to catch detects early. Then you have to do monitoring and reporting. You have to monitor each stage and report errors quickly and fix them ASAP. Then you use version control, because all code should be committed to a version control system like Git. And you have to keep your pipelines small and fast. Shorter pipelines improve speed and make a failure easy to debug. So those are some of the important, let's say, CI/CD practices all over here. Now let's move on to some of the advanced level question. And the first question that we have is, what is DevSecOps? So see guys, DevSecOps is an extension of DevOps that integrates security practices within DevOps workflow. The goal is to shift security left by incorporating it early in the development process rather than leaving it as afterthought. So this is all about DevSecOps. Now let's move on to our next question. And the next question is, how do you handle secrets in a DevOps pipeline? So see guys, secret management involves securely storing and managing sensitive information such as API keys, passwords, and certificates, which are used in DevOps pipeline. So you use tools like HashiCorp, Vault, AWS Secret Manager, or Azure Key Vault, which are commonly used in this purpose. Now let's talk a bit about next question, which says, how does Terraform differs from Ansible? So see guys, Terraform is primarily used as an infrastructure as a code tool, which is used to provision and manage infrastructure, where Ansible is a configuration management tool that automates the setup of software and systems on the infrastructure that has already been provisioned. Now let's talk a bit about the next question, which says, how would you implement high availability in the DevOps environment? This is a pretty interesting question. So availability in DevOps environment can be implemented using load balancers, multiple server replicas, automated failover systems, and cloud services with built-in redundancy. And this ensures that critical services are duplicated across regions or data centers that improves availability. Now, let's talk a bit about what are the key metrics to measure DevOps success. And the key metrics include, for example, you have something called as deployment frequency, which says how often code is deployed to the production. Then the next parameter is change lead time, which basically says what is the time taken from code commit to the deployment. Then you have mean time recovery, MTTR, which says how quickly systems can recover from failover. Then one more parameter is change failure rate, which says the percentage of failed deployments. Then you have something called as customer satisfaction, which measures how satisfied customers are with the product. Now let's talk a bit about the next question, which says, how do you ensure zero downtime deployment? So see guys, zero downtime deployment strategies include rolling update, which means that you have to gradually update application instances to avoid downtime. Then you have blue-green deployments, which says you have to switch traffic between two environments. Then there is canary releases, which means that you have to gradually roll out changes to a subset of users before full deployment. So guys, with these, you can actually ensure zero downtime. Now let's move on to our next question. And the next question is also a pretty interesting one, and it asks, what is chaos engineering? So guys, chaos engineering is the practice of intentionally introducing failures into a system to test its resilience. So by simulating various disruptions, for example, network failures, server crashes, with which team can identify weakness and improve system reliability. Let's move on to our next question. The next question says, how do containers improve CI/CD process? And the answer for the same is, containers help streamline CI/CD by providing consistent environment for development, testing, and production. And this eliminates the work on my machine, as you say, and which actually solves the problem and ensures that code is behaving the same in all stages of the pipeline. Now let's discuss a bit about the next question. And the next question is also a bit interesting, and it has more of a realistic significance, which says, how does cloud computing integrate with DevOps? So see guys, cloud computing provides on-demand infrastructure, scalability, and flexibility that supports DevOps practices. Cloud platforms like AWS, Azure, and Google Cloud integrate with CI/CD tools and facilitate automated deployment, scaling, and monitoring. Now let's discuss our last question, which says, what's your approach to troubleshooting a failed deployment? And your options are, you have to check logs first. Start by reviewing the logs from the deployment process to identify the errors. Roll back. Let's say if the issue is critical, then you can roll back to a previous stable version. Third thing I would do is isolate the problem. You can use debugging tools and isolate the issue in the pipeline or the code. Next, you do test and staging process, where you have to replicate the issue in the staging environment to prevent any future occurrences of that problem. And finally, collaborate, engage with development, operations, and QA teams to resolve the issue.
And with that, we have reached the end of this session on DevOps Engineer Full Course for Beginners. Should you need any assistance or any other resources used in these sessions like PPT, project documentation, GitHub links, doubt clarification, and others, then please let us know in the comment section below. And a team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning. Stay tuned for more from Simplilearn.